Hi and welcome to Crio.Do's ultimate guide to your introduction to Java programming. Over the next 10 hours, our mentors will guide you through a comprehensive course designed to help you master one of the most powerful and widely used programming languages in the world. Used both by developers and companies globally, Java comes in handy while building a wide range of applications, including web and mobile applications. Due to these reasons, Java is an essential skill set if you're looking to grow your career as a developer. By the end of this coursework, you'll be able to create your own Java applications and tackle more advanced topics with confidence. Before we dive into the world of Java programming, check out our website www.crio.do to learn more about us and the programs we offer. You can find the link in the description below. So grab your keyboards and let's get started on the exciting learning adventure into the world of Java programming. All the best and happy learning!
Introduction to Java. In this course, you're going to learn everything about the Java programming language, and you will be able to create and write programs which would be helpful in your real world tasks. So without waiting, let's go ahead. In this week, you're going to study about the basic constructs of the Java programming language. In the next week, you're going to study about object-oriented concepts, and in the final week, you're going to study about some advanced topics of Java. Rest assured that after understanding all these tasks, you will be able to complete your assignments and your projects, and you will be able to do any program in Java language without any problem, because we are going to cover up each and every topic of Java. In this week, we are going to study about the features of the Java programming language. What makes Java different from the other programming languages? We are going to set up the environment for Java. Obviously, we would want to keep doing our coding, right? Then we're going to understand exactly how Java functions, the entire ecosystem of Java, what is there on your machine and what is it that helps make Java its magic. Then we are going to understand IDE, meaning Integrated Development Environment, which is going to be really very helpful for us. And we are going to use one of the IDEs, which is very famous in the Java domain, which is Eclipse. We are going to understand how to use an IDE and what are the benefits of using Eclipse, and how to be very productive in Java coding. Then we will write our very first Java program, and then there is no stopping and there is no looking back. We're going to see how we could run Java application and how we could do some sort of debugging. So debugging is a process to find bugs or problems or errors in your program. Obviously, whenever you start doing some things, it may not be that in the very first go your program will run very well, right? So there might be some problems, and problems are a part of the whole coding journey. In fact, you're not learning anything if you do not land into problems. So if you have problems and you want to find out what are these bugs, what are these problems which are coming to me, and from where exactly they are coming to me, how to solve them, that process is known as debugging. We will understand how to do that debugging in our IDE and generally within Java program. We're going to deep dive into what are the various data types and what are the various operators available in Java, because after all this programming and everything is something which we are doing to ease our tasks, to automate things, to do some calculations, right? So we need to know how to use the language to do our tasks. We will see how we can use conditional statements of Java to either go ahead or not go ahead for certain things. We will see how we could use iterative statements of Java to keep doing a certain task again and again and again. And after all, we use machines for that only, right? And we will see what are the other control statements which Java provides us, which would make our programming life very, very easy. Then we will see how we can reuse a particular set of code again and again just by calling it by name in terms of functions and methods. And then we are going to see how we could use a special type of data structure in Java, which is known as array. It stores our data one after the other in memory like a row. So we just want to call that particular data row with a name, and we can simply use that name to find out any data within that row, manipulate the data, work with that data essentially. So we will study how we could work with that data which is put one after the other in memory. Then we are going to work with strings, meaning that data which I just told you, which is put one after the other in memory, that data, if it is in the form of characters, just like this whole paragraph and bullet points which I just wrote, right? All of this information is a string of characters, and we just want to know how we could work with these whole set of characters. For example, if we want to search anything, if we want to replace anything, all of that common tasks, how do we do that in Java? We're going to study that. And we are going to study much, much more. So stay tuned with me. So let's look at some of the features of Java. The very first and the most important features, I would say, is that Java is very, very simple. So earlier, the programmers would have to write in a particular programming language in which they would have punch cards in a supercomputer, and then those cards would be run one by one in batches, and that was the whole process. You also know that machine does not understand any language other than zeros and ones. Now imagine if you would have to code in that language which only involves zeros and ones. Your brain would explode, right? You would not be able to write a very simple program as well. Today, the market is such that we can write complex programs. The programming language and the processes are in such a good place that we are able to output so much to an end user. How is that possible? That is possible with simple programming languages like Java. So as you know, that the first programming language which became very, very famous when object-oriented programming constructs were added to the C language, that became C++. Java is also similar to C++, but then it avoids any poorly understood or confusing features of C++. Like, for example, there is no need of header files, pointer arithmetic, structures, unions, operator overloading, or virtual base classes in C++ if anybody is from that background. But Java is very easy. It's a high-level programming language, so it's not a machine language of zeros and ones. It is something which is easier to understand. It has avoided all the confusing aspects, and a person is able to easily learn and use it. The other aspect, which is object-oriented programming, as I just said, that really changed the scenario of programming. So earlier, let's say the C language was procedure-oriented. You did not care a lot about data. You cared about procedures on that data. So you give me any data, I would do X, Y, Z things on that. And that was the main crux of how the programming language would work. But then object-oriented concepts said that no, data is not secondary. Data is primary, in fact. Our data or objects in real life are primary, right? So object-oriented programming is simply like real life. We have objects and we have things which we can do with objects. Every object has some properties. Every object would have something which we can do with them. So Java also took that concept of object-oriented programming from its very beginning. So Java from the beginning itself was an object-oriented programming language, just like C++, and that's why we have all the advantages of object-oriented programming in that. Java is also an interpreted language, meaning that Java has an interpreter for each machine, each operating system on which it works. So here's the thing. There are a number of operating systems in this world, right? Would you mind writing different codes for different operating systems doing the same task? Of course not. You want that I want to write just one code and I want some mechanism in which that code should run on Windows operating system, Mac OS, or Linux, or different versions of Linux, all of that. So that is really possible if you could have some sort of an interpreter which will actually take the code and see to it that, oh, this is exactly what the user wants. Now let me just convert it into some form which would be very friendly for this particular OS on which I am installed. So what it will say is that, see, this is the user program. I have converted it to what you want and please execute that. That is the interpreter. So it would take that Java bytecode, and I'll just explain what a bytecode is in a moment. So it would take the Java bytecode and it would run that, execute that directly on any machine on which an interpreter has been ported. Okay. Java is distributed, as in it was designed with the distributed environment of the internet in mind. So internet uses all these protocols, right? TCP, IP, HTTP, FTP, all of that. So Java has extensive support, extensive libraries for your routines of all these protocols. Okay. So we can simply use Java in any distributed environment, and it will be able to do all the communications with these protocols. Now, when you have a distributed environment, when you have a lot of communications, the main important aspect of any application is security, right? So Java is something which would help in that. It would help in enabling the construction of virus-free or tamper-free systems. And then again, Java is robust. There is strict typing in Java. which would help in error-free programming. So it's not that your programs are not reliable. If you feel that your program is working on your machine, it would be working on the environment as well if you have configured things properly. It is pretty robust. It does not break. It does not give errors in any other form which you might not expect to. And there is a lot of early checking of possible problems happening. So Java gives a lot of that aspect, and that's why it becomes robust. So if it is secure, if it is robust, if it can be worked on a distributed environment, what is that application which would definitely want to work with Java? Any guesses? Banking applications. So banking applications generally use Java. So even today, if you work for any banking application, you would realize that most of the times it is on the Java programming language just because it is so secure and so robust. Java is also a dynamic programming language in the sense that libraries can freely be added, new methods and instance variables, all of that can be added to Java libraries. The star of Java is actually automatic memory management or garbage collection. So what happens is that you create data while you are coding your program. It may be that you do not really need that data henceforth. So what used to happen earlier, like with C language, even today, there is a lot of memory issues which would happen just because the waste memory, which is not to be used, is not freed from the space. It is as if your code is using a lot of memory, while in fact, it is not really using all of that memory. So what Java does is that it collects all the useless data and it simply frees that memory to be available for any other data which you want to use or you want to create with your code. So that automatic memory management really helped Java to be very, very efficient. Architectural neutral, of course, as I said, that whatever architecture is there of the machine or of the operating system, we do not care about that. So you have your Java code. What happens is that your Java compiler will convert that code to something known as bytecode. Okay. So once that bytecode is created, then that bytecode can be run on any different OS just because of the different interpreter of Java on that particular OS. So that's why it becomes architecture neutral, or you can say it becomes portable. So how does it become portable? Just because it has a particular Java runtime system for that particular OS. And again, Java is having a lot of high performance, and that's really important for applications, right? And the last thing of Java, which is one of the most important things, is multithreading. Java programs allow different threads, and we will go into what exactly these threads are, how they work, how do they communicate, all of that. But in simple terms, let me put it in such a way that you have one program, but that one program can do multiple tasks at the same time. That is possible just because you have different threads which are doing those different tasks. And Java allows multitasking with using multiple threads running at the same time. Okay, so that's a simple definition of that. Multithreading means a single program having different threads executing independently at the same time. Okay, so I just have given you so much of information about Java. Now, if you did not understand any of that part, that's absolutely fine because I'm going to show you everything with practical examples. So there you will definitely understand it. So stay tuned with me. We have a lot to cover. Now, what can we make using Java? We can make desktop applications using Java. We can make web applications using Java. We can create applications just for use within big enterprises. We can make enterprise applications using Java. We could create mobile applications using Java. And we could create embedded system applications using Java. So mobile applications, as you already know, if we want to create applications in Android, we would really use Java, or we would use Kotlin, which is similar to Java. Even for embedded systems, we would want to code using Java. For example, your programming which is done, let's say, for your washing machine or for your microwave, that embedded system programming also can be done using Java. You could create programs for smart card using Java, or in robotics. You could also create games using Java. Now let's understand the whole ecosystem of Java. How Java actually works on, and what are the various things which we would have to have in mind while working with Java. The most important aspect of understanding Java is the Java virtual machine. So if I ask you, or if anybody asks you, why Java is portable? Why is it architecture neutral? Why is it platform independent? You would say that yes, Java is platform independent, because Java can be run on any OS and the programs would run without any difference on any particular machine or any particular operating system just because of Java virtual machine. So as I said earlier, that you have your Java code, which is known as source code, that would be converted to the machine code of for that particular machine, right? And now in between, as I already told you, that your Java code is actually converted to an intermediate code format, which is known as the bytecode. So your bytecode is really a very optimized set of instructions, which is designed to be executed in your Java runtime system. That Java runtime system is actually called Java Virtual Machine. So now you know the actual name of that. So Java Virtual Machine is that interpreter which I was talking about, which would convert your bytecode to the code which is specific to that particular operating system. Another thing you need to know is the Java Development Kit. So you would have to actually install the Java Development Kit, which would come with all the features which you would require for creating Java programs, plus running your Java programs on your machine. So essentially, what JDK would contain is a Java runtime environment, which is JRE, and all the libraries which are used for creating applications. So this is your Java code, and you want to run it on your machine. What is lying on that machine? On top of that machine or on top of that operating system, you have your JVM. So your Java code is essentially working on your JVM, which is on top of the operating system. So once you have your source code, that would be taken up by the Java compiler. It would be compiled to a bytecode, and that would be given to the operating system interpreter. That would be converted to the machine code, which would run on your particular OS. So I hope that with this diagram, you understood the entire flow of how Java is converted systematically to machine code and giving you all that benefit of platform independence and being very efficient at the same time. Now really, a lot of talking has been done. Let's go ahead and set up the environment for Java. The first thing which we would do is to install JDK on our machine. The next thing would be to install any particular IDE. You can use any integrated development environment to write your code, to run your code, to check your code, and to debug your code. Checking your code means testing your code, testing that it is really running very fine as you want. So for that, to help ease our process, we use some sort of an integrated development environment. One of the IDEs, which is very famous, as I told you, is Eclipse, but you could also use IntelliJ or NetBeans. Now, use of IDE is really optional because people can possibly write a Java code on, let's say, a simple notepad and save it and run it using JDK, and it would run fine. But then you do not have all the autocomplete features, you do not have all the highlighting features, you do not have all the logging features which you would really require while running Java program. So for that, almost every person uses an IDE while coding for Java. Then we would set all our environment variables just to make sure that our Java program runs properly and we do not have any concern while running it on our operating system. Now remember, JDK is Java Development Kit and IDE is Integrated Development Environment. Now let's install the Java Development Kit. You could simply Google JDK download and you will get a list of all the results. Now you might be thinking, what is this black bar do I have over here? This is something really useful if you are developing programs and you simply want to do a Google search and you want to see the result which a number of other developers might have put in this particular tool. Then you can install this extension which is called grepper. So once you install this extension in your Google Chrome, over here it would look like this, and then it could simply, once it has access to your web page, it could simply always understand what you're searching for and give you the relevant results. So you could use that because I use that a lot. Now when you check for JDK, you would be given the first result, which would be the Oracle website. Oracle has bought Sun Systems quite a few years ago, and that's why it has all the Java documentation and all the Java libraries and all the Java downloads as well. So right now, the latest version for the SE platform is Java SE 15. So what do I mean by SE? So there are different versions or different editions of Java. which would work for different types of applications. The first is Java SE, which we just saw, which is known as Java Standard Edition. Another is Java EE, which is known as Java Enterprise Edition. This one is generally used to create enterprise applications, which comes with a lot more features and a lot more use cases for enterprise-based applications. Then you would have Java ME, which is the Java Micro Edition. You would also have Java FX, which is generally used to create user interfaces. But generally, we would use Java SE only. And then if you really want to upgrade yourself, you could check out how you could use Java EE and some various constructs like annotations and all of that. So Java EE is really the superset of Java SE. So let's go ahead and start working on Java SE, and you should be able to do everything which you require unless and until your company or your code really uses Java EE, which you want to make sure that you know. So now let's go ahead and download the JDK, which is available for the latest release, which is Java SE 15 at the time of recording this particular video. Now you would obviously have to find out which operating system to install this on. Why do you think I really have to choose an operating system? Why could it not have been a common thing for all the operating systems? Can you guess? The reason for that is we want it to work on different operating systems to convert our common code to that particular operating system's machine code, right? So we would really require this particular development kit for our particular OS. So right now I'm working on the Windows machine, so I would just install JDK for Windows. Now once you install Java, you would find in your C drive in program files, a folder is created called Java. Then when you get into Java, you would find the JDK folder installed over here. Now you might be thinking, why does JDK 14 and not 15? Just because I have already installed 14. So after installation, you would see JDK 15 installed, or any JDK which is the latest current version while you download that. So the whole idea is that your JDK folder would be created over here. Within this JDK, you would find a number of folders. The most important is bin, because that's where your Java executable lies. That's where your Java compiler lies. So this folder is very important. You simply have to now check this entire path, copy that, and you really want to update the environment variables of your operating system. Now, whatever procedure I'm talking about is for Windows, but that same procedure can be applied for a Mac OS or for Linux as well. Now, if you just check how to set environment variables, you would see over here, edit environment variables. Now, you can just come over here and check the path property, the path variable here, and then you can click on edit. So as you can see, I have set the C drive program files Java JDK 14 bin over here. If you obviously cannot see that for the first time, then you have to create a new and then paste it over there and simply do an OK, which would update that path variable. So right now I don't have to do that because it is already updated. Again, for system variables, you would find this variable Java underscore home. Create that variable and make sure that its name is Java underscore home. Again, paste your JDK path over here. And again, in the path variable over here, you will find that it is the one which is updated from here. So that's all about setting environment variables. The next thing which you want to do is to actually install Eclipse. So you can simply type Eclipse download. Again, you would be given the first link as Eclipse.org. That's the place where you want to go. And then you have to check the latest option which you have. So here, there is this Eclipse IDE 2020-12, which we have over here. You could also check the other offerings which they have, but we could simply just download this IDE or whichever latest IDE you would have at that point of time. So you could download it over here, but I have already installed Eclipse in my system. So I'll just go ahead and show to you how the Eclipse folder would look like after you have installed that. So This Eclipse folder is really on my desktop because I've just put it over there, and simply you can open that and check for the application file of Eclipse, and you can just open that. So once your Eclipse is open, you could see something like this. Obviously, you would not have all these projects over here because I've been working a lot on Eclipse, but you would essentially not see this Projects Explorer. So you could go to File, New, and then you have all these various options. So don't worry about not being able to understand all the options. That you have something known as Java project. You could create the Java project, and I'll just create the name to be Java short course. And this is how I would generally name things, and this is how you should generally name things. Now here it is asking what JRE do you want to use. So let's just use the default JRE, which is coming with the JDK 14, right? And we'll do a next. Now we'll see that a Java short course project is created, and it really has the SRC folder over here. And there's nothing within the SRC folder, okay? So we'll leave all the options as it is, and we will click on finish. So now this is how one project for our Java is created. And you can see over here that it has all the system libraries which is imported from the JDK, which we just installed. And these are all the libraries which are really very important for us to work with Java with ease. So we don't have to worry about that. I want to do some sort of networking first. I should just, install the library and then work on that. No. Or I want to do some logging first. Let me just, install those things. So all the common things are already there for us just because of JDK. And now all we have to do is create a new program in our SRC folder. This is the source folder where all of our Java code would lie. Okay. Now let's try to write our very first Java program. First, we will understand a little more about the Eclipse IDE. We'll try to run that Java program actually on the terminal on the shell. And then we will say how we could, make our program a little readable by adding comments. And then finally, I'm going to show you how we could actually do some sort of debugging if we land into problems in our code. That this is the Project Explorer where you would find all your projects and you can expand them and view the various libraries or the various files. This is the menu bar. This is where you would want to save your file, import or export any projects. You would want to do a simple copy paste, but obviously for that we generally use the shortcuts, right? So you can find all the shortcuts which Eclipse uses at the right over here. So let's say, for example, you want to do a search in your entire project. So it's not just one file, because in one file we generally use a control F, right? But if you want to do a search in your entire project, then you can simply type control H and then your search dialog would be opened. So this is something which we would use generally a lot, because it's not that our code might lie in just one file, right? We would have multiple files and those files would have a lot of code. So if you want to search for a particular line, a particular code snippet, then you would use this search tab. Now over here, you can see that I have a particular window in which the name is console. If you do not have this, then you can try to find where it is lying over here. So here I can see the problems tab, or I do see a restore tab. So here my problems are coming over here. I don't want to see them. And there are many such tabs. If you don't find this console tab, you can simply go to window and then show view. And then you can try to find out the console tab over here. If you still cannot find, you can press on other and simply type console, and that's where you will find it. You can just open it and place it over here. The other tab which I have open over here is the search tab, wherein again, as I said, that if we want to find anything within all of our projects, then the results would come over here in this particular tab. So these two tabs are like really very important. Other than that, you would have this particular bar in which we have all these small icons, but the most important icon is over here, which says run, because that's where we would click to run our program. Another one is the debug button, which we might use for debugging our programs. Now let's write a new program. So for that, we have to click on our SRC button, the right click. We have to go into new, and then you will find all these options. If you do not find your particular option, you can again go to other and type that option. But I do find an option which says class. That's what we have to click. And here for the class, I will give the name, let's say first program, and then I will click on finish. That's it. That's all we have to do over here. What this will do is that it will create a small code snippet for us on which we could work, and now we would start typing our first program. So to create a hello world program, the first thing is that all your Java programs have to be within one particular public class. We would go into details of what is public, what is a class, etc. But essentially, we have this public class and then our file name and then our open curly braces and close curly braces. These open curly braces and closed curly braces form a block. All of our code would be within this block, and make sure that this public class name is the same name as the name of the file, the class file which you just created. So the name was first program. So Eclipse automatically created the name to be first program, but otherwise you have to always make sure that this name is same as the file name. Remember, the first thing to remember is how to add comments in a particular program. Now, if I just type 2 / and write this is the first comment, then you will realize that it is coming in our different color. And now this is the first comment. If we have to actually add more information as a comment, then let's say I write that remember your code always starts with the main method. Now, can you see all these squiggly lines coming over here, red color? There is one red mark over here. It says multiple markers at this line. There is some syntax error. Start cannot be resolved to a type. All of these errors are coming. Why? Because it feels that this is code, but obviously we are not writing the correct format of Java code. So obviously it is giving us all of these errors. So as I said, that Java really helps us to understand, and IDE in fact really helps us to understand where we are doing a mistake by highlighting things beforehand before we even run our code to realize that there is some problem with our code. So what it means is that this is not a comment, but I just put a 2 / over here, right? That is because this is a single line comment. If I want to make this line also comment, I can simply add 2 / and now all the errors go away. Or if I want a multi-line comment, I could simply remove all of this part and then have a / and at the end again, a star and /. So this is going to create a multi-line comment, because here I can keep writing anything else and it would just keep writing the comment for me. So comment continues, and this is multi-line. Okay, so this is how we would write comments in our code. That is just because we want to write some explanation in our code without letting the compiler know that this is something which we want to execute. So the compiler will simply ignore all of this information and start executing your program with the main method. Now remember, your code starts always with the main method, okay? The main method. Your class should have a main method, okay? So how to write a main method? I would write it saying public static void main, and after that I will put 2 round brackets, and then I will write string args, and then I would put 2 square brackets. Now what is public static and void? What is string? What is args? What is this square bracket? What is this round brackets? All of that information we are going to discuss soon. But when I create this new block within my main, now here is where my code will start executing as soon as I run this program. Now, we just want to print something like hello world in our console, let's say, okay? So for that, what we have to do is we have to print it. So to print, we have to write system.out.println and then again curly brackets and then a semicolon. Remember, all of our statements in Java have to end with semicolon. And I cannot emphasize this enough that you cannot forget adding semicolons, because you will have so much of errors just because you forgot a semicolon. And that's the constant frustration which programmers have, that I got errors and I was so behind what is the problem, and finally I realized that I just forgot a semicolon. So make sure that you always add a semicolon at the end of the line, okay? Now, what system.out.println does is tell the compiler that I want to print something on the console. So what is that something? That something is hello world. But if you just write hello world like this, it is going to again, show some error. Why? Because if you understand that public, static, void, main, string, args, system.out.println, this is something which the program understands. But this hello world, that it doesn't understand. So we have to actually tell the program that this is not something which is programming related. This is something which I want to show to the user in the console. So for that, I have to add an inverted comma pair. Okay, so with that, my hello world is coming within this, there is no error, and I can simply control S to save my program. Now to write this system.out.println, Eclipse has a very nice shortcut in which you just type this out and then you press control plus space and it will open up the system.out.println totally for you. And that is pretty amazing. So this is easy. Okay, and then I save it again. Now, if I have to run this, I can simply go to my project, right click on it, and then you can see a run as. It would ask other options, but we do not have to worry about the other options. We would simply select Java application. When you select that, it would find the file which has your main method. And as I said, your execution starts from main. So it will execute these two lines and it will display hello world. This is easy. Now, did you realize that I just wrote hello world and this is easy? I did not tell it in any way that you have to actually go into the next line. How is this happening? This is happening because of this println. What it is doing is that it is saying that create a new line after every time I print. If we just put it like print over here, then you would see if I again do run as Java application, there would be no new line. So if you want a new line, you could simply use a println. Otherwise, you are fine with using simply print. Okay. Now, this public, as I said, public is something which is going to make sure that all of this information is available for the compiler or for the other creators of this particular software. Again, this is the class which we are going to discuss a lot further in detail in object-oriented concepts. Remember, main always has to be public because the compiler has to find out where the main is and execute it. So how will the compiler be able to execute main if you have not exposed it to all the public, right? Meaning the compiler as well. So it has to be public. Now, void means what? You understand the English meaning of void, right? There is nothing in something, right? So we have a program, but here there is nothing. There is a void. Why? Because we are not returning anything over here. We are not saying that, okay, once we do all of this, now pass some information to the compiler or to the one which has called me. No, we just don't want to pass anything. So we would just not, we would just say that this is void. And static, again, we are going to delve a lot in detail when we talk about object-oriented concepts. Main is the name of the method. What is a method? Method is this block of code which has a particular name, and here the name is main. And now these curly braces, they would have all that information which the person who called, or let's say the compiler are calling main method to execute, right? So the compiler can pass some information to the main method that, okay, I want you to actually use this information which I am passing. So that can be passed on along like a string whose name is args. And these square brackets essentially denote that row of data which I was talking about, right? So this row of data would have a number of strings, a number of characters, and you can simply use that in your program. But here, we are not using this because we simply have just called to run this program without any information passing over here, right? So this is something which we might not even use a lot, right? So, but this is the syntax. We have to at least mention that we can use string args. So this is something which is compulsory. Public static void main, string args, open and close curly braces. This is the format for writing the main method. To print anything, we have to write system.out.println. It is going to tell the system The java.lang.system library, as you can see over here, as soon as I put my mouse pointer over there, it is highlighting what this means. So you can just put anything on a particular library and it is going to highlight that. So java.lang.system library, it actually helps you with some useful class fields and methods, which is going to do some common tasks. So here within system, there's this outstream, and within that there is this println method, which is going to take some string. Again, this string is something which we pass over here, and it's simply going to print that for the user. Okay, so now how did we pass a string? As I said, we have to always put semicolons in the beginning, at the end, to make sure that this is not common code. This is a string which I have defined over here. So what string is there? Hello world. Here, what string is there? This is easy. Everything is between semicolons, and that's how it is going to print that. Okay, so this is how we have created our first program, and we are going to do a lot of changes with this particular format as well. But to write anything, make sure that you at least have this amount of code ready with you, and then you can just go ahead and type whatever you want to show to the user over here in the console. Now, if you see over here, this first program which we wrote, that actually went into a default package. By default, we did not have to do anything. It just says default package, and then we have our program within it. What this means is that we can have different packages just which would actually package different files in under one particular name. Okay, so here the name is just default package, but we can actually name it to something else like basic code, advanced. We could really have so much of application for that, and we are going to look into a lot in what packages are and all of that. So here it is within the default package. If we really want to see where exactly this file is lying within our system, we can just right click, go to properties, and see the resource path. Here it just says java shortcodes src first program.java, but this is the exact location where this java file is present. So let me just copy this. And here, when I paste it, I see that yes, my first program Java file is present over here. You can see the type is Java file. And then, I can simply open it in any other IDE. If I just simply open it with, let's say, Notepad, you will see that my first program is written over here. And this is something which you can do as well. You can simply open a simplest thing like Notepad and just type your Java program. You can click on save and you can run that as well. So let's try to see, without an IDE, how we would have run that. So again, I would open a command prompt of Windows, but then you are open to open any other shell in your OS, whichever you use. So I would just click on the whole address, type cmd, press enter. This is going to open the command prompt at this particular location. What I want is that I want to execute this file and I want to see its output just in my shell. I don't want to see the output in my IDE or something, and sometimes it might be useful to do that, but generally people use IDE only. So I just want to show to you how we could do that. So the first thing which we really have to do is to compile a Java program and then execute it. Obviously, you cannot just execute it. First, we have to compile it and then we have to execute it to see the output. How would we compile it? We would compile it using the Java C, and then we would write the name of the file. So I just wrote the name of my file, and then we will press on enter. It is successful in doing that. Why is it successful in doing that? Because we had marked all our environment variables correctly. So it is able to successfully compile that file. And as you can see, as soon as I compile this first program.java file, there is a class file created over here. Okay, and now we will simply execute that class file. The only change we would do is remove the Java extension over here and remove the C part, because now we don't want to compile. We actually want to run this file, right? So I'll click on Java first program, enter, and now we are able to see the output hello world, and this is easy over here as well. So this is how you would run any Java program by using Java C, file name.java, and Java file name, and you will be able to see the output of that program, whatever it is logging over here. So that is another way in which you can execute Java programs. The next thing which I wanted to finally tell you is about debugging, right? So over here, there is this small space or small line available over here where if you click over here, then you will see a small point appearing. Can you see this point appearing? I hope you can see this breakpoint over here. It says line breakpoint and first program line number 8. This is where I have put. In fact, if it might be difficult for you to work on small fonts, then you can simply, try to find some hack. So you can simply search for increase font size in Eclipse. Probably you would find a link, let's say in Stack Overflow, and then probably in your answers, you could simply get the answer of how to do any particular thing in Eclipse. So here it says to go to Preferences, General, Appearance, Colors and Fonts. So we will go to Preferences. So Preferences are in under Windows. We go to Preferences, General, Appearance, and here we have Colors and Fonts. And now it says to expand the basic folder, select the text font and change that to whatever size we like. So let's really go to basic. And then really you can see all these options available. You will simply go to text font and then increase the font, let's say 220. We'll do an apply and close. Oh, and this is like really big, but it serves our purpose. So this is your program, and this is where my tiny breakpoint lies. So the whole idea is to actually try to debug this program. So now it just asked me whether I want to switch to debug mode or not. So if we say yes, then it opens something like this. If it opens multiple other windows as well, you can simply minimize. So the whole idea is that it runs this program up till a particular breakpoint, from where we simply want to check what exactly is happening at each line. So here it started, it went into main, all of that is fine. But then now it is on this particular line, and I want to see line by line what is happening in my program. Now our program is running very fine, but then it may be possible that our program has some error and we want to find out which line is causing that error. So we put a breakpoint on that particular line from where we want to start debugging, and that's where we will start using this particular navigation bar, which is changed when I switch to the debug mode. So now if you can see over here, this button says resume, this says terminate. So this will simply stop the program. This button will simply resume. So if I click that, the whole code is resumed, and I'm not able to check one by one, but that is also easy because once you understood what the issue is, you don't want to keep on doing that for the remaining lines, right? You simply want to resume. So we would do that. But let's say, we want to try to run this again. So if I again click on debug, so again it came to this particular breakpoint, and now we can simply use another step, which is F5. We can step into, meaning let this execute, or we can step over. So let's execute this. If we step into, now it actually went into the class file of println. Now I don't want to do that. So let's instead step over in F6 using this button. So as we step over each and every line, now here only this particular line executed, right, with hello world. Now again, if I do a step over, this another line is executed. Then if I again do that, then it says terminated, meaning that our program is done at this particular line. So this is how you can do a debugging. Simply click on debugger, keep on stepping over. If you really want to get into a particular method of how it is doing things, you can do a step into, or you can simply do resume, which would run the remaining program, or you can simply terminate it using the red button over here. So let's now switch back to our normal mode and not the debug mode. So we are right from where we came. We could simply click on this particular debug button again to go back, or click on that to come back to our main view again. So that's all about using Eclipse, creating our first program, debugging, and running it on shell. I just printed a simple string which says hello world, right? But what if I want to display something which keeps on changing based upon what my program is doing? Sometimes I want to say hello world, good morning. Sometimes I want to say hello world, good evening. How would that change? It would change based on the time of the day it is. So what I can do is I can check what the time of the day it is at that particular place, and then Based on that, I want to show the message to the user. Now, how is that possible if I don't have the option to change what I am displaying? We do have an option to change what we are displaying just by making sure that we are not hard coding things. So by hard coding means that I actually put the exact value over here. I coded it from my own hand, right? So that's hard coding. I don't want to do that. I want to say something like greeting. Okay. But now if I just write greeting, it is giving me an error. So how do I make sure that this error is gone and I actually can change the greeting based on different times? So that gets me to the concept of variables. So now there are two things, okay? Let me roll back my changes, save this, and create a new class called variables. Now over here, again, I would write public static void main brackets, string args, square brackets, curly braces, and then within this, I want to do a sysout, and I would say variable lesson, right? I would save this and I would try to run this. So let's just press on run. Run as Java application, and it says variable lesson. Okay, so now this is all good. But again, I said, right, that I don't want this, I want something else. So for that, we can create a variable which would be called a greeting, and we can assign something like hello world. Hello world, good morning. And I want this greeting to be shown not as a string but as a variable. Okay. Now I've been talking about variable, but what exactly is variable? Variable is just a name which is storing our data, and we can keep changing our data and still call that using its name and still have the changed data being used by the program. Now what about all these other words? Public, class, public static void, system out, println, main, string, args, all these are also words, right? Why they aren't variables? They're not variables just because Java already knows its meaning. So Java will not allow you to use these words as another name for something else. So these words are known as keywords. So you have all the words which Java understands are keywords. And now you have variables which Java does not understand, and we have to define what it is, and variables cannot be keywords. So if I just put over here public, okay, can you see how different it is looking just because it is a keyword and we cannot use that? So I can just put something else which Java does not understand. But here again, you know, there is a squiggly mark over here, and it says that greeting cannot be resolved to a variable. Why? Why can't greeting be resolved to a variable? Because Java is a statically typed language. Statically typed means that Java wants to know from before what is going to be the type of greeting. Would greeting have a number? Would greeting have a string? Would greeting have just a character? Or would greeting have some other value like a fraction or something? So we have to actually tell the Java that greeting is actually a string, and now that error goes away, and we are able to simply save this program and run this over here, and now it says hello world, good morning. Now as I said that this variable can be changed, so now if I just write greeting equal to, instead of saying hello world, good morning, this would say hello world, good evening. And I save it, I run this. As you can see here, it says hello world, good evening. Why? Because greeting is now changed to hello world, good evening from the hello world, good morning. And the first time we declare greeting, we need to tell Java that, you know, this is a type of string. But from the next time, we can simply use the name as over here. Again, here we did not write string or something, right? We simply use greeting. So this is how you can create variables. Now, as I said, that variables can have different types. So that gets us to understanding what are the different data types. What are the types of the different variables which we can have? So it is divided into two parts. One is the primitive data types, which would be simple numbers, numeric types, or simple non-numeric types. So we could have integers, or we could have numbers with a decimal point. So those are known as float. Or we could have non-numeric types like characters, or characters which are simply, one character of an English alphabet. Or we could have something like a Boolean, which means that it would either be true or be false. Okay, so something which has only two values, true or false, 0 or 1, that is a Boolean. A character can have all those values which are available in the English character plus all the special characters on the keyboard, all of that, right? And floating numbers, again, decimal point with a lot of digits after the decimal point and before the decimal point, integer again, from the smallest number to the biggest number, positive and negative both will be present in the integer type. Now, there are some non-primitive data types which I already told you about, like for example, arrays. You also know that there are some things known as classes, which we are going to see later on. Then there are some things known as interface, which we again are going to see later on. So we also saw about keywords. Now we come to the identifier rules. What do I mean by identifier rules? Identifier is what we call as variables. So both are the names of the same thing. This is a variable or this is an identifier. And we have certain rules of naming identifiers. We cannot simply name them anything which we want. One rule, as I already told you, is that it cannot be the same word as another keyword. Another rule is that the first character of any identifier must be either a letter or an underscore or a dollar sign. So if I have this letter meaning G, which is at the beginning, then we are fine. Or we can begin it like this with an underscore, and simply, I can copy that over here and here, and it will not be an issue. Or it could start with a dollar sign as well, right here. But what are the other things which is not allowed? Like spaces are not allowed. If I just write like this, here, can you see an error is coming? So that is not allowed. And the identifier beginning with any number, that again is not allowed, as you can see over here. And it beginning with any other character other than the underscore and dollar sign, again, it's giving me errors. So all of these things you should take care of. You should not be bewildered that, why my error is coming over here. Remember that it can only begin with letter, underscore, or dollar sign, and it cannot have any spaces. Also, that identifiers are case sensitive. So like, for example, I type greeting over here, but here I actually write greeting, and here again, I actually write greeting with a capital G. So here, as you can see, these red lines are coming. Why? Because it says greeting cannot be resolved to a variable, but I just defined it, right? No, I did not define it. I defined the greeting with a small g, so it is case sensitive. And that's it. Some small simple rules to know. Another thing which I want to just tell you is the use of final keyword. So final is another keyword in Java. What it says is that this greeting is actually final. You cannot change this greeting. So as you can see, as soon as I added final, here a red line is coming and it says the final local variable greeting cannot be assigned. It must be blank and not using a compound assignment, meaning that you cannot reassign something else to greeting. We have to use the same one. So whenever you are actually working with something which you do not want to change, for example, let's say I want to initially declare the value of pi. Okay, pi is what? 3.14. Okay, I want to use this everywhere. Now I don't want anybody to change it to 3.1416 or 3 like any other number, right? I want this to be exact same thing. So I can simply define pi to be final. So let me just remove final from greeting, add a final to pi, and that's it. But here again, some error is coming. Why? Because we have not defined the variable type. So greeting was string. What is pi? If we see over here, pi can be one of any of these data types, right? So can it be integer? No, but it has a decimal point. So it has to be float. So I'll just type float over here and those errors will go away. And this is going to be our pi value. Another way to actually write this is double. So double again means float. And here, as you can see, again, any error goes away. Here, it just says that the value of this local variable is not used. So let's now use it just to print that, and let's run this. So we'll save and we will run this. Okay, so 3.14 is the value of pi. Now there's this yellow line under greeting again, just to warn you that you have defined something but you have not used it, so just make sure that everything is correct or not. So this is how. Now if I would try to change this to something else, then it just would say the same thing, right? Final local variable cannot be assigned. So this is how we would use final variables as well. Now we saw float, we saw double. Let's create an integer. So I could create an int number, and I could just assign, some random number 5, and I could simply use this number to print that over here. Let me just comment out. If I want to comment out a number of lines, I can simply take all these lines over here, and I can simply press Control plus / on my keyboard, and here can you see that all of those lines are commented. So let me just comment this line as well. Now we simply have our number, and which is present over here, and this is where I'm printing this out. I just save this, I run this, and here we see 5. What about Boolean? I told you, right, that there's something known as Boolean. So I will say Boolean, and we generally name it as is true or is false. So let me just assign again, true to Boolean. Now true, as you can see, it looks something like a keyword in terms of formatting, right? And it is indeed a keyword. So I do not actually have to put inverted commas over here, because then it will become a string true. But we do not want a string true. We actually want to say that is true has a value of true. So if I just print that, let's save this, let's print it. Now we have the value of true. If it becomes false, then it will have a value of false. So we would use Booleans a lot as well. Again, if we simply have a character, an English character, so let's just write a char a equal to, and then a character is put within inverted commas, and I will just put it as D, and then let's print out a, and let's run this. So the value of the character a is D. Now that sounds something strange, right? Value of character a is D. The only thing is that a is the variable and D is actually the character constant which we have assigned to a. So if we print a, we actually get the value which is assigned to a, which is D. So I hope you are clear about all the variable namings and how to add the types of variables beforehand and then simply use it by the name. So let's look into some more details. We have primitive data types, which each of those have a type name. Obviously, we used int, we used float, we used double, we used Boolean and char, right? So there is, again, there is long, which is actually large integer. There is short, which is actually a small integer. And then there is byte, which has only 8 bits assigned to it. So 8 bits is assigned for a byte in the memory. For a short integer, 16 bits are assigned. For a normal integer, 32 bits are assigned, meaning 4 bytes. For a long integer, 64 bits are assigned, meaning 8 bytes. For a floating integer, which has a floating point, meaning a decimal point, for them, we assign 32 bits or 4 bytes. And again, for double, we have 64 bits, which is 8 bytes. For a character, we have only 2 bytes. And for a Boolean, which is only true or false, we have only 1 bit, okay? Only 1 bit, which will either be 0 or 1, will determine whether the Boolean is true or false. 0 is false, 1 is true, okay? So the range, again, true or false. Character range, for 2 bytes, how much would be the range? So character always is a positive number. And when I say number, you would be surprised, right? Because character is a character, it is not a number. When I actually would write a character A, that is converted to an ASCII value of a character, and that is used by the compiler to display which character is meant by that user. So if you check about ASCII on, let's say, Wikipedia, it would say that ASCII is American Standard Code for Information Interchange, short form, and it actually encodes characters. So if you just come down, you would realize that each of the characters actually have a value associated with it. So your capital A would have a value of 65, your capital B would have a value of 66, your small a would have a value of 97, and your small z would have a value of 122. You also have different values associated with different character types, even if they are digits or they are special symbols. So here I can just write 1 over here and save it and run it, and then you will realize it is 1, but it is actually the character 1 and not the number 1. So if I just write char b equal to 2, and if I just try to do a plus b, and plus is actually the plus operator. If we would have given numbers, then it would have given 1 plus 2 equal to 3, right? But then these are characters, so it would not be giving 1 plus 2 equal to 3. Let's see what it gives us. Oh, it gives us 99. That's why I say that they are not numbers, they are characters. And why did it give us 99? Because if you see, the ASCII value of 1 is 49 and the ASCII value of 2 is 50. So it did 49 plus 50 and displayed 99 to you. So did you understand that I was actually speaking the truth, that it is converted into ASCII characters, and that's how we have the character encoding for our programs. So now, since we have this encoding, it obviously is a positive number. So with 2 bytes, how much number can you get? You can get from 0 to, can you guess? 2 raised to 16. 2 raised to 16, because 16 bits are there, and we will have 0 to 2 raised to 16 minus 1, because 0 is 0, right? So it can't be 2 raised to 16. It has to be 1 less than 16, because we are using 0 indexing, right? So we start from 0. We actually don't start from 1. So 0 to 2 raised to 16 minus 1. Again, for let's say integer has 32 bits. Now we use something known as 2's complement to store integers. 2's complement is just a way to store positive and negative integers. So negative integers are having 2's complement and positive integers are just their values. So in 2's complement, we can go from the positive side 0 to 2 raised to 31 minus 1, because 1 bit is stored for the sign bit, okay? And then in the negative side, we can simply go to minus 2 raised to 31. So this is how the ranges work. You can check all the other ranges as well. We saw the types, the size, and the ranges. We saw, how we could declare a variable, how we could initialize a variable to a particular value. So what we saw over here is actually this part is declaring the variable and this part is actually initializing it to this value. So we could actually have, taken this out over here, and we could have done just like this. And this is the declaration part in which we are declaring the variable. What is the meaning of declaring the variable? We declare the variable means that we are assigning memory to the variable. Assign memory to the variable, okay? And here we are actually initializing the variable. Initializing means giving an initial value to the variable, okay? Initializing the variable. So that's it. In case you're wondering why this is red, this is actually doing some spell checking. I don't want that, so let's just remove that. This is how we would initialize the variable, and then we can simply use the variable anywhere. Now, since we saw about all these types and their ranges, but let me tell you, most of the Java programmers would not be using these primitive types. Generally, like if I would have done it, I would have used something like this. Integer num equal to 5. Okay, and if I just print num over here and run it, this says 5, and this again works like an integer. Now you might be thinking this is just another name for it, but actually if I press on control and if I click on this particular small int, then nothing happens. I keep doing that. But if I press control and click on this, I actually go to the integer class. So I realize that Java engineers, somebody known as Joseph Darcy, has actually written this class known as integer, which would extend other classes. So we are going to talk all of that. But then what I want to say is that this is actually not primitive data type. This is known as a box which encompasses my integers which are primitive, okay? So int is primitive, but integer is a class which acts as a box around it, and what that helps me with is some common procedures which I would want to do that on integers. So let's say if I write number and I do a dot, then nothing happens. But if I just write num and I do a dot, then I have all these options with me, and all these options are actually all these methods. So Like we have the main method, like we have this println method, which is actually helping us to print things. We can have different other methods which Java provides us, the Java class integer provides us, and that actually helps us to do various other things, like we can compare to another integer, we can convert it to a double, we could convert it to a float. Let's say if I just write this num.float value, let me just cut that and paste it over here. Let me run this, and you will realize that earlier I just could print 5, but now it is 5.0. Why? Because it just got converted into a float. So this is a good thing, right? So because it may be that I want to do so many other things with an integer. So what we do, we have a box around it. We have a class defined by Java, which helps us to have all the most common things which we want to do again and again on a particular number, which we don't want to actually type out ourselves. The common things which we don't want to type out ourselves, Java engineers have done that for us, and this is known as boxing. Okay. Similarly, for character, you have the character class. So you could have something like this: character C equal to A. You could have the float class, which is actually helping you with all the other floating points. You could have a double class. So now you would have realized that actually the words are a little different, but again, they all start with a capital letter. And even when I created a new class with the name of variables or with the name of first program, you would have realized that it always has a capital first letter. Okay, so remember, to name classes, we need to have capital letters. So capital letter used for beginning of class names. Okay. So we saw something known as auto boxing. Auto boxing is just a way in which wrapper classes are there on each of these primitive types. And then the opposite would be unboxing. So you actually don't want any box. You would want to unbox it and just use the primitive types. That is known as unboxing. You can even go to the Java documentation, which is easily available on docs.oracle.com. You can simply do a Google search and you can read upon autoboxing and unboxing as well. So here, as it just takes a simplistic example of a character ch, and it actually helps you realize that how much you can do with boxing and unboxing. So here it had an integer I, and it just called the absolute value method on I, and it actually converted into the primitive int, and it would simply do a system.out.println. So all the other things which might be confusing you right now, we are going to cover all of that, so don't worry. But the whole point is for you to understand that we can change it from the primitive to the class just by making sure that we are declaring it using the class name, or you can change it from the class to the primitive data type. Now, what are some best practices in doing whatever we have done? So, for example, you want to name your variables, you should always try to use the camel case. So, this is camel, okay, and this is the kind of case we want to use, based on his hums. We want to always capitalize the next word's initial character, okay. So, that's the way we would name variables always in Java. We have to give proper and meaningful names, not like A or C, which I was giving. It has to be meaningful, what it does. It cannot be like very, very long or too short to not be able to understand. So it cannot be encoded something like QRFW, because I don't know what is the meaning of QRFW. And semicolons, always remember to add semicolons. The next thing which we will discuss is about operators. One operator which we just saw was the plus operator, which would do an addition. Similarly, we have so many other operators in Java. We have unary operators which work on only one operand. Operand means that number or that variable or that data which we want to work on with that operator. So if we just have one data on which that variable works, that is a unary operator. If an operator really requires two data or two variables, then that is a binary operator, which may be arithmetic operators, relational, logical, or assignment operators. You would also have operators which actually work with three data. That is known as ternary operator. And then we will understand what is the meaning of precedence and associativity of different operators. And then finally, we will look at a specific type of operator known as instance of operator. Now, in this Java short course folder, I'm creating a new Java class file with operators title, and here let's talk about the various operators. So first, let's add the public static void main string args, and here let's create two integers. Int a is equal to 4 and int b equal to 6. Now we were talking about unary operators, right? So unary operator like minus will act on a particular operand, which is just one operand, and that's something which will give us the negated value of a. So if I just do a sysout of minus a, and let's save it and print it, run as Java application. Oh, so there was an error over here. I forgot the void. So let's try to run this now. As you can see, a got negated and now its value became -4. Similarly, you could have a plus operator, which again, it's not going to really do any change. Another thing is the logical not operator. This is generally something which we use with a boolean. So let's create a boolean is true equal to true, and now what we want to do is we want to find out its value. So if I just save this and print it, this will become true. But what if I actually add an exclamation mark before? What this is going to do is it's actually going to change the logic of is true. So if it was true, now it will become false. So let's save this and run this. So now as you can see, this has become false. If it was actually false, then if I run this, now it is becoming true. So this is the logical not operator. Another unary operator, which is something which is very important, is the increment operator. So if we have a, and then if I just say plus plus, what does this mean? What this means is that a will now become 5. Okay, so this can be after a or it can be plus a. Let me just show you what happens if I just put plus plus a. If I run this, now you can see a was 4, but now it became 5. So if I do it after a, again, a will become 5. But then when I print this, right now I'm getting 4. But oh no, how come this is possible? If I just do a sysout again, and if I just print a again, and if I run this, then you will see that now it is 5. So the first statement actually resulted in 4 and the second statement resulted in 5. Why is that so? When I said that this plus plus is going to increment the value of a, it is actually doing that because the next time what is there in a, it is 5. But here my printing is happening with the original value of a. Why is that so? So that's the difference between the pre-increment operator and the post-increment operator. So pre-increment is plus plus and post-increment is plus plus, but then it is a plus plus and here it is plus plus a. Okay, so this is the difference between pre-increment and post-increment. And what pre-increment does is that it will increment the value of a and then return. So it increments and then returns. Okay, but what about post-increment? Post-increment actually first returns and then increments. It first returns and then increments. Okay, this is the difference. So here what is happening is that first it is returning the value of a and then it is incrementing to the next value of a. Then there are binary operators. So we already saw what plus would do. If we do an a plus b, then you will realize that if I just comment this out, you will see that a plus b is giving us 10 because that is 6 plus 4. Similarly, we could do an a minus b and that would give us -2 because this is 4 minus 6. Or if we did a multiplication operator, again, we would have the proper multiplication answer. Or if we did a division operator, then we would simply, have the division quotient available with us. What if we want to find the remainder? For finding the remainder, we use the modulo operator, and that is the percentage mark. And this is actually going to give us the remainder. So 4 divided by 6 is 0 quotient and remainder is 4. So that's the arithmetic operator part of it. We also have relational operators. So we can just write something like a less than b, and when I run this, it will say true. Why? Because A is indeed less than B. Similarly, if I write A greater than B, this will be false. We also have less than equal to B, and this will also be true just because, you know, A is actually less than equal to B. Similarly, we have A greater than equal to B, or we can have simply like A equal to B, because that is going to give us false, because, you know, 4 is not equal to 6. And what about not equal to? That is exclamation equal to mark, and this is going to give us true because A is indeed not equal to B. Now, all these are conditional operators which are giving us true and false values. What if we want to actually find out a combination of all these different values? So, for example, I want to see if A is not equal to B and if is true or false. Okay, so A is not equal to B, and somehow I want to find whether is true equals to true or not. Okay, but then here again some error is coming because I cannot just write and, I will have to write ampersand ampersand, and this is going to give me my result. So now it says false. Why? A is not equal to B, that's right, but is true is equal to true? No, it is equal to false, so that's why it was giving us false. What if I just write this thing? So now it's giving me true. So what AND operator does is that only if both of them are true, it will write true. In any other case, it will write false. What if we want a case that, no, I don't want to be so strict. What if I just want, at least even if one of them is true or both of them are true, then also it should write true only. For that, we have a logical NOT operator, which when I run this, this is going to say true because just because, you know, both of them are true. What if I just change one of them to be false? Still it is giving true. Why? Because at least A is not equal to B, right? So we are fine with that. So these two are logical operators, and or. And then when we come to talk about binary operators, we have assignment operators. So this int A equal to 4, this equal to operator is actually an assignment operator. So what is happening is that 4 is actually assigned to the name A, okay? 6 is actually assigned to the name B. Now, what if I do, let's say A equal to 6. Obviously, 6 is getting assigned to A, and that's what we are going to print now. Let's see. So now A is equal to 6. That's fine. What if I do A plus equal to 6? What this actually means is that A equal to A plus 6. Okay, this is a compound assignment operator. When we run this, what happens is that the initial 4 is added to 6, and now we have an answer of 10. Okay, so this is how compound assignment works. This could also work with a minus. So here it is actually doing a subtraction to 6. Again, you know, it would work with multiplication, division, and modulo, similarly the way we saw earlier. Okay, so I'll just keep it like this. And finally, we were talking about a ternary operator. What is the meaning of ternary operator? It works with 3 operands, right? So that has a skeleton. So the skeleton is a question mark and a colon. So anything before the question mark will be any condition which we want to check. If the condition is true, then the thing after the question mark should be executed. Otherwise, the next thing after the colon is executed. So this is the ternary operator. So again, you know, if I just take this print statement over here, I just check if A is equal to B or not. If it is, then I want to just print equal, or I want to print not equal. Okay, so let's save this and let's print it. So it says not equal. Why? Because A is actually not equal to B, so it is false. So false means the next part. If it was true, meaning if I just do A not equal to B, meaning if I actually change the values of A or B, so if I just make A equal to 6, and if I try to run this now, so now it will say equal, because now A is actually equal to B, so that's why it will say equal. Okay, so that's one way in which you can use ternary operator, and there can be many other ways in which you just want to add a condition over here, execute this part of it. If you actually want to execute multiple lines, then you would simply write a block over here. Okay, so whatever I've shown in system.out.println, all of this need not be within system.out.println. It can be even outside. Okay, so if I can just write something like string equality check, And now I want to just print this equality check. Then if I run this, again, it would be not equal just because A is not equal to B. So this is how you can do within Java, or you can actually execute a number of lines of code in this part and in this part as well. Now, when we talk about operators, it may be that sometimes some operators take more importance than the other operators. For example, if I do A plus B into A, then what is going to be the answer? It's going to be 28. Why? Because first B into A is actually implemented. So first we do 6 into 4, which is 24, and then 4 is added to it. And it's not that 4 plus 6, 10 into 4, which is 40. So why is this so? Because multiplication has a precedence over plus. And that's where comes the concept of precedence and associativity. So let's say A plus B minus A, okay? And if we run this, it's going to be 6, okay? And let's do minus A plus B plus A. If I run this again, it's 6. The reason for that is plus and minus both are the same level. So however I use it, it doesn't matter. But then it would matter whether it is coming from the left to right or right to left, okay? So now if I just add a C and make it 3, and if I just write C over here, and let's save this, print this, then what is happening is that first A and B are added and then C is subtracted from that. So what do we say? We would say that arithmetic operators have an associativity of left to right. So how would we know which operator has high precedence and which types of operators have left to right or right to left associativity? I'm going to provide you with a table which is going to make sure that you know that unary operators have the highest precedence. So obviously, if I do plus plus A over here like this, and if I run this, what is happening is that A is first getting incremented and then it is getting added to B and then C is subtracted from there. So unary operators are definitely the ones which have highest precedence. Then comes arithmetic operators, and then you have your relational operators like less than equal to or greater than or equal to. And then you would have your logical operators like and or, right? So that precedence table and what is the associativity, that is something which I'm going to provide you with. And lastly, if we just want to check, the type of a particular variable. So let's say I just want to check the type of, C. So, oops, that's not the way. We really have to say if C is an instance of int or not. Okay. But here we should have a class, and instance of would take this class and check whether C is an instance of integer or not. So if I run this, it is saying true because C is actually instance of integer. What if I say string? Is C an instance of string? So here it says incompatible conditional operand types, integer and string. What if I just want to check is it an integer instance of float? Again, it says incompatible conditional operands. So instance of can be used for this task. Now, what if a variable is of a particular data type, but we want to change it to another data type, right? So I already told you about unboxing, right? So what if I want to change this class integer type C in the primitive data type int type C? So if I just add the int with the round braces before C, this is actually going to convert C into the integer type over here. It is going to convert C into the primitive integer type. If I could also have done it, let's say double, and then if I would have printed it, here it comes 3.0. So that's how we could have type conversion. We are actually converting the type of, let's say, primitive integer A to double. Okay, so again, we have this type conversion, but also it is possible to have an automatic conversion. So for example, A is what? 4. Okay, if I do A into 1.5, okay, now if I print this is not 6 because 4 into 1.5 is 6, but it is not 6, it is 6.0. Why is that so? Because 1.5 is a floating point number. It's a double, okay? And that's why A got automatically converted to this whole thing just because of another variable of a higher type, which is double, and that's how integer got converted into double. So again, how these conversions are taken. So if you have byte, it can be converted to short. If you have short, it would be converted to int. If you have a character, and that could also be converted to int. So int will not get converted to a character. Character can be converted to an int. If I just write a into a character c, and if I just print this, then this would say 396. So why is this not converting 396 to the ASCII equivalent of 396? Just because int will not be converted to character, character will be converted to int. Okay, similarly, int will be converted to long and not long to int. Similarly, int will be converted to float, int will be converted to double, long will be converted to double, and float would be converted to double. Similarly, long would be converted to float and not vice versa. Int would be converted to double and not vice versa. So I hope you understand, the smaller one gets converted to the bigger type of data. So there are two ways, either automatic conversion or you yourself typecast it. So what I did earlier was actually typecasting. So this was typecasting. Let's go ahead and understand how our statements are executed in Java. We have some things known as control statement. So otherwise, our Java code would sequentially run one after the other, right? But then we are able to change the course of that sequential execution, let's say using conditional statements or selection statements or iterative statements. So let's go ahead and look at some conditional statements. Conditional statements are just the ones which help us make a decision based on some condition. So here, let's say the person wants to go either this way or that way. So if a person feels that, let me think if I want to take the road less traveled. If yes, then I would just go towards this road. Let me think that no, I'm not up for any adventure. I just want to take a safe road. Then I would take this road. So how can we do that? So in Java, we have some things known as if statements. So let me just create a new file over here for conditional statements. So this is going to be our class conditional statements. So now we want to add public static void main. Instead of that, I can just write main and again do a control plus space. That is going to add our main method for us. So this is how we can include the main block as well. So let's take int a equal to 4 and again, int b equal to 6. I just want to check if a is equal to b, then I will say equal, otherwise I will say unequal. So if a equal to b, I will say sys out equal. Let's see what this outputs. So I'll just run it, run as Java application. And now it does not execute anything because a is actually not equal to b. So let me change the code now. And now you can see that the output is equal. So what if I just wanted to say that if this is not true, then do something else. So for that, we would use an if else statement. Now after this else, I can simply write sys out and then, just type not equal. Now let me save this and run this. Now it says equal, but if I change the condition and if I run this, it will say not equal because a is actually not equal to b. So this is not true. So what happens is that whatever condition you give within the if statement, if that returns true, then if block will be executed, meaning anything within if would be executed. Otherwise, it would go into the else block and it would be executed. If we do not have any else block, then nothing will be executed. Then this if will not execute and that's it. What if I want to add further lines into it? We cannot just keep doing that. We have to actually add a block over here. So by adding a block of curly braces, I can now keep on writing other lines as well. Similarly for else, if we want to add multiple lines within else, we have to actually add a particular block. And if I save this and run this, you will see now the output is the same. Again, this condition can be, any complex condition which, can be combined using an AND operator. So if A is equal to B and B is equal to 5, I just want to check, that again, obviously it is going to print the else part. but let's say if A is not equal to B and B is not equal to 5, then it should, print this part, just because, actually A is not equal to B and B is not equal to 5. So this is how the if else block works. You have if condition, and then you have a single statement or a block of statements, and then you have else and then a single statement or a block of statement. If you want to keep adding if nested in this way, so you can just write else if A equal to 5, then print else if block, else, which is actually going to execute, in case all of these if statements are not executed. This is the else block. Okay, now I'll just change it to the if block. So when I execute this, as you can see, since this has come out to be true, this is executed. But if I just add another thing like and 0, that's it, or and false. So now IDE itself says that this is dead code. Why? Because it definitely knows that what if it is false over here, this is definitely never going to execute. So if I just execute this, here it says that it comes to else block. Why? Because A is not equal to 5. If I just change this condition, then else if block is executed, just because A is actually not equal to 5. So this is how if else and else if works. Another way to actually avoid all of these different if statements, because what if I just wanted to check the values of A and B, and then based on that I wanted to print. So all of this is really a lot of work, right? So let me just remove this part of it and comment out all of this, and I'll introduce you to another statement which is known as the switch statement or the switch case. Okay, so what happens is that in the switch statement is that we pass a particular variable to switch, let's say A in this case, and then it has various cases for the values of A. Let's say the value of A could be 0. In that case, the case 0 will executed, or the value of A could be 4. In that case, the case 4 is executed. We could have, multiple cases like this. So it can be a case 4, case 5, or it can be a default case as well, like nothing, just in case nothing is actually the value of A, which is matching with the value of this particular variable over here, then the default will execute. Okay, so if the value of A is 4, then I want to execute something. So I can just write sysout case 4. Or if the value of A is 5, I can just write to the console case 5. Or if it does not match anything, then I can just write, case default. Okay. Now here's an interesting thing. If A is equal to 4 and we know that it will match the value over here, it should print case 4, right? If I execute this, here case 4 is executed fine. But why is case 5 and case default also executed? I didn't want that. To avoid that, we actually have to add a keyword known as break. So what happens is that whatever statement is happening, this break keyword will actually break it. No brainer in that. So it is going to break it, and it's not going to allow it to actually execute in a waterfall fashion. I mean, it cannot keep on executing it just because the first case got matched to it. Let's say if there was no break over here and the value of A was actually 5, then if I execute it, again, even though 5 got matched to it, still, the default case is executed. So we have to actually add a break over here. So let me now change the value of A to 4. Let me execute this. So now the case 4 is only executed and not case 5 and case default. Now remember, the variable which you pass over here, the data type of this case constants always have to match. So if it is A is integer, you cannot have a character 4 over here and expect that, this will match the case. So if I save this and execute, it actually did not match the case 4. It actually matched the case default. Why? Because the data types are different. And remember that these variables can only be either character or byte or short or int. Now, other than conditional statements, we have iterative statements, or what you commonly call as loops. So you might have heard this saying, right? make hay while the sun shines. So the whole thing is that as the sun keeps on shining, we should keep on concentrating on making hay. So that's not a one-time thing that, oh, now the sun is shining, let's make hay. It's like continuous thing, and that's what we want to do in our program as well. We want to continuously check if some condition is true or false, and then based on that, we want to execute a number of statements again and again and again. Those are known as loops. So now for iterative statements, I'm just creating a new class file, iterative statements, and I press on finish, and then again I write main, control space, select the main method, and now I can write my statements. So the first iterative statement which I want to tell you is the while statement. So let me just write int a equal to 9, and I want to actually run the while statement if a until a is either less than or equal to 0. I want to run all of these statements. So I can just write a is greater than 0. And always make sure, now this is the initialization part of it, okay? This is the initialization. Then you have this part, which is the conditional checking part. So we have conditional checking. And then the last thing which we really want to do is updation, because if we do not do anything over here, then what will happen is that this while loop will keep on running infinitely, and it will really crash our Eclipse and crash our Java, system which is working on my laptop. So I don't want that. So I'll just let's say decrement over here. So it starts with 9, it keeps on decrementing, and then as soon as it reaches 0, I want this while loop to stop working. So I'll just save this, and when I run this, so now nothing is getting output. So why is that so? Let me see. A is equal to 9. So as A is now having the value of 9. Here, is A less than or equal to 0? No. So the condition was wrong. A has to always be greater than or equal to 0. So here, if I save and I run this again, now you can see a number of times this has been output. So now how many times it has been output? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 times it has been output. Why? Because first, A is 9, A is greater than or equal to 0, yes, print this. Then decrement it. Now A is becoming 8. Then print again. Then A is 7. Then 6, then 5, then 4, then 3, then 2, then 1, and then 0. Because A is equal to 0, yes, again it will print. And then finally when A is minus 1, then it will not print. So if I don't want to print it, I just want A is greater than 0, then I'll just remove an equal to sign over here and then print it. This is how you do the debugging part of it. This is how you understand what should be your exact condition till when you want to execute these statements. So now you will see that it has only executed 9 times. So this is how you run a while loop. Remember, there is initialization, condition checking, and updation. Otherwise, you will have infinite looping out over here. If you don't want to use this syntax, then I'll just comment this out, and we can also use a for loop. So what happens is that in for loop, we have all of these 3 things at the same place. So first we have initializations. So I can write int a equal to 9 over here itself. So I don't actually need this. So let me just take all of them and do this thing, and this really did not become pretty to look at. So I'm just removing the other parts as well. We defined int a equal to 9. So remember that this a will only be now accessible within this for loop block. That's it. Again, as we talked about in the if statement, if we do not have multiple statements, we can simply get rid of this block or even the while block. If we just had one statement of printing it out or just one statement of updating, then we would not need these curly braces. But obviously while statement definitely needs this updation along with anything else. So But in for, if you don't need this whole block, if you just want to work with one statement of sysout, then we can do that as well. So a is greater than 0. And now after I have updated it, I actually want to check, right? So a is greater than 0, and then I want to do an updations, which is a minus minus in this case. Now I already told you about the increment operator, right? Pre-increment operator and post-increment operator. Similarly, we have pre-decrement operator and post-decrement operator, okay? Now, remember that we have semicolons over here. So this statement would also work exactly the same way as earlier. We again, have all these 9 statements which we wanted to output, okay? So this is the for loop, and that was the while loop. Now, if you want to keep on adding initializations over here, you can do that over here like so. You can just add a comma over here, and you don't need this int, because in Java you can simply initialize it with a single int like here. And then, if you want to add multiple conditions, then you can use the logical operators as usual. So you want a to be greater than 0 and b to be greater than 0, okay? And then again, for updation, you can have multiple updation operators just by adding commas as well. So you can do b minus minus as well. And then when I run this, you will see that it is run only 4 times. Why? Because b actually became equal to 0 much before a. So that's why this condition failed, and that's why our for loop stopped working and our for loop got terminated. Now there is another version of the while loop which is known as the do while loop. In that, it actually runs once at least. So if I say do and then something in the block, then this will actually run at least once. So runs at least once. This is post test loop. Why? Because here we are not checking before, we are actually checking later on. So that is why it became a post test loop. Okay. So now I'm going to check while a is greater than 0. We want to keep doing this. Again, let's initialize a equal to 9. And again, do not forget the updation part of it. A minus minus. Now, let's just keep it a small number. Now let's try to print this. I forgot the semicolon. Let's try to print this. Now, can you see that it ran only for 3 times? So initially a is 3, it ran once, and then it became 2, but 2 is greater than 0, that's fine. Then 1 is greater than 0, 0, that's fine. Now 0 is not greater than 0, so that's why it ran for 3 times. So that is the do while loop. Very similar to the while loop, but it will run at least one, and it is post. We also have another version of the for loop which is specific for Java. This is known as the enhanced for loop or the for in loop. In this for loop, what we do is we use the for keyword again, and then we have the declaration and an expression. This is also a good time to introduce arrays to you. So before we jump into the for in loop, let me create an array of integers. So if I just write int a equal to 9 or equal to 3, this is an integer, right? But what if I want to create 3 integers, one after the other in a row? For that, I can just add a square bracket pair, and here instead of just writing 3, I can write 1, 2, 3. Okay. What this is doing is it is creating an array of integers which will be called by a, and this is actually stored 1, 2, 3 in a row in the memory. That's how simple is an array. An array is a data type which is actually storing your values one after the other in the memory space. Now remember, arrays can only have one single data type. So for example, this is an integer array, so we just have all ints over here. Now if you want to actually use the enhanced for loop of Java for this particular array, then what we can do is we can simply create another variable int temp. This is just storing the values within a temporarily. So we have int temp from a. Okay, so a is an array actually, and temp is each integer within a. This is what this means, okay? And now I just want to print temp, okay? Now, when I save this and I click on run, this is actually printing 1, 2, 3, each of them to me. What if this was an array of strings? So this would be hello, this would be world, and this would be your name, okay? And here, as you can see, there is some error coming. Type mismatch, cannot convert element from string to int, because here temp also has to be the same data type as a. So now if we run this, this says hello world, your name. So this is how the enhanced for loop works, or for in loop. So we saw about the while loop. While loop really depends on the state, okay? It was checking the state of the variable a. For loop is something which we would use when we would only have fixed iterations. So as you remember that we actually added the initialization and the updation and the condition part all at one place, just because we know how many times we want for loop to run. But for example, we don't know until when we want to run. We just want to run until a particular variable state is changed, okay? For that, we would just use the while loop. Now let's look at the continue keyword. Here in this enhanced for loop, let's see if I want to check that I just want to print hello world. I don't want to print this your name, okay? So I want to just check if temp is equal to your name, and then I don't want it to print it. So here I want to write some logic by which it actually does not go ahead with anything beyond this. So I can just say continue. And then if I say continue, it is just going to come up, check if there is anything else remaining. I would just save this, I would run this, and now you will see that it only print hello world. If the temp was your name, then it actually caused it to not execute anything beyond but go back to the first statement. Instead of continue, if I would have written break, what would have happened is that if it was your name, then it would have completely gone out of the loop. So if I clicked on run, then again, we have the same result. But then there's a difference between break and continue. I will show that by putting this your name in the beginning. So ideally, you would see your name hello world if this thing did not exist. So if I just comment this out, I run this, this would say your name hello world. But now if I uncomment this, and initially it is checking whether temp is your name or not, and if it is, then it wants to break out of this loop. What break means is that it will terminate this loop. This loop will be forever over. When I run this, nothing is getting printed, because as soon as it saw your name, it broke out of this loop. But if I just use continue, then it would not break the loop completely. It would continue to the top part of the loop, and then the loop will keep on doing that until it stops. It's just that the remaining part of the loop will not execute just when the temp is equal to your name. So when I execute this, again, we have this hello world. So that's the difference between continue and break keyword within loops. Now the last thing within loops for you to know is that loops can be nested one within the other. So I can have this for loop. I can actually nest another for loop within it, okay? So I can just write for int I equal to 0, I less than 3, I plus plus, and within this I just want to write this is nested loop running. Okay, now what will happen? How many times will this be printed? This is nested loop running. Will it be 0 to 2? That means 3 times, or will it be more than that? So let's try to print this. Now, if you saw that it started, it saw that initially temp is your name. It said continue, so nothing executed. It really went back up. But then it saw hello, which is not equal to your name. So it went ahead and it actually printed hello. But then after that, it printed 0, 1, 2, meaning 3 times this nested loop running. And then it actually went ahead and executed For world, again, so again, the inner loop will always run as many times the outer loop. So how many times would the inner loop run? That you will get by multiplying the number of times the inner loop runs with the number of times the outer loop runs. Okay, so that is 3 into 2, which is 6. So that's how we got how nested loops work. Similarly, I can nest a while loop within the for loop, a for loop within another for each loop, a do while loop within a for loop. So all sorts of combinations are possible. So that's it about loops. The last things I want to share with you about control statements is the use of labels. So for example, I put this label 1 for this for loop, which is our main for loop. And within this for loop, we have another for loop. And now I want to tell this for loop to continue with the loop which is present after label 1. So what will happen is that when this is getting executed, it will not continue back to this particular for loop, but it will continue back to this particular for loop. Okay. Now let's see how this runs. So now, since we did not have anything after if, this is actually checking something, but then nothing is there, and the print statement is just after if. So that's the problem which was there. So let me just comment this part and run this again. Now, you will see that for each of the temp, it is printing that it is coming to the loop. This is nested loop running, but then it is continuing back to the top. And now, just because this label is there, that's why it is continuing the same process. And that's why the inner for loop is not running for how much time we actually planned, just because we actually caused it to continue back from the starting. Okay. And as soon as the temp is over, we do not go ahead with anything else. Now, the last keyword which I want to share, which will actually disrupt this flow, is the return keyword. If I just write, if I check your name, then this should return. If I just do this, what will happen? I click it and nothing happens. Why? What happens is that this return will actually return the main method, the method which is causing all this code to run. It is actually returning the main method and stopping the execution of the program. Okay. Let's say if I just cut this and put this after. Okay. And if I click on run, then what is happening is that it is checking for temp, it is executing this loop, and it is continuing. The return statement is not executed at all. Okay. If I just remove this continue statement, or if I just comment this out, and now if I run this, now you can see that your name will be executed. Okay. Then this is nested loop, this is nested loop running is executed 3 times as we expect. And then it is checking whether temp is your name. Yes, it is. Then it is returning. That means for all the other elements within A, this is not getting used. This is how return will actually completely stop the execution and return from the method which is calling. Now remember, we can have any number of for statements, any number of continuous statements, any number of break statements, any number of other loops as well. But return has to be only one. Okay. So if I have a return over here, then this will run only once. If I have multiple returns after that, these other returns will not execute, just because as soon as this return executes, then it actually returns, and none of the code after that is actually going to execute. So that's why we generally use returns with an if statement only, or whenever we check a condition, based on that condition only we want to return. Otherwise, we want to keep doing that. So if I actually change this condition to world, so it should return only after world, then this will execute for your name, hello, world, and then it's going to return. If I just change it to hello, then as you might have expected, this will only run for your name and hello, and then will return, not executing for anything beyond hello. So this is how return statement works. Now let's understand the next concept, which is of functions or methods. We already have seen how we can use inbuilt methods to common classes like integer, string, all of that, right? Why all these methods are there? Obviously, we want to use it again and again. That is why. We can also create our own methods. So if we create our own methods with a particular name, one method is something which we have already created, which is having the name of main, right? So that's the method which is getting executed when you run the program. But you can also write other methods with other names, and you can simply call those methods with their names inside your main, so that that entire piece of code can be reused. Okay, and remember that whenever you create a method, always have this thing in mind that you are creating a method to reuse your code. So your method should only have a single concern. For example, you create a method which will add two variables. So let it just add two variables, do a summation of two variables. Create another one for subtraction, create another one for multiplication, right? If you want to just say operation, then that is not a really single concern for each method. Within your operation, you would want to do an addition, subtraction, multiplication, other things, right? So remember to always have a single concern for each method. Now I'm creating a new class for showing you the methods. So this will be called methods. And in this, again, I would just want to create main. And now I want to show you that within main, I can call other methods. So how do we create methods? Now remember that methods will be called by other methods. So you would either want to always make them public or change that settings. We will talk about that later on. But right now I'm just creating a public method. And since main is static, I have to make this static as well. This again, we are going to talk about in the next week. And now I want to add a return type over here. Let's consider that this method will return an integer, and this will add two variables, namely A and B. And what this will do is it's actually going to return A plus B. Simple. And now I want to call this from main. So I want to call this by name sum, and I want to pass two variables, 2 and 3. Let's see what happens. When I run this, nothing happens because there is no print statement. Okay, so either I print over here, so we do a sysout and put this whole sum call within our system.out.println, and now when I print this, we will see that the sum is 5. Okay, why? Because it has returned an integer, which is the answer of addition of A and B. This is how we can create other methods and reuse this same method for any other task. So I can just do the same thing with other numbers. So I actually don't have to create different methods, or again and again, I don't have to, write the same A plus B again and again. So obviously A plus B is a very small thing, but what if, you wanted to actually do a lot of other work within this method and then just call that with different arguments. So this is a type of method which would take two arguments, but what if we want a method which would just not take any arguments? So for example, if I just have public static void announce. Okay, it doesn't do anything, it just announces something. Okay, I'll just write announcement. And if I call announce over here, and if I run this, you will see that it actually prints announcement just by calling announce from main. Okay, so this is not taking any parameters. This is taking two parameters. You can take one parameter, you can take any number of parameters. You can use these parameters over here. This method actually returns something. This method does not return anything. So I have written void over here. So these are the three types of functions which are there. The ones which don't take parameter, the ones which take parameters, the ones which return some data types. Okay, so this way you can create functions and reuse a set of lines again and again. Now what's the difference between creating a method and creating loops? Loops, however many times you will tell it to run, will run one after the other. But function, you can actually call any number of times. So I could have actually used the sum method and then called the announce method, and then later on, after a lot of lines of code, I remember that now I want to actually sum 4 and 5, so I would just call sum again. So when I run this, sum need not be called one after the other. That's the benefit of methods instead of loops. Now the next important thing while we are working with methods is the concept of passing by values and passing by reference. As I said, that for example, we are passing a value of 3 in the name of x. Okay. So in Java, we have primitives like int x, which are passed by values. But if we have objects like arrays, they are passed by reference. Okay. So how does pass by value works? If I'm having a new method with the name of test and I'm passing the value of y in it, and I just increment y and I print that. But in my main, my x is equal to 3 and I call test x. So what will happen is that 3 will get passed, okay, and 3 will be incremented, and what will be output? 4, okay. And then in my main, if I just print this x again, what do you think? What would be x be? Would x be 3 or would x be 4? Now, if you consider this diagram, x is actually passed in this method with the name of y, okay, and this y is actually known as the function argument, okay, and x is actually the local variable. Now, y is the function argument. It is incrementing 3 to 4 and then it is printing 4, fine. But when you come back to main, actually this y does not exist in main. In main, only x exists, right? X did not change its value. Why? Because here the value of x is taken up by y. Y cannot change x's value and x will have its own value 3. Even though we would have changed the name of y to x, let's say we had int x equal to 3, test x, and then here also test int x, x plus plus. It's not about the name. It's about the variable where it is used. This variable is the function argument, and whatever it changes does not affect the variable which is in the calling method, okay? But what about pass by reference? If we have an array, let's say we have an array x with the values 2 and 1, and we call this test with this particular array. And now in this, I changed the first element of the array. Now, how do we change the first element? We have this square brackets, and in this square brackets, we pass the index of the element. Remember that in Java, arrays begin with the 0th index, okay? So 0 means the first element, okay? What was the first element? The first element is 2. That became 1, okay? Now, we just come out of this particular method and now we are printing the first element in x. What do you think? Will the first element be 2 or will it be 1? Now here, the first element actually changed because of this change, and now the printing or the output would be 1. If you see that x and y both are pointing to the same object, and that's what we mean by pass by reference. Arrays, when I pass x to here in the name of y, y is actually the same as x. If I change y, then x also changes. So here now, x and y both are pointing to the object array 1 and 1. Now, if you do that over here, if I just change the variable a to 5, and before that, let me create an int sum equal to a plus b, and now I just want to return sum, okay? So what happens is that my sum is the same, but I just changed the value of a over here, okay? Now, the sum is actually going to print the same, but I actually want to see the value of a. So let's consider a was equal to 2, and that's what we passed over here. But now I want to print a again. Let me just comment out this part and let's try to run this. Now, as you can see, sum is 2 plus 3, as usual 5 which we got. A became 5 over here, but now if we are printing a over here, we see that this 5 did not affect anything. We still have a equal to 2 only. Why? Because it is passed by value. What if we have b, which is an array of only one element, let's say 3, okay? And here we are passing the first element of b, which is b square bracket 0. This is how we access the values within an array. If I send that, and now over here, if we change b0 not to be 4 instead of 3, okay? Now let's try to print b0. If we run this, there is some exception. Okay, so here this B is actually not an array. This B is just an integer. Okay, so I'll just change B to 4. This should change B 0. Now let's try to run this. Now this is still 3. And why is that so? Let's think. Why is that so? It is because we did not pass an array, which is an object. We passed an integer. So again, it is a pass by value. What if I just want to pass B? That's it. I will pass B. Here, I have to change this to int square brackets B. So int B square bracket or int square bracket B, both of them are same. Now access B0. And here again, I will access B0, return the sum, and now try to print B0. Now when we run this, now we sent an array with an element of 3. We got the sum to be 5, which is 2 plus 3. But then when we came out of this, if I'm trying to access the first element in B, it is actually 4. Why? Because we changed that over here in the called method, and this is actually changing the value in this particular array. So this is the difference between pass by value and pass by reference. You just have to make sure that your method is actually not changing the values of any arrays which are being sent to you, or any strings which are being sent to you, because that is going to be passed by reference. Any primitive value would be passed by value. Do you know that methods can also actually call themselves as well within their bodies? So that is known as recursion. Let me just create a new class called recursion, and let me just show that to you. So again, we have main. Now I'm just creating a new public static method, which is just called recursive. And now it is simply printing a message. Okay. What I want is that it should call itself. Now think if this is something which I did, that it calls itself, and then from my main, I call that method. What will happen is that main will call the recursive method, and then the recursive method will print out the message, and then it will call itself, and then it will print out message, call itself. This will keep on happening for infinite time, and this is something which we already have seen in terms of loops, right? That it is definitely going to keep on executing that. In this case, what happens is that the methods are actually stacked one upon the other. So first the main method is executed, then on top of that recursive method, then on top of that another recursive method. It will keep on happening, and then that stack will keep on growing, and then one fine time the stack will overflow, and that's how we call it stack overflow, right? So this is not something which we want. So we want to actually just call it on a particular condition. So let's say we are just printing the value of A. Let A be 3, for example. So now I just want to call it if A is less than 3, or if A is greater than 0, as we already saw earlier, we should call recursive. And again, you know, it would keep on happening until I update A somewhere. So initially A is 3, not over here, but over here. Okay, initially A is 3, we send the value of A over here. It is going to take an int A. It is going to check if A is greater than 0, and then it's going to call recursive with A again. But now every time within this, I am decrementing the value of A. Now let's try to run this. When we run this, now can you see what is happening? We sent a value of 3, 3 becomes 2 over here, 2 gets printed over here. If A is greater than 0, yes, and then again recursive is called, and then again this decrement is happening, and then we print 1, then again we print 0. As soon as A does not remain 0, this recursive is not called. As soon as if A does not remain greater than equal to 0, then this recursive is not called, and that's how this recursive just returns, and then we can simply go ahead with doing anything which we want to do over here. Okay, so this is how recursive methods work. So now if we want to see how recursion works, we initiate the recursive function, meaning we pass in the data, we check the base condition, If the base condition is actually true, then we simply return the data and terminate the function. If it is false, then we actually call that method again, do something with the data, and then we keep on doing that. So what is this base condition in our code? The base condition is actually a is less than 0, because if a is less than 0, then we do not do recursion. If it is greater than 0, then we do go ahead and do recursion. So now for recursion, we could have a recursive call anywhere, Right now, our recursive call was at the end of the method body, but then we could have the recursive call in the beginning of the function. That would be head recursion. What we did was a tail recursion. We had the recursive call after we did all the other things. We could also have the recursive call anywhere within the method body. So that is body recursion. Now let's go ahead and understand the other data types, which are non-primitive data types. For example, enum. So as you can see, I've created a class called enum, and in this I have actually created an enum called dates. What this does is that it actually creates a number of values associated with the days, and then based on that I can simply access that. So what I can use enum as, whenever I want to choose Monday, let's say for example, I can just do days.mon, and this is what will be executed over here. Let's try to run this. So now as you can see, mon is displayed, and this is a simple enum. We just have days, and all these attributes are definitely associated with this enum only, and that's how we will refer to it. So that's a simple use case of an enum. The next data type is arrays. We already have seen arrays which are single dimension, meaning it is one row of same data type data. We could also have multi-dimensional arrays. So now, as I said, that arrays are a collection of items having the same data type which are stored in contiguous memory locations. The first element is stored at the smallest memory address. Okay. Now, as you can see over here, you have an array which starts with 0. 0 can point to a string, dog. 1 can point to another string. 2 can point to another string, let's say cat, and 3 can point to another string. This is a string array. These are all the indexes of all the elements which are stored within that array. Similarly, you can have a 2D array, meaning an array within an array. So the first element is actually having another array of 3 elements. The second element is having another array of 3 elements, and the third element is having another array of 3 elements. So that's how we would have a 2-dimensional array. So now here I'm creating a new class for arrays. And now in this, I'm creating a main block, and within this, we already saw how we can define an integer array 1, 2, 3, 4, however much we want. Or we could use the new keyword. We could create an int a, let's name it different, int b, with a new keyword. It would be new int bracket, and that's it. But here we have to actually specify the size, because here we understand that the size is 4 from 0 to 3. We really want to specify the size over here as well. So let's write 4, and the error will go away. Now we can simply access the different elements B0 or B1 or B2 or B3. What if we try to do B4? Let's try to print and try to run this. Essentially what I'm doing is that I'm actually trying to access something which is actually not present in B or not initialized in B. So when I run this, it gives an exception, array index out of bounds exception. Why? Because this index 4 is out of bounds for length 4. What you need is that your indexes are always between 0 and 3 for length 4 array. So you cannot use 4. So if I try to print B3, then we see 0. Why? Because here I've just initialized it. I have not assigned any other number, so it will be 0 only. If I do an A3, then if I print this, then this will be 4, because 3 is equal to 4. Now, if I try to actually create a 2-dimensional array, I can simply create it using 2 sets of square brackets. And now, if I want to initialize it, I will be having to use a number of curly braces. So in the first level of curly brace, I have my different rows, and then I have to create different columns using 3 different curly braces as well. So this is row number 0, this is row number 1, and this is row number 2. And what about the column number? It can be 0.1, 0.2, and 0.3. This will be 1.1, 1.2, 1.3, and this will again be 2.1, 2.2, and 2.3. Now these are all double, so let me just change data type. Now if we try to print C3, this again will cause an index out of bound because we just have 0, 1, 2, total 3. So we'll print C2, and now you can see we actually have this output, which is definitely not what I want. So we actually have to mention the element which I want to display. So if I take the first element, I will have from the third row, the first element will be 2.1, or I can have the second element using 1, or I can have the third element using 2. This is how we actually access and initialize a two-dimensional array. I could also have done it using the new keyword. So we can do something like this and just create new int, again 2 brackets, and then simply called d20. Again we have to specify the size, but then even if we specify the number of rows, that's absolutely fine. If I print this will say null pointer exception. Why? Because the number of columns are not initialized. So let's initialize it to 2. And now when we print it, this will be 0 again because we have not given any other value for this. So this is how we have single dimensional arrays and two-dimensional arrays. Now we could have something known as jagged arrays, meaning that the columns within different rows are different. So here I have a two-dimensional array. The first row has 3 columns with elements 1, 2, and 3. The second row has only 2 columns with elements 4 and 5. So if I try to print E02, meaning I want to print 3, then I would definitely have 3 printed over here. But then if I just change it to E12, then let's see what happens. Again, there is going to be an array index out of bounds exception just because I tried to access something which is not present. So obviously I cannot display from the second row the third element because there is no third element. Can I do for the second element? If I try to print this, as you can see, 5 is printed, which is correct. So this is also one possibility of using two-dimensional arrays using Java as we really deem fit for our problem solving. Now let's talk something about strings. Just like arrays, we could have strings as well, right? After all, array is contiguous allocation of memory for same data type. So what if the data type is just, different characters like A, B, or C? All of them together can make an array, right? Similar to that, we have strings which can be represented with double quotes, just as I wrote hello world, right? But using strings really, has many useful methods. That's why we generally do not work so much with character arrays, but we work a lot with strings. So in my Eclipse, again, I'm creating a new file with the class for strings. Now in this, let's create a main method. Now, as I said that there can be character arrays. So let's say I have this character array A, B, C, D. And now, what if I just wanted to print all of them? I would have, had to create a for loop for I equal to 0, I less than ARR. And I actually want to find the length of the array. I don't know how long is this array. So for arrays, we have a very nice property, which is length. So I can simply do I less than ARR dot length, I plus plus. And then within this, I can simply, access ARR. And now I want to access each element within this array. How would I do that? I can simply use this index of I. After all, I is from 0 to array.length, right? So if I want to have 0 to array.length minus 1, I can simply use I, because as soon as it becomes array.length, it would break, right? So I can just do a sysout of this ARRI, and this is how I would print this character array. Now instead of println, let me just use print to show you how it looks like. Oops. So these are actually thought of as variables just because I did not put my single quotes around them, and single quotes are compulsory for characters, right? So let me just save this again, run this. Now you can see ABCD. But how easy it would have been if I just could create a string called str and I could just use double quotes and write ABCD, and that's it. Let's comment this out and let's try to print str. Let me save this and run this. Now you can see again we have ABCD, but it is much easier to simply define a string instead of using this whole character array. Now how can we define a string in another fashion? We would have string str. We could also use the new keyword, new string, and then I could simply assign. So we can say str1 and I can assign str1 to be some other string. So EFGH. Okay, so that's some other string which we have, and let's print str1. When I run this, I see EFGH, which is the value on str1. So this is another way. Or I could actually have created a new string based on my character array ARR itself. So I can create str2, which is going to be new string, and simply pass this character array ARR to this. Let me try to now print str2. Now, as you can see, I have my ABCD output over here, which is actually the output for this character array. So this is a very easy way to convert the character array to a string. Now, why we would want to do that is because we have a lot of good methods available with strings. So for example, just to find out length, we have the length method. Now, if I print that, this is 4 because the length is 4. Also, we can concatenate two strings. So for example, dot, we go to concat and we add another string. Let's say this is str2, which is ABCD, and this is str1, which is EFGS. Now let's run this. Now, as you can see, this is ABCD EFGH because we have concatenated ABCD with EFGH, and the resulting one is something which is returned to the system.out.println method. So this is how we can concatenate two strings or add one string after the other. Similarly, we have many different methods. You can just press the dot and you can check all these various methods. For example, it has a caret method in which you can simply pass the index. So let's say if I just do char at 0, I'm just going to print that, and then I will have a because the character at index 0 is a. I can have any other method like compare, or we just saw concatenate, or we can have a method of ends with, which will check if that's this string ends with a particular suffix or not, or we can use an equals method to find that this string equals to another string or not, or we can find index of a particular character. So for example, I just pass b and I want to see what is the index of b. Again, we just forgot this character. We really need single quotes to make sure that this is the character constant. So now str2 has b at the index 1, which is correct, right? So these are so many other methods which really come handy when we want to actually manipulate a lot of text and a lot of data. So you can just go ahead and work with strings and practice yourself. You can try using these different methods, and all the description of each method is actually given in this box, so it really becomes easy to use the Eclipse IDE. You can use the starts with method to check for a particular suffix. Something interesting is the substring method. For example, I just want the string from index 1 to index 2. That's it. This is the string which I want. So if we run this, you realize that you only have the output of B. And why is that so? If you see that it says that hamburger from 4 to 8 will return URGE. And why is that so? 4 is U, 5, 6, 7. So the last one does not get included. That is the reason. If we would have put 3 and if we run this, then we would get BC. So from ABCD, we got BC just by using the substring method. So this is the way you can use all these various methods and try to find all these things. The reason I tell you is because once you know all the various methods and all the various things which you can do with strings, then it will become very easy for you to think that I want to do this thing. How can I do that? Oh yes, there is some method which string has which allows me to do something like this. So let me just go ahead and find from this list what was that method name exactly and use that. So that is one very nice way of learning strings. So now we saw that string is represented by double quotes. It has many useful methods. So strings are actually special types of arrays, which are storing characters. Remember, Java strings are immutable. What is the meaning of immutable? Immutable means that once I assign the string some value, then I cannot change it. What if I want to really change it? Then what happens is that Java actually creates another string with the new value and assigns that new object to your name or your reference which you have created. So for example, I created str equal to abc, but I want to change it to abcd. So what Java will do is it will create a new string object and assign the value abcd to it and return that as str. So the earlier memory is lost and a new memory and a new object is returned. That is how Java strings work. Now, the knowledge of this is really important, because what if you're dealing with a lot of text and you just want to make a small change? If you're using strings, then even that small change can become very expensive, because Java program will take a lot of time to create a new object with all of your text with that small change and assign that to your string name. You don't want that. If you do not want a lot of processing just for some changes, then you can go ahead with other classes. As for string, we saw how we can just create a string, and that would not take a lot of time. We can create a string with an initialized value, or if we want a mutable string, then we can use a string builder class. So instead of using the word string, you can use the word string builder, and that is really going to take the same syntax as earlier, and it is just going to create a new string builder. Now, string builder is a mutable string. You can simply, change that in place. It will not really worry about creating a whole new object and copying one by one, So that is something which comes really handy with string builder. Now, if you really want to access the ith element, we saw how we can use char add. For the size of the string, we saw how we could use length, or to concatenate, we saw how we could use the concat method. Even for appending, so in string we would concatenate, but in string builder we can simply append it, and that is not going to take a lot of time. And if you really want to change the string builder string to actual string class string, we can simply use the toString method after the name of the object of string builder, and that's how we will get the actual string back. Now remember that with arrays, we cannot change the size of the array once it is defined. So that problem is again, the same with arrays. So if we just wanted to add something more, or if we wanted to just change the size, grow the array or reduce the array, again, we would have had to create a new array, and then we would have had to copy everything from this original array and then add the things which we wanted to add more, right? So that is a concern with arrays as well. So when you're working with arrays, remember that once you create an array, once you define the size of the array with the new keyword, let's say, you cannot change the size of the array. Similarly, once you define string, then you cannot really mutate it without realizing that there is an additional cost. So you can simply use string builder, or you can use string buffer as well. So string buffer is another class, and we will just, create a new string buffer. And now assign string v equal to xyz. And now let's just print that. Now this is showing some error because it is really expecting that this would have been an object of string. So instead of this, let's just cut from here and paste it over here to initialize it. And then if we really, for example, want to add some value, we can just use an append and then, add some other values like 1, 2, 3, and, really be able to print all of this string B now. So now you can see that if this is xyz 1, 2, 3, we can use string buffer as well. Now you might be thinking that we already understand string builder, right? And string buffer is also the same thing. So what's the difference? So string buffer is generally used when we work on a multi-threaded environment. I told you, right, that we can create multiple threads within a Java program so that, different tasks can happen simultaneously. So string buffer is generally used in that because, your strings will not be changed just because your other threads are working on the same. So we really can have that safety with threads with string buffer. With string builder, we cannot have that. So that's the only difference. But otherwise, for the mutability part, both of them are same. Also, I just wanted to share with you at last that we saw a number of exceptions and errors happening, right? Array index out of bounds, etc. So, for example, if I just try to access ARR4 and let me just try to print that. Now, if we try to print that, you can see that it says exception in thread main, and this is array index out of bounds exception. So this exceptions or errors can be handled by Java. There's a way to do that, and that is something which we are going to study in the coming weeks. Now, we studied a lot in the Java programming language, and in fact, with whatever we studied, you will be able to go ahead and understand most of the Java code which is written, and you should be able to understand what is going to be the output of a particular code, and you should be also able to write small Java programs. As part of how we work in the industry, it is really important for you to know that as well. So remember that you can add comments to make sure that another user understands what is going on in your code, but then you make sure that your comments make sense and they are actually true, because otherwise, you can keep adding some or the other comment and it might not even be reflecting the actual code which you have written. Also, remember, if you have written your code again and again, try to avoid duplication, because that is definitely an enemy of a well-designed system. So avoid duplication. Let's have all the code in one place. You can create a method, let's say, with all that code. Simply pass arguments to that method and then let the code work on those arguments and then return to the caller. So that is how you can reduce duplication in your code. Also, remember, don't think of complex ways of doing things. Do the simplest thing that could possibly work to solve your problem. Whenever you're writing any Java code, always follow this principle. Now, to summarize this week's module, we studied about variables, we studied about the various data types and the various operators which we can work on with the different variables. We saw selection statements, iterative statements, and method calling. We also saw recursion within method calling. We also saw how we could pass by value using primitives or pass by reference using objects, and how it really makes a difference if the called method really changes the object. Then we saw everything about arrays and strings, how we could use them. So now you can simply use all of this knowledge to complete your assignments. All the best.
Welcome to the part B of Introduction to Java, week 1. Now, we are going to do some practice exercises on all the basic constructs which we have studied in week 1. The first practice we are going to do is to write a program based on strings. In this program, what I want to do is to swap two strings. So for example, if we have string 1 which has hi and we have string 2 which has hello, then what I want to do is I want to put hello in string 1 and hi in string 2. Now how would we do it? One way to do it is using a temporary string which can be called as temp, and the procedure would be to first put whatever we have in string 1 in the temporary string and then put whatever we have in string 2 in string 1. So now we do have hello in string 1, so that's good. And now finally we have hi in the temporary string. That is something which we can put in string 2. So finally we have hi in string 2 as well. So now as you can see, we have swapped the two strings successfully. How would we use this logic in a Java program? So over here I have created a new class known as string swap, and in this we want to write this code to swap two strings. So I will create a main as usual. This is where our program begins, right? I will create a new string str1, and here I'm going to put the value hi in this, and we have str2 which would have the value of hello in it. Now what I want to do is I want to actually swap these two strings and then print them both. So if I do a sys out str1 and similarly if I do a sys out str2, now we are not doing anything, we are not swapping or doing anything of that sort, right? So what I should be having is hi and hello as my output. So let's try to run this. As you can see, our expected output is hi and hello, and this is what exactly we have got. Now what we want to do is swap these two strings. So as I said that we can create a new temporary variable and we can use the new keyword for this. So I would use a new string, and this would not have anything. And now in this temporary variable, we would put our string 1. And then in our string 1, we would put our string 2. And then finally, in our string 2, we would put the temporary variable. Let's see what output do we have now. So if I run this, we have hello and hi. So as you can see, we have successfully swapped both these strings. So this should be good for this particular program. But I want to show you how we can make our code better. So if you see that this part, I can actually create a new method for, So let's say, for example, my method name would be swap, and then I pass both the strings. I have str1 and str2, and what I want it to now output again hello and hi instead of string 1 and string 2. As you can see, there is a red mark over here. It shows an error and it says that the method is undefined. So we can use this option create method, and this is actually going to create a new method stub for us. The method name is swap. It has two arguments, str1 and str2. It is going to return void. That means it's not going to return anything. It's supposed to be static because main is static, and any method which is called from a static method is also supposed to be static. Also, we are going to see, what is public and private later on. But now all this code I want to not be over here, instead be over here. Now temp is not defined, so this definition also we are supposed to cut from here and paste it over here. So now we have simply two strings. I'm calling a method which is passing in string 1 and string 2. This method is taking string 1 and string 2, doing the same computation, and then finally it's going to print str1 and str2. I'm saving this and let's try to run this. What do you think will happen? Is it going to output hello and hi, or is it going to give any error? So when I run this, it doesn't give any compile time error, but it gives a runtime error in the sense that we do not get the output which we want. We have a hi and hello, and str1 and str2 is hi and hello. So that means there is no swapping happening. Why is that so? Can you think? This is because str1 and str2 which has come over here, that is not passed by reference. That has created a new object, and then it's doing the same computation, but then whatever was str1 and str2 ahead, that still remains so. So instead of outputting it over here, we could simply cut this from here and paste it over here. When we save this, now when I run this, we would have the output which we want. We would have both of these strings swapped and then output it over here. So this is how we could swap two strings in Java using a method. Now look at the next problem which we have to do. In this program, we are supposed to create a program which would display a multiplication table from 1 to x. So x could be anything, it's going to be the input by the user, and the tables should be displayed as multiplication table for 1, and then we have 1 into 1 equal to 1, 1 into 2 equal to 2, and so on. Then we have multiplication table for 2, the same thing, multiplication table for 3, and all that. So now how do we implement this particular program? So the first thing that we need to learn is how to take input from the user. So the first thing which we need is obviously the main method. That's where our program is going to begin. In this, we are going to first tell the user to input a number till where they need the multiplication table. So please input till where you need the multiplication table. Now the first thing which comes to my mind is, instead of actually taking this entire problem in and of itself, why not break it into a small part? So first we really need to create a multiplication table for any number which the user would input. So here, let's first actually write a program to create a multiplication table on any number which the user would input. So here we will tell the user, please input the number for which you need the multiplication table. Now we have to create an object of the scanner class. So we would just have, scanner sc equal to new scanner, and this is actually going to be taking an argument which is going to be system.in, and now we have this sc object. Now you can see there is an error over here, and it's actually telling us to import scanner. So we would be importing scanner from the Java util class. Now we have this sc object, and what we would do is we would take the next integer which the user is going to input. So sc dot, and then we are going to use the next, and we are going to check what methods we have over here. So it's actually, we do have a next int over here. So we are going to use that, and whatever integer we have gotten, that is supposed to be put in X. So that's the multiplication table which we are going to create, right? Now the first thing which we want to show to the user is multiplication table for so and so. So that's what I'm going to output over here. I'm going to write multiplication table for, here we would do a plus X, and that's how we are going to show to the user that we are actually going to do a multiplication table for X. Now let me just save this program till here, and then let's try to run this. So now it is asking us to input the number for which we want a multiplication table. So for now I'm going to input 5. Now it says multiplication table for 5, and now you can see over here that it has terminated. So that means our program is running very well till now. So now what we need to do is, now we need to generate the multiplication table for X over here. So now how are we going to generate a multiplication table? The thing is, we need to loop from 1 to 10 and then keep multiplying and displaying the result, right? So I'm going to use a for loop. So we have a for int I equal to 0, I less than 11. We are actually going to start from 1 to 10. That's how we are going to do. So we do an I++. So it's actually going to loop from I equal to 1 to I equal to 10. So this should be less than or equal to 10. So it's going to loop from 1 to 10 correctly. And now what we need to do is, we simply need to multiply X with I, and this is going to be our result. But then we need to display it somehow, right? So before that, I'm going to do a sysout, and we are going to write X and then a multiplication sign. Now the multiplication sign which is specified over here is a simple X over here, and then we are going to write our I, because that's going to begin from 1 to 10. And then finally we are also going to add an equal to sign. So this should have space, and now we would output our result. So what's going to be the result? Result is this X into I. This is what I'm going to put over here, and then hopefully we have our entire multiplication table ready. So let's try to run this. Now again I'm putting 5, and now as you can see, we do have a multiplication table of 5. 5 into 1 is 5, 5 into 2 is 10, and so on. So finally I have the multiplication table of 5 over here. Now let's try to extend this to our original problem of implementing a multiplication table from 1 to X. So now we are going to ask the user to input the number till where you need the multiplication tables. So now this user is going to input, let's say 5, and we are supposed to now output from multiplication tables from 1 to 5. So now as you can see, I have this integer X. So now this is going to just output the multiplication table for X. I want to also do this for 1. So instead I would create a for loop over here, which is now going to take int j equal to 1, and then j should be less than equal to X. Now we are going to do it from 1 to X, right? And then j++. This is what we want. And within this for loop, I want my multiplication table for so and so should come. But then what is this X? X is actually the one which the user has input. So that's the last thing, right? Instead, I want to actually write multiplication table for that particular value which we are considering. So it will start with 1 and then it would go to all the way to X. So every time we are actually using the value of j to show the multiplication table of the value of j. Now similarly, I'm going to cut this particular for loop and then put over here. But now this is not going to be X anymore over here. It's going to be j, because we are going to show the multiplication table for j. And let's now try to run this code and let's see what we want is indeed what we get. So I'll just clear this console and try to run this. And now for simplicity's sake, I'm just putting 2. Now as you can see over here, we have multiplication table for 1 and then we have multiplication table for 2. That's good, because that's exactly what we wanted. Let's try if we can get for a higher number. So I'm trying to run this, and now I'm putting that I want multiplication tables till 17. So when I run this, as you can see, We start with multiplication table of 1, then multiplication table of 2, multiplication table of 3, and we have the results, exactly correct of the multiplications as well. So we go from 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, and 17. So exactly what we wanted, we got it. Now, as you can see, we have a for loop within for loop. This is how we can nest loops and gain what we want from any particular output of the program which we need. In the next example, we are going to try to create a simple tic-tac-toe game of 2 users. And it says that, they declare the winner as soon as any player wins. Now, if you do not know what a tic-tac-toe game is, it's actually the simple X and zeros which we used to play in our childhood. The idea over here is to use a 2D array. So, we had this 2D array, and let's say the first player would put an X, the second player has option to put a 0 anywhere over here. So let's say the user puts 0 over here. So what we need is, first of all, the position where the user wants to put in. So we need the row and the column, and then based on which user it is, we are going to put a X at that particular place. Now the user 1 again has the option to put X anywhere over here. So let's say the user 1 puts it over here. So now every time the user puts the move at any particular place, then we are supposed to say whether that user has won the game or not. So what we will do is, as soon as the user would put an X over here, we would want to see that if there is an X in this particular row or not, if there is all X in this particular column or not, or if there is X in the 2 diagonals. But since this X is not in a particular diagonal, then we would not check it. Now in the next move, whenever the second user wants to play it, the user, let's say, would put it over here. So now over here, we would want to check again, if there are all zeros in a particular row. But then in this row, we would see that, there are still, empty cells, and, we would not declare the winner over here. Then we would check the column, and here again, there is going to be 1X, and then, finally we will see if it is there in the diagonal or not. But no, it is not there. So we are not going to check the diagonal. Now again, if we try to give the control to the user 1, and the user 1, let's say, chooses to put X over here, then again we are going to check if X is present in this particular column, but we see that it's not all X. Then in this row it's not all X, and in the cross diagonal, then we are going to check the cross diagonal, but then the cross diagonal is not all X, and even this diagonal is not all X. So the winner is not yet declared. Then we pass the control to the user 2, and then the user 2 would put, let's say, a 0 over here, and then again we are going to check the column, the row, and whether it's in any diagonal position or not. But the winner cannot be declared over here as well. Now the user 1 has the option to put X in any of the empty places. So now the user 1 puts an X over here. We are going to check if the column has all X. No. The row has all X. No. But the diagonal has all X. So we do have the winner, which is user 1 over here, and then we would stop the game and declare the winner to be user 1. This is how we are going to do. Now how are we going to check the row, the column, and the diagonals is something which we have to think about while we are coding. So here I created my class tic-tac-toe, and the first thing which we want to add a convention over here is that obviously in our 2D array we cannot put X and zeros. So as a convention, what I would have is a 0 to be 0 and an X to be 1. So wherever we have X, we would put 1, and wherever we would have 0, we would put 0. Or how would we show that the place is empty? So instead we put a 0 for empty, for X we put 1, and for 0 let's put -1. So this is how I would have my 2D array populated. So let's create a 2D array over here. So this is going to contain int, and then we have a 2 dimension, and then this is going to be the board of the tic-tac-toe, and this we are just creating new int, and then let's just have it 3 by 3 for now. So we have a 3 by 3 board. Now what I want to do is I want to always alternate between 2 users. So before that, let's try to actually gain some input from the user. So for that, as we saw that, we could use the scanner, object, and we are going to take the position, and we are going to take the row and the column wherein the user would want to input. So for that, again, we would put in system.in, and then we would do an sc.nextInt. But before that, we need to import the scanner from Java util, and then we are going to have, everything from this particular object. We can now call sc.nextInt. But now, as you can see over here, there is some problem happening. And why is that so? Because I missed a very important thing, and that's actually the creation of main, and everything begins with main, right? So we need to actually put all of this in the main. But in fact, the board is definitely going to be something which is common to the entire class, and also, the scanner object. So let's actually take this out and put this over here as variables of this class. And now inside our main, I'm trying to use this scanner object to now take input from the user. Now I'm still not able to do, and if you can see that, there is a red mark over here, and the reason for that is we need to change this to static. What we need to do is that we need to use this particular object only in the static context, because main has static. So now we would use a nextInt over here, and this is going to give us the integer. So now, for example, the first thing which I want to take from the user is going to be the row. So I'll put it in int row. And the next thing which I want to do is take the column from the user. So I'm going to put it in int col. And this is what I'm going to, give the message to the user as well. Input the next move row, and similarly I would ask for the column. So input the next move column. So now I know that a particular user can input the row and can input the column. This is exactly where I would want to put the user's mark on. So now in our board, in the row and in the column, this is where I want to put the mark. Now what is going to be the mark? That depends on who is the player. So let's say we have a player over here, and that's exactly what I'm going to put. So now there has to be two players. So the first player would be inputting 1, which is x, and the next player would be inputting -1. So what I can do is I can actually check if the player is equal to 1. Because if the player was equal to 1, now the player has to change, right? So the player now has to become -1. So this is how I would, change the player. But we have not yet defined player, and that's why it is giving an error, right? So first let's define player, and we'll do that over here. We have integer player, and let's just, put this equal to 1, because, we always begin with the player, with the player who's going to put the x in the board first. So we have this player, and this is 1, and now this player has to be static. So we'll just change the player into static, and this is because we are doing it in a static context of main. So that's why if the player is 1, then change the player. Otherwise, if the player is -1, then we'll have to change the player to 1. So how do we do that? So here, this is a check only if the player is 1. So basically what we want to do is we want to toggle between the players. For this, let's actually just use a simple if else. So if player is equal to 1, then we actually change the player to -1, else we have the player to be 1. And the reason for this is the player can only be 1 and -1, right? So if the player was -1, then now the player should be 1. So this is the whole thing. And now what we want is that this player should be able to make the move to this particular row and column and put the corresponding number at that particular position. But now this is giving an error just because the board is also supposed to be static. So let's put the static over here, and now we'll be able to change the board position. So let's see if our code is working fine till now. Let's try to run this. So now it's just asking us to make the first move. So I'll just put a 0 by 0. And what we have is that, the player, which is 1, is actually putting the move to the board. But what is going to be the move? So for that, we actually want some method which is going to print our entire board for us. So I'm actually going to create a new method to print board. So I'm going to call it print board, and I'm passing the board over here. And what this method should actually do is just, sys out the entire board. So I'm just creating this method over here. It just changed it to board 2, but I'm just going to keep it board. And what we really want is to actually now output everything inside the board. So what I'll do is I'm going to begin from I equal to 0, I less than what? Board dot length. Okay, because this is actually going to, give us the whole length of the board, in terms of row. And this is going to be I++. Within this, I will create another loop, which is now going to pass through the number of columns in the board. Okay, so I'm going to do int j equal to 0, j less than board. And now for this, I really need the first row, and then I'm going to find the length of the first row. That's actually going to give me the number of columns in this particular row. And then this is going to be j++. And then we have this board, I and j. This is what we want to output. So we'll just do a sys out, and then we are going to output this. So we'll cut this thing from here, put this over here. So let's try to now see what was the thing in the board. So when I run this, and again, I would want to make a move 0, 0, it gives us an exception. And the exception says that array index out of bound, index 3 of the out of bounds for the length 3. So now here there is an issue. The issue is that we went on from 0 to the entire length, but actually we would have gone to length -1. So this is the change which I would make. I'll try to run this again. Again, I'm going to put 0, and here again it gives us the same issue. So here again I'm using I, and that's the problem which I was having. Let me try to run this again. So now it gives us only 4 values, and it actually put -1. So now this is the big thing, which I see over here, because we wanted to actually put 1. And the reason is because we actually are making a move after we have switched the player. So instead, let's make a move first and then switch the player. Okay. So when I would have done this, and if I try to run this and I try to now input what I want to do. So now we do have 1 over here. But now as you can see, what we really want is a proper way of printing, and this is not a proper way of printing, right? So what I want to see is just a print. I do not want a new line, and after every element I just want a space. And then once my inner loop is done, then in my outer loop what I want is a new line. So let me just put brackets over here for your understanding. So we have this particular line executed within the inner loop, and then after the inner loop is closed, then I want to create a new line. And the reason for this is because I want to add a new line every time my row completes. So if one row completes, then we need a new line, and then we want to keep doing that. So let me try to print this again. Let's try to see what we get now. And now instead of a 3 by 3 matrix, we have a 2 by 2 matrix printed over here. And now I realize that the change which I made over here from I to j, that was the problem. The length was not an issue. So let me just get it back, because we are not doing a less than equal to, so that should not be an issue. Now let's try to put the move. So now correctly we have an X in our board. So that's the first win which we got, that we are able to put things in this particular place in the board. Now the next thing what we need to do is we need to actually do this continuously until a winner is announced. So before doing anything, let me actually create a winner. So this is again going to be static integer, and this is going to be a winner, and right now there is no winner, so let's put it to be 0, because this means that the game is going on. So winner equal to 0 means the game is going on. Once the winner becomes 1 or -1, we would know who the winner is. So we need to keep looping this until the winner becomes somebody else other than 0. So what do we need to keep doing something until something happens? If you think carefully, we can actually use a while loop over here. So now we would use a while loop, and we are going to check while winner is 0, then we keep doing these things. Okay, we can keep doing these things. But now if I try to run this program will go in infinite loop. And why is that so? The reason is because when I actually keep checking, if the winner is 0, it is always going to be true, right? I have not updated the winner anywhere. So now whenever we are trying to make a move, this is the place where we do the move. After this, we want to check the winner. After every move, we want to check the winner. But how do we check the winner? The winner would be if this same attribute is there for all elements in the row, for all elements in the column, and for the diagonals as well. So now instead of making it too complicated in the beginning, let me actually only declare the winner if the entire row is having, this player. So I would actually want to check for all the columns, right? So I would do an int I equal to 0, I less than both 0 dot length I plus plus. And then within this loop, I just want to keep checking if the board I for that particular column is equal to player or not. And if this board I equal to player, then I want to say that this is going to be the winner. But then it may be that only the first one is the player, and the remaining two are not the player. So what am I going to do? I can actually have a count. If the count is equal to 3, then it's going to be the winner, right? Because for all the 3 columns in this particular row, we want that this player should be present. All x's are there or all zeros are there. So what we were doing is we were actually checking for all the columns in this particular row. So the row is going to be constant, but the column is actually going to be variable over here. So it's supposed to be board row, and then for each column we are going to check if it is equal to player, and then we are going to increase the count of the score. Okay, so I'm going to do a score plus plus, but we have not yet given the score, right? So the score would be equal to 0. So let's just have an int score over here. It's going to be equal to 0. I am going to increase the score every time, the board row I equal to player. But now, I want to check if the score is equal to 3, then my winner is going to be this particular player. Else, what would happen? I want to toggle the player. This is what I want to put in my else if the winner is not yet declared. Okay, and as soon as the winner is declared, you will see that my while loop will break. Okay, so what I really need to do is every time one of the rows has the same thing, that is going to be the winner. Now I forgot a semicolon over here. Now why do I put a score over here? Because I always want to have my score 0 before I start doing something. Okay, so my score is definitely supposed to be 0 before we start checking who the winner is. So let's try to run this and try to play the game now, just by seeing if the row is the element which is giving us the winner. So when I try to run this, and let's say I make a move at the first position, and this is where the move has started. Now again we can give another move. Now this is going to be the user 2 who's going to do that. So let's say the user 2 just gives it to the second row and the first column. So this is how the board looks like now. Now the user 1, I would just put it in the first row in the second column. Now this is how the board looks right now. Now the user 2 has the option, right? So the user 2 is wanting to do, let's say for example, the second column and the second row. We have this particular board. Now the user 1 has an option, so I would put the first row and the third column. Okay, so this is how we have the board right now. And now, as you can see, the program terminated. The program terminated and it is not asking me to input the next move because it already got the winner. So what we would do is, so when the score is 3, that time we are declaring the winner, right? That's where we would also output who the winner is. So we would say the game has ended, the winner is, and then we would put the player over here. So that's only when we would have an if, right? Because after that we just have an else. So this is what we have over here, and then that way we would have a winner. So the player 1 and the player -1, that's going to be a little bit of confusion right now, but then we are going to actually cater to this later on. So now over here we have actually checked the score, for everything within that particular row. The same thing we want to do for that particular column as well. And similarly, we want to check for the 2 diagonals as well, right? So let's actually try to do the same thing for the column as well. So if we want to have a column, the score has to change, right? So this is going to be a row score. And what we need to do is we need to have a column score as well. So row score equal to 0. Similarly, we need a call score again, equal to 0. And we'll do the same thing for column. So now we will have int I equal to 0, I less than board dot length, I plus plus. If board I call equal to player, then we would change the column score. When we actually check for both rows and columns, then we are going to get the winner. So it's either that, the row score becomes 3 or the column score becomes 3. So in any case, we would have a winner, right? Even if it is row, even if it is column, we are going to have a winner. Now let's try to actually run this and check for a column win. So when I run this, let's start with 0, we have this. Then for the next player, let's put 0, 1, and now let's actually try to put 1, 0. So we have the first column. That's what we are wanting to target. Then for the next player, let's put 1, 1, and now it comes back to the player 1, where we now put 2, 0. So now it say the game has ended, the winner is 1. So the winner is 1, which is the player number 1. So now we have a winner just because we also have the call score to be equal to 3. So now this is working fine. Let me actually print the board just after the move. So this is where we will print the board, so that the board is printed before we display the game has ended, the winner is so and so. If the game does not end, then it would keep on telling the next player to input the next row and next column. So now to make it easy, let's try to actually display who the player is, and then tell the player to input the next row and the next column. So we would just do a simple sysout again. We would just write player, whoever is playing right now, give your next move. So yeah, that's a good way of asking the move from the current player. And now we have this row and column. Now we want to actually check the same way we want to check for the diagonal as well. So now how would we have a diagonal? The diagonal would be beginning again at row 0 and column 0, and it will keep going until every time the row and the column have the same value. So it is either 0, 0 or 1, 1 or 2, 2, right? So what we really need is 2 variables now. So we have int I equal to 0, j equal to 0, and then the condition would be I equal to j, and then we are always going to increment I and j as well. So this is going to give us the diagonal, and we are going to check every time, is ij equal to player? If so, we are going to increase the diagonal score. Again, diagonal score is something which we are going to initialize over here to be equal to 0 initially. So this is how we are actually going to win using the diagonal, and let's actually also add how we would win using the cross diagonal. Okay, so for cross diagonal, again, it's actually supposed to be, if it is 0 row, then the column has to be length minus 1. If it is 0 column, the row has to be length minus 1. So that's exactly what we want to begin with. So we are actually going to begin the row from length minus 1, and then we are going to keep reducing the row and checking if I is equal to j. So I is actually going to be board dot length minus 1. This is where I is going to begin. It's going to be the very last. So now actually this is going to make it from the bottommost row to the topmost row. So instead of going like this, let's try to actually have the last column and then keep decrementing the column instead of decrementing the row. So we'll begin with the row over here, but here it's going to be board 0 dot length minus 1. So this is how we are going to actually keep incrementing the row but decrementing the column, and every time it should decrement until if I is equal to j. So now here there is a problem. So first of all, there's this error over here. We don't want that. Another thing is that over here it's always going to check for a particular condition before breaking out of the loop. This is not the condition wherein we want to actually break out of the loop. This is the condition which we want to actually put in the if condition, that if I is equal to j, then every time if the board ij is equal to player, and then increase the score, and this should keep on happening. So there is an if within an if, but here we really need a condition, and the condition is that I should be less than the board length, and again j should be less than board 0 dot length. So here in the for loop we cannot have commas while we are checking the condition. So we need that both these conditions should be satisfied. So for that, what do we need? Both the conditions need to be satisfied, else come out of the loop. What do we need for that? We need an and, right? If I is less than board length and j is less than board 0 dot length, then you can go ahead and do things. Similarly over here, this I equal to j is not something which we want over here. This is supposed to be checked within the loop. And how do we actually check the condition of the loop? It's going to be the same as I is less than the board dot length and j is greater than 0. That's what we want, because j can get decremented every time, and we do not want it to go below 0. So it should always be greater than equal to 0. That's exactly where we want it to stop. Okay, so if I is equal to j, is this the condition which we really need over here? Because first of all, this condition is only getting satisfied for the diagonal, right? Not for the cross diagonal. So we don't need that over here. Even if it does satisfy, we don't need it over here. And the reason for that is we are already beginning from 0 and we are already incremented till board dot length. And here again, it's always going to be incremented till board 0 dot length. So every time we know that, I is equal to j, just because it is incrementing at the same time. So it starts from I equal to 0, j equal to 0, and then it keeps on incrementing until the end of the board, and we know that the situation is always going to satisfy. So we don't need that over here. Again, over here we don't need that. Over here we cannot increment the diagonal score. We have to actually increment the cross diagonal score, because that's the last thing which we want to check, right? So again, cross diagonal score equal to 0. This is what we want to use. Now here we have yellow marks just because we have not used them anywhere. So here the last thing which we want to add is for both these conditions, right? The diagonal score should also be equal to, can also be equal to 3, and the cross diagonal score can also be equal to 3. So if any of this case happens, then we are going to declare the winner. But now again, there is an issue over here, because this diagonal score and cross diagonal score, this is something which we only want to check. So basically these loops are something which we only want to check if the next move is at the diagonal or not, But really, even if we do not actually worry about that, even if, let's say, every time we are checking the diagonal and the cross diagonal, this is going to give us the correct winner, just because any move, if not made at the diagonal or cross diagonal, will not affect the score, right? It will not affect the score. If I'm not making any new move on the diagonal or the cross diagonal, then this is not going to affect the score, so we need not worry about that. So let's try that, if this is really working as we want, or is there some problem in this. So I'm going to run this. So let's try for the diagonal now. So now it's saying, player -1, give your next move. So that's good, right? So we know that, the next player is being asked. So let me just give, 0, 1. And then, from the player 1, I want to give 1, 1. And then from the player -1, I want to give 0, 1. So now here's the issue, right? So it's actually making a move where we do not want to make a move, just because, there was already a move over there. So that's something which we will deal, after we have confirmed if our game is working properly or not. So let's actually add the last move from the player 1, which would be 2, 2. Now it says the game has ended, the winner is 1, and the reason is because, the diagonal is actually complete for the player 1, so we do not worry about the winner getting selected based on the diagonal or the cross diagonal. Let's actually add this particular, issue, concern which we just saw, that, we should not make a move if the move is already made. So we should actually, give some message to the user that, this move is already made. So we are making the move over here, but instead let's check that, if this particular position has 0, then we can make the move. Else we would, want to say that the place is already marked, choose another position. So now after we say that choose another position, we should give the same player a chance, right? So we would not switch between the player, we would not print the board or anything. What we really need to do is we want to actually restart this loop back, okay? So what, what we would do is we would say continue. So when we do this, let's try to actually, try doing that. So there is some error over here, unreachable code. Oh yes, and the reason for this is every time this continue will be executed, because we do not have brackets after the else, and every time it is going to be executed, and all the remaining code now becomes unreachable. So to avoid that, the compiler is very kind to us to actually point out that we have actually done some mistake over here. And let's try to run this now, and let's try to give the first move from player 1, and now from player -1 I'm giving the same move. But now it says that the place is already marked, choose another position. So player -1, again, give your next move. So this is how, we would actually, go ahead with the game. So instead of doing all of this, I'm actually wanting to just, terminate this. So I'll press on the red button, and then, this is going to get terminated. So now we are good. I believe that, we have implemented a simple tic-tac-toe game with 2 users, and it is declaring the winner, as soon as any player wins. This is how we have implemented it. But really, do you want to show a player 1 and player -1? Why can't we just show player 1 and player 2? So that would change only when we are displaying some message to the user, right? So this particular player out here in this sysout, and the winner is player so and so in this sysout, right? So there we would just, we would want to put another value. So instead of player 1 and -1, let's actually change it to player 1 and 2. And the reason for that is always we are just checking for the particular player, right? So we need not worry about 1 and -1. We can just, put 1 and 2. So over here, the idea is that, every time we have an X, we would put 1, and every time we have a 0, we would put 2. So that's how each player would mark their X and zeros. And let's try to run this, and then, we should be having, the correct player displayed. So let's try to run this. So I'm going to put 0, 0 for the first player. Then for the second player, I'm going to put 1, 1. And then you can see over here, right, this is player 2 playing, okay? And here, in the board as well, we have player 1 and player 2 marked correctly. So that's good. Then from player 1, let's say I want to put 0 and 2. And then from player 2, I want to put 1 and 0. And then from player 1, I would want to put 1 and 2. And then from player 2, I would want to put 0 and 1. And then from player 1, I want to put 2 and 2. And that's how, the game has ended. We have the player 1 who has won the game. So yeah, I mean, this game looks pretty correct to me. The next thing which I want to show is, now once your code is working, it is actually according to what you want, how would you refactor it? So one good thing which we had done is to create another method just to print the board, because we are already, we are calling the method over here. Instead of putting this code over there, we actually created another method whose responsibility is only to print the board. So whenever we create methods, we follow a single responsibility principle, in the sense that every method should only have one single responsibility, and the name should be appropriate the way, the method is supposed to work. So this is going to print the board, and that's exactly what it does. It doesn't do anything else, right? So now, how can we actually modularize or refactor our code in, some other better ways? So we see over here, we have a loop, and this loop is actually running through this entire main method, okay? So we can't do anything about it. Within it, we are asking for the next move, we are asking for the row, we are asking for the column, and then, we are checking if we are actually wanting to make a move now. We are always checking, if the move is made or not, and then, we are making the move. So why can't I actually have a method which is going to be called make move? This is going to give the row and column of the move which we want to make, and it's actually going to pass, the current board which we have. So it's going to take the board, it's going to take the row and column, and all this thing which we are doing, it's actually going to do that within this make move. So let's try to take this if else from here, and in fact, the entire thing. But if I want to take the entire thing, as you can see over here, we are setting the winner, and this winner is going to be changed of this particular class because it is a static asset. So we need not worry about anything. Let's try to actually take this whole thing outside this particular loop and paste it over here. Once we do this, let's try to run this, if we land into any trouble or not. We do see some trouble over here. We see that we are actually continuing to some place, but we actually are not continuing over here, because the while loop is actually over here, right? It's just making the move. So instead of continue, what I can say is it's going to return 0. And this should just, display that the move was not successful. And if the move was successful, then we would simply return a 1. Now here there is some error coming just because we have not returned an integer. Instead we are returning a void. So we would return an integer over here, and then we would always check, if it is equal to 0, that means, the move was not successful. So we will check if this move is equal to 0, then we will continue. Else, we do not have to worry. The move has happened and the winner would be declared. So we need not worry about that. So now this method is actually checking whether the move is correct or not. It is telling the user that, the place is already marked, choose another position, and then, the loop will continue. If the move is done, then we are calling the print board, which is good. And then we are actually checking the winner, right? So this whole code of checking the winner can also be put in another method, which can be called as check winner. Now, every time we are checking the winner based on the board situation, right? So we are going to pass the board again to check who the winner is and whoever is, the current player. Now, how are we changing the player? We are changing the player over here. So over here, let's pass on, who the current player is. and if this particular player is the winner or not. So we are going to create this new method of check winner, and then we are actually going to put all of our code till here. We are going to actually cut it, and then we are going to paste it over here. So what this check winner is doing, it's actually taking the board and it's actually taking the player and it's going to check. So now here row and column is also something which we have to pass on. So from here we can just, take the row and column, right? So we'll just pass the row, the current column, and then we are going to add these parameters over here as well. So this is how the winner could be checked. Now the winner may change or may not change, and this else is actually left over here just because we have an if over here. We do declare that the game has ended. So what we can do is we can return a 1 from here because we already checked who the winner is and we actually got a winner. So this should return an int. But let's say if there is no winner, so we would return a 1 over here, else a 0. So again, if check winner is equal to 1, then we know that we have a winner. But if it is equal to 0, because here it's returning a 0, if there is no winner, then we would want to toggle the player. So that's what we are going to do over here. So now we have our check winner method over here, properly modularized. What do I mean by modularized? It actually means that, you are breaking your code down to smaller sections which can be reused again and again, by any other method if they want to use it. Also, it makes your program more understandable. You know that, okay, now the board is getting printed. Now the winner is being checked. And now what this code is doing, this code is toggling between the two players. So we can actually also have another method just to toggle the players, because it may be that, in another instance, we would want to actually change the player. So I will say this is going to be toggle player. And then, I'm going to pass the current player so that the player is changed now. So we will create this over here, take this entire code from here, put this code over here. And instead of player 2, now we just need a player. So this has actually changed the player to 1. And now, hopefully the player is actually changed it is static, right? So it is for this particular class. Since it is for this particular class, it is going to change and it's going to work properly. So now can you see how easy your code has become to be understandable? So you have your main. While winner is equal to 0, meaning that, the game is still on, we would tell the next player to do the next move. Then the player would input row and column, and then we would call the make move. Within the make move, we are first checking if the move is valid, so the place is valid. If yes, then we are making the move, else we are actually saying that it is marked. And then we are printing the board, checking the winner, and then toggling the player, and then, returning 1 if the move is correct. And this is how, we would have a good way of writing down this particular code. Another thing which we can also do is, while we are making a move, we can actually first check move valid. This is also a method which we can call to just check if the move is valid and then make the move. What this would do is it was just going to check if the board is equal to board row and column is equal to 0. If yes, then it should do this thing. So why we would do this? Because it just has a small thing, right? But we would still do it just because, it makes our code very, very understandable. Okay. So if check move valid equal to true, then we would want to do something. So I'll just cut this part, and this method is not defined, so I just added it, and it automatically says that it is supposed to return boolean, and that's why this would say true. Now here is where I would want to check if board row col equal to 0, then I'm going to return true, else I'm going to return false. So we don't have to actually write else. If it is returning true, then as soon as it returns something, it's actually going to end, right? So the reason that this thing has not yet executed, that means the if condition is not valid, so it will automatically return false. We don't have to write an else over here. Now we have a red mark on row and column, so we have to actually pass the row and column over here because we defined the row and column by passing this over here. So we need to pass this row and column, so we'll just do this, pass the row and column, and then add those arguments over here, intro in column. That's fine. So over here again, we don't have to actually pass the board and the player, just because the board and the player are both the instance variables, so we don't have to worry about this. We would remove the parameters from there as well. So let's see if we can make any other change to make our program better. Again, we pass the board over here. We don't need to pass the board because the board is something which is present of the particular class. So this is just going to print the board for us. Now again, we are passing the board in make move. We don't need to do that. Similarly, we would just remove this argument from here. And over here as well, while we are toggling the player, we need not pass the player. It's actually going to change the player, which is the instance variable of this particular class. So we'll remove the player from here. So we just have the main has args. We just have row and column over here, here, and that's it. So let's try to run this program if it really works properly as before. So we'll make our first move, then the player 2 will make the next move, then player 1 will make the next move, then player 2. So now let's make a move to 2, 0, and then 2, 0, 2. And now we can just put it anywhere. So this is the way we would actually, do some testing by actually changing our inputs and trying, the various ways in which we can probably catch any error, any logical issue in our program, whether it's there or not. So I would just put 1 and 2. So now we have it over here. And then I'm going to also, for the player 2, put it at 0, 1. And then, finally, we just have the last thing left. It says that, the place is already marked. So we, again, the player 2 is supposed to give the next move. So I want to give for 1 and 0. So here, and then finally, we just have one, position left. It's going to be 2 and 1. And then finally, we do have a winner over here. So yeah, I mean, we actually completed the game and then we do have a winner. But what if, sometimes the game has a draw and we never get a winner? In that case, we need to check if the entire board is completely full or not. And then, we would never be able to make any new move, right? So that's where we really need to check. If the board is full, then, the game is definitely going to be over. So there are two ways in which we can do this. One is to actually, we check the winner. We check if the board is completely full or not. Let's say we do not get a winner over here. We are in the else part. So here we can actually check whether this board is full or not. Or what we can do is we can count the number of moves, how many moves happened. If the number of moves is already, 3 by 3, which is 9, then we know that the board is full. So now, when we are actually, making the move, so we check whether the move is valid. Yes, the move is valid. Then we are making a move over here, right? So now, while we are actually making the move, we can actually increment the move count. So what we can do is, we can say that, move count plus plus. Needless to say that, we actually have to create a move count over here. So we have int move count equal to 0. And now, we really want to check how many moves happened. So this move count is actually something which relates to board also, right? So we can simply get it out, make it a static variable, how many moves happened in this particular game. So initially the move count is 0, but every time we do make a move, which is over here, our move count is going to increment. And whenever we check the winner, if the move count is 9, then do not toggle the player, just end the game. That's what I want. So if the check winner is equal to 0, then toggle player ends, else we are returning 1. So over here we can actually specify that the game also has ended. So if we have, a long program, and if we want to keep checking a particular method, what we would do is just press on Control on your keyboard, and then you can see that, you are able to click on the name of the method to go to the definition over here. So now when you see the check winner over here, you would check if the winner is the player or not. But when we are at else, we would return 0. But before that, we would just say that all moves exhausted, the game has ended, and is a draw. So none of the players won, it's just a draw. Okay, and this output should not be present, every time, right? It should not be present every time. It should only be present if the move count is equal to 3 into 3. Because that's our board, right? If it is equal to 3 into 3, then this is going to be displayed. Otherwise, we are just going to return 0. And what we really need is that now our while loop should not continue. So this make move should not be equal to 0, right? So in that case, we would return a 1. So in this case, we would return a 1. Now really, if you think that the move count is equal to 9, and it says that, all moves are exhausted, and it returns a 1. But where does it return a 1? It returns a 1 over here. And if it returns a 1 over here, it is simply going to continue the while loop. We don't want that, right? So we should return another code, and that should be equal to 2. So I just chose 2 because we would just check, if it is equal to 2, then it means that the game has ended. So instead of actually calculating again and again, we would just get a winner status, which is going to be check winner with this particular row and column. And then we will check, if the winner status is equal to 0, then we would toggle player, because now, the winner is still equal to 0. Else, if, the winner status is 2, then what would happen? Then we don't want to toggle the player. Instead, we just want to print what we were printing over here. So instead of printing this over here, let's cut this from here. Here we are just, going to return true, just because our move count has already reached at the position 9. And we are just going to print this. So now, as you can see, that we have first checked whether there is a winner or not, and then we have returned a 1. It will simply return a 1 and give you the winner. But if it does not return a 1, then what will happen? It will either return a true or a 0. If the number of moves are completed, it will return a true, or it is simply going to return a 0, right? So based on 2 and based on 0, then we are going to actually work on whether to continue the game or whether to just declare the moves are exhausted. So here again, the winner status is something which we are checking over here. But then what about make move? Make move is either returning 0 or returning 1, and it's definitely going to continue if make move is equal to 0, right? So that's not exactly what we wanted. We actually wanted to do this thing, in fact, over here. So again, we are going to return 2 over here, and similarly we would check if the move returns 0, we would continue. Else, if make move, it actually returns 2, then what? Then we would print this. So Can you see how I'm actually changing the positions where I'm wanting to print where the game has ended? And this is how logically you can keep improving your program. And instead of continuing this loop, you're just going to break this loop. That's it. You are going to break this loop at this point of time. So now this else is actually supposed to come over here. Yes. So now let's check this again. While winner is equal to 0, we are outputting the player to give in a move. When we actually try to make a move and it is equal to 0, that means the move is not valid. Then we continue. If it is not equal to 0, then we check, is it really equal to 2? Because then, the game has indeed ended, and then we would break. But if the game has not ended and it is equal to 1, then we know that we have toggled the player over here. So let's try to actually run this and check, if whatever we did not run into any issues and whatever we have wanting to achieve is achieved or not. So let me clear this console and let me run this. Again, we'll try to actually get in a particular situation in which the tic-tac-toe is a draw and not somebody winning the game. So the first move by the player, let me just put it in the first row and the second column. So this is where I want, and then for the player. So now as you can see, there is some issue. The place is already marked, it says, and it is asking for the player 2. So there is one issue which I see over here. Let's try to go ahead and see how this issue is something which we are going to tackle later on. But now I am going to put my next move by the player 2, which is going to be 0 0, and then again it gives this message. That means that there is some issue with our code. How there may be something which we did which actually caused the issue. But let's actually go ahead and try to give the next input by player 1, which is going to be 1 and 1. Then for player 2, I would give 2 and 1, and then for player 1 I want to give 1 and 2. Then for the player 2 I would give 0 and 2. Then for the player 1 I would give 2 and 2, and then for player 2 I would give 1 and 0, and then finally for the player 1 again I would give 2 and 0. So now as you can see, this game is a draw. Nobody won over here, and now it says player 1 give your next move, input the next move. And here we did not want this, right? We did not want this. We wanted this to be executed. All moves are exhausted, the game has ended, and this did not happen. That means we have to really check for both the issues, why the space is already marked is coming, and why this print is not happening over here. So let's try to look into this. I'm just terminating the program over here. We had the two problems, right? One was that the moves were not getting exhausted. Why is that so? So let's try to look into how the code is working. So let's begin from the beginning. We do have our assumptions over here. We have our board 3x3. We have the scanner, the player, the winner, which is 0. The player is defaulted to 1, and then we have a move count initialized to 0. So we are good over here. While the winner is not yet declared, meaning the winner is always 0, then we tell the next player to give the next move. And this is also one thing, right, that all the moves are exhausted, the game has ended. We really want to break this particular loop. So we would break this particular loop only when we are having make move equal to 2. Now, this keyword break is present inside an if. But remember that the break statements, they do not have any effect on if statements, okay? Break is only for the loop. So it should break if make move will result in 2, okay? So let's go to make move. Now, the make move is going to take the row and column. It's going to check if the row and column is valid or not, the move is valid or not. And the only way to check it is if board row call is equal to 0, then it would return true, else it would return false. So that looks proper to me. So if this is equal to 2, then we do the move and we increment the move count. Else, and we have this. So this should not execute. Now let's go ahead. It would print the board. It would check the winner. Now, if it checks the winner and the winner status is 2, that is where it would return a 2. So let's go to check winner, and here what we are doing is we are checking the score basically. After checking all the score, if the scores, any of the scores are 3, then the winner is the player and the game has ended and we are returning 1. Else, if the move count is equal to 3 cross 3, so instead of move count equal to 3 cross 3, if I just put it equal to 9, that's at least, something which probably might be making an issue. Let's try to check this. So I checked it, it's a draw. We still, do not have the proper output the way we wanted it. Okay, so now one issue which I see over here is we are always, calling the make move method twice. Now this is a method which is actually changing the state of our board, right? We cannot call it twice. We have to call this only once. So I'm going to cut it from here and then paste it over here. It should be called once, and here we are going to check, the move status. And this is the move status which we are going to now check, whether it is 0 or it is 2. And over here, let's just have it an int over here. And, every time we are making a move, we are, creating the move status and checking whether it is 0 or 2. And now let's try to run this again. So I'll just check, whether again it gives me the proper output for my inputs for a draw board or not. So now I checked it. I do have a board with a draw. It does not have any winner, but then it says, the game has ended and the winner is 1. So that means that there is some, logical issue which is happening in my code. So even though now we do not have that particular message, the pace is already marked, just because, we are not making a move again and again. We just made a move once and then we have a move status. So we do not have that issue, but we do have, this issue that, the game is ending and declaring the winner over here, when actually the game is a draw. So to actually check for this, why this has, entered this particular loop and, it says the game has ended, we really want to just, for debugging sake, we want to check what is the row score and what is the column score. So I'm just going to put what is the row score, and similarly, what is going to be the column score. This is a good way of debugging and finding out the parameters which may cause some error in your program. So now I'm going to print what's the diagonal score. So I want to know, where the issue is lying. And finally, I'm going to check, what's the cross diagonal score and why, we have that kind of a score every time I'm having this kind of a board, and why this player 1 is, shown to be the winner. Because this is the statement which we have over here. It is not present anywhere else. So it has to be present within the particular loop. So the winner 1 is there, in the diagonal. So we do have this particular game, the winner 1 winning. So instead of now having this print statement over here, or let's just keep the print statement, let's actually, try to, in fact, input some case in which we do not have the diagonals and the cross diagonals making any player win. So let me try to run this now. So I would put for the player 1, I would put 0 and 1. And then for player 2, I would put 0 and 0. And then for 1, I would put 1 and 1. And then for the player 2, I would put 1 and 0. And then for player 1, I would put 2 and 0. Then for player 2, I would put 2 and 1. Then for player 1, I would put 1 and 2. For the player 2, I may put 0 and 2. And then for player 1, finally, we just have this, 2 and 2 left. So now it says correctly, all the moves are exhausted, the game has ended and is a draw. So yes, now our program is working correctly. We never had the game ending and the winner being established. So this line needs to be printed, which is a great thing. So I'm just removing this. So yes, so we do have our correctly working tic-tac-toe ready by now. This is how, you would create something working functioning for the user, you would modularize it, you would refactor it, you would debug it using either the debugger or the print statements. You may also want to document it properly to say that, the player with zeros is marked as, the player 2, and the one which with the X's is marked as player 1, and the empty board would be marked as 0. So this is going to be your tic-tac-toe. You can also, look into the code and do any improvements if you feel that, any more refactoring would actually make it more readable, simpler to understand. And then all the best for your assignments.
Welcome to this week of Introduction to Java. In this week, we are going to study everything about object-oriented programming within Java. So, to recap, what we studied in last week was totally about the basic constructs of the Java language, like variables, data types, operators. We also saw some different statement types like selection statements, iterative statements, and method calling. We also saw how we could use arrays and strings as well. Now let's come out and look at Java from a bird's eye view. From a bird's eye view, Java is definitely an object-oriented programming language. Now let's look at what is object-oriented programming language and what all principles are there. Remember that this week is extremely important, because if you say that I know Java, then you will be questioned about all the object-oriented concepts and you should be well versed with them. Now, in this week, we are going to study everything about classes and objects. We are going to study what are constructors and how they are used. We are going to study the this pointer and its importance. Then we will look at what do we mean by the static keyword. You remember we use static keyword a lot, right? Especially with main. And we will also see how we can use final keyword as well. We will see then how we can give different permissions to different variables to be accessed from different places. Those are known as access modifiers, and that also really helps Java become so secure. Then we are going to see one important principle of object-oriented programming, which is inheritance, which is also called as an is a relationship, or we are going to see another principle, which is composition, which is called has a relationship. Then we're going to see what are abstract classes and what are interfaces. And then we're going to see another very nice flexibility which Java programming language provides, which is method overloading and overriding. And then we are going to look at another principle of object-oriented programming, which is polymorphism. And lastly, we will cover all the remaining aspects of object-oriented programming by making you understand that whatever I have done, how that actually is encapsulation and abstraction. So now let's begin with classes and objects. Now, what really is object-oriented programming? As I told you that earlier, programming used to be very procedural. That was known as procedural programming, in which we always focused on the procedures of the tasks which we are doing. Given any data, what procedure and what things I have to do to accomplish that task. So it was created using different functions, and each function would do certain tasks on that particular data, and the data would be freely flowing from one function to another function. There is no security in this. What object-oriented programming paradigm says is that imagine you're programming just like real life. In real life, we have different objects, right? In real life, the world is not created just using procedures. The world is actually created using real life objects. Each object would have certain properties, and each object would have certain methods of doing certain things. Why not encapsulate that? Put all of that information into a particular capsule, put all of that information in a place which would define the type of object, all the variables of that object, and all the information and all the methods which this object would use. For example, we can say a dog. We could have different, so let's consider one object in this world is, let's say, a dog. The dog would have a species, dog would have a height, a weight. The dog would have methods like moving, barking, sleeping, etc. So why not put all of that information in one capsule, and let's reuse these different capsules to make, let's say, more and more dogs, to assign all the dogs different names, and then finally be able to understand which dog is moving, which dog is barking right now, that particular dog's color is what, and that particular dog's breed is what. So that is the whole idea behind object-oriented programming. Now, object-oriented programming really helped us to actually think in the sense of objects and have a lot of security and a lot of robustness in the programming language. Also, object-oriented programming paradigm helped us in making it very, very maintainable, because not everything is exposed to public, not everything is exposed to any other software developer who would want to change or use our code and extend our code basically. So that really gives us a lot of flexibility and a lot of maintainability in terms of writing and maintaining code. For classes and objects, I'm going to create a new file, which is going to be a Java class, and that's what we are going to understand what it is. So I will name it class objects. Now here, as you can see, one class is created. Okay. Now, what class exactly is? Class is just a skeleton, a blueprint of another entity, which is its object. So you can say that class is just an idea of how things are. For example, a human being is just an idea of how a man or a woman would be. But then you and me, with our own names, are actual human beings who are living in this world, right? So human being would be a class, but you with your name is the object of that class, and you are actually the one who's actually existing, and you are called a human being with so and so name. Similarly, we would have a class, but then this class is just an idea. It is just an idea residing in the Java memory. When I create an object of this class, only then I would say that an entity exists of this particular class. So what we would say is object is an entity of the class, or you can say in a better word, an instance of the class. So object is an instance of any class. Now in this, we used to have main, right? So I'll just include main over here, and let me create another class of name vehicle. Now every class would have two things. One is variables, which we already studied, and another is methods, which again we have studied. So for example, for the class vehicle, logically, what do you think each vehicle has? Let's say the vehicle has a color, so I would say string color. Every vehicle has speed, so let me just assign that to an integer speed. So let's just keep these two things out here. Now these two things are the variables of the class vehicle, and then it could have a method. For example, move or drive. So drive can be a method, and right now let me just create it to be public and not return anything. And drive is just, let's say it's just printing that I am in motion. Okay, so now this way we can have multiple methods. For example, we can write a method called stop, which again we would put public, and this again will just say that I have stopped. Okay, now let me just rename it to start. Okay, now this is how vehicle class is, but now I just want to create an actual vehicle. Let me just create an object of this vehicle. And how would I do that? I would do that using the new keyword. We have already seen how a new keyword is used, let's say, to create a string object. Similarly, for vehicle, we can create an object. Let's say I would say vehicle car equal to new, and then I would write the class name again. And remember, the class name always begins with a capital letter, and then round brackets. Okay, now this is actually going to create the car vehicle. Now remember that your variables as well have to be shown whether they can be accessed or not. So if they are public, we would just write public, but we can also add other access specifiers or access modifiers as well, which we are going to see later on. But right now I'll just keep all of these public, and let us just try to assign car.color equal to, let's say it's a white car, and we would say, let's say car.speed equal to let's say 200 kilometers per hour. And this should not be a string because it's supposed to be integer. Okay, and let's call car.start. Okay, once I save this and when I try to run this, it says I'm in motion because we just started the car. Now let's create a special type of method which is known as a getter. Okay, now getter means that if I want to get something from here, so I could actually access it using class.color, but I could also have another method which would help me access this color. So I would say public string get color, and this will simply return color. And similarly, I could have a getter for speed, or in an easier way, we could have all the getters of all the variables in a class using the Eclipse functionality. I would just right click, I would simply go to source, and I would go to generate getters and setters. I would click on speed because that's not something which we have right now, and then I would say generate. So what it did is it actually generated a get speed method for me, which is the getter for the speed variable. And similarly, we can have setters as well. So when I right click and when I go to source, and again, we click on color, and then if I generate, you can see that since I already have the get color method, what it did is that it created a set color method for me. Since we already have the get speed, since we created getters and sisters for speed, we already had the set speed as well. So now I can simply use these getters and setters to get the speed for that. So I would just use the object name. Remember to always use the object name or the instance name. Object is also called an instance, right? So I would just use the instance name to call that method. So we would just do a dot get color, and that color would be returned to us, and we can do something with that color. So I would just print that for now. And similarly, we can get speed and print that. And when I run this, you can see why 200 and I'm in motion, just because I try to print the color, the speed, and execute the start method. And similarly, to complete this, I can execute the stop method as well, and this would simply say that I have stopped. Okay, so these are the basics of classes and objects and how we can create another class. We can have variables in this, we can have getters and setters, and we can simply call them from our main method. In fact, we can call these from another class and its methods as well. It only determines if we can access things from this class or not based on what access specifier which we have mentioned. So now everything is public, so we can access everything from another class as well. So I could actually access everything from class vehicle in my class objects just because everything was public. As you can see over here, this is class objects.java, and we just have one public class out here, which is class objects, and that's the same name as the file, but we can have multiple other classes in the same file as well. You already saw about class and that we have variables and methods in it. So variables are also called data members or data member variables, and methods are also called member functions. So this is something which can help you work with classes and objects from now. But there is one very important aspect which you should know, is that whenever any object is created, so here we try to create an object car. So what happens is that this thing is called using the new keyword. And what is this thing? This thing looks like a method, right? Because it has two round braces over here, and round braces always denote methods, right? So what is this method which is called? This method which is called to initialize this car object is known as a constructor. So to show you everything about constructors, let me create a new class called constructor. And now over here, I'm just creating my main method again. And over here, let's just create class called as, let's say, attendance, and you would have attendance in classes, right? So here, let's assume that we have our student count and we have our subject, and then probably we can add getters and sisters over here as well. So let me just have these two as public right now. So I'll select all, generate, okay. Now, let's create an object of this class attendance. So I would just write attendance, and let's assume that every time an object is created for this class, meaning we want to enter a particular class, any student wants to enter a particular class. So I would just write enter Java, because let's say the student wants to enter the Java class, and this object would be created, and then using enter Java we can assign the student count, the class name as well. Now think logically. When you actually create a new object, you are calling a particular method which you cannot see over here, but is created by Java to actually initialize this student count and class name. Now, what do we mean by initializing? Initializing an object means that memory is assigned to all its variables, right? So memory is assigned to student count and memory is assigned to class name as well. Now, once memory is assigned, you can simply assign some value to it. So I can just write enter Java dot student count equal to 1. Okay, and what I want is that every time this object is created, the student count should increment. Okay, so now the student count becomes 1. So why not have a way in which I can initialize it in a better manner? So what I want is that I want to actually redefine this constructor, not the default one which Java provides, but I want to actually write a constructor myself. I would just use the same exact name of the class, which is attendance in my case. And here we can simply assign what is the initial student count and what is the class name. So for example, the student count initially, like the first time this object is created, the student count really becomes only 1, right? So that's the thing. Now, what about the class name? I want different classes, right? So this is a default way in which, our attendance object can be initialized. So if I just do in the enter Java dot student count, and if I just try to print this, you can see that now I'm able to print the student count which is created. But I want to assign the class name as well. This means that student is entering the Java, means the class name is supposed to be Java. Well, how can I assign the class name over here? To do that, we can have attendance, and then we can pass some parameters out here. So let's say I want to pass an integer, which would essentially add to the count, and I want to pass in the class name as well. So I would just write string class name. Now over here I would say student count is equal to the count which I just passed, and class name is actually equal to the class name which I just passed. And we just save this. Now can you see this yellow line over here? The assignment to variable class name has no effect. Why? Because you're just essentially assigning the same thing to the same thing. How does it actually know that this is my instance variable which I want to assign, and this is the local variable of this method? To do that, we have a special type of pointer which is known as this pointer. We can just put this dot class name out here. What this would say is that the class name without the this pointer is actually the local argument of this method, and with the this pointer, what it means to say is that for this object and its variable class name, I want to assign this local variable over here. So when it says this dot class name, it means that the variable class name of this object. Okay. So once we do that and we save it, when we try to now create the object over here, let's say with one Java, and let's try to now print the class name as well. And this is supposed to be a string constant. So let me print this. So now it says one Java. Why? Because the student count is set correctly to 1, which we passed over here, and the class name is set correctly to Java. Let's say another student wants to enter the same class. We would simply write now the count becomes 2 and the class is Java, which the student wants to enter, and the name can be, something different, because otherwise it is giving a conflict. So when we try to run this, and we try to use the second object which is created over here instead of the first. Now let's try to print this. Let me just correct the name. So now we have 2 students and Java, which is printed over here just because I sent 2 and Java out here. So now this is how we can create a default constructor. This is known as the default constructor, meaning which does not have any parameters. And the other one is known as parameterized constructor. There's one more type of constructor which you should know, and that is known as the copy constructor. So what we essentially do is that we want to have that kind of flexibility that, I want to actually create a new attendance object, but I want to actually just copy another attendance object A and just initialize my variables from that. So I would say this dot student count from A dot student count, and I would say this dot class name from A dot class name. Now what this will help us do is, if we have a new construct, if we have an older object, and if I just want to create another object based on this old object, I can simply pass enter Java, which is the old object out here, and we would have enter Java 1 created out here. So when I save this and when we try to run this now, you will see one Java. Why? Because the older object was created using these values 1 and Java, and now when I try to create a new object just by passing the old object, then I'm getting the same values from here just because of this copy constructor. Now you may even have different versions of constructor. For example, I just want to mention the class, that's it. I don't want to actually now mention the count of students. So for that, let me just, put this dot class name equal to class name. So this will really help me to actually initialize it with just the class name as well. Now, it may be that instead of writing this, I can just want to call this particular constructor. This is known as constructor communication. So I just want to show you what is the meaning of constructor communication. I want to say that this constructor can be called by another constructor. So if instead of this, I just call this and put the class name out here. So now here, this is giving an error. The reason is that it says constructor call must be the first statement in a constructor. So that means whenever we want to call another constructor, we have to just remember that that should be the first thing we do. So first we call the other constructor to assign the class name, and then we assign the count over here. When I save this, and then when I run this, you can see now there is no issue. Why? Because while creating enter Java object, I just sent the number of student count and the class, and it called this particular constructor, and for that it first called this constructor, that is constructor communication happening over here, and it assigned the class name to this dot class name, and now here we assigned the count to student count. So this is how we have done this constructor communication. If I just use the older one instead of the new object and print that, again, we'll have the same thing. So that's not a worry for us. Now, in our place, every time we create a new object, the student count should increment, right? So before even creating any object, I just want to make sure that the student count is equal to 0. Now, if I just do something like student count equal to 0 after, let's say, all my constructors are defined. So I just want to write student count equal to 0. That's it. And I want to save this. But here it is giving me an error, and it says that, it is actually expecting something else. The reason is because whatever operations we want to do, we can either do it within the constructor or within methods, right? If I just want to do an initialization out here, we need something known as the initializer block. So I would write over here initializer block just to show you that with an open curly brace and a closed curly brace around this, now we do not have that error, and this is actually going to initialize our student count to 0. So once we do that, and whenever we create a new object, this student count will then become 1. So this is how you can use, or you can write any other initialization statements within an initializer block. The last thing you need to know is that we have a concept of anonymous objects in Java as well. So I would just show this to you. This is in the latest Java 10 version, and you may want to use this sometimes. So for example, I would just use a var keyword over here. This var is just going to show that, this is a new data, and I would just call it anonymous object, anonymous obj equal to, we would use the new keyword. And then over here, since I want to create an object, right? So what is the class from which I would make the object? So since we already defined attendance and constructors, but here we have an anonymous object and we do not want to actually assign it from a proper class which we have created, we would just use the object class of Java. And in this, with a curly open and closed brace, here we can define the various data members and methods which we want. So let's say, for example, I would just write subject equal to, and I want to use this value of, let's say, enter java dot class name over here. And this subject is going to be string, right? Because the class name is string. Let's not forget the semicolon over here. And let's just save this, and let's try to print now from this anonymous object the subject which we just assigned. So anonymous obj dot subject, and when I save this and let's just comment this out and I print this, now it says Java. So correctly, from the enter Java, the class name is assigned to the subject of this particular object, which is actually, just an anonymous object. It is not from a class which we have just defined. We just defined the class or the details over here right now, and we are able to actually have a live object with us. So here, what is happening is that with the new keyword, we do not have any blueprint or any class over here. We are directly creating an object. So this is something which you might want to use sometimes, but otherwise we are good with all the other syntax which we just studied. Now, the next thing which I want to talk to you about is the use of static. What is the static keyword? What does it mean? Why do we ever use it? All of that. So to show you that, let me create you a new class called, let's say, static. And here, I would just want to actually copy this entire class definition of attendance and paste it out over here. Now, in our main of this class, I want to make sure that every time an object is created of this attendance class, the student count increments. Now, let's consider we try to do that over here. So, as before, let's create an object of attendance, attendance Java equal to new attendance, and this would be the first one, and the class name is Java. Now, again, if you want to do this, then we would just write 2 out here, And then this is how we have to manually do it. We could also actually have created an integer count equal to 0, and then every time an object is created, we could have put count plus plus into this, and then again count plus plus over here. But now as you can see, every time I'm creating an object, I have to manually write count plus plus over here. Why not to have a mechanism in which my count of the particular class gets incremented automatically as many objects I create. So let's say the student1 enters, and here count plus plus happens, then student2 enters, and then again the count plus plus happens. This should happen automatically. So for that, what I would want to do is that I want to make the student count static. Now what is the meaning of static? Static means that this student count is common to all the objects of attendance class. So static is all the common variables or methods for all the instances or objects. So instances and objects both are the same, right? So what happens is that this student count is going to be the same for all the objects. So let's say, for example, student 1 enters. Okay, so now the student 1 sees that I'm the only person in the class. When student 2 enters, the student 2 knows that I'm the second person in the class. There are total 2 students in the class. Even student 1 can see that now total students are 2, right? That is the behavior which we want to implement using the static keyword, that all the students know who came before or who came later on what is the latest student count. That is the use of static keyword. The static keyword is used to make sure that this student count is actually associated with the class. So static is always associated with the class and not with specific objects. Now what about this class name? Class name is not static, okay? So any non-static variable is associated with each object. So now this class name is associated with each object. Okay, so let's say, for example, there is a student 3 who wants to enter but not in the Java class, in another class. So we can simply allocate the class name differently, right? Because for that student the class is different, and for student 1 and student 2 the class is different. So everything which is non-static in a class, that is associated with each instance. Okay, now let's say, for example, we create a student 3, and here we would just pass in the class, and this is going to be, let's say, data structures. Okay, for student 3 the class is data structures, but student 1 and student 2 the class is Java. Now we did not want to do this manually, right? So I would just remove this from here, and we want to make sure that every time a new object of, so right now let's consider the case of only one type of class, okay? And what I want is that every time this new object of attendance is created, I want that the student count should increment. So that is going to happen over here, because every time we just initialize using the class name, I want the student count to increment. So student count would become 1 if it is 0. So here we define that the student count is 0 in the initializer block, right? So this is going to become 1. Now remember that for static variables, even if we do not initialize it to be 0, they are always initialized to be 0. So static members are always initialized to be 0. Now, every time we create a new object, this student count is going to increment. Now let's try to print this. Remember that static variables are always associated with the class. So I could have written student1 dot student count and then print it. Now here our output is coming 1, and the reason for that is this initializer block, right? So let me just comment this out, and instead of that let's just initialize it to 0 out here, just in case this thing doesn't work. So when we try to print this, now as you can see that even though I am accessing it from student1 dot student count, and the student count initially was 0, when student1 was created, it actually got incremented over here. So it should be 1 logically, but then just because it is static, when student 2 came and student 2 actually made it to be 2, it is visible to student 1 as well. So when I try to access it using student 1, it is coming to, again, with student 2, if I try to access it, it will be the same, because it really is not associated with specific objects, it's associated with the class. And just because it is associated with the class, we don't really need to specify any object name. We can simply specify the class name over here. I would write the class dot student count, and then just print this, and again I would have what I want. So really this doesn't work specific to students. Now if you see this code, you would feel that there is some issue in this code, and even the IDE is telling you this. See, what it is saying is that the static field student count should be accessed in a static way, and here we have accessed it using this pointer. Now remember, this pointer is always associated with an instance, so we don't need this pointer over here. We can simply use student count, and since this student count and this student count is really not making any sense, so let's just change this count over here. So this is how we could use this. Again, over here as well, it's saying the same thing. Let's just remove this dot student count, and now a.student count, again, with a.student count, it is giving the same warning over here. We don't really need student count to be accessed from an instance, but just because we are passing an instance to copy, so let's just leave it as it is, because otherwise if I just remove this again, it won't make sense, student count equal to student count. So let's just use that. But the whole point is that static members are not associated with objects, so better to just call them by class. So now it really makes sense, because right now the attendance is how much? 2. So we can simply call attendance dot student count. That's it. We don't need to actually ask any student, okay, student 1, how much attendance can you see in the class, or student 2, how much attendance can you see in the class. Just by looking at the, let's say, attendance register, we can say that oh yes, attendance dot student count is 2 right now. So this is how we can keep creating a new object of the Java class, and every time the student count will increment automatically just as we create. So in fact, if I just create a student 3, let's say, entering a class without even mentioning the class name. So just because a new object is created over here, we would again try to do a plus plus out here, and then when we print that, again the student count is 3, just because we made sure that the default constructor also increments the student count every time. So this is how we use static to make sure that we have a parameter which is not explicit to a particular object or instance. It is something which is associated with each class. Now similar to variables, we can have static methods as well. So this variable student count is static. We can create another method. So let me just remove this initializer block from here, and we can create another method which is static. So let's create a public static attendance count, or let's call it get attendance count. Okay, now this method is static, meaning that this method is associated with the class. The objects are not going to get a copy of this method, it's just only available with the class. Okay, now this get attendance count will return the integer which is going to denote the attendance count of this particular class, let's say, and let's return this student count from this. Okay, so let's save this. Now instead of using attendance dot student count, we can use attendance dot get attendance count, and that's really going to give us the same thing. And now you can see that it is 3 again. But the main point of understanding the static method is that static methods can only access static variables. If I try to access class name, let's say, and I want to return class name, and let me just change the return type as well and try to run this. This is giving me an error right here, and it says clearly cannot make a static reference to a non-static field class name. Now what it says is that class name is not static, meaning that class name is associated with every object which we create. For student 1 the class name may be different, for student 2 the class name may be different, for student 3 the class name may be different. What I'm doing is that I'm creating a static method and I'm trying to access class name as if class name is associated with this attendance class instead of its objects student 1, student 2 and student 3. So it's saying that no, this is not common, this is not static. I cannot just return something from myself, because I can be called by just the class name attendance dot get attendance count, and I cannot just return a common class name because it is not common, it is not static. So really always make sure that you do not land into this trouble. Obviously your IDE is definitely going to help you in that, and just make sure that every time you are creating a static method and accessing static variables as well in this. Now main is always static just because the compiler has to make sure that the compiler can simply use the main which is associated with this class static, and that's why we also name is static.java, so that it's able to run this. So main is not dependent on any object which we create of static, and then through that object we are calling main. No, we can just call main using the static class, and then we can just call main. So that's how the compiler works, and that's why main is always static. Now remember, if main has to call some other method, since main is static, the other method also has to be static. Or so remember that every method which is calling another method has to be static. So if we just want to, instead of return student count, if we do this, we would return get student count, and I try to save this. Now it is giving me a red error, and it's saying the same thing, cannot make a static reference to a non-static method get student count. Why? Because this get student count, even though it is referring to a static variable, we have not declared this to be static. So what it is saying is that, see, I'm static, I'm associated with the class. You cannot let me call another method which is associated to various instances instead of the class. So I cannot just go and call something which is not common, which is not static. Okay, so don't do this mistake. Always let's make references to static only from a static context. So that's it about static, and you will really find good use of static keywords, good use of static variables and static methods in your Java programming journey. Now let's delve into the this pointer a little more. Now why do we even need the this pointer? Remember that in the class memory we have all our static members, right? Also all of our methods also are in a memory which is not exactly in the object. So when we create an object of this particular class, it will only have its instance variables. Now, if you are executing any method from this, the method is actually supposed to change, let's say, the instance variables. How is the method going to know which object to change the instance variable of? There may be other objects created of this class as well, right? So to understand which is the object for which this method is now binding and is now changing the instance variables, we have to use the this pointer to make sure that this is the object which has called you and this is the object for whom you are going to change the instance variables. That's why we use the this pointer. So now to show to you the use of this pointer, I have created the this.java class, and here again I just have my main, and I copied the attendance class, except that I changed its name to classroom now and remove the comment. So essentially the code is the same which we were using earlier. Now in this we already saw that we could use the this pointer to call a particular constructor. So here we are using the this pointer to call the constructor which is taking just one string argument and it's updating. And we also saw that we are using this pointer to call to signify the instance variable over here. So these are the two uses of this pointer which we saw. Now let's say if we have a method which is actually going to take an object of this particular class. So just like this constructor, we may have another method which is taking the object of this particular class and let's say returning the class name. Okay, so it will take attendance, for example, A, and it's going to return a dot class name. Okay, now the name of this method, let's say, would be get class name. So now if we want to call this particular method get class name from any other method. Let's say, for example, over here, we have this particular get class name, but this is without any arguments. And what we can do is, instead of just returning class name over here, we could actually call this particular get class name and pass on the current object which is calling this. So if the object calls the get class name, we want to pass that particular object. Now, how do we know which object is calling? Again, using the this pointer. So here we have some error. It's not that we should use attendance. It's actually that we need classroom, because I just changed the name, right? So now let's try to create a new classroom object. So classroom C equal to new classroom, and let's just pass the class name over here as well, Java. And what we want to do is C dot get class name, and that's it. Let's try to run this. And we do not get anything because we do not have a sysout over here. So let's just do a system.out.println and save this and run this. So now we have Java over here. Just because, it called the get class name out here, but then, the get class name actually called another get class name, passing the this pointer, and this is actually taking the classroom A, and then it is returning a dot class name. Now you might be thinking that, how can we have two methods of the same name? And that's something which we are going to see going ahead. Now, similar to how we have, passed this to a method, similarly, this object can be passed to a constructor as well, just like this. So here, instead of attendance, if I would have had classroom, I could easily, call this particular constructor just by passing this pointer. Also, if I want to assign another object with this new object, so let's say I just create a classroom C equal to new classroom, that's it. And what I want is that in this C1, I want to assign C. So let's say if I want a method, let's say assign to other. Essentially want is that this assigned to other should return an object which would be assigned to C1. So here again we have an error just because we do not have this method. So let's just create a method over here. This is very easy with Eclipse. As you saw, I could just click on that error and it gave me a method body public assigned to other, and it is returning the classroom object. And here this is just generating this stuff for me. I'll just delete that, and I just want to return this pointer. So what essentially this is doing is that this object C is calling this method, and this method is actually returning the entire object C for C1. So now if we just try to print out the class of C1, let's see what we have. You can see that we have C1's class name to be Java, although we did not define any class name for C1, right? Just because it returned the entire object for us. So this is how we could use this pointer. So we saw how we could, use this pointer to refer the current class instance variable. We saw how we could use this pointer which would invoke the current class constructor. This pointer would also pass an argument in the method call or in a constructor call. It could also return the current class instance from the method which we just saw right now. So that's it about this pointer. Hope you do not have any confusion with this example. The key to avoid any other confusion is to keep practicing. Whatever I'm coding, you can keep practicing along with me, and then you will be able to understand how things are working. Now let's discuss something about scope. What is the meaning of scope? Scope shows what is the lifetime and what is the area in which that variable can be accessible. Now, for example, in this class and in this main method, if I just create an integer scope test equal to 1. Now, if I want to access this scope test over here in my get student count, I want to write scope test equal to 2. Now it's giving me an error and it's saying scope test cannot be resolved to a variable. Why? Why are certain variables not able to get resolved in certain places? Just because their scope is different. Integer scope test is not over here. The scope of this integer scope test is over here. So now if I just use scope test equal to 2 over here, now it's simply assigning scope test to be 2 and without any issue. So what is this scope? And how do we know that where can certain variables be accessed? So the first thing is instance variables. So as you can see, class name is an instance variable since it's a non-static variable. Now instance variable can only be accessed within this particular class or using an object of this class. For example, we created an object C. So I can use C.className and I can, let's say, assign something else, for example, data structures. And this would not be an issue. But if I just write class name, then there would be an error because it would say that class name cannot be resolved to a variable because this is an instance variable. It has to be accessed using an instance only. Similarly, we have static variables or class variables. Now these can be accessed using the class names and not necessarily an object name, which we just saw. For example, if I would have done classroom.className, this still wouldn't work. Why? Because it says that cannot make a static reference to the non-static field classroom.className. So, but can we do classroom.studentCount? Absolutely we can, right? So this is not going to be an issue. If we assign any other integer to this, this is not giving us any error. So these are the two scopes. The next thing which you need to know is a method scope. So whatever you define inside a method, you cannot access it anywhere outside that. So let's say I create a new string demo class, okay, and I would just write that this is the demo class for Java programming. Okay, and now I want to access this demo class from, let's say, set class name. I cannot do that. Even if I try to assign something else to it, this cannot be done because this is only available within this method. It cannot be accessed anywhere else, not in any other method, not in this class, not outside this class. So all the variables which you create within a particular method are accessed only within those methods. Similarly, if you have any arguments like this classroom A, you can access this A only in this particular method. You cannot access this A, which is an argument of this method, in any other method or in this entire class as well, or in another class. So now we know in scope that there are static variables, there are instance variables, there are local variables to various methods. We know that in functional scope, the variables defined within functions, within methods are available only within that particular function. And remember that methods cannot have methods within them. So if you are coming from another background in which you have learned any other language like JavaScript, it would have functions within functions, but Java does not have methods within methods. Now let's look at one of the most important principles in object-oriented programming, which is inheritance. So to show you that, I'm going to create a new class called as inheritance. And now over here, we would have a main as usual. Now let's consider a problem in which you have a number of vehicles. So we already took an example of a vehicle class, right, earlier. So the vehicle class would have speed and color. So each vehicle would have some or the other color and it obviously has some speed, right? Now there are different types of vehicles because earlier we wrote for the vehicle start and stop. So the starting could be driving, it could be riding, it could be flying, it could be sailing. But so different vehicles can have different methods. They can have different attributes as well. So for that, let's consider that I create a class of car and a class of bike, a class of train, a class of boat, etc. And each of these would have at least the color and the speed in common, and there could be many more things. So my idea is that why can't I have all of these things in one place, let's say in vehicle, and I want to actually use all of these things of vehicle within my other classes. And remember that this entire thing which I want to do is a relationship, meaning that car is a vehicle, bike is a vehicle, train is a vehicle, and boat is a vehicle. Okay, so this is an is-a relationship, and whenever you have an is-a relationship, you would want that all these variables and all the methods of the vehicle class should be available for my other classes if I create for car, bike, train, and boat. And I should be able to have that flexibility add on to all the common things over here. Now, how do we do that? For that, we need inheritance, and we use a keyword which is extends. So let's create a class vehicle, and over here we would have string color and integer speed, and let's make both of these public. And let's add now the getters and setters as well. Now, other than this, let's not have anything else. Now let's create a new class called car. So this is class car. If I want everything of vehicle to be available for car, I will have to extend it using the extends keyword, and this will extend the vehicle class. When car is extending the vehicle class, all these things are available for the car. Now we can add other things like public string model, let's say, and then we can add a method, public void ride, because we ride a car, right? Sorry, drive. We drive a car. Okay. And then this is just going to print I am driving the car. Okay. Now let's add a getter and setter as well. Okay. Now let's just save this, and in my main method I'm creating an object of the car class. So car Mercedes equal to new car, and I want to make sure that this Mercedes car has a model of, let's say, Mercedes-Benz. Okay, this is just an example. Now, what I want is that I want to set its color and speed as well. So Mercedes dot color, let's say it is black, and Mercedes dot speed, maybe it can be 300 kilometers per hour. So this is where I set all my variables, and I want to now call the get speed method, and I just want to also call the drive method. So now when we call the drive method, it's going to print it for us. If we just, get this Mercedes speed, then, we will have to system.out. And over here, if I just want to add some information before that, driving at speed, and then with a plus operator, these two strings. So Mercedes dot get speed will return a string, and so even if it returns an integer, it will automatically be converted to a string just for system.out.println, and it's this plus sign is going to concatenate both the strings and then display that to you. So when I save this and when I print, You can see over here, I'm driving the car, driving at speed 300. So this is the thing which is helping you understand, even though we created an object of the class car, but we could actually set its color and speed, which is not present within it, right? Color and speed is not present over here. Color and speed is present in the vehicle class, but just because the vehicle class could be extended by the class car, then we have all these attributes as well in this. So we have our model, which is a part of the car class. We have color and speed, which is a part of the vehicle class. We have the drive method, which is a part of the car class, and we could get speed, which is a part of the vehicle class. So as you can see over here, I can simply reuse the things from my vehicle class in my car class or any class which we want to inherit vehicle from. So now I can create different classes, like I can create a class bike, which extends vehicle. I can just, create a new method for ride, and then, I can have class boat extends vehicle, and, I can have another method for sail. And let's say I can have a class train extends vehicle, and probably you can have methods like pull out or pull in, etc. So these are the various ideas behind using inheritance. Now you can have different types of inheritance. So right now you saw that my vehicle class was extended by the car class. So the car inherits from the vehicle. You will call vehicle to be the parent class and car to be the child class. Or vehicle is the superclass and car is the subclass. Or vehicle to be the base class and car would be the one who is extending the base class. Okay, so if you have this super and sub or parent and child, then this is known as inheritance. You could have this type of a single inheritance, but you could also have a multi-level inheritance. For example, we created a class car from the vehicle class. I could also create an entire class for Mercedes and extend the car class just to have all the attributes within the car class and within the vehicle class as well. So both the attributes, both the methods of these two classes will be available for Mercedes, and it can add its own attribute, its own methods as well. So this is known as multi-level inheritance, in which one base class is extended by another class, and then that class is extended by another class. You could also have a hierarchical inheritance, meaning just like I showed, right? The car can inherit from vehicle, even the train can inherit from vehicle, and multiple other classes can inherit from the same parent. Now, another type of inheritance is possible in other programming languages, which is known as multiple inheritance, in which a new class can inherit from multiple parent classes. But in Java, that is not allowed. In Java, you can only extend from one single class. You cannot extend from multiple classes. Now, why is that so? That is because if you extend from vehicle, let's say car and train is extending from vehicle, and then I create a new class, my transport, and I just want to extend car, train, and other classes as well, just to make sure that my transport has everything about the car, everything about the train, and all the other things. But then there would be multiple versions of the vehicle variables and methods, right? Because the vehicle variable and methods are also present in the car class. The vehicle variable and methods are also present in the train class. So all these same copies of the data is present in all these different classes, and then I'm just extending from these classes. So now how many versions would I have, and which version would the compiler use whenever I do a call for a particular method of the vehicle class or a particular variable of a vehicle class? Now that really becomes confusing. It is known as ambiguity. Ambiguity is there because it is not able to design exactly what you want. And whenever there is ambiguity, there is definitely a lot of error issues, right? So that's why Java does not allow that. There is no multiple inheritance. You cannot extend from multiple parent classes. All we have is single, multi-level, and hierarchical inheritance. Now, what about static variables? Now, in my vehicle class, I created a static variable vehicle count and initialized it to 0. And in my car class, I actually created an constructor. Whenever an object of the car class is created, then my vehicle count should increase. Now here we created a car class, right? We created an object, Mercedes. So now I just wanted to print the vehicle count from Mercedes, and as you know that we don't really need to call vehicle count from Mercedes. We can simply call the static variable from the car class. The idea is that is the static variable from the vehicle class inherited to the car class just to be called by this name. So let's try to run this. And as you can see that now the vehicle count is 1. That means I am able to access the static variables of parent class as well from the child class, and I'm able to actually use the static variable directly. I could also use a keyword to access other variables of the parent class. For example, I could just use super dot, and then this is also going to work the same way. If let's say, for example, I wanted to call get color within this. So over here, let's say in my drive method, I also want to share the color of my car is, and then I want to actually access get color, which is a method of the parent class. So if I just write get color, and let's try to run this. So now we are able to access the method of the parent class as well. So this is how we can actually access everything, all the variables and all the methods from the parent class in the child class, whether they are static, whether they are non-static. And we could also use the super keyword to access certain variables which would probably have the same name. For example, let me just create a new public int x equal to 0, and here I would just write public int x equal to 1. Now the name of this variable in the child class and the parent class is the same, right? Now if I just write that x is, and then I would just write x. Now when I run this, you will see that x is 1, because in my car class x is 1. What about if I want to access the x of the parent class instead of the child class? For that, I need to use the super keyword. Without this, it will not be resolved, because here for the child class and x for the parent class is different. So now when I save this and when I run this, as you can see over here, x is 0 now. So this is how we can differentiate between any variables which are having the same name than the one which is there with the parent, and that's where the compiler also makes the difference. If the compiler sees super dot, it understands that okay, that's the version of the parent I have to use. If we avoid super dot, then it understands that we are simply accessing the child part of the variable only. And similarly for methods, if there are any methods which are static, you will be able to extend that and simply use those static methods within your child class, and with the object or with the direct class definition, and you can simply call the static method as well. So that's how inheritance works, and that's how it gives you a lot of flexibility while working. And the magic doesn't stop here. Let's continue with other concepts which will give you so much of flexibility while working with Java, and you would simply start loving this language. A very important concept which comes very handy while working with inheritance or object-oriented programming in general is the use of access modifiers. So we really want to have some sort of an access control over the variables and methods which are present in different classes. As we wrote that everything would be public till now, but then I really want to have some flexibility in making certain things available to everybody else to access and certain things not available to everybody to access. I want certain things to be available to the child classes who are extending my class, but I don't want those things to be available for any other class who's not extending my class. So these are the different access control measures which I really want to take, just because I want to make sure that my software and my code does not get tampered by any other development effort or any other code of any other person using my class and changing my variables and their values and accessing my methods which are not supposed to be accessed. For that, we really need some sort of modifiers known as access modifiers. We already saw what is public, but then other than public, we have private, we have protected, and if I do not mention public, then something default is happening over there. So what is that default? Again, we are going to see. Now this is very similar to the access which let's say be available for different users of a particular software. So a software would have certain public things for people who are not logged in. For example, if I just go to Facebook, the home page is public, right? The home page is not only for those people who are logged in or for any other restriction. It is public. Anybody can go to facebook.com and check their homepage. But then somebody has to log in to check out the other features of Facebook. Okay, so I really need to sign up, register myself, and log in to be able to see other features of Facebook, like sending friend requests, accepting requests, posting certain things, being a part of groups, etc. These are the various things which a logged in person would have only. Now, Facebook would obviously have some sort of a dashboard for administrators of the Facebook website or of different Facebook groups. There would be a dashboard for settings and all the other things, right? So that is only available to the admins of Facebook application or the admins of those groups within Facebook. So these are the different levels of access which not everybody can access. Some things are available for public, some things are protected, and some things are like very, very private, okay? So these are the same things and same ideas which we are going to see in the Java programming language as well. Now to show this to you, let me just create a new class for access modifiers. And now over here, let me just type out my main and let's create a class A. And in this, let's just have a simple integer X, and let's create a class B which would extend A, and this would have a simple integer Y. Okay, and this is the extends keyword. Now here there are no access modifiers which I have made available, and this would be considered default. Now earlier we saw how we could use public and that would be accessed everywhere else. Let's look at how we could use private. So now this integer X is actually private to class A. Now let me just create an object of class A equal to new A, and this small a dot X is something which I want to access from my other class access modifiers through the main method, and I just want to sys that out. And let me just correct this. So now if I just try to print this, it obviously shows some error. Now what this says is that there is a language error, unresolved compilation problem. The field a.x is not visible. Okay. Now when you say a.x, this is actually capital A.x, and I actually use the object name to access that because it is anyways an instance variable, right? But I cannot just access that over here because it is private. If it would have been public, then we could simply have gone ahead and ran that and it would have just given us null because this is not initialized to anything. But then since it is private, we cannot access that from anywhere we want. Okay, let's say for example over here I create a new method. So let's say this is public void get X, and here I just want to print super.x. Okay, now I hope that if I just create instead of this, if I just create an object of class B, bb equal to new B, and from B I want to call the public method get X. Okay, and let's try to run this. Again, this says that a.x is not visible just because over here we try to access something which is private. So a private variable or a private method is not accessible using an object of the class, is not accessible even in the subclass. Okay, so where is this private variable accessible? This is only accessible in methods. So let's say for example I create getters and setters for this. Okay, and now these getters and setters are public. So if I want to try to get X now, so if I just write get X, okay, and if I try to run this, now I'm able to absolutely work well with this because get X is public and I'm calling get x in the child method, and the child class method has access to this particular method because it is public and it is returning x. Now here when we try return x, this method, since it is in the same class, x is getting returned without any issue. So even though it is private, I am able to actually create a public method which can access this private method. Now this is really very important because here I can just define a particular capsule, define a particular way in which you can actually work with my variable x just by getting its value or setting its value to a particular integer, and that's it. So for example, I do not really want anybody to set my variable as well. I'm okay that, okay, if you want to get the value of my variable, fine, take this public method to get the value, but I don't want to give you any other way to access or change the value of this particular variable, because I have made it private and I have not created any public method which can allow you to access or change this variable in the way you want. So this really gives so much of power in Java. So I can have all different sorts of private variables and just be able to give another person, another developer, another code base and access to my variable only through a particular type of interface or a particular type of method which I deem fit. Okay, so that's giving me a lot of privacy, a lot of access control on my variables. And similarly, we could have private methods as well. So I could just write private void print something, and this is going to print something, of course. But then the idea is that this will not be visible for everybody. So if I just write this is private and I try to access it, let's say using this particular object of A class or this particular object of B class, like so. So if I do b.print something, this is not going to work because here again it says the method print something from type A is not visible because it is private. So I cannot do that. Instead of this, what I can do is I can actually call that using any other public method. So I could actually have called this in this particular method, let's say, and this is not giving me any error just because this is a public method of this same class, and this method of the same class can access all the private variables and private methods of this class. But then any other method of the child class of the other class or main method cannot access the private variables. Now what about protected? Protected is something which can be accessed within this class, of course, but it can also be accessed within this child class. So here we saw that the child class could not access print something, but then the child class can access things which are protected. So let's change this to the protected access modifier. Let's try to access print something from this particular method of the child class. And as you can see over here, I'm able to save this without any error. And here this print something is getting accessed, and this is printing this is private. It's actually not private, this is actually protected now. So when we try to run this, here we have this is protected. We are able to access the protected variables and methods from the parent class in the child class, but we cannot do the same thing outside the child class. Let's try to do this. Let's try to actually call print something over here. And now let's print this. This is able to be accessed just because I can access that from the child class, but can I access that anywhere else? So let's consider I create another class C, and this is really not extending anything. This is a class in and of itself, and well, actually creating a class C over here, let's not do that. Instead I created two new packages over here, a new package, another package, and we can do that just by right clicking over here, new and Java package. We'll understand more about packages later on, but here I just created two packages. And here in my a new package, I created a class called A. And here I just copied the code which we had just in A. Now can you imagine that we already have a class A over here in one of these files in the default package, but I could also create a class A in this particular package as well. And now in the class C, which is actually there in another package, I want to actually import the class A. So I would just import a new package dot A, and that's how the import would work. And then I would create a new object of A like so. And I could do that just because my A class is public. but then now I want to access the print something over here. So let's try if this really works. And when we save this, and as you can see, there is already an error coming, the syntax error on token print something, identifier expected after this token. And the reason for that is because, we are just randomly calling this anywhere. We should rather write a main out here, and inside the main, let me just create this and now try to access get something. Sorry, what do we have? Print something. Okay. I should try to run this again. The method print something from type A is not visible just because it is protected. And what about this getX? Are we able to call this one when I run this? Yes. So I am able to call this one. It's just that it's simply returning an X and not printing anything. So that's the whole idea behind protected. You're not able to actually access beyond the package or beyond your child classes. Okay. And what about default? If I did not have anything like this, if we just have default, then this would again work similarly, that it is accessible only within your package. So even if there is a class who's not a subclass, then the class is able to access your methods and variables, but it has to be in the same package. So let's say, for example, in A, I just created a method void this is default, and this again it's just printing this is having default access specifier. Okay, and if I just try to access this from here, and if I just save this again, this red line is coming, and the reason for that is the method this is default from type A is not visible. Even though we could actually access print something, we are not able to access print this is default, just because it has a default access specifier, and default access specifier would never allow another package to access those things from the other package. So these are the different access modifiers. So to summarize, we have default, which can be accessed by the same package subclass or the same package non-subclass. But if it is in a different package, whether it is a subclass or a not subclass, it is not going to be accessed. For private, whether it is a subclass or a non-subclass, whether it is in the same package or in the different package, it cannot access private variables. The private variables can only be accessed by that particular class and its methods only. Okay, and for protected, the same package subclass can access that, but a non-subclass cannot. And similarly, different package subclass can access that and a non-subclass cannot. And for public, as usual, and anybody can access those variables and methods, which we saw quite a lot, right? A very important concept which comes very handy while working with inheritance or object-oriented programming in general is the use of access modifiers. So we really want to have some sort of an access control over the variables and methods which are present in different classes. As we wrote that everything would be public till now, but then I really want to have some flexibility in making certain things available to everybody else to access and certain things not available to everybody to access. I want certain things to be available to the child classes who are extending my class, but I don't want those things to be available for any other class who's not extending my class. So these are the different access control measures which I really want to take, just because I want to make sure that my software and my code does not get tampered by any other development effort or any other code of any other person using my class and changing my variables and their values and accessing my methods which are not supposed to be accessed. For that, we really need some sort of modifiers known as access modifiers. We already saw what is public, but then other than public, we have private, we have protected. And if I do not mention public, then something default is happening over there. So what is that default? Again, we are going to see. Now, this is very similar to the access which let's say be available for different users of a particular software. So a software would have certain public things for people who are not logged in. For example, if I just go to Facebook, the home page is public, right? The home page is not only for those people who are logged in or for any other restriction. It is public. Anybody can go to facebook.com and check their homepage. But then somebody has to log in to check out the other features of Facebook. Okay, so I really need to sign up, register myself, and log in to be able to see other features of Facebook, like sending friend requests, accepting requests, posting certain things, being a part of groups, etc. These are the various things which a logged in person would have only. Now, Facebook would obviously have some sort of a dashboard for administrators of the Facebook website or of different Facebook groups. There would be a dashboard for settings and all the other things, right? So that is only available to the admins of Facebook application or the admins of those groups within Facebook. So these are the different levels of access which not everybody can access. Some things are available for public, some things are protected, and some things are like very, very private. Okay. So these are the same things and same ideas which we are going to see in the Java programming language as well. Now to show this to you, let me just create a new class for access modifiers. And now over here, let me just type out my main and let's create a class A. And in this, let's just have a simple integer X. And let's create a class B, which would extend A. And this would have a simple integer Y. Okay. And this is the extends keyword. Now, here, there are no access modifiers which I have made available, and this would be considered default. Now, earlier, we saw how we could use public and that would be accessed everywhere else. Let's look at how we could use private. So now this integer X is actually private to class A. Now let me just create an object of class A equal to new A, and this small a dot X is something which I want to access from my other class access modifiers through the main method, and I just want to sys that out. And let me just correct this. So now if I just try to print this, it obviously shows some error. Now what this says is that there is a language error, unresolved compilation problem. The field a.x is not visible. Okay. Now when you say a.x, this is actually capital A.x, and I actually use the object name to access that, because it is anyways an instance variable, right? But I cannot just access that over here because it is private. If it would have been public, then we could simply have gone ahead and ran that, and it would have just given us null because this is not initialized to anything. But then since it is private, we cannot access that from anywhere we want. Okay. Let's say, for example, over here I create a new method. So let's say this is public void get X, and here I just want to print super.x. Okay. Now I hope that if I just create instead of this, if I just create an object of class B, bb equal to new B, and from B I want to call the public method get X. Okay. And let's try to run this. Again, this says that a.x is not visible just because over here we try to access something which is private. So a private variable or a private method is not accessible using an object of the class, is not accessible even in the subclass. Okay. So where is this private variable accessible? This is only accessible in methods. So let's say, for example, I create getters and setters for this. Okay. And now these getters and setters are public. So if I want to try to get X now, so if I just write get X, okay, and if I try to run this, now I'm able to, absolutely work well with this, because get X is public and I'm calling get X in the child method, and the child class method has access to this particular method because it is public and it is returning X. Now here when we try to return X, this method, since it is in the same class, X is getting returned without any issue. So even though it is private, I am able to actually create a public method which can access this private method. Now, this is really very important because here I can just, define a particular capsule, define a particular way in which you can actually work with my variable X just by getting its value or setting its value to a particular integer, and that's it. So for example, I do not really want anybody to set my variable as well. I'm okay that, okay, if you want to get the value of my variable, fine, take this public method to get the value, but I don't want to give you any other way to access or change the value of this particular variable, because I have made it private and I have not created any public method which can allow you to access or change this variable in the way you want. So this really gives so much of power in Java. So I can have all different sorts of private variables and just be able to give another person, another developer, another code base and access to my variable only through a particular type of interface or a particular type of method which I deem fit. Okay, so that's giving me a lot of privacy, a lot of access control on my variables. And similarly, we could have private methods as well. So I could just write private void print something, and this is going to print something, of course. But then the idea is that this will not be visible for everybody. So if I just write this is private and I try to access it, let's say using this particular object of A class or this particular object of B class, like so if I do b.print something, this is not going to work, because here again it says the method print something from type A is not visible because it is private, so I cannot do that. Instead of this, what I can do is I can actually call that using any other public method. So I could actually have called this in this particular method, let's say, and this is not giving me any error just because this is a public method of this same class, and this method of the same class can access all the private variables and private methods of this class. But then any other method of the child class, of the other class or main method cannot access the private variables. Now what about protected? Protected is something which can be accessed within this class, of course, but it can also be accessed within this child class. So here we saw that the child class could not access print something, but then the child class can access things which are protected. So let's change this to the protected access modifier. Let's try to access print something from this particular method of the child class. And as you can see over here, I'm able to save this without any error. And here this print something is getting accessed, and this is printing this is private. It's actually not private, this is actually protected now. So when we try to run this, here we have this is protected. We are able to access the protected variables and methods from the parent class in the child class, but we cannot do the same thing outside the child class. Let's try to do this. Let's try to actually call print something over here. And now let's print this. This is able to be accessed just because I can access that from the child class, but can I access that anywhere else? So let's consider I create another class C, and this is really not extending anything. This is a class in and of itself, and well, actually creating a class C over here, let's not do that. Instead, I created two new packages over here, a new package, another package, and we can do that just by right clicking over here, new and Java package. We'll understand more about packages later on, but here I just created two packages. And here in my a new package, I created a class called A. And here I just copied the code which we had just in A. Now can you imagine that we already have a class A over here in one of these files in the default package, but I could also create a class A in this particular package as well. And now in the class C, which is actually there in another package, I want to actually import the class A. So I would just import a new package dot A, and that's how the import would work. And then I would create a new object of A like so. And I could do that just because my A class is public, but then now I want to access the print something over here. So let's try if this really works. And when we save this And as you can see, there is already an error coming, the syntax error on token print something, identifier expected after this token. And the reason for that is because, we are just randomly calling this anywhere. We should rather write a main out here, and inside the main, let me just create this and now try to access get something. Sorry, what do we have? Print something. Okay. I should try to run this again. The method print something from type A is not visible just because it is protected. And what about this getX? Are we able to call this one when I run this? Yes. So I am able to call this one. It's just that it's simply returning an X and not printing anything. So that's the whole idea behind protected. You're not able to actually access beyond the package or beyond your child classes. Okay. And what about default? If I did not have anything like this, if we just have default, then this would again work similarly, that it is accessible only within your package. So even if there is a class who's not a subclass, then the class is able to access your methods and variables, but it has to be in the same package. So let's say, for example, in A, I just created a method void this is default, and this again it's just printing this is having default access specifier. Okay, and if I just try to access this from here, and if I just save this again, this red line is coming, and the reason for that is the method this is default from type A is not visible. Even though we could actually access print something, we are not able to access print this is default, just because it has a default access specifier, and default access specifier would never allow another package to access those things from the other package. So these are the different access modifiers. So to summarize, we have default, which can be accessed by the same package subclass or the same package non-subclass. But if it is in a different package, whether it is a subclass or a not subclass, it is not going to be accessed. For private, whether it is a subclass or a non-subclass, whether it is in the same package or in the different package, it cannot access private variables. The private variables can only be accessed by that particular class and its methods only. Okay, and for protected, the same package subclass can access that, but a non-subclass cannot. And similarly, different package subclass can access that and a non-subclass cannot. And for public, as usual, and anybody can access those variables and methods, which we saw quite a lot, right?
Now let's look at another very important concept in inheritance and Java, which is method overloading and method overriding. Method overloading and method overriding. So I'm creating a new class in my default package, which would be named as overloading, overriding. And you've seen actually overloading before as well. So for example, in this class, I have my main method and I create another class A. And in this, I just create a method void print, and then I would just print something. So this would say method print in A, and let's consider that I have a class B which would extend A, and in this I have another method with the same name, and this method with the same name would print method print in B. Now consider when I'm saving this is actually not giving me any errors other than the error which would say that, in this particular package, you've already declared somewhere A. So I would just write A1 and let's just resolve this over here. So this is the thing. Okay, so
Now when I save this, there is no error. So that means I am able to define for my class B1 a method of the same name as class A1, which is it is extending from. That means I can have two copies of the same name. But how is this happening? This is happening because of a concept known as overriding. So now what is happening over here is this method is overriding the parent method. Okay, now let me just create an object of A1 class. So A1A equal to new A1, and here I'm just wanting to call print from A. Now let's see what this would print. So this is printing method print in A1. Now let's create an object of B1. So we would do b.print, and then let's see what this runs. Okay, so this is actually printing this method of print. Now, can you think how I can actually call the earlier print method in this? So if you would have guessed that we can use the super keyword, then you are right. So we could use super.print, and now we will be calling the print method of the parent class instead of the child class. So I'll run this now, and now it's correctly outputting method print in A1 and then method print in B1 when I'm calling the print method over here. So this is actually helping us a lot with flexibility so that we don't have to actually remember, understand, know all the methods and all the variables of the parent class, because it may be that the parent class is having a lot of variables and a lot of methods and we don't want to actually remember everything. We can simply define our own method, and this would simply override the method of the parent class. If we really want to use the same method name from the parent class, we can use super.print. So if I just create another method as well, so this will really help me to call any methods from this particular class or the parent class. So here again, if I want to access the print class, I can simply write super.print. This print method is actually going to be the print method of the base of the parent class. So this is method overriding. Now what if I want to have another method with the same name within the same class? So here if I want another method, let's say print, but see, it's not that I always want to print this particular line, right? So it may be that I want to take an integer a and I want to print this particular integer. So I would just write that method with a parameter integer, and then I would pass this a over here. And I want to actually use this particular print method and not this print method. How will the compiler distinguish whenever I call a print method of class A1, whether it is this method or this method? Can you guess? So when I save this, when I run this, you will see that this particular version is called. But what if I actually create an integer a equal to 5 and then pass, oops, this is already defined, so I'll just pass d over here. And now if I run this, what do you think would be executed? So now this part of the print method is called, and why this version of the print method is called is because it is distinguishing it based on the parameters which I'm passing over here. So now this is known as overloading. Overloading means that you can have methods of the same name but different parameters. It may be that the parameters are different, the number of parameters are different, or it may be that the number of parameters are same. So I could have another print method with only a single parameter, but the type of the parameter would be different. So here I'm taking an integer. It may be that I would take another print method which would take a string. So let's say it has a string s, and here what I'm outputting is string method parameter, and I would just do plus s. And here if I just create a string s equal to some string and just pass s over here, then what is going to be executed? So here this method is executed, this version of the print method is executed just because I sent a string instead of an integer. So these are the ways in which we can distinguish. The print method. Now let's look at another very important concept in inheritance and Java, which is method overloading and method overriding. So I'm creating a new class in my default package, which would be named as overloading, overriding. And you've seen actually overloading before as well. So for example, in this class, I have my main method and I create another class A. And in this, I just create a method void print, and then I would just print something. So this would say method print in A, and let's consider that I have a class B which would extend A, and in this I have another method with the same name, and this method with the same name would print method print in B. Now consider when I'm saving this is actually not giving me any errors other than the error which would say that, in this particular package, you've already declared somewhere A. So I would just write A1 and let's just resolve this over here. So this is the thing. Okay, so now when I save this, there is no error. So that means I am able to define for my class B1 a method of the same name as class A1, which is it is extending from. That means I can have two copies of the same name. But how is this happening? This is happening because of a concept known as overriding. So now what is happening over here is this method is overriding the parent method. Okay, now let me just create an object of A1 class. So A1A equal to new A1, and here I'm just wanting to call print from A. Now let's see what this would print. So this is printing method print in A1. Now let's create an object of B1. So we would do b.print, and then let's see what this runs. Okay, so this is actually printing this method of print. Now, can you think how I can actually call the earlier print method in this? So if you would have guessed that we can use the super keyword, then you are right. So we could use super.print, and now we will be calling the print method of the parent class instead of the child class. So I'll run this now, and now it's correctly outputting method print in A1 and then method print in B1 when I'm calling the print method over here. So this is actually helping us a lot with flexibility so that we don't have to actually remember, understand, know all the methods and all the variables of the parent class, because it may be that the parent class is having a lot of variables and a lot of methods and we don't want to actually remember everything. We can simply define our own method, and this would simply override the method of the parent class. If we really want to use the same method name from the parent class, we can use super.print. So if I just create another method as well, so this will really help me to call any methods from this particular class or the parent class. So here again, if I want to access the print class, I can simply write super.print. This print method is actually going to be the print method of the parent class. So this is method overriding. Now what if I want to have another method within the same class? So here if I want another method, let's say print, but see, it's not that I always want to print this particular line, right? So it may be that I want to take an integer A and I want to print this particular integer. So I would just write that
method with a parameter, integer, and then I would pass this a over here. And I want to actually use this particular print method and not this print method. How will the compiler distinguish whenever I call a print method of class A1, whether it is this method or this method? Can you guess? When I run this, you will see that this particular version is called. But what if I actually create an integer a equal to 5 and then pass, oops, this is already defined, so I'll just pass d over here. And now if I run this, what do you think would be executed? So now this part of the print method is called, and why this version of the print method is called is because it is distinguishing it based on the parameters which I'm passing over here. So now this is known as overloading. Overloading means that you can have methods of the same name but different parameters. It may be that the parameters are different, the number of parameters are different, or it may be that the number of parameters are same, so I could have another print method with only a single parameter, but the type of the parameter would be different. So here I'm taking an integer. It may be that I would take another print method which would take a string. So let's say it has a string s, and here what I'm outputting is, string method parameter, and I would just do plus s. And here if I just create a string s equal to some string and just pass s over here, then what is going to be executed? So here this method is executed, this version of the print method is executed just because I sent a string instead of an integer. So these are the ways in which we can distinguish the print method. Now there's one small thing to know over here. So whenever we do method overriding, we have to make sure that the method which is overriding it cannot be more restrictive, cannot have more difficult access modifier than the other one. So for example, this is a public method of class A1, which is the parent. Now B1 is the child of class A1, and here we are wanting to change the access specifier. Let's say we could do private, or even now it is giving an error and it says that you cannot reduce the visibility of the inherited method from A1. So we have to actually make it public as well to make sure that the accessibility is not reduced. So the idea is that you cannot reduce the accessibility of the overridden method, okay? So if it is public, it has to be both public. If it is, let's say, if this one is private, then you can have this to be public. That is fine because you're not reducing the accessibility. Now in inheritance, we've already seen how we can create constructors, and those constructors are different for the parent and for the child. But when we create an object of the child, then what is the sequence of the constructors being called one after the other? Because as you know that in the child, everything from the parent resides. So from the parent, we also get the constructor, right? So let's create a constructor out here, and that is just going to print something for us. So this is going to say constructor A1, and similarly we could define a constructor for B1 as well. And this would again, just say constructor B1. Now in our main method, let's only create an object of B1. So let's try to run this. Now look at the order in which it is called. The constructor of the parent is called first, and then the constructor of the child is called, and then whatever your method of the child is called. Over here, just because we call that method explicitly. But then over here, when we actually define an object, the constructor of parent will be executed and then the child. So if there was multi-level inheritance, then the constructor of the greatest parent would be called, and then the next parent, and then the next parent, and then finally the constructor of the class would be called. This is how constructor sequence works in inheritance. Other than this, we have already seen how we can overload constructor as well. So we are talking about overloading and overriding, right? So we already saw that if we had a constructor with a parameter, let's say string s, and it would do something. Similarly, we could have another constructor just overloading the other one, and let's say this works with an integer I. And there may be another one which would simply work with two int a and int b, and this would really work to overload these other constructors just because it accepts two parameters. Now we have already seen about overriding and the final keyword as well. So if we have a final variable, then we cannot redefine it again. As we saw earlier, final pi equal to 3.14, and we cannot redefine it again to be something else. So this is going to give us an error over here. This is double, let's say, and it's going to give us error over here. It will simply say that the final local variable pi cannot be assigned. So there can be final methods as well. For example, if I make this print method to be protected final, and if I save this, you will see that there is an error coming over here, and it says that cannot override the final method from A1. So final methods cannot be overridden in the subclass. Okay, final methods cannot be overridden. So if we have to really override something, then we have to make sure that those are not final. Now remember, whenever you are creating any class, then if you do not want any method to be overridden by any other class which would extend your class, then you always have to make those things final. Okay, so you would find a lot of methods in, let's say, Java class which is already created to have a lot of final variables and a lot of final methods, just to make sure that those are not overridden and they are not really manipulated in ways that are not supposed to be done. So right now I will just comment this out to avoid the error. Finally, even a class can be final. Yes, so if I make this class A1 to be final, and if I save this, you will see there are a couple of errors coming over here. When I look at this, it says that type B1 cannot subclass the final class A1. That means if I define any class to be final, then it cannot be subclassed, or it cannot be extended. It cannot be inherited from. Okay, so make sure that if you do define a class with final, that it cannot be inherited, and if you don't want your class to be inherited by anybody, then you have to make sure that it is final. So that's the use of the final keyword. Now as I remove the final keyword, all my errors go away. So that's the use of final, which we just saw. It can be a final variable, it could be a final method which could not be overridden, or it could be a final class which cannot be extended. Now let's look at another concept of object-oriented programming, which is abstraction. Now what exactly is abstraction? Abstraction is a concept in which you just want to show to the user or make available to the user what is important for them and hide all the other details and nitty-gritties. For example, for you have a fan and you have a switch turns the fan on. Now the person who has done all the electricity work, installed the fan, installed the switch, all of that, the person knows that for you, the only thing which is important is to know that there is this switch which can be turned on to turn on the fan and which can be turned off to turn off the fan. That is it. So what the person would give you is a switch and the output, which is the fan, right? But then let's say you got some problem with the fan. Now, if you call an electrician, the electrician would open up the switch or check the fan windings, all of that, right? So all of that information that, when the switch is on, that electricity is going, it is actually, changing the electrons and protons within the windings, and that's how, the motion is generated. And all of that information is really completely irrelevant for you. What you need to know is that there is a switch and I can turn it on to turn on the fan and turn it off to turn off the fan, and there is probably a speed regulator, all of that, right? So that is the amount of abstraction which is required in programming as well. So now to have this thing, we have two methods. One is to either use an abstract class and another is to use an interface. In both of these, we really work on abstract methods. What abstract methods would give you, it's just an idea that this is the method, it takes all these arguments and it would return something like a string or void or any other data type. And that's it. That's it. There is no implementation over there. What you need to know is only that part, and that's something which is available for you. So to demonstrate that to you, let me just create a new class in my default package. And this is going to be called abstract class. Now in this, I actually want to create another class which would be an abstract class which would have abstract methods. So now to show to you, I created this example. In this abstract class, I just have a main as of now. We have a class called vehicle2 and that I made abstract just by adding the abstract keyword before that. This class becomes abstract and it has an abstract method. Okay, the abstract method would definitely have an abstract keyword with a return type, a name and any arguments which are required, and that's it. There is no curly braces allowed over here because otherwise it will not be abstract. You cannot add any body to this. This is just a definition of that. This is just an idea of that method and this becomes an abstract class. Now if we try to create an object of this class, so let's say I use the new keyword, so vehicle2 v equal to new vehicle2, and if I try to save this, this will give me error. Over here you can see that it says cannot instantiate the type vehicle2, and the reason for that is because it is an abstract class and an abstract class cannot be instantiated. Okay, abstract class cannot be instantiated. And what is the meaning of instantiated? What is an instance? An instance is an object, right? So and I cannot create an object of an abstract class. That's the meaning of instantiated. Okay, so this is not right. And why is this abstract class created in the first place? This class is created so that I can extend this and now implement all the abstract methods. Now remember, if I do not implement all the abstract methods of a class which I'm extending, then this new class would also not be able to be instantiated, because to make object you really need to have all your methods defined, because if you call that method from that object, you will not be able to call an undefined method, right? So if I want to actually define start, I would just call this other method ride in it, and this would just say riding the bike, and this method is defined and that's the call which I want to make over here. Now obviously by looking at this you can understand that it would have a lot of flexibility, right? So bike can extend a vehicle2 class. Now vehicle cannot be just a vehicle, right? It has to have a type. So always we do not want to create an object of vehicle2, okay? Because vehicle is always of a particular type. It would either be a truck, a motorbike, or it would be a car, or any other vehicle which you can think of, right? So there is no vehicle which doesn't have a type associated with it. So in that way, I want to use inheritance, but I do not want to instantiate this particular class. I want to still give an idea that each vehicle would be starting, would be stopping. You do not really need any arguments for starting or stopping or any return types. Similarly, probably, every vehicle would be giving an information about is working. So if it is working or not, so that is some information which you would want to give. So all these abstract methods you can define, and you will be able to expose these things to any other class which would extend that. But now over here, as you can see, there is an error coming on the word bike, and Eclipse is telling me the type bike must implement the inherited abstract method vehicle2.stop. So if I just implement that as well, it would still give me an error for is working, because now if you see, the type bike must implement the inherited abstract method vehicle2 is working. So until and unless I implement all these methods, I will not be able to instantiate this. And the thing is, it is seeing that it is not an abstract class, so it really has to implement all these abstract methods. So that's the thing. This is an interface to a vehicle. This is an idea about a vehicle which you really want to now implement, and that's the whole thing about abstraction, right? The abstraction is given to you. You do not know what is the implementation behind. You just know that vehicle2 or any vehicle, even bike, would start, stop, and we can check whether it is working or not. So that's the whole idea about abstraction and abstract classes. Now over here, I just removed the stop, and now I want to create an object of bike, new b, and here I just want to call b.start. Let's see what it outputs. Okay, there's some error. B cannot be resolved to a type. Oh, so this is supposed to be new bike. Okay, so now this can be instantiated. We can create an object of it. It can call the start method, and this is going to actually implement this method. This is how abstract classes work. Now, the reason why I said abstract class could give anywhere between 0 to 100% of abstraction is because not all methods need to be abstract methods within an abstract class. So I could have some methods which are implemented, but there are other methods, one or more which is not implemented, which is abstract. So at least minimum of one method has to be abstract to actually make it an abstract class. That is just an idea. Otherwise, you can just write the class to be abstract and actually implement all the methods, and still, the class would not be able to be instantiated. But the idea is that it should at least have one method which is abstract, so as to give that kind of abstraction, right, in object-oriented programming. So consider over here, we created this method write in the subclass, but even in the parent class, if I just have method write and this would just override the other one, and I still run it, it's not going to give me any issue. And I would still not be able to create an object of vehicle2 because it is an abstract class. So remember that an abstract class may or may not contain at least one method with empty implementation, and abstract classes may contain both instance as well as static variables. And the reason for all this is just to give a default implementation idea which can simply be extended to the subclass and then be implemented based on the subclass requirement. So that's it about abstract classes. Now let's look at interfaces.
Interfaces are actually very, very similar to abstract classes. So over here, I just created a class called interfaces, and in this I have defined my main. But the main thing is that I have to actually create an interface with a keyword interface, and this would denote a new interface called, let's say, vehicle, which we really wanted to have all the abstract methods only, right? Now, interface would have only abstract methods. That's the difference between abstract class and an interface. An abstract class may have abstract methods, but it may also have other methods which are having their own implementations. But interfaces cannot have implemented methods. Interfaces can only have abstract methods. So we would write void start and void stop and void is working. So all these are abstract methods, and we really don't even have to write the abstract keyword over here. This interface is assumed to have abstract methods only. So let's say if I would really want to implement something and save it, this is giving me an error. Abstract methods do not specify a body because it is really expecting an abstract method only. And again, this is already defined. So let me just save with another name. So now we cannot define the method. These are all abstract methods. Within an interface, it cannot have any implemented method. And that's why I said that interface is something which gives us 100% abstraction, because everything is just an idea. Nothing has an implementation. How would we do an implementation? We have to actually inherit from this interface and then implement all these methods. Now, how to inherit from an interface? So if I create a class bike, it has to extend from an interface, but for inheriting from an interface, we do not use extends, we use implements. And it really makes more sense because interface is giving us an abstraction. We have to actually put an implementation to that abstraction. So here we are wanting to implement this particular interface called vehicle3, and here we will now implement each of these. So now we have the option over here as well. It will simply, put all the methods which we have to implement and, just generate an auto-generated method stub. And in here we can, write whatever we want to write. So this is how we would, implement an interface.
Now, I could also create another interface, and this interface, let's say I want to actually create an interface called as car, because I really want to create other classes like Mercedes, BMW, Maruti Suzuki, any other car model, and I can simply use this particular interface of car to implement its methods. Now, this interface can actually inherit from the vehicle tree interface, and an interface inheriting an interface really needs only the extends keyword. So this would extend it because logically it is extending an interface, right? So interface car would extend the vehicle interface. I'm so sorry why I'm writing again and again this interface word. Okay, so this car would extend vehicle 3, and it would create its own methods, void drive, and it would definitely not implement that just because it is an interface and it is supposed to be implemented. Now, the good thing of interface, another good thing of interface is that with interface, we can actually have multiple inheritance, which I told you, right, that we cannot have in Java. So that was because we could not have ambiguity. Because if we have the same implementations of the same method in different classes, and then we are actually inheriting from all these classes, then which method to call when we actually call the name of the method, then there lies the ambiguity, and that's why Java does not allow multiple inheritance. But with interface, there is no implementation, right? We just have an idea, we just have an abstraction, so we can actually inherit from multiple interfaces. So for example, so let's say this interface car does not extend from vehicle 3, it is just an interface of itself, and then there is a class Mercedes which wants to implement the two interfaces car and vehicle. So we can just add a comma, and we should have a capital out here and over here as well. So this would implement a car and vehicle 3. And this really works because now this Mercedes class is supposed to be implementing everything within the car and within vehicle 3. So now we just click on add unimplemented methods, and we have all these methods. Drive is working, stop, start. So can you see how we are able to use all of this? Let's just call it car1 because it says that it's already defined. So now we have all these methods to be implemented out here. So this is how we can have multiple inheritance using interfaces. Now remember that all these methods in an interface are public because obviously they have to be implemented, right? So any class which would implement the interface, whether in the same package or in any other package, is supposed to be implementing these methods, right? So they are public by default, and obviously they are abstract by default. So this is how it works. We saw how multiple inheritance is possible using interface. A class would always extend a class would always implement an interface would always extend an interface. Now the last things which I want to tell you is from Java 8 and Java 9, we have some nice features. In an interface, we can create a method which you have to actually define to be default using the default keyword over here. And this would be a default method which would be present in an interface. Now, how could we use them? So we have this class Mercedes which is extending, which is implementing this vehicle 3 as well, right? So let's say in my start, I want to call the default method. I can do that over here, or I can, simply call the static method square off with passing any number which I want, and just use the class to call the static method, because we already studied, right? The static method can be called from the class name. So we do not have to actually have that functionality to create an object, because obviously we cannot create an object of the interface vehicle 3, right? So we would simply use the name of the vehicle 3 and call the method square off and pass the argument however we want. Now you can see that it is not giving any errors, and it is definitely going to give us the result when we try to call this using the Mercedes class. So let's try to create an object of the Mercedes class. Mercedes M equal to new Mercedes, and here we would call M dot, and we can simply call the default method which is present in the vehicle 3 interface, or we could call any other method. So let me just call the start, because start will anyways execute the default method out here. So when we run this, there is some error.
So now let's try to run this. So the error was just because of the bike class it was defined earlier. Now we have this default method being called from here when we call the start method, and that's how the default method would work. Similarly, we could call the stop method to find the square of 3, and we can just sys out over here just to see. Okay, we have to actually return as well. Now remember, with methods, when you define a return type, then you actually have to write some return statement. If you do not have anything to return, then you can simply write return 0 or return 1. So now we have the answer of 3 squared, just to show you that how we can use the static method within an interface as well. And remember, whenever you are trying to actually return 0 or 1, you should definitely try to return 0 only, because return 0 would actually signify a successful return. Lastly, in Java 9, we could also define private methods. So as I told you that it has to have public and abstract methods. We could also have default and static, but we could also define some methods to be private. For example, we could define this to be a private method, and now there is going to be an error out here. It's saying that the default method is undefined for the type Mercedes. So now let's try to get this back to default. Now remember, when I'm telling you about Java 8 and Java 9, you need to make sure that your program is running on a JDK version which is supporting more than Java 9 for all these things to work. The last concept which we have to learn in object-oriented programming, which is a very practical concept, that is composition or has a relationship. We already saw an is a relationship with inheritance. Now what is a has a relationship? For example, we saw a vehicle. So class car extends vehicle. Car is a vehicle. But within car, we could also have engine and tires and other parts, right? And those things are the ones which we can say that car has an engine, a car has tires. That kind of a relationship is composition. So how would we define that a car has an engine, etc.? We can define that using container classes, which is a class within a class. So we could have nested classes and even nested interfaces in this way. So for that, I created a new class called composition, and here again we would just write our main method. Now over here, let's create the same class vehicle, and since we are using these within our package, let me just create the name to be something else. And now another class which is car would extend this vehicle, and this would be called car 3. Now this is an is relationship because car is a vehicle. Now car would also have an engine, right? So we could create a new class called engine, and in this we could have let's say integer cc and many other things, but let's just keep it over here now. So this is actually a composition. So car has an engine, and this is how a has a relationship is created. And remember that we always give priority over composition over inheritance. So composition is much better to handle than inheritance, because we could define all the classes which are a part of this class, and we could define the other methods instead of a car extending from an engine class and then overriding the cc and other values, right? So that is not something which we try to do. We generally try to have an as a relationship always whenever it is feasible. Now similarly, we could have an interface, and this would also be having a nested entity within it. So I'll just create an interface I which would have another interface j within it, and this would have other things. So this is how we could have nested interfaces. We could have nested classes. We could have inheritance out here. And this is the beauty of object-oriented programming, by helping us understand all the relationships between different objects and how data is flowing, how data is actually accessed by various ways,
and how the access can be stopped from, any places which we do not want, and many other things. So let's now go ahead and actually discuss about, all the various glories of object-oriented programming with all the concepts which we have learned till now. Now, once we understood so many concepts and so many ways of programming in Java, let's now discuss about the main crux of object-oriented programming, the main concepts, and how these concepts are actually translated with Java concepts which we have, studied in this particular module. So we will discuss about abstraction, encapsulation. We would also discuss about polymorphism, and we have also seen so much about inheritance as well, right? And lastly, we really understood so much about message passing as well. So let's discuss about each of them one by one. Now, what about abstraction? What abstraction says is that you hide the implementation details, you only show the functionality to the user. As I gave you an example of the switch and the fan. We saw how abstraction is actually implemented using abstract classes, abstract methods, and interfaces as well. Now, if you think, what is a class? A class is just a blueprint of an object. It is just an idea of an object. It is not until we create an object do we have actually a live implementation of that class residing in the computer memory, which we can actually, set some information and retrieve some information from. So the class is just an abstract idea of an object. This is how we actually implement abstraction in Java as well. Now, coming to encapsulation. I told you when I was talking about class, what is a class? It is simply a capsule of all the variables and all the methods which are working on those variables. That is truly what is encapsulation. And especially, when we consider a special type of class which we call as Java Bean class, that is a fully encapsulated class. Now consider this class which we wrote. This class vehicle has all these variables and it only has getters and setters for the variables. That's it. This class can be called as a Java Bean class. Technically, a Java Bean class should implement the serializable interface of Java and Java I/O, but we will look at this in the next module. For now, you need to know that this type of a class which would have, a single constructor, so we could create a constructor out here, which is just the default constructor, that's it, and which would have, these variables and especially all the getters and setters for the variables. Okay, now this really is encapsulating all this information, and this really becomes a capsule of an object, and which is just giving us the ways of getting or setting the variables. And this is how encapsulation is implemented in Java. So we use getters and setters, which would make the class read only or write only. So if you just want a class to be read only, we only have getters. If you want the class to be write only, we could only have setters. Now this really gives a good data hiding possibility. Now what is data hiding? For example, I told you that certain variables have scope only within methods. Those are known as local variables of methods, right? If I try to access those variables from outside the methods, then they do not have scope. So what we are essentially doing is that in a particular method, we have all these different variables of some names, and we are hiding that from any other code which is outside that method, right? Because of this, we could have, variables of same name within different methods as well. So we could have a method A with a variable A, and we could have a method B with again a variable named A, and both of them would not clash with each other just because we have this sense of data hiding, which is hiding all those variables from outside world and actually working on those private local variables only, right? Similarly, by having the variables hidden inside the class and only allowing the outside world to be accessing those variables through some getters and setters only, that gives a good possibility of data hiding, and that's how encapsulation works. This also helps us in doing easy testing with our code, because we definitely know that the variables are not accessible outside the class. They are only accessible through only these ways. So we only need to be concerned about those methods and those testing ways. When we talk about object-oriented programming, we talk about how good it is for the design and development of softwares, right? Two of the concepts of object-oriented programming really to help us understand what a good design would be. And those are coupling and cohesion. So what is cohesion? Cohesion actually determines what a class can do. So for example, you have a class known as staff, and in that you are sending emails, you are checking their data, you are incrementing their salary, you are doing many things. Okay, that really makes the class actually do many things, many broad things, and it would have many unfocused methods. It would, maybe check things within their departments, and maybe have some methods which are totally not related to staff at all, right? So that means low cohesion. So this class has low cohesion because it has some unfocused and broad methods. We do not really know the intent of the class, etc. But some class, if that class has a higher cohesion, means that it has focused working. It would only have those variables which are related to the class. So for example, the staff would have name, salary, email ID, etc. And it would have methods working on that: get email ID, set email ID, increment salary, all of that. But all the other details like, sending emails, checking finances, anything related to other department, all of that is not really going to help this class focus on its intent. So high cohesion is something which is desirable because that really helps the class focus on what the intention of the class is. The next thing is coupling. Coupling really determines, how related or dependent two classes are towards each other. So you would have loose coupling, meaning that, the two classes are not really dependent on each other and not really related to each other. So the code is in such a way that if you change anything in one class, it will not at all affect anything in the other class. That is loose coupling, and that is something which is desirable. On the other hand, if you have really tight coupling, two classes are very dependent on each other and they are very related to each other, then, if you do make a change in one class, you would obviously have to make a lot of changes in the other class as well. That is a bad design. We do not want tight coupling. Okay, so a good software design means that classes should have high cohesion and low coupling.
The next principle of object-oriented programming is polymorphism. What is the meaning of polymorphism? Polymorphism is a Greek word. Poly means many and morph means forms. So the idea is you could have many forms of a particular thing, and that should work perfectly fine in Java. Now, one type of polymorphism is something which you have already seen. Can you remember what is that something which has the same name but can have many forms? Any guess? Function overloading. So we have method overloading, right? We have the same name of the method, and then we have different variety of arguments going within it, and that's how we achieve polymorphism over there. That is something which is static binding or early binding, which we say. Why? Because in an early part of our development life cycle, what the compiler does is that it binds that particular function call to the function definition. That is known as compile time polymorphism, and an example for that is method overloading. For this, I created a new file called polymorphism, and in this, I just created a new main, and we have a class called shape, and shape has a method called print, and this is going to simply, give some output. And then we have overloading with print taking an integer a and print taking in a string s. You've seen something like this before. Now, if I try to create an object of shape s equal to new shape, and now I try to call from s the method print. Now, as I write print, it does not give any error because here compiler knows which print to call. Now, let's say, for example, I pass in 5 and 3. Here, there is an error coming, and it says the method print integer is in the type shape is not applicable for the arguments int, meaning that it should not accept two arguments which are int and int. It should either accept one integer argument or any other. Now, think that it says the method print integer. That means it tried to bind it in the first method which it felt would be closest enough, because otherwise it would have just said, print. It would have just said the method print and nothing in it to bind it to this particular version of print. But no, it actually tried to bind it. So whatever is happening right now is happening very early on, when I'm typing it, the IDE is telling me, or the compiler would tell me, as if I try to run this. Here we will have a compile time problem, a compilation problem. And here it would say the method print integer in the type shape is not applicable for the arguments int. So even if you are not really looking into what IDE is telling you, but the compiler would give you this type of an error. This is known as early binding. The compiler tries to bind the function call to the function definition. So I'll just comment this out. Another type of polymorphism is something known as dynamic binding or late binding. This is known as runtime polymorphism. So what happens is that you compile your entire program, but while running, your Java runtime environment is trying to run your code in the best ways in which you might have specified that, but that is not something which would be binded beforehand, okay? And that is something which we have seen using the concept of method overriding. That is also known as dynamic method dispatch. All these words are extremely important in the object-oriented programming terminologies. Hence, you should always remember what is the meaning of these words. Dynamic method dispatch is method overriding, meaning binding those method definitions to whether it is being called of the parent version or the child version. And that is happening dynamically on the runtime. That's why it's known as dynamic method dispatch. So here, we have our class circle, which is extending shape, and circle is a child of the shape class, and we have a constructor over here. So this is constructor of circle, and here we have the method print again, which is overriding the print method of the parent class. This is the method print of circle, and then we might probably have another method. So now here, if I call print method using the circle object, it would call this particular version of print. So let me create an object of circle, circle C equal to new circle, and this is going to be C dot print, and let's see what it says. So first the constructor is called, and then you have a method print in circle. So let me just comment out the constructor for now. Now we see that we have method print in circle executed over here. Now one way we can really gain a lot of good benefit of polymorphism if we could actually create an object of a parent using the constructor of the child class. So here I would do shape S equal to new circle, and I would save this and just rename this particular object since we already have S over here. Now as you can see, there is no error coming, and if I just run this, this is running without any errors. Now if we try to run the print command, let's say from this object S1, so if we do S1.print and then I save this, let's just comment this earlier part out and let's run this. So now this would say method print in circle. So can you imagine that this is actually an object of the parent class, but it is initialized using the child class, and that's why it is returning the print method of the child class instead of the parent class. This is a dynamic binding or runtime polymorphism. So now this process of actually casting a child's object to the parent is known as upcasting. So I will just write over here upcasting. So what is happening is over here is that this actually is creating a child object, but you have assigned it to the parent, and now from the parent's object name you are able to call everything of the child just because you could assign the child to the parent. This is known as upcasting. Now you might be thinking this is a pretty complex thing. Why would we even need something of that sort? So let's just consider an example that there is shape checker, let's say, and this shape checker would take in some shape and it would check the shape and do something with it. Okay, and now once this shape checker works, the shape checker would return something, all of that. Okay, so now if we have this type of a method, then what we want really is to be able to pass any object. So let's say you have a circle out here, but then you may even have a rectangle, let's say, and this would also extend shape, and this would also have, let's say, a print method, okay, public void print, and this would say the same thing. method print in rectangle. Now let's say you had this particular method. So let me just uncomment this and comment out this part, and we do a public void shape checker, which is taking a shape, this one. And now this is giving some error because we are inside a main, and I said that there cannot be a method within a method, so we'll just put that outside. Now this is the shape checker, which is taking the shape and doing something with it. Now what we want to do is we want to call this shape checker using any particular object. So let's say we have this object C, and we want to pass this C in our shape checker. So we'll call this method from our main, and we want to pass C. So this has to be static just because we are calling it from static main. This is something which we already saw when we were discussing about static. And now as you can see, the shape checker gives no error even though a proper object of circle is passed to it. And the reason for that is because of this runtime polymorphism coming over here. So now for example, if we just do shape.print and let's try to run this. I'll just comment out this part and run this again. So now you can see that the print version of circle is called. What if we have a rectangle r equal to new rectangle? This is creating a new object of rectangle. Let's pass r over here. And let's try to run this now. Now as you can see, the print method of rectangle is called instead of circle. So can you see how flexible Java is? Even though we have any type of shape, we have a rectangle, we have circle, or we have any child class, but this particular method does not take each of them. In fact, it just takes the parent class and then it does some things based on whatever object you are passing. So now you have all the flexibility to pass different child class objects as parent class, and then you are able to call those methods of the parent class, and then you will be good to go. You will have everything of that child class itself just because of this runtime polymorphism. Now remember how this runtime polymorphism works. The child is actually upcasted to parent. Now if you really want to not have anything of the parent and just call something of the child specifically, for example, this another method is present in the child class. So even though I just put this another m over here and pass in the circle object and save this, still here it is going to give me an error that the method another m is undefined for the type shape. So remember that when we are actually upcasting, we are only going to use everything of the parent so that we could have this kind of flexibility which I just showed to you. So this is how upcasting would work. Now there is another thing known as downcasting. So now what is downcasting? If you kind of logically understand what it is, upcasting is actually we are casting the child object to the parent. Downcasting would be to have a parent object casted to child. So you would have something like this. You have a circle which let's say is called not circle, and this is S1. So S1 is actually shape, right? But then it is initialized with the object of circle. So now what you could do is you could simply cast that using these round brackets of circle and then put that in another object of circle, and this will definitely work as you would expect. So let's say this is not circle.print, and let's just comment this part out, and when I run this is going to print the one of circle itself. So there's no issue in downcasting as well. But remember that this type of upcasting is actually done implicitly. So implicitly your child object is casted to the parent. Downcasting, you have to do it explicitly. You actually have to put the round brackets and put that this should actually be casted to circle and going back. Now remember that if S1 was not defined like this using the child class constructor, then this would not work. So if you just have shape S equal to new shape and then you want to downcast it to the child object, and if we try to run this, here there is going to be an exception. What it would say is that class shape cannot be cast to class circle. Shape and circle are in unnamed module of loader app. So what it says is that your shape class object cannot be cast to circle. If only it would have been, initialized using circle, if it was actually a circle object only, then you could have casted it, So this is how downcasting works. You define it in this way to get this kind of a flexibility, but now you really want to work with the circle object. And why is this so? Again, this is something a little complex, but then why do we have this type of a flexibility in Java? And the reason for that is, let's say you have a shape S2, and this is being returned from some method which returns specific shape. And now I just created this particular name just to show you the intent of what this method would do, but obviously this is not at all a nice way to name a method. So now this is some method which returns a specific shape. Now you don't know which shape is this. We don't know what it is returning or what shape it is returning. So we don't know that. We just know that it's returning some shape. Why not just, upcast it to shape, object, and then put that as S2. And then finally, let's say if it was a circle or if it was a rectangle, then we want to do something, right? So now what we would really want to do is we want to check if S2 is instance of circle, then we want to do this. Okay. Then we want to actually downcast S2 to circle and then do whatever we want with a circle. Okay. So this is going to be our if block. Or if S2 is going to be a rectangle, then again, what we would want to do is we would want to downcast it to rectangle. So now I would just write it to be R1. This not circle is actually giving confusion. So this would be C2. Okay. So now this would be rectangle. Cast it for S2, and then we would just, do R1, let's say dot print. This is all we want to do. So now this is how we would use downcasting. This would be the reason why would we use downcasting. If we have, something returning a particular shape, we would just, put that in parent and then, check if it is an instance of circle. If it is an instance of any particular child, then downcast it to that child and then start using that child object. Okay. Why would we do this S2 instance of circle? Let's say if it was not an instance of circle, let's say it was actually an instance of a rectangle, let's say. So this would give you an error. This part would give you an error. What error? This same error. Class so-and-so cannot be cast to class circle. If you try to do this. Or if you tried to do this, if it was circle or if it was just, the parent shape, then again, this error would come that, class so-and-so cannot be cast to class rectangle. So this is how your upcasting and downcasting and polymorphism works in Java. Now, as you can see, it's a little complex, but it gives you so much of flexibility, and that's why Java language is so flexible and very nice to use, very nice to implement complex algorithms, complex ideas into code. So to make things easy, upcasting would mean that you have a parent A object name and equal to new child. So this is actually creating an object of a child, assigning it to a parent, and then let's say you work on that particular object. And downcasting would mean that you create an object of child and then taking an object of the parent, you're downcasting it by explicitly, putting the type to be child. Now A obviously has to be defined in this way, otherwise there would be an error. So also explain to you in what conditions you would want to use polymorphism in this manner. So that's it about polymorphism. Let's look at the last topic in our discussion of object-oriented programming in the next video. The last topic which we are going to study in this particular module of object-oriented programming is to understand association between different classes. Now, we already understood, association in terms of is a relationship using inheritance. We also understood has a relationship using composition. So, composition is actually the tightest association. Okay, one class within another class. That is what composition is, right? That is the tightest association. But we also have another type of association which is known as aggregation. And really aggregation allows us to reuse code or reuse those classes which we would have actually created inside another class if we were using composition. But aggregation allows us to not have one class within another class, but two different classes can be having an association using aggregation, and so that we can use that class which we would have defined inside one class. So here, if you look at the composition file, I just made a few changes. So here we have a class called as monument, and then from this monument class, we are inheriting the class building. So building is a type of monument, right? So that's why we are having the inheritance association over here. But then a building has a room, okay? And each room would have an area. So that's how we would have composition over here, okay? So now remember that a room cannot exist without a building. So it's not that there is a room, but there is actually no building in which this room is there. Obviously, it's not possible. You need to have some structure, a house, a building, or anything to have a room within it, right? So here we would definitely use composition. But then what if we had another way of association? So I just created another file for you, which I would call aggregation.java. And here we again, have a simple main. But now what I want to show you is that if we would use composition, so let's say we created a class department, and within the department, we have a number of students, right? So I could have created this class student within this particular class of department, and this would be a composition of department and students. But then, so that I could use this particular class for other things as well, because it's not that students are always a part of department. It may be that we want to work with students separately as well, okay? So now instead of actually having student within department, I can have a student outside my department and then have a list of students or an array of students within my particular department, okay? This association in which we actually have a list or an array of the other class within our particular class, this is known as aggregation, and this really allows us to reuse the code of this class student in another way in any other class as well. This is not as tight as composition, but this is something which we really want to use. So aggregation is something which we really want to use instead of composition. So this aggregation is also has a relationship, because department has different students. And also a student should also have a pointer to this department which they are associated with. So they could have a department D, so each student could only be, let's say, mapped to one particular department. So can you understand how we are using association over here? So association can be one-to-one, it can be one-to-many, it can be many-to-one, or it can be many-to-many. So for example, this is actually a many-to-one relationship, because many students can be in a particular department. So each student has one department and every department can have many students. So this is again, student and department, this is many-to-one. But you could also have, let's say you could have, to extend this particular aggregation, you could have, let's say, an institute, and an institute would have multiple departments. So you could have a list of department or an array of department. So let's say I'm creating an array of departments. Okay, so this is how aggregation would work over here. So again, one institute, many departments. So this is also going to be a one-to-many relationship. So that's about everything in object-oriented programming. I hope you got a good base in object-oriented programming principles. Let's discuss some best practices which we need to follow in the industry. So a famous author has said, just as it is a good practice to make all fields private unless they need greater visibility, it is a good practice to make all fields final unless they need to be mutable. So remember that if you want to give visibility to a variable, only then make it non-private, otherwise always have them private. Also, if you want to change them in future, only then make them not to be final, but otherwise make all the fields to be final. And then another author wrote a very nice quote, which is, a long descriptive name is better than a short enigmatic name. A long descriptive name is better than a long descriptive comment. Meaning that you should name your variables very, very sensibly. Also, the ratio of time spent reading code versus writing is more than 10:1. So make it easy to read. And that's how it would make it easy to write. So remember that whenever you are writing any code, it should be readable. It should not be so complex that, the other person is not able to read it, or you have to actually add a lot of comments and all of that. So remember to name your variables properly so that it is very easy to understand what your variable is doing, and to be able to write your code in a very readable fashion that the other person is able to read properly and be able to understand what is your intent of doing what you are doing. So in summary, we learned everything about object-oriented programming. We learned encapsulation, abstraction, we learned constructors, the this pointer, we learned what is inheritance, we learned what is method overloading and method overriding. We also learned about what are the various access specifiers or access modifiers, private, public, protected, and default. We also studied about abstract classes and interfaces, and then we studied about what is composition, what is aggregation, and what is polymorphism. Now, go ahead and do a lot of practice with these principles and make sure that whenever you are creating any code, to follow these principles, make them actually object-oriented, make them actually modular, make different classes based on different intentions, and have relationships between them, have their variables and have their methods perfectly aligning, and use all these various object-oriented principles for your benefit and to get good marks in your assignments. So all the best for your assignments. Welcome to the part B of week 2 of Introduction to Java. In this session, we are going to practice everything about object-oriented programming which we learned this far. So this time, we are going to actually create a proper project with, multiple classes, creating multiple objects, having the methods interact with each other, having the classes interact with each other, and thereby coming up with an object-oriented solution for a particular problem. So the problem which we are going to work on right now is on an e-commerce website project. So an e-commerce website would require a Java project, to be able to do tasks for them. So for example, probably after viewing the products, a user might want to actually put the product in the cart and then, go through the entire checkout process. The seller might be wanting to insert a new product and so many things. An administrator would want to add a particular product to various categories. So how to do all these things is something which we are going to see right now. So in Eclipse, we can actually create a new folder. We will be creating a new Java project, and I would just call this e-commerce, and I will click on finish, and we would create a module. So here we do have a particular module and we have this e-commerce, but actually we don't have to worry about this module, I'll just delete this module info.java and let's create a new class, and we would just call it home, or we would call it store. So this is our e-commerce store, where everything would lie, and I would just create a main over here, and let's just do a sysout. Welcome to the e-commerce store. And that's it. Let's try to run this project. So now how do we run this? We would run it as a Java application, and this would say, welcome to the e-commerce store. So now this is the way we would create any particular project. But, obviously what does your project do? It just prints a line. That's not a very impressive thing, right? So we're supposed to actually create an actual e-commerce store. So let's think about this. We can actually have an e-commerce store ask, which type of user are you? And you could be a customer, or you could be a seller, or you could be an administrator. So now you have a user, and a user can be a customer. The user can also be a seller or an administrator. Now let's say if the user selects customer. So the customer would be having a number of options, right? For example, view products, view cart, or contact us. And the seller might have options like view your products, just to check, which products the seller has uploaded, or add a product, or contact us. Now, after a customer chooses, view products, then the customer is probably given option to add the product to the cart. And then, if the customer, let's say, chooses to view cart, then the option which is given to the customer is to check out. Similarly, for the seller, if the seller chooses to view your products, then the seller can be given an option to delete this product. And similarly, if the seller chooses to add a product, then the seller is actually given the option to submit details of the product. If it is an administrator, then the administrator might have certain other options, but we are not going to talk about this right now. Let's look for the customer and for the seller, how we could actually implement these things. Now, how many objects can you imagine in e-commerce domain? We obviously do have, other than customers and sellers who are users, we do have products, right? We could have, a lot of details of the products. So now each product would also have categories. So we would have categories of products. And then, as you know, that, the customer can add products to the cart. So we also have a cart object. So we have a cart object, we have category object, we have product object, we have user, we have seller, we have customer. All these nouns which you can see, these are all objects which you can create. And lastly, you could also have an object of order, which would actually have the entire order of a particular customer. So this is the way you could actually, think about an e-commerce software design. So now over here, we just have, a sysout to welcome you to the e-commerce store. The next thing, which is something which we want to do, is which user are you? And then, give them option of customer, and then you have seller and admin. So now we really want to take, some input from the user. So we would just, use again the scanner object with system.in. And then from this, we would want to actually get the next int from the user. And after this, we are going to put that in the choice. So there's going to be a choice of the user. And now what are we going to do with the choice? So now if choice is equal to 1, then the user is actually a customer, right? So we have to create type of user, and this is going to be customer. And that's it, Similarly, you could have the seller and the admin. So it is 2 and 3, then it is seller, or it's going to be admin. Alright, so we do have the type of user over here, else. So we could put else if in all places, and then finally else, it's not a valid type of customer. So you would just do a sysout invalid input, and then we'll write try again. And then, we could keep doing this thing until we do have a type of user. Now, when we talk about the different types of users, for that, don't you think that we should have a class specifically of user? So, and now each user is actually going to be a customer or a seller or an administrator. We can have more different types of users going ahead. So we should never be able to actually create an object of a user, but we should only be able to create an object of either a customer or a seller or an administrator, because we do not want an abstract user, right? We just want a pretty concrete person to use our e-commerce website. So instead of a class, we would create an interface known as user. And in this, now what does a user generally have? A user would definitely have a user ID. So we would write it as user ID. The user could also have password. So that's what we are going to write. And let's just keep it at this. So now over here, we do not have any attribute to user ID and password. And now when we go to source, if we try to generate getters and setters, it says it is not applicable to interfaces. Now that's important, because here we want to only have those methods which are not implemented, right? We need abstract methods. So over here, we could actually create abstract methods for user ID or password. We could also create things like what is the login status? Is the user currently logged in or not? And we could have an abstract method which would, verify user. So this could be a method which would, verify the user based on the user ID and password, and then, return a Boolean which is going to be, successful verification or not. So this is how we would have a method in this particular user interface. Now let's create our multiple users over here. Let's create our customer class, Now this customer class is actually going to extend or implement, in fact, the interface which we just created. So we would implement user. So this would implement the user. And now we have, it says the type customer must implement the inherited abstract method user.verifyUser. So now we will add the unimplemented method. So now, for example, over here, I would just, return true. Always, I'm verifying the user. This is what I will do. But obviously, in a real world project, you would obviously want to verify the user based on the database which you have of the users, right? So right now, it, adds an override annotation above this to just to show that, this is overridden from the inheritance, from the implemented interface which we have. So now we are going to verify our user. And now over here, you can actually, also try to add the cart associated, with the user. So I would just create an object of cart. So we would just write cart, and then, we will try to use the cart of this particular user, but then, cart is not yet created. So we would create a new class cart. So now this class is created, but we would actually work on this a little bit later. For now, we just have a new cart of this particular customer. Now in this cart, there is supposed to be a list of products, right? So we would create an array of products. So there would be product, and then, let's just call it list of products. And that's it, a cart has a list of products. Now, again, it says that, this product class is not yet created. So we would create this particular class of product. Now, each product would definitely have a product ID, right? So we would have string product ID, and then, every product would also have a cost associated with it, right? So we would have string cost. And then, what's the name of the product? We would have, product name. That's it. Let's keep it simple right now. Over here, I'll also generate the getters and setters. So let's go to source and generate the getters and setters for this particular product. So now we have all our methods and, instance variables available with us. We do have a list of products in our cart as well, and each customer has a one cart. So this is how the relationship between different classes are possible. Now we also have multiple more users, right? We also have a seller and an admin. So let's create a seller class. The seller would again implement the user interface, and then, we would add the unimplemented method over here. We would, automatically just verify this particular seller again as we did for the customer. Now each seller has a list of products of his own, right? His or her own. So we would have a list of products similarly which we have for the cart. So let's copy this and paste it over here. So list of or we would just say products listed, because the seller is actually going to list products in the e-commerce website, right? So the naming has to be correct and nice so that it's understandable. So we have a list of products. Even for the list of products, we could add a getter and setter. So this is how it's going to get the list of products and set the list of products. Similarly, we could do the same over here in cart. We could have a getter and setter for the list of products. And really, this is so important to have, the getters and setters and make this particular product to be private, so that, nobody else is able to actually work on this particular list of products without, being able to just get and set. That's it. We just provide that interface. And this is a very good abstraction way in which we just give the user that, you can get the list of products and you can set the list of products, but you cannot do anything else with the list of products over here. And this is the, beauty of Java, how, abstraction is given to the user, and this whole concept of encapsulation happens over here. Similarly, we would make these attributes private. Now this is the thing, right? It's always the thumb rule. If you don't have any specific reason of making it public, then you always should keep things private. If you don't have any specific reason of modifying a particular thing, then always make it constant or final. So that's what we follow, in industry as well. Let's make this cart private as well. We may even change things if we feel so, but for now, let's keep these things private and then, just generate a getter and setter based on what we would want to use. So the thing which is left is category and order. So let's create a new class for category. Now this is going to have the category name, and it may also have a list of subcategories. So now really, what is a subcategory? Subcategory would also be a category in and of itself, right? So it actually is having its own self within it. So we have an array of categories, which we would call subcategories. So it may be null initially, there may be nothing, in this, or there may be a number of subcategories for a particular category. So we would want to again, generate getters and setters for this. Now, if you want to change the formatting of any particular code, you can just press Ctrl, Shift and F, and then, you would have it in a better format, and it looks better and more understandable. And the last thing which we want to add is an order, because a user can create an order. So we would have an order class, which would have an order ID. So this would be order ID, and we would definitely have, the order ordered by a particular user, right? So we would really want the user ID of the person whose order this particular order is, right? So now again, we'll just generate the getters and setters and make these private. And we'll make this category name and subcategories private as well. Let me just correct my spellings. And now, as you can see that, as soon as I try to correct the spelling, the other places started giving error. So we will correct the error over here. Let's also correct the spellings over here. Now, regarding this order, when we actually have this associated with a particular user, instead of actually adding the user ID, we should be adding a user in and of itself, So every order is associated with a particular user. Now the user can be a customer and the user can be a seller. The order can also be associated with any type of user, right? That order can be of a customer, or an order can be associated with a seller. So now there are two people who are associated with this order, but then there can be multiple sellers for different products, right? So right now, for this order class, we would only have a customer associated with this. So instead of user ID, I would just have the customer, in fact, working as the user for us. So now these getters and setters don't value. Now we actually have to create a getter and setter for the user, in fact. So now for this particular user, this order is valid. Similarly, every product is associated with a particular seller, right? So can there be a product without a seller? So we can actually add the seller who is selling the product. So now obviously a particular type of product can be sold by multiple sellers, but then the product ID would be different for those products, right? For this particular product ID, who is the seller? That is somebody which we can add, the person who is selling this particular product, that seller is the one who's associated with this particular product. So let's actually add for this as well the getter and setter. And let's change the formatting. So it looks good. Now we have product ID, the cost of the product, the name of the product, and the seller who's associated with the product. So this is how we would have associations between different classes, and a class associating with itself. And we would have inheritance using interface, so that we can actually extend more type of users instead of simply have everything in one class and then keep modifying the class. There is a very important principle: open for extension and closed for modification, and that is something which we actually implement using this. Now let's get back to our program. Here, as soon as we understand that the type of user is customer, we would want to actually create a new customer object over here, right? So if the choice is equal to 1, then we would create customer current equal to new customer, and we would want to set the user ID of the customer. So we would now ask the user ID of the user. What is your user ID? And so we would ask the user ID, and we would, again take the next line from the user, which is going to be a string, and that's what we are going to add to current dot set user ID. So we would do current dot set. So now we do not have any setter for user ID. So to actually work on this, we actually have to create a setter for user ID. So now if we go to product, you see that, there is this get product ID and set product ID. We can actually simply take this type of code and use it within our customer to actually get the user ID and set the user ID. So now this is something which we can do. So now over here we have an error on user ID, and it says that the final field user.user ID cannot be assigned. And the reason for that is because, we have an interface, and everything in the interface is going to be public, static, and final. So instead of actually having an interface, let's just have a class of user, and we will be implementing this class of user by using the extends keyword, in fact, because that's what we are going to actually be using. So we would have this to be again a public class, but we really do not want to actually use it for instantiation, but we can actually use it to gain benefits of polymorphism while we are actually working on any particular problem. So now over here it says that, instead, why don't you just make this method to be abstract. So I would just write it abstract boolean verify user. We have a public class user, and this would make it abstract, which is great because we cannot instantiate it then. Now instead of implementing, we would do an extends of user, and similarly for the seller we would do extends. Now in customer over here, even if we did not have these getters and setters, again, we can just go to source and generate the getters and setters. Or let's try to do this over here. So we do have our user, customer, and seller ready for us to work on. So now we can actually set for the current user the user ID, which we are going to get from sc.nextLine. That's how we are going to set it. Then we are going to ask the user for the password. And then, similarly, we could set the current user's password over here as well. And we would not use the user ID, we would set the password over here. So now we have to actually verify this based on this user ID and password, right? So now I would call the verify user, but verify user is something which is not implemented over here properly. It's just, we are always verifying that the user and password is correct, and we can just go away with that for now in this particular example. So now we always have the user verified. So if the verify user is equal to true, then we are going to just say that user verified, and after this we would ask the user, what do you want to do? So now we will ask that do you want to view products, or what, view cart or contact us, right? Do you want to 1 view products, 2 view cart, or 3 contact us? So now obviously the person is going to give some input, so we are going to actually read the next int, and this is going to be really again a matter of choice. What is the choice of the particular user? So we are going to put choice equal to sc.nextInt. If the choice is going to be 1, then we want to display the products to the user, right? So now we want to actually show the catalog of products, but now we do not have a catalog class. We just have a product class, right? We need a catalog class. So let's create a class known as catalog, And really, an e-commerce website or everything is pretty complex, but for now I just want to show you how easily and quickly and with a small example we can actually build a real world type of project. So this catalog is actually going to have multiple products. So again, we have a list of products. So an array of products is something which I'm going to create. So this is going to be list of all products, and really I'm just going to list every product which is present in this particular e-commerce website. So I'm just going to create getters and setters for this, and the list is actually private. So I'm just going to get the list of products from this catalog, and I'm going to display that to the user. So let's go back to the store. If choice is equal to 1, I want to create a new object of catalog. So I'm just going to create catalog is equal to new catalog, and I'm going to just get the products list from there, guest list of products, and I'm just actually going to print all the products. So when we actually get the list of products, let's have the array of products over here. So I'll just call it all products, and we have all the list of products over here. This is called product. And now what do we do with all these products? We want to display them, right? So we can actually sys out everything. So I want to actually iterate through this entire array, right? So what I'll do is, for int I equal to 0, I less than all products dot length and I plus plus. So this is we are actually iterating through all of the products, and then I want to do something with each of those, right? So for the index I, what I want to do is I want to actually get the product name and show the product name to the user. So I would just do a sys out and put this particular product's name out to the user. And in fact, I actually want to also show the product ID as well. So before this, so let's put a space between them, and I want to actually get the product ID as well. So I want to show the product ID, I want to show the product name. What else do we have? We have the cost as well, right? We don't need to show the seller to the user, right, for now. So I'll just add the cost of the product as well. So we'll get the cost, and that's what I want to show to the user. So for every product, we want to show the product ID, the product name, and the cost. And then we want to ask, do you want to add any product to the cart? Do you want to add any product to the cart? And then we can just write Y or N. So, and then you just take the next line from the user, or we could actually take the next character or something. So we'll just take the next line and put that inside string add to cart. So now if add to cart is yes, then we want to do something, right? We want to add that particular product ID to cart. So now we would just ask similarly, what is the product ID, or input the product ID of the product which you want to add. Okay, and then we are again going to wait for the product ID. So we are going to just take the next line from the user, and then put that in the product ID. So let's have the product ID over here. So this is the product ID which we have taken, and then we would want to check from all these products, which product has this particular product ID, and we want to add that to the cart. So first we will create an object of cart over here. And for this particular cart, every cart is associated with a user. So here in the user, we only have user ID, password, and login status. In the customer, we do have the cart. So we didn't have to actually create a cart over here. We actually should be using the cart of the particular customer, right? So here we already have this current customer, right? So in this current customer, we can set the cart with a new cart which we create. So the same cart, I can actually create again, and then we should add this particular product with product ID to the cart. So now this cart would have a list of products, right? We really want to add for cart products, so let's have an array of cart products of the user, right? So these cart products is going to have all the products which the user is choosing. So now to add to this cart product, first we should have the product, right, whose ID is product. So now let's try to find that from these products. So we do have all the products from the catalog, right? So let's loop through all the products again, okay? And in this, let's try to find out whose product ID is this one. So if all products I.getProductID equal to this product ID which the user has put in, then we need to add this particular product, all products I, to this cart product. So let's actually put that over here. And now here we can just take this cart products and then put that the first product can be added, which is going to be this particular all products. So this is something which we can add over here. Now you can see that there is a problem coming, and it says initialize variable, because we create an array, we have to initialize it using the new keyword. So I would create an array of products using the new keyword over here. But the catch over here in using arrays is that we have to signify how many products we are going to add. So let me just give any random number. So I would say that in my e-commerce website, a user can max have 50 products in the cart, and that's it. I cannot allow any more than 50 products for one particular order. So here we just want to add the first product over here, and then in the cart I want to add all these list of products. So I would just add this cart products in this particular list of products of cart, and then set for the current user this particular cart. Ask the user later on, how do you want to do you really want to check out? So now once this thing is added to the cart, and then I want to tell the user that the product is successfully added to the cart. And this is something which I would want to tell to the user within the if statement itself, just because, the cart is successfully set with the cart which has the product in the cart products. So now the product is successfully added to the cart. So this has happened. Now I want to ask, do you want to check out once you do have the cart? But that is something which we can even do if the user views the cart, right? If the choice is equal to 1, then I believe that, we are done with at least the major part of it. And then, we can go ahead and add if the choice is equal to 2, then what do we want to do? Now, what would we do if the choice is 2? If the customer actually chooses to view the cart. So now, this particular customer current would have a cart. We would just get the cart, and then we want to show what is present inside the cart. So if I just do a dot over here, and then in this we have all these methods. So now there is this method of get list of products. So now from this current user's cart, we do have the list of products which we can get. And now this list of products is something which I can actually assign to something similar to this cart products, right? So I can actually copy this from here and paste it over here. So now here in this particular scenario, we have this cart products. And now similar to earlier, we can actually loop through our entire cart products and display those products to the user, because the user chose to view the cart, right? So we would just take this loop from here, and we want to actually show everything from the cart products this time. So we would go from 0 to cart products.length. I would just want to show the product ID, product name, and the product cost as well. So here it would be cart products instead of all products. So this is how we can show the cart of the current user over here. And regarding this third, for contact us, we can simply just display some random email ID just for the sake of this example. So if choice equal to 3, then we can just tell the user to contact us, please email on store@ecommerce.com or something. So this is just an example. So this is how this should work, and we should have, these else ifs, and then finally we do have an else which would just tell the user that invalid request, invalid choice, please try again. For this, the user would have to actually go through the entire choice flow again. Now, to automate this entire choice flow, because you are telling the user to try again, right? So how would the user try again when the user gets the same choices again, right? So for this, once the user is verified, we can actually, create an infinite loop which would, just be a while true. And within this particular loop, we are actually wanting to put everything. So I'll just cut the closing tag from here, and then wherever we are saying to try again, that's where I want to close this off. So now over here, once I tell the user to try again, then the user would have this particular option to view the product, view cart, contact us, or exit. So once the user selects exit, that's where we would want the while statement to break. So if choice equal to 4, then we would simply break the while loop. So this is the way, we can keep on working on this particular product. Now, how do I test this feature which I just created? I want to test it, right? But how do we get the products from the entire catalog? What we can do is actually, we can have a sample list of products created in the store, and then, I can just show that from the catalog. Let's just actually, instead of returning this particular list of all products, I can actually, populate some products over here, and then I can actually show those products in the catalog. So let's actually create 2 products over here. So I would create product 1 equal to new product, and then I would just do product 1 dot set product ID to be 1, then product 1 dot set product name to be product 1, then product 1 dot set cost to be 100. So this is just for an example which I want to share with you. And then, finally, we would have product 1 dot set the seller to be seller 1. Now, similarly, we could actually have another product, and we could simply, just have the product 2 and, the cost to be 200 and seller to be 2. So now this is going to be product 2, and for this, I'm going to set everything for this particular product. So this is how it works. And now it says that, you cannot actually put a string. We actually have to put a seller over here. So let's just keep the seller empty for now, just to make it simpler. Now what I want to do is I want to add these 2 products in my list of products. So what I would say is my list of products is 0 is equal to product 1. And in my list of products 1, I would put my product 2. So we have 2 products in this array, and then I'm going to return this. This is actually going to return this particular list of product, and that's going to be displayed in this particular catalog. So let's try to actually run this program, and let's see, how it works, and where we might have made any mistake. So when I run this, it asks me if you are a customer or a seller or an admin. If I just say 5, it says if invalid input, try again, and the program terminates. So that's a good feature which we put when I run this. And then, if I simply give 2 or 3 anything, this would just terminate, not do anything, because we have not put anything over here except, changing the type of user. So now I'm actually going to run and put 1, and now it's asking me, what's your user ID and what's your password. So I would say that, my user ID is 1, and, that's it. It just says user verified, just because, we have always made the verified to be true. Now, what do we want to do? Do we want to view products? Yes. So here we do have a null pointer exception, and let's try to see why this thing has happened. So now it says this dot list of products is null, and over here, so let's actually first try to create a new product array of size 2, because we have only 2 products, and then we're actually assigning it over here. So let's try to run this program again. So we are the customer, we just put anything, it doesn't matter, and now we want to view the product. So now we do have these two products, the product ID 1 with the name product 1, the cost is 100, the product ID 2 with the name product 2 and the cost 200. So that's good. Do you want to add any product to the cart? It is asking us for yes or no, and then it's immediately asking us the next question. So we don't want this thing to happen. Here what's happening is that before even actually working on this particular add to cart, it's actually going out and checking for all the choices, and then simply breaking the loop, coming back to the same thing. Do you want to view products or view cart or contact us or exit? So we really want to pause over here. So turns out that we actually have to take a new line so that this next line is actually not skipped. So let's try to do this. Even when we are actually trying to get the user ID and password, let's try to actually not skip the next line over here. Let's not forget the semicolons. Okay, so I'm trying to run this now. So we are the customer. See, now it's not skipping it, right? So I'll just put any random user ID and any random password, and it would just say user verified. And now I can view the products, and now it's waiting for us. It's waiting for us to actually write yes or no. Do we want to add any product to the cart? Absolutely. I want to add, let's say, for example, the product number 1. So I would just write capital Y, because that's exactly what we are going to check over here. If I write anything else, it's not going to work. So when I do that, now it should be saying input the product ID of the product which you want to add to cart. But then it doesn't say that. So there is a problem over here. And the reason for that is always going to be, while working with strings, remember that this equals to sign is going to give you problems. So string is actually an object, and this Y object which I just created over here, this string object is considered different. What we really want to do is we want to compare the values and not the exact same object, because this equal to sign is only going to give us true if this other object on the right hand side is going to be the same object. So if I do add to cart equal to add to cart, it's going to be same. Or if I actually create another string which is going to refer to this same add to cart, so if I just actually created with another name and then put add to cart over there, and then I do if add to cart equal to another name, this is going to give me true, just because it's just another name of the same object pointing to the same thing. But over here this is not the case. So for that we really have the string method which is dot equals, and there where we want to put our information which we want to compare. So let's try to actually now work with this. So like we can have any user ID or password. We want to view products. Okay, now I want to put yes. So now it's going to tell me to input the product ID which I want to add to the cart. So I would say 1, and then it says the product is successfully added to the cart. So now if I try to view the products, it still gives me the product, and it may not be really desirable because I just added it to the cart, but I didn't check out, so that's fine. I don't want to add any product as of now. So now it's asking me again what to do. So this time I want to view my cart. So now here again there is some null pointer exception which is coming over here. Now what does this say? It says cannot invoke product.getProductID because cart products I is null. Now let's look at what our cart products I has at line number 66. So this is actually going from 1 to the length which in our case would be 1. So it should only go one time, but then it says that current.getCart.get list of products, that is actually giving us the product which is null. So we do not have anything inside this cart products. This is what it's saying. So now to actually work with these cart products, let's go back to cart, and here I want to actually add a cart ID as well. If I do that, and obviously it should be private, and I want to add the getter and setter for this, and save this. So now over here, when I was actually trying to create, set the list of products of this particular cart, I could also try to set the cart ID to be, let's say, 1. And now when I try to actually get the cart ID of that same user, because we just did current.setCart to be cart, and here before, doing this particular statement, I want to actually see what this current.getCart.getCart ID would give me. So I would just do a sys out over here, cut this, paste it over here, and now let's try to run this. So now again, I would have to add the product in my cart. So I would just add the product ID of 1. And then, I want to view the cart. So now it gives me 1. So that means the cart ID is correctly set. That means that I can actually get the products within this particular cart, right? So now I want to see what is present within the carts. So now first of all, I want to just check how many times my loop is running. So how many times the loop would be running is going to be represented by I, right? So let me just first work on this. When I run this, again, we go through the same process. I want to add something to my cart. I would just, put 1, and then I want to see the cart. So now we have a lot. Okay. And the reason for that is because, we have, these 50 cart items, and that's something which it is going to explain me what is happening over here. So I don't want to actually go through the entire length if we do not have, the product ID set. I only want to go through all the cart products in which I do have the product ID and the product name set. So now to avoid all those problems, I will just create the products with only one single element, and then let's try to now run this because we do have a single element in the cart, right? When I run this and I try to do the same thing, and I want to view the product, I want to add it to my cart, I want to add the first product to my cart, it is successfully added. Now I want to view my cart, and now it gives me another null pointer exception because it says cart products I is null. So now again, we will do the same process. I want to see that what is cart products I, in fact, what is I? So let's try to run this again. Okay, so now it says that I is 0, and then we do understand that, that cart products 0 is null. That's what is set over here. So now when I actually try to do a getCart.getID, now this is actually working fine, but then for the get list of products, it doesn't seem to be working properly. So let's try to see what is present in our customer get cart. We have this particular cart which we just set earlier, right? But in the cart, when I try to get the list of products, that's where we get the list of products which is actually set based on this set list of products. And that's exactly what we are calling from this particular place. So now what are we setting over here? We are setting cart products with this particular product. Let's actually try to check what is set over here. So let me just do cart products dot get product name. Let's see, which product is actually getting added to the particular cart. So when I try to run this, again, I do the same process. I want to add something. I will add the first one. And now here it says, on line number 60 that cart products 0 is null. Okay, so that means that this cart product actually not getting updated over here. And the reason for this could be I actually couldn't do this update just because I didn't use the equals method. So let's actually use the equals method over here. And now let's try to run this. So, okay, we do see the product in the cart. So now let's actually remove the unnecessary print statements which we had added just for debugging sake. Okay, so now we do see, that this product is present in the cart. And then further ahead, I can just ask, do you want to check out? And then, simply call the checkout method. And that checkout method would also be a part of the cart. So let me just format it first. I want to actually have public method which is just going to return true or false if the checkout happened properly or not. So this is going to just be called checkout, and it's actually turning true for now. We're not actually doing a real world checkout, right? So if we simply go ahead and understand that the user is viewing the cart, the next logical thing is to check out the cart. So do you want to check out? Yes or no? And if the user gives the next line to be yes, so this is what we want to actually use it twice just to make sure that we do not have any error. And now if the checkout is yes, and don't forget it should be dot equals, and if this is y in capital, then we would just call the checkout of the current user's cart. So we would just do a current dot get cart, and here is where we can call that particular method for that particular cart to checkout. So we'll just do a checkout and check if this checkout did happen. Then we would just write simply your order is placed successfully. So now this is how you would go ahead and keep coding for your entire e-commerce website, and you could now, as an assignment, add the order functionality. Like here we said that your order is placed successfully. Instead of this, what I want you to actually do is create an order object and assign this. So what is there in order? Order has an order ID and user, right? So assign this user to the order with an order ID. Also, I want you to have a similar program for the seller and the admin as well. So I want you to give all these kind of different steps and, logical things, what you can expect from an e-commerce website. I want you to give all of that in this particular store code. The last thing which I want to show to you is how you could create a class diagram based on, all the relationships of the classes which you have. And to do that, we have, a couple of softwares available. For example, in Eclipse, you can actually go to help and then go to the Eclipse marketplace and then choose any popular class diagram creating option available. So, for example, I have in my system, I do have certain things installed. So I can just show you what I have installed. I have installed this ECLEMMA Java code coverage. I have installed this object aid UML explorer, and this is really going to give me the option to create class diagrams. So you can also type in this object aid UML explorer, and once you do install it using this help and Eclipse marketplace, so now we can actually go to new, and then I would just go to other and then select a class diagram. So now we do have an object class diagram, and then just create a name over here, a random name, whatever we want. And now over here, I'll just close others. And in this particular window, we can select all the classes we want to include in our class diagram. So I pressed Control. So now we can actually add all these classes which we want in our class diagram, and I just pressed Control, and now when I put things over here, it is generating this class diagram. So now it actually correctly displayed that we have a category which is pointing to itself. So if I actually try to shift the position, you will be able to see it properly, that this is a category class. It has a particular variable category name and all these methods, and the green dots show that they are public methods. It is pointing to itself. And similarly, we have order, we have user, we have store, which we just created. The order is related to the user, who is the customer. The customer is extending the user, and the seller is also extending the user. The customer has a cart associated with it. The catalog has, a list of products associated with it. So the association is also showed properly, which variable is actually associated of the catalog with the product. And similarly, the cart is also associated with the product as list of products. The customer is associated with the cart with its own cart value. So now we do have a seller. So I'll just take it over here so that you are able to see properly. The seller has the products listed. So it also has a list of products, and then this is how the relationship is present, of the seller and the product, because every product also has a seller associated with it. So this is how you see that it also shows that there is a one-to-one or one-to-many relationship. So if it has a star over here, if you can see, it's a little tiny, but it does have a star over here. So it means that, it has a one-to-many relationship. So a product can have only one seller, right? But a seller can have multiple products to sell. So that's the relationship. It is something which it is showing over here. So this is how you can actually create a class diagram and show this particular concept to others. And then you can just right click and then click on save as image, and then you will be able to save as image. This is how you have actually used the different object-oriented programming concepts which you learned to create something which is actually going to be more feature-rich if you keep adding more features in your e-commerce portal project code. So all the best for your assignments. Welcome to the week 3 of Introduction to Java course. In this week, we are going to study about some of the advanced topics in Java, but which are very, very important. So what are we going to study in this particular week? First, we are going to look into what exactly are packages and why do we use it, what are the advantages and all of that. This is something which we have also touched while explaining access modifiers, public, private, protected in the earlier week. The next thing which we are going to study is exception handling. What is an error in a program? What is an exception in a program? How do we handle if there is any exception? And we are going to look at some of the important syntax which you are going to see in most of the Java code written by other programmers as well. The next thing which we are going to study is file handling and input output. So in our program, many of the times we would have to, work with different files of our server. We would also have to take inputs. We would have to give outputs. How does all these things happen? This is something which we are going to study. Also, we are going to study about garbage collection. What is this magical thing of garbage collection which has set Java apart from C and C++? How does this thing happen? What is the benefit which we can take from this? How to code such that we do not have any problem with leaking memory? So what is the memory leak problem? All of that we are going to study. Lastly, one of the very important topics in Java, which is multithreading, and one of the most beneficial thing of Java, I would say, that is, being able to actually work on a particular task in multiple threads instead of, just one single thread of working in a particular program. So we can actually simultaneously work within a particular program. How is that happening with multithreading is something which we are going to study in this course. So stay along with me because we are having a very interesting time this week. Now let's talk about packages. Packages are a way in which you would organize your code, just like you have folders in your operating system, right? So for example, I use Windows, and in every folder, we can have different files. We can have a folder within a folder. Now the names of the files in a particular folder cannot be duplicated, right? So we cannot have a file called test and another file called test as well with the same extension. But can we have a file called test.java in one folder and a file called test.java in another folder? Yes, right? And making these folders helps us first in making our entire file structure very easy to understand. So let's say, for example, you want to store, everything about your full stack development in a particular folder. Now within this, you may create a folder for front-end development first, okay? And then you would create a folder for Java and so on and so forth. So now, when you have anything within the Java folder, you may also have it within the front-end developer folder, right? So for example, the Java folder would have students material. The front-end developer folder would also have students material. And then within the students material, you would have, any file, let's say, the file would be named first. So whatever do you have in your folder structure, you do not worry about the names, overlapping. And you also use this folder structure to give you a logical organization. Packages help the same way. Packages give logical organization to our files. It also helps us to not have any, overlapping name problem. So for example, in your project, in your software, you have a software for a particular company. Now the company would have, the HR department, the finance department, the engineering department, the marketing department, and all of that. Now in every department, you would have certain things. For example, if you have an e-commerce project, you would have, the seller package different and the customer package different and all of that. Now, in the customer package, what order means is the order which the customer has given. For the seller package, order would mean what the seller is actually, catering to and is actually going to ship. So, different things with the same name would mean different for different packages or different logical entities. That is why we use the names of packages. So packages help us with namespaces. So now in Java, there are two different types of classes. One is the inbuilt classes and another is the user created classes. So the classes which we create, so in the last session you saw that I created a couple of classes. I created the order class, I created the categories class, I created the user class and the customer class and the administrator class and all of that. Those are the classes which I have created. There are also classes which Java has inbuilt, right? And some of those we have already seen. In our e-commerce store which we created, you could see that we used the scanner class, which is an inbuilt class of Java within the package of java.util. So scanner is a part of java.util package, and that's what we imported and used over here. Now, all of our code earlier was within a default package. Instead of the default package, if I want to create a new package, I could just, right click, click on new and package, and then I would write a package name. So I could write a very simple name, for example, store package, e-commerce package, or, cart or any other. But what we choose is to have a fully qualified name in the sense that it would have the domain of our e-commerce website. So let's say, for example, our website would be swagofindia.com. So I would write com.swagofindia. This is going to be, my package beginning. And then I'm going to actually divide, further what I want to add. So let's say I have a store over here and I finish it. So this is the package in which, I want to put my store. So I would go to my store, and here before everything, I would just write package, and then I would write my fully qualified name, swagofindia.store. So this is going to be the package of store. And now I will put this within this store package. So now as you can see that my store has gone within this package, and now it is giving all these errors. What are these errors? It says that, it is not able to find, cart, and it is not able to resolve. Why? Because cart is in the default package. So we would put all of these in different packages and then import them one by one based on their package names. So the convention which we follow is to have proper qualified package name with the domain, it either begins with com or org or whatever your extension of website is. Then you have the domain name, then you put the package name, and then finally you have this particular class name. So right now the thing which I created was com.swagofindia.store. And the class name was store again. So this is how I would create packages, for different things. So you may have a test package, you may have, a controller package, you may have, different logical entities within an organization. So for example, if you have everything related to the HR of the company, you would have, com.companyname.hr.so-and-so. Then you would have com.companyname.finance.so-and-so, com.companyname.legal.so-and-so, and com.companyname.engineering.so-and-so. So this is how you would name your packages so that it is very unique. You understand, these classes belong to this particular package. And one more important advantage of using package is, as I said, that we can have the same name classes but in different packages behaving in a very different way. So here what I could have done is, create a new package. I would just write, com.swagofindia.package1, and then over here in this I would have created a new class. I would just call it, let's say, record, and in this I would have the main method, let's say, and I would just write this is record of package 1. Now similarly I could actually create another package, com.swagofindia.package2, and within this again I would create a new class, record, and within this again I would write something very similar to what I wrote earlier, and this would just say I am record of package 2. Now as you can see, there is no error in this file structure, just because we are having record in different packages. And now within store, I could just import, if I wanted to actually, create a new object of the record class. So I would say record r equal to new record, but it will not be able to find this record class. So now I can import this particular record class, right? So how do I import it? I would use com.swagofindia.package1, and then if there is a star over here, just like here, then everything within the package1 would get imported. So if there was record, then any other files other than record, all of these would be imported. So if I just save this, now it says that explicitly import package1.record or explicitly import package2.record. So I would just import package1.record and just get away with this. Now instead of main over here, I'll just write the name to be test. I'll remove these arguments, and similarly I would just rename this to be test as well. So now once we have test, I can actually call our dot test and then save this. And so let me just delete all of this part for now and save this. Let me just run. And now it says this is record of package1, which is great, right? Because we imported the package1. What if we would have imported package2? And if I run this, it says I am record of package2. Now this is great, right? This is exactly what we would expect by using different packages. If I want to use the record of package1, I should be able to use it. If I want to use the record of package2, any class of any different packages who are behaving totally different, but just because I imported it from a different package, I get a different behavior with the same name. And now that gives me a lot of flexibility in using the Java, the Java language with the packages and everything. So I'll just get back our changes, remove any other code which I have included. Okay. So now you saw that how access protection is provided by using classes. You cannot access a particular class without importing it correctly. So if there are two classes with the same name in different packages, you would not be able to access or change any particular class without importing it properly from its own package. So you have access protection. We also saw how we could import classes and everything from a package, in fact, using the import statement with a star or just the class name. Now remember that if we want to import all the classes of a particular package, we will be able to import that. But if we want to also import sub packages of a particular package. So now over here we do have a package called com swag of India store and com swag of India package1. But if we want to actually create a new package, which is actually going to be a sub package of store, then I could create a new package and I would just write com swag of India store. And then within this, I would create a sub package. So I can just, write sub package to be customer store. So now this is the store which, only relates to all the classes relating to the customer. And we could have, a totally different package with, for seller store as well. So now in this, I can, actually put my customer class or any other class which I want to put. This is how you would create a sub package. Now, if I want to import in my package1, everything from the store, then if I do com.swagofindia.store.star, okay, this is how I would do. But if I want things from the customer store as well, this would not work because this would only give me the store and any other files within the store. But if I want from a sub package as well, I have to actually specifically write that I want from the customer store everything. So this is how I would have to import the sub package as well. Now we also saw that Java itself has built-in packages. So here this java.util is a built-in package of Java, and it is providing the scanner class to us within this particular package. So we saw, the different features of a particular package and, how and why we would use that. We saw about sub packages. We saw how we could use the different package members. So we can use classes. We can also import static members of different classes. So for example, let me try to show you with an example. Let me just put the store back over here. So that, we are done away with the error. We do have an error over here. So I'll just comment this out. Okay, so let's close all these other things and let's concentrate on what we have within the store. So let's say, for example, I want to use the value of pi. Now, pi is present in a math library, right? So what I would want to do is actually, let's say within my main, I just want to show pi value is, and then, I would want pi in this. But here there is an error, right? So we cannot define what pi is. So for this, what I can do is simply I can import java.lang.math.star. Within this, I would get, to use math.py. You can see that it is coming to me as an option over here as well. So I can simply use math.py, and if I save this, if I try to run this, this is going to give me the value of pi is 3.14159 and so on. So this is how I can actually import the built-in classes and the values provided by Java. But even with this, every time I would have to use math.py, math.sin, math.cos, anything within this math library, I would have to use the, fully qualified name of math. I do not want to do that. I want to have, more freedom of just using the name pi. For that, we can just, do a static import. So over here, I just have to write import static, and instead of importing everything, I would just import pi over here, so that I just remove math.py from here and I do not have any errors. As you can see, there are no errors, and if I run this again, I have the same output. I can have the value of pi, and I can just use pi directly without using math.py. That is possible using this static import statement with the relevant the relevant variable which I want, or any relevant method. So if I would just have done cos, this would give me the cos method to use over here, if I want to find cos of any number. Okay, so this is how static imports work, just by using different packages. And now you can see, you can have a world of files in different packages and logically organized, just to be used in your software, just because you have all the plethora of Java built-in packages plus your own packages. And now finally, your packages facilitate encapsulation is something which you might have understood by now, that within your package you can write anything and that would be encapsulated there. Whatever you need is going to be provided by the package name and the file name, and that's it. Whatever you need to use, that is something which you can use just by the name. So now you have one option: put all your different classes in a particular folder and only in a single folder, and that's it. Or you have another option, is to use packages, and you will realize that we use packages a lot in Java. So always make a practice to keep using different packages for different things. As I said, that if your domain name is, let's say, cisco.com, your package name would begin with com.cisco. If your domain name is swagofindia.com or .org or anything, it would begin with that package name, .org.swagofindia, etc. Remember that we should always avoid using unnamed or default packages in real-world applications. So in our e-commerce project, in the beginning, we only have a default package, but that's not good. We should have, different packages and different files within the packages, and then import it properly using the entire name of the package. And then, we will be able to use any class, whichever we want within our required class. So I'll just remove this part from here and the math import as well. We had also seen in our earlier lectures in the Java short course that we did have everything in our default package, but then you understood how we would have protected elements only accessed within a particular package or from outside only by the subclasses and not by a non-package, non-subclass. So only those who are inheriting from your class or only those who are in the same package as your class is able to access protected members. So this is also one good way of understanding that on those elements which we can make available only in the same package, that is something which we would make protected. Otherwise, we would not make them protected. So that's it about packages. I hope you learned a lot in this. So let's go ahead and try to learn the other topics now. Now let's talk about exception handling. You need to understand that there are two things in any Java program which can happen. One is that some error can happen. Now errors can also be, during compile time there was an error and that's why the program could not get compiled, or during runtime some error occurred that actually gave us the wrong output. Now errors are such that you cannot do anything about them. You have to not have errors. You have to work against errors. You have to make sure that your programs are error free, because the program will definitely not compile if there are errors, or the program would definitely give a wrong output if there are errors. Another thing is exceptions. Exceptions are something which again can happen or can be detected during compile time or which can happen during runtime. Now exceptions are such that they also halt the program, they terminate the program, but then if you know that some exception has occurred, you can actually handle it within the program and not cause the program to terminate. That is known as exception handling. We can handle exceptions if there are any in our program, and then based on what exception occurred, we can actually, do some workaround, do some, repair work within our code as well. That really makes so much of our code workable, because otherwise we would always, land into some trouble with the user using our program, not giving a correct input or anything of that sort. But with exception handling, we will be able to work around all such scenarios of any wrong inputs, any wrong mishaps happening while our program is running. So now there is this throwable class in Java, and the throwable class is extended by two classes, exception and error, both of which denote exception and error. So now whatever is extending exception, that becomes an exception which we can catch. Okay, so when we say that, the program caused an exception or the program has an exception, we say that the program threw an exception to the user. And you have seen this, when we were working, we either had array out of bounds exceptions or we had null pointer exceptions. You saw it, right? That it actually terminated the program. It gave us a red message in the console that this exception has occurred and on so and so line and due to so and so reason, etc. So those exceptions are extending the exception class. Now exception handling, as I said, it helps with, no automatic termination of program. That really helps us a lot. There are two types of exceptions. One is a checked exception and another is an unchecked exception. The checked exceptions are those which the program can check while it is compiling. So those are compile time. For example, they can be like class is not found, so it would say class not found exception, or we are trying to access some code which we cannot access from being from this particular class, so it would say illegal access exception, or we are trying to call a particular method but it doesn't exist, so that would be a no such method exception. And you remember, right, whenever I would call a method which I did not yet create, it would give a red mark. So those red marks, even the IDE is helping us that these are the red marks and these are the compile time problems in your code itself. So why not, just clear them up before you actually try to compile and then get those checked exceptions. So those are the things which we can work so that our program is compiled. But then once it is compiled, then whatever exceptions occur while the program is running, those are unchecked exceptions. For example, we could have any arithmetic problems like there is a divided by 0. Now, divide by 0 is an exception. So that would be an arithmetic exception. Or as I said, we are going out of bounds with an array index. So it would say array index out of bound exception. Or we would, have any argument which is not correct. For example, I took next int to take an integer from the user, but the user did not provide an integer, the user actually provided any other character or string or something, then it would give something like illegal argument exception, etc. So if you have any null pointers in your program and you are trying to access a null value, then it would say null pointer exception. So all these are unchecked exceptions. Now for these unchecked exceptions, we can actually use some sort of mechanism by which we can understand that any unchecked exception has happened, and then we can actually try to work around that. So now, even with an unchecked exception, so all these names which I gave you, null pointer exception, array index out of bound exception, illegal argument exception, arithmetic exception, all these are built-in exceptions. These are exceptions which Java knows are there. But what if we have an application? So let's say in our e-commerce application, in our Java program, we are trying to work with the age, and age can always be between 18 to 130 years for our e-commerce website, or let's say 15 to 130 years. We are not allowing any user, let's say, with below 15 years of age. And we know that, in the demographic which we have, we do not have any person living more than 130 years. So we would always have that in between these two bounds. But what if in our program, we realize that our age is more than 130 or less than, 15? Then we would have our own exception, which may be age not appropriate or age out of range exception. We can create our own exception. Those are known as user-defined exceptions, and we can handle those exceptions as well in a program, similarly the way we would handle an inbuilt exception. Now, all those exceptions which we would be building by our own selves would also be extending this exception class. Now, let's try to actually work with some exceptions. In my Java short course, I'm creating a new file, a new class called exception handling. And in this, I want to add my main method. And now I want to actually calculate a result of an arithmetic problem. So I would say 15 divided by 0. Now I know that this is something which I am purposely doing, but it may be that you are doing any arithmetic exception and suddenly this figure comes up in your program. This causes an exception and you are not catching that exception and not handling that exception. So what would happen? So when I save this, so let's actually try to output this result. And when I save this, I try to run this. You will see that it says java.lang.arithmetic exception and it says divided by 0, where on the line number 4. Okay, so here is where it says that, this particular exception has occurred. Now, we do not want this ugly exception to come to the user. Okay, so what we do is we can use something which is called as the try and catch. So what I'm doing is I'm trying some code. So within my try block, I would add all those lines of code in which I am doubtful that there may be some exception occurring just because, I'm doing some heavy arithmetic, or I'm trying to open a close a file which may not exist, or, any other indication which I would believe that, may cause an exception, or I'm working with age and, age might not be appropriate, etc. So all those lines I would put inside my try block, and then if it throws any exception to the user, I want to actually catch it. Okay, so that's why it's called catch. So I would catch that exception in my catch block. So I would write exception and I would just name the exception to be E or any other thing which I want. So here I just wrote E, and what I'm doing is I just want to work with this exception. So right now I'm not doing anything. I would just, print it. I would just print the exception E. So it won't make a lot of difference. Let me put this sys out over here. Now let's try to run this. Now it has a neater message. What we have is we are printing this particular exception from the catch block instead of from the try. Why? Because the exception got thrown, it actually is caught by this catch block, and now we are just printing it. Okay, so now we can actually work in many ways within that catch block. Now this exception is a generic exception, but what we have gotten is a specific exception of arithmetic. So we can actually write and catch only arithmetic expression over here, and we can actually catch any other type of exception in another catch block. So this would also work in exactly the same way. Now it is catching the arithmetic exception. If any other exception occurs, then this will not be able to catch it. It would go without catching. So Another thing which I want to show is how do we create user-defined exceptions. So let's say we do have an integer age, and I'm putting this age to be 200, let's say. Now this age value is not correct for our program, and we want to see what age we are using. If there is any age which is above 130, we want to throw another type of exception, which can be called, let's say, age out of range exception. So what I would do is, I would just try if age greater than 130, then I want to tell to the program that, this age is not correct. So I would throw a new exception. What is going to be that exception? I would say age out of bounds or age out of range exception. So I would throw this exception. Now this is not defined, and we actually have to use the new keyword over here. Now here what is happening is that I am purposely throwing this exception. So the program is not throwing, I am programming it to throw it, just so that we will be able to handle it within our code and we are not messing up with our entire remaining project program. As you can see over here, it says that it cannot be resolved to a type. So what it's saying is giving me an option to create this class. So I am going to create this particular class. So now it automatically extends exception for me over here, which does not happen with other classes, right? Whenever we try to create, it understands that this is a type of exception because we are using the throw keyword to throw this. So now over here, what I can do is probably I just want to show to the user what is the exception. Now here I would just create a simple constructor of this exception class, and I would just write super and just call the constructor of the exception class. That's it. Or I could create another constructor which would actually take the message and then call the super class constructor for the same message. This is just to display the message to the user. That's it. So this is a simple code which we can write in a user defined exception, but the main thing is that I just threw this exception. So now we can actually have nested tries. So we can have a try within a try. I have this main try in which I'm checking first the age, and then I am trying for this particular result, which would be age divided by 0, let's say, and then I'm actually trying to catch any issue with this division operation as well. So if I close this, now any try should not be closed or is not complete without a catch or a finally statement. So I should definitely catch the exception. And over here, what exception can I catch? I can catch this age out of range exception, right? So I would take this as A, and I would just, again, I would just want to write to the user that, the age you entered is not correct. So now I'm trying to format this, Control Shift F. As you can see over here, the indentation. First we have a try. I'm writing some code over here. This code might throw an exception based on the value of age. My value of age can be anything. I just put 200 over here just to check. Then I have my code which is surrounded by another try within this try, and this is being caught over here. This code can throw arithmetic exception. That's why I am catching arithmetic exception over here. Then my main try, what can it possibly throw? It can throw age index out of range exception. So that's why, I'm catching it and showing the message to the user. Let's try to run this and see what happens. So now this says that, the age you entered is not correct. So immediately as the age out of bound range exception is thrown, it actually terminated the entire try. It did not even go ahead. Let me try to change the age now to 20. And when I try to run this, now it says that, there is an arithmetic exception. So can you understand how we can use a nested try and multiple catch to be able to work with the different types of scenarios in which, we may want to test our code? Another thing which I can think is, instead of doing this, we can actually remove this try, and instead of, trying it multiple times, we can only have, multiple catch statements for a single try. So it may be that I'm trying to find what is the age. So I just formatted it. I'm trying to find what is the age. If the age is inappropriate, I throw an exception. But otherwise, if the age is appropriate, I'm trying to do something and I know that, there could be this exception which I want to catch. Also, there could be an arithmetic exception happening, which I want to catch. So both of these are possible, and this is another way in which we can use multiple catch statements for a single try as well. So let's try to run this. We do have this arithmetic exception over here just because our age is correct. But let's change the age now and run this. Now we have that, the age age out of range exception is also there. So you understood how we could use try, how we could have nested try statements, how we could have multiple catch statements for a single try, how we could throw our own exception, how we could create our own exception by extending the exception class and just creating, the relevant constructors. Now lastly, there is a type of statement which is known as finally. This is another keyword which we have along with try and catch. So finally is a block of code which would execute every time the try block succeeds or fails. So in both the cases, this finally statement will definitely get executed. This would have, anything like, closing any open files or, undoing anything which is open. So anything, which you want to close, any session you want to close, any resources which are open you want to close, whether the try passes or fails, you would do that over here. So here I will just, simple do a sysout completed execution. Now let's try to run this. So it says completed execution even though our try fails and we do have a catch executing. Or let's try that, none of the tries fail. We do not have a divide by zero exception as well. Let's try to run this. So now it gives us the result, but it also completes the execution. So finally statement is definitely executed, in any case. So let's try to put these exception conditions back. One very important thing which we need to know is that whenever you are using these multiple catch statements, you should always make sure that you are going from specific to a generic exception. For example, if you actually try to catch an exception over here, which is of the generic class exception, from which we are actually, extending these other exceptions, age out of range exception or arithmetic exception. If I actually, try to print over here or do anything over here that, exception generic caught. Now you can see it itself says that, unreachable catch block for age out of range exception, it is already handled by the catch block for exception. So it is giving us two quick fixes that you either remove this catch clause or you replace this catch clause with throws. So we will see what is the new and the last keyword, throws. What does it mean? But the point is that if we try to actually execute this, you will see that it says that, these are already handled by the catch block for exception and these are unreachable. So you should not go from generic to specific. You should always go from specific to generic so that it is able to catch the relevant exception for you. Now the last thing which is left is the throws keyword. Now let's say, for example, this was not in main. We do have another method. Let's say we have a private check age. And in this actually we are, checking this particular age. We do have an age. So I'm taking this entire try catch over here. So I could actually call just the check age. And passing this age of 200 over here, this would take an integer age and check this whether age is 130 or not. This should be static and void. And this part, let's just comment this. Now as you can see, we do have an age and it will check an age and there is a try and catch over here. This is one way in which you can do. But generally, if we do not have a try catch over here, let's say, Now, there is a red mark over here. And what does it say? It says unhandled exception type age out of range exception. We have to add a throws declaration. And if we add a throws declaration, what this would mean is that this particular method is capable of throwing a particular exception in any condition. It may be that we are ourselves throwing that exception, or it may be that our code is doing something, let's say using or opening or closing files, or doing some IO transactions, or doing something in our program which may cause some or the other exception. So your IDE will be happy to tell you that your code can actually create some exception. So either you surround it with try and catch, or you throw it from your method. So instead of actually adding the try and catch, we could also use throws so and so exception, and then finally work on this particular exception in the calling method. So what is the calling method of check age? For check age, we have the calling method which is main. Now here again it says that there is this unhandled exception. Either add a throws declaration or surround it with try catch. So if we add a throws declaration, the main would also throw age out of range exception. Now obviously there is no other method which is going to call main. Main is already called, right? So the Java runner will actually then handle the exception. Instead of actually throwing this exception from the calling method, we could also surround it with try and catch. So now what's happening is that it is actually catching the age out of range exception itself, and then printing the stack trace for us. So now instead of print stack trace, I'll just do the same sys out that age is incorrect. And then I can uncomment this entire part, just because now I can also catch any other arithmetic exception or any other thing which is happening. Now if we try to run this says age is incorrect, completed execution. What if the age was correct? I save this, and when I run this, now it gives an exception. Where is this exception being caught? This exception is being caught over here. And that is because this check age is actually also throwing the arithmetic exception back to the calling method, and now calling method is actually working to catch an arithmetic exception over here. If we did not have this part, then this exception wouldn't have been handled. So if we actually save this and ran this, now you would see that the exception was not handled properly by the program. So we need that part of the code as well. So this is how you would actually use the throws keyword if you don't want to handle the exception within this method, and make sure that the calling method actually now works with handling this particular exception. If the calling method also does not handle the exception, then lastly, the Java runner itself, the JVM itself is going to work and handle that particular exception. How is it going to do? It is just, simply going to print it in the stack trace just like this. So that's pretty much about exception handling. We saw the nested try statements, we saw multiple catch clauses, we saw how we could have chained exceptions, we saw how we could define our own exceptions. We also saw about the finally keyword, whether an exception occurs or not, whether it was handled or not. The finally clause will definitely execute in any case. We also saw about throw and throws. And we also saw that, if there are multiple functions calling each other, so one method calls another method, who calls another method, etc., the exception is thrown, let's say, by the innermost method, and that is actually, if it is not handled by the method, it is actually propagated to the calling method and then to the calling method, and finally, it is handled by the JVM if no other method is handling that. So I hope by this you are very clear with exception handling, and you will have no confusion by looking at anybody's code or doing your own coding for exceptions and for handling them. So that's it. I'll see you in the next video. Now let's look at how we could work with files in Java. So Java helps us work with a number of files in our system. So let's say you have a feature in which you have to create files on your server. So whatever the user is inputting, let's say you want to store it as files, or you want to create a file, a PDF file or an Excel file, and submit that to the user for downloading. So all this file handling can be done using Java. Also, the inputs and outputs which we have been taking from the user and giving to the user, all of that is also handled with Java, as you have seen till now. So now we are going to see how this input and output processing can be done using the files and their streams. So we had an input stream and an output stream from the user from the console, right? But other than console, we can also work with files which also work like streams. Streams meaning like streams of water? Yes, exactly that. It works like a stream of water. So Java would take line by line the stream of information from the file and then also output line by line into some particular file. That's how it works. We will also see how we could check the permissions and change the permissions in files. We would also see, how we could open files, read files, write to files. We could close files and delete files. We will also see the usage of buffer reader class. So we have seen till now the usage of the scanner class, but we will also see the usage of buffer reader and what is the difference between these two. And lastly, we are going to see something known as what is serialization or deserialization. Now for this, I'm creating a new file with the name file management. And in this, we are going to actually try to create a new directory and a new file, etc. Now, before anything, let me just remind you that we have already seen some streams. System.out, this is the output stream. System.in, this is the input stream. And system.err, this is the stream which would store errors if there are any while running your program. So these streams are already provided by the system in Java. We do not have to create them, but we can actually use them, especially the way we have been using system.out.println or system.in within our scanner class. Now let's try to actually create a new file. And for that, I would create an object of the file class and I would write new file. And in this, I would just write some random name hello.txt. That's it. So this is going to be the file which I want to create. Now we have an error over here. It says to import the file. So we have imported it from java.io package. Now we could simply do a file dot create new file. Now here's the issue. I always forget to create the main method before anything. So let's just create the main method first. And let's put this code from here over here. And now here this is giving us a problem. It says either add a throws declaration because it expects that the exception type of IO exception might be thrown by this. Now that's how the use of IDE would help us. It already knows that IO exception is something which is going to be thrown. So either you add a throws declaration or surround this with try catch. So we would surround this with a try catch. This file one.create new file is something which is going to be surrounded by the try catch. And in this catch, it's just printing the stack trace. So this is how we can actually create a new file. Let me just try to run this now. So now it has run and it is terminated. So let me just try to now refresh this entire project. Now you can see that there is indeed a file hello.txt created over here. And the reason why this is created over here is because we have not specified any absolute path. This is actually a relative path of the file. Wherever your src folder is going to be, that is where it is going to create a new file. Now if you have to create a new folder and then a file within it, let's say for example, I want to write test and then slash. So I would put two backward slashes just so that it is escaped properly, otherwise it would give an error. So we have these two backward slashes. Now don't worry that your program might run on Windows, on Mac or on Linux, and it's going to work exactly the same. Let's just save this and run this. And now it says that the system cannot find the path specified, and the reason for that is that we have not created a folder called test. So first we need to create a folder called test, and then we can create a new file called hello.txt within it. So for doing that, first let me create a directory. So I would just call it dir equal to new file, the same way we would do it just like earlier. I would call the directory to be test, and now I would do a dir.mkdir. This is actually going to create the directory for us. Now once this directory is created, then we should be able to actually work around this. So let me try to run this now. Now there was an error over here. Just because we have used mkdir, instead of this we have to use mkdirs, because that's actually going to make multiple directories. If we, for example, had nesting, within the test, we wanted to create another directory, etc. So then we really need to use mkdirs. When I try to run this, now it does not give me any error, and when we try to refresh this, you see that there is a directory created with the name test, and now within this we do have a hello.txt over here. Now once we do have this file created, we want to check what default permissions does this file have within Java. Can we write into it? Can we read from it? Can we do anything like executing the file from Java? So to do that, let's actually try to check whether the file exists or not first. So when we actually create a new file, then let's actually just have a boolean which is maybe called exists, and for this I want to check if this file1 exists or not. So we do have this exists method. If it does exist, then what do we want to do? Then I actually just want to do a sysout whether this file is readable or not, is writable or not, and for that I would do file1 dot can execute. This is actually going to share whether this file can be executed or not. So I would just write can be executed, and similarly I would actually try to do the same thing for whether the file can be read, whether the file can be written or not. So this would be can read, and this would be can write. These are built-in methods which we can use just to check the file permissions. So when we run this, you can see that we do have permissions for doing all these things. Now let's say we do not want to give these permissions to the user in the program, whoever is coding any other part of the program. Let's say I do not want to give them the permission to, let's say, write in the file. So for that I would actually remove all these. So let me just comment it, and now once the file does exist, what I would do is I would do a file dot set executable true. That's fine, because by default executable is true, but what I want to do is, let's say, set writable, and here I want to make it false. So now we cannot write over the file. Now if I try to actually run this part of the code, just to check if the file can be written or not, then if I run this, now it says that no, it cannot be written. So the file cannot be overwritten, whatever is there in it. Now the file is blank, we know it, but we do not want anybody else to write it. So we could use something of this sort. But for now, I would just comment this out, and we should be working with the file and wanting to write something within the file. Now to do that, once the file exists, I would, let's say, call a method known as write to file. Now this is something which I am giving the name and passing in the file object. Now I'll create this method, and now within this I would want to write to this file object. So I'll just rename this to file just for simplicity, and now I want to really work on this. Now to write to a file, I need to create a buffered writer. This is a class of Java which helps us to write on files. So let me just create the name to be BW. So I would do a new buffered writer, and in this I'm actually going to pass a new file writer. This is just a syntax which you have to in fact follow. Once you actually create this buffered writer, do the relevant imports. And now it says that you really have to surround it with try catch. So we would surround it with a try catch. Now once we have this buffered writer object, now we can actually write onto our file. So we would just call the write method, and in this I'm going to pass some string. So I would just write this is a test file writing, and let's say if we want to add a new line character now, so I would just write bw dot new line. and then probably write writing complete. And yeah, just to make sure that everything is complete and I get a relevant message on the console, I will just write writing to file is done successfully. And let's say it is not done successfully, then I would probably want to do a simple sysout writing to file is unsuccessful. So just do a formatting, and let's try to actually run this and see if it works. So yes, it says writing to file is unsuccessful. We do not know what error occurred, so let's actually have e.print stack trace as well, and let's try to run this. Now it says it is unsuccessful, and now it says that the access is denied, and it's not able to find this relevant file over here. Now, one of the reasons why this could fail is because we are trying to actually write to a file within the test folder. Let's actually, for the sake of demonstration, get rid of the test folder and just let's work on the hello.txt file which we have over here. So I'm actually deleting this entire thing. So we do have just the hello.txt over here, and now I'm trying to write within the hello.txt. So let me clear the console and let me try to run this now. So now the writing is indeed successful. Let's see what we do have in hello.txt. So now we do not have anything over here. Let me just try to refresh this. So now we do not have anything within the hello.txt. So we actually have to check, why this thing is not working properly. Now, one reason for this is because we actually used the buffered writer object and we never closed it. And that's exactly what I told you when we were working with the finally, right? That every time whenever we are done successfully writing to the file or not, we should have the buffered writer object to be closed. Now, instead of putting it within the finally, let me just put it over here. This is something which we really need to make sure that we actually close the buffered writer. So now when I try to run this, it says that, the writing to the file is done successfully. And when I open this, now we do have everything written within our file. So here we need to make sure that the buffered writer is closed. Now, instead of actually, worrying about closing the buffered writer, there is another way of actually creating the buffer writer object in such a way that we do not have to worry about closing it always. And that is by actually creating this buffer writer object within the try parentheses. So we do have a round parentheses around try, and now we can actually put this entire line from here. Let's just cut it and put this over here without the semicolon. And now this is not giving us any error. That means that this is a correct syntax to use. And when we actually try to run this, it still says successful, and we do have, our contents within the hello.txt as well. So we do not have to actually close this BW object just because we actually use this type of a syntax in which we are putting things within the try brackets itself. Now, another thing which we really need to understand is that every time we run this code, the contents of the file would be rewritten. So earlier we said that, this is a test file writing, and then we wrote, writing complete, and then, I can just add some gibberish over here. And if I try to now run this, it says successful, and within our hello.txt, this gibberish has, overwritten over the text which we had. Now, every time we do not want to really overwrite things, right? Sometimes we may want to even append to whatever we have written to the file. For this, if we go to the documentation of the file writer class of Java, we can just check that there is this file writer method with a boolean append flag over here. Now, if we actually set this to true, then it would not overwrite on the file. It would actually append to the file. So we go back over here. We have this file over here. We actually add the true flag for appending. And now let's just actually remove the gibberish and try to run this. And now let's open this. You can see that, it has actually appended instead of overwritten. So we do have the earlier gibberish, but now everything else is appended after this. Another thing which you need to know is that here we are always creating the file, but without even creating the file, this buffered writer will check if the file exists or not, and if it does not exist, then it is going to create a new file and write these things within the new file. So you do not have to actually worry whether you have, this file created or not every time. So instead of actually, creating the file, checking whether it exists and, if it exists or not, I'll just comment out this entire thing and actually take this try catch block from here and put this within the earlier or with, exactly where we define this particular method. So let me just remove this entire method from here and save this. So now let's just rename this to file1. And now I'm trying to run this. Okay, so now it says unreachable catch block from IO exception. This exception is never thrown from the try statement body. So now it's able to intelligently understand that, IO exception can never be thrown. So, there's no point of actually having this part of the code. And let's actually remove this try as well. So yes, we have our parentheses correct, and let's try to run this now. So now it says writing done successfully, and we do have this hello.txt. Let's try to actually delete this hello.txt. And now when I try to run this, it still says the file is done successfully, even though we do not have this hello.txt and we actually did not even create it using the create new file method. But it's this buffered writer actually just checked whether it's there or not. If it is not there, it created it and then it would write on it. So let me just refresh it now. We do have this hello.txt and it has its content well written as well. Now let's try to read the contents of this file. And just like we have this buffered writer, we also have a buffered reader with Java. So once we have, actually written successfully to this particular file, let me actually come down and now create a new try block, or let's say, let's just start working with the buffered reader. So I do have a buffered reader object now. I would create it using the new buffered reader. And just like before, we would actually pass a new file reader object. Now this is a syntax which you really need to understand and remember. We would have passed, the file name. So I can just, simply pass the file1 as well. And now we have to do the necessary imports as usual. Now, what I want to do is, I want to actually create a new string and let's say I would just call it contents. And within this contents, I want to add the contents of the file. So what I'll do is, I'll actually, read line by line this particular file. Now it says that, we have to surround it with the try catch. So I would surround it with the try catch. And now instead of, working with this over here, I would just paste it over here. And now what I want to do is, as I just said, that Java is going to consider the file as an input stream, right? It's like a stream. So it's actually going to read line by line. We have this BR object and we do have this particular method of read line from this particular file. So we are actually going to read the line and then we are actually going to, let's say, print the line. Now, it's not just one line which I want to read and print, right? I want to actually keep reading and keep printing until the file ends. So for that, we really need a while loop, and until we can keep reading the line until this is not equal to null, then I would actually, want to keep doing something. So what I will do is I will actually assign this to my contents. So this would be contents equal to br.readline, and until this is not equal to null, then what I would want to do is, let's say I want to do the sysout of the contents. And once this is done, remember we need to close this, right? So we would just close this. Now here again, it gives us that, this part of the code is, can create a new exception. So what we'll do is we can create a new catch clause, which is actually going to throw an IO exception. So earlier there was an exception, file not found, which could be possible using this particular statement. Now we can have an IO exception as well. So let's just do away with this particular comment. And now let's try to run this. So now as you can see, the writing was done successfully, and we do have, this entire contents of the file, printed again over here. And if we open this, we do have this particular same content. So we are able to successfully read from the file properly as well. Now there's another way in which we can actually do the same thing. We already saw the use of the scanner class, and I want to show that over here as well. So let's create a new object of the scanner class. Now scanner class we have always been using to take the user input, right? Now we are actually trying to use the scanner class to get the input or get the file read by our program. So here again I'm going to pass this file1 object within the scanner class, and I'm going to do the same thing, create the contents and then try to print that. So let's first import the scanner class over here, and here it says surround it with the try catch. So I would do that same thing, and I would actually do this this entire same thing over here. Again I would create the contents, and then I would try to use the while loop, and in this scanner object I would always check if this has something after it, and this is the syntax which you are supposed to use with the scanner object. So now in my contents I would write sc.nextLine, and this is going to give me the next line of the particular file, and then what I would do is just a simple sysout of this content. And lastly we do have this sc object to close, so we'll just close this. Now once this thing is done, let's try to run this. So I'll just comment out this buffered reader part, and let me try to run this now. So now as you can see, we do have something read from the file, and we have that exact same thing written onto the file as well. So now this scanner class does the exact same work as the buffered reader class. So this is just another method of doing the same thing. So let me just uncomment out this part, and let me just actually write a new line after this writing complete, just to make sure that we do not have any of this unformatting issue. So now this is quite a lot we have learned about the file reading and writing. Now when we actually try to read, we have these two options, right? Buffered reader and scanner. The difference between these two is not a lot. Buffered reader is something which is synchronous, which actually we can work for writing onto files if we do have a multi-threaded environment. And what is a multi-threaded environment, and how that is going to affect our writing or reading from a file, that is something which we are going to see in this particular week ahead. But for now, understand that buffered reader is capable of writing and reading from files in a multi-threaded environment, and scanner is not. So buffered reader is definitely preferred in that sense. Also, buffered reader has a large buffer. So if you have a big file to read, it does have around 8 kilobytes of buffer, and which is huge. But scanner has a small buffer like 1 kilobyte. So obviously in that case as well, we do have buffered reader working much better for our use. And also buffered reader is a bit faster because it simply reads the sequence of characters, and scanner is a little slower because it actually wants to even parse the input data. So generally for working with files, we do have we always use buffered readers. But let's say for example if we want to take input from the user from the console, we can also use the scanner, because there we do not really need a lot of buffer and all that. Now once you are done, let's say by working with a file, and you want to delete the file, for that you can simply take the file object and call the delete method. So what you can do is just take file1 dot, and then you can call the delete method, and you really want to check whether this file is deleted or not. So this delete method is actually going to return a boolean to us, and which is going to tell us that the file is deleted or not. So if file1 dot delete is successful, then we would just write that the file is deleted successfully. And we could also optionally add an else part of it, and this would just simply say error while deleting. So let me run this. Now it says file is deleted successfully when I refresh this. As you can see, we do not have the hello.txt. So once we actually got done with, working with the file, we actually deleted it as well. I really want to remind you again of this particular block. Now this block is really important. Why? Because as I said that we do not want to have this cumbersome task of, closing the resources. And if we do not close the resource, then we would have errors in the program just like we saw earlier. Also, this would cause a resource leak. So we actually opened the resource, we worked on it, but we did not close it. So that would cause a resource leak. We do not want that in our program. So make sure that you actually use this particular block, which is called try with resources. So this is pretty much about working with files. The last thing which is left is serialization in Java. Now what is serialization and deserialization in Java? So serialization in Java is just a mechanism of writing the state of an object into a byte stream. Now we really want to convert the object in a byte stream so that it's easier for Java to write that particular object directly into the database. So we are actually going to study about Hibernate and JPA, which is helping us to write the state of the object in the database. For that, we really need to convert the state of the object into a byte stream. So that is known as serialization. The deserialization is, just the opposite process in which we convert the byte stream from the database into an object of Java. Now, how do we do that? That is done using the serializable interface which is created in Java. So let me actually try to create a new class. Let's say, for example, I would call it student. And now this student, student is already defined, so I'll just write it student1. Now it is something, which is defined within this package. And let's try to now rename this particular file to student1.java. So yes, we have the student1, and now what we really want to do is implement the serializable interface in this. So this implements serializable, and why I want to do that is because I want to convert this particular object to a byte stream. Now we just simply have to import it and we'll be able to use it. So let's say, for example, I have, ID of the student, and let's say I have the name of the student. And then, probably we could have a constructor as well. So let's create a constructor using the fields. So we do have this particular constructor as well. Now, once we have the student1 class, I actually want to create a new class which is going to, work with the database. So I would just write, persist in DB. And in this persist in DB, what I would want to do is I would want to actually create the main method first. And in this, I want to create the student1 object S1. And this is going to be new student1. And I'm actually just going to give some random ID of 1 and the name of student1. That's it. Now, what I want to do is actually I want to create a file output stream, fout, let's say, and I'm just going to create it using the new keyword as usual. And again, I would just want to work with the hello.txt. Now let's do the necessary imports. Okay, so now it says, surrounded with the try catch, which we are going to do. Now over here, once we have this particular file output stream object, I actually want to work with the object output stream. So I create object output stream and I would just call it out. And we have this new object output stream with the file output stream. And now what we have is out.write object. This is the method which I want to use, write object, and I want to actually write this particular object S1, which is the student 1 which we have, and then I would just flush it. This is the syntax which you're supposed to use, out.flush, and finally you're going to close this particular stream. What I would do is out.close, and then finally I would just write that object serialization successful. Now here it says to add the exception to the catch clause, or create a new catch clause, so we are going to do that, and let's save this. Now once we save this, let's try to now run this. And now it says object serialization successful, and when we actually refresh this particular project, we have this hello.txt, and in this we do have some data, but obviously we are not able to understand what is there. This is the serialized object which we have gotten. Now let's actually try to work in the reverse direction. Let's try to actually deserialize the data from this particular file and actually convert it to our student1 object. So for that, what I'll do is I'll actually create a new class, and this is something which I would, let's say, call dPersist from DB. Now in this, I'm actually going to create again a main method, and then create an object input stream. I really want you to not get too scared about this whole syntax, the new syntax which you are learning right now. The simple reason for that is because every time you actually are going to work on a particular task, the documentation really helps you in helping you with the syntax. So you don't have to stress about the syntax, but yeah, you need to know that what you are wanting to work with. What do you want to do exactly? You want to deserialize, you want to depersist from the DB. What you want to do is basically read from the database and actually convert it to a Java object. That's exactly what you want to do, right? So now we are actually going to read from a database. Let's say hello.txt file is the database which we have, and we really want to take the object from there and we want to convert it to a deserializable form. So let me just do the necessary imports over here and surround it with a try catch block. And now once we have this particular object input stream, what I want to do is convert that into a student 1, and again we would just call it S1, and this is going to be in.read object, and this is how we are actually going to read that particular thing from this object input stream. And we'll actually have to add a cast to make sure that this is a student 1, and we'll add a new catch clause as well, just in case it throws an error. And now what we'll do is, we have this S1. What we want to do is we want to actually use this S1. So what I'll do is I just want to understand what is the ID of the S1, and let's say the name of S1. So I want to get these two things, and I want to print that. And once this is done, I just want to close this particular resource. Again, remember to keep closing this, any resource which you have opened. And when I try to actually now run this particular program, now as you can see, it correctly gave us, the ID 1 and the name student 1, even though we actually did not create an S1 with the ID 1 and student 1 in this particular program, but it actually read from the hello.txt, and it actually, did the deserialization for us. So this was, I hope, in a simple way you understood how we could actually write to a file a state of an object and read from the file what this object really, has the data. Remember that, if you are actually dealing with inheritance, then if there is any class which is implementing the serializable interface, then all its subclasses, so if you did have, any subclasses of student 1, let's say, then that would also be serialized. Okay, so you will be able to actually convert it from the object to a byte stream. Also, let's say for example, within your student 1 class, you actually had an object of any other class. Let's say you have this student S, and then you want to actually serialize the student 1. So make sure that even the student or any other class which you would have within this particular class which we call aggregation, right? We already saw what is the meaning of aggregation. We saw that, there can be an object of another class within, another class. So if you do have, make sure that everything implements serializable so that you are easily able to convert this particular object of student1 to a byte stream. Also remember that whenever you are converting the state of an object in a byte stream, it converts the state of the object and not the class. So if you have anything static, let's say you have a static int I like this, and let's say you initialized it to 0, this I would not be a part of your object. Okay, what you are doing is just converting the object state in a byte stream and not the class or anything related to the class. So remember that about serialization. And the last thing, to work with serialization, you really want to make sure that your application has security, that you are working with the correct data. And you can see over here there's a warning coming up, and it says the serializable class does not declare a static final serial version UID field of type long. And this particular field is really important to make sure that the thing which you are working on is exactly the same. So what we can do is we can add a default serial version ID, or we can add a generated one. So let's add some default over here, or let's actually implement a generated. So this is actually going to generate a pretty long string for us. It's actually a long integer, and let's now save it. And when we actually try to work with this particular code, let's try to run this. Now it says object serialization successful, and let's try to run this again. And we do have this particular thing. Now let's actually change the long, and now when we try to run this again, now it gives an error. It says local class incompatible stream class DESC serial version UID so and so. So that means it says that the serial version UID are different, and the thing which was created was with serial version ID something else, but what you are telling me to depersist is something else. So this actually gives us a very good security while working with serializable interfaces, so that we are actually not doing anything wrong within the database and not reading anything wrong from the database. So this is also something which you need to know while working with serializable, and not get scared by looking at a long number whenever you see somebody's code with the serializable implementation. So that's about working with files, writing to a file, reading to a file, writing an object to a file, reading an object from a file. I hope you are pretty clear with all these concepts, and practicing is really going to help you, and solving any relevant problems is really going to help you with all these concepts in case you are confused in any way.
Now let's look at some small but useful ideas which we can do using Java. The first thing is dealing with nulls. For example, if we want to check if strings are null, we would generally do if string name not equal to null, and then do some things. But then in Java, if you see somebody's code, to keep checking the nulls, it becomes a little messy, because every time you keep on checking certain things in different strings. To actually work against that, to not have that problem, Java introduced optionals. To show that, let me just create a new file for optionals, and I would just say this is optional use. Now in this, let's create a main method, and within this, for example, we have a user class, and let's have actually a string users, and this is going to be a new string, and let's actually have it as 5 users. So it's going to be an array of users. And now I actually want to access user2 dot char at 0. This means that I want the first character of user2, and I just want to do a sysout over here. So I'll just cut this from here, paste it, and I'll try to run this.
Now, when we run this, as you may expect that, we do have a null pointer exception. Why? Because user2 does not exist. User at the index 2 is null. And we are trying to actually find the first character of null. And that's what exactly this is saying. User2 is null. So you cannot invoke the char at method of null, and that's why you have this null pointer exception. Now, to do that, what we would generally do is we would check, if user2 is not equal to null, then we would do something like this. Otherwise, we would just simply return. So when we run this, this program runs and terminates, and this is the kind of null check which we would want to do. Now imagine that we actually have to do this null check for each and every line, each and everything which we want to do, whether it's using this user array or whether it's using any other data type, which maybe some method which would return any other data type which is present maybe in some other class in its instance variable. You can have null in any data type in any variable, right? And if you keep on checking this null, it would become really messy looking at the code. So for that, Java introduced the concept of optionals. So optional is a class in which you have different methods to deal with, different values. For example, you can over here create an optional of the type string. So you use these diamond operator, two angle brackets basically. And then you can actually create an empty optional. So you would write, let's say, for example, empty equal to optional dot empty. This is actually going to create an empty optional for you, and it's going to return an empty optional instance. So no value is present for this particular optional, and we can use method is present for this. So if we do empty dot is present, and this is actually going to return to us if this optional is present or not. So let me just do a sysout and put this value within the sysout. And let me just comment this part out. So now when we try to run this, it says false. That means this particular value is not present, so it is empty. Look at this, that you can see that it does not throw a null pointer exception. That means it is empty, it's not present, but it is not null as well. Another thing which you can use using optional is, for example, you do have a string name, and here I'm just putting, name1, just for example. And for this, what we can do is we could have an optional string again and just call it, for example, name1 equal to, and then what we could do is use optional dot off. And what this would do is, let's say we pass the same name over here, and let's try to print this now. Let's try to print name1, and let me just comment this part out. So when we run this, you have this particular optional with the value name1 in it. Now what this off is doing is basically creating a particular optional using the off method. And this would return an optional with the specified, non-null value which we are sending. So this is a non-null value. It's not null, right? Name1 string is not null. And we can create an optional using the off. But what if we actually want to send something which we don't know if it is null or non-null? So we know that, name is not null, so we are fine. What if we are wanting to create an optional with some null value? So for that, we may want to create using off nullable. So instead of this, what we could have is the exact same thing. Instead of using off, I would use dot off nullable. Now when we use off nullable, we are free. If the name is null, then also there's going to be no issue. So for example, let me just pass null over here, and let's try to run this now. So you do have an empty optional. That means if you pass a value which is null, you would have an empty optional. Otherwise, you would have that particular element. So let me just pass name again over here, and let me try to run this. And now you do have, optional name1 over here. So this is the way you can actually use an off nullable optional to be able to work, with null values. So what you could simply do is, instead of doing this particular not equal to null check, what you could do is basically just do name1 dot is present or is empty. If it is present, then do something. Otherwise, that it's not present, it is empty, then you would do something else. So let me just put that around if. So if this is present, then you do something else, do something else. This is how you would generally work with optionals. You could also actually work with is empty. So I would just write or use is empty. And what is empty will do is do the exact opposite of is present. And this is, generally available only after Java 11. So you need, your version of Java to be more than 11. Is empty is going to return false if there is a value present. Otherwise, it would return true. So that's, opposite of working with is present. Now, how do you actually get the value? So for example, if name1 is present, what I want to do is I want to get the value of name1. So I would call the get method and then, pass that in a string, value of optional. This is just a random name which I have given. And then, I would just do a sysout over here. And I would just want to print the value of optional. So let me just comment this out. So when I try to run this, now you can see that I do have the value of this particular optional, which is name1 printed over here. So it's a simple thing. And over here, what I could do is that, since we do not have any value, I would just, print null. This should be a string. Okay, so when we run this, we do get name1, but what if name1 was, null? Now when I print this, I do get null over here. So this is how you could, have your program work differently if you do have different values. If your name has some value, then it would work differently. If it is null, then it would work differently. Most importantly is that it would not throw a null pointer exception, and you have handled null pointer exception very well just by using the optional. You could also use something like or else. So for example, you do have this, optional dot all of nullable, and let's say for example your name may be null, so you want to add some default name. So what you would do is you would call the all or else, and in this you're going to give the value, some value. Let's say for example I am giving the value of null. So if your name does have something, it would be the name, but if it does not have anything, then it would be null. So now when we are actually trying to use this, we don't need to actually declare this name1 to be optional. We can simply change the type of name1 to be string, just because we are sure that, if it is not null, then we would have a string. Otherwise, we would have, this value of null in this. And now since it is not optional, then we do not really need to use this particular is present. Or what we could simply do is we could simply use this name1 value, and if it is null, then it would simply print a null. Otherwise, it would print the value of that particular optional. So let me comment this out, and then, let me try to run this. So we do have name1 over here, but what if, this thing was null? And when I save this, and print, then this would be printed as null. So this is how you could actually work with optionals, just by making the use of the various methods which it provides. You could simply have a lot of flexibility in your code. And lastly, there's a last method which I want to show is, instead of using or else, you could also have used or else get. And it's similar to get, but obviously, if you do not have anything over here, so since it is null, you could also do an or else get as well. So the syntax of that would be inside or else get, what you could do is you could create a lambda, and you are going to learn what is lambda later on, but it's just, a function which I would just create using these round brackets, a hyphen, an angle bracket like this, just by making it an arrow, and then, pass on any name which I want to pass, or null which I want to pass. So or else has an easier syntax, that's why I'm showing you over here. But just in case you see somebody's code which is using or else get, and then within that it's actually passing a function sort of a thing, a method sort of a thing, just by having it in a very small syntax, 2 round brackets, 1 arrow symbol, and then the value of null. So this is also equally valid. So this is how you would use optional. Instead of every time checking if the user is null, you would probably want to create an optional using .off or .off nullable, and then check if it is present, and then get the value of it. Or you could also write or else and get the value of it to be defaulted to something else if it is null. So this is how you would use optionals. The next thing which we need to see is how to actually create a copy of a particular object. Now you might be thinking that what's the big deal in creating a copy? We can create a new object and then assign that using the equal to operator, and then we have a copy of the object. But there's a problem in this, and let me show you that. For this, I created a new class known as object clone, and let's say for example in this I want to create some instance variables. So for example, I would create an ID, and like for example I would create a name. And now in this let me add constructor as well. So now we have a constructor based on this particular object. We are wanting to create it using an ID and a name. Now in this main, I create a new object of this object clone class, and let me just call it obj, and this is going to be created using the new keyword like always. And now I want to pass in the ID of, let's say, 1, and name would be name1. So this is a simple thing. Now I want to create another object obj 2, let's say for example, and I want to create a copy of this particular obj in this. So I'm going to create it using the new keyword, let's say. So I'm going to use the same thing again, but now I want to actually put everything in of obj into obj1. So this is what I want to do, and let me actually have a default constructor as well. So the fields are not really relevant over here. So yeah, what I want to do is I want to actually put everything in obj1, and now I want to print what is there in the ID of, let's say, obj1. So this is something which I'm going to put in my sysout, and I want to cut this from here, paste this over here, and I want to run this now. So now we do have the ID of 1, so we do have things from obj into obj1. But now let's say for example I want to change what is there in obj1.id. So now let's say for example I make it 2. And now when I try to print this, we do have 2 over here in obj1. Now let me actually try to access what is there in obj. The original object which we created with the ID 1. What is the ID of that? When I try to print this, we have the ID to be 2. But actually the ID was 1, right? What we did is we changed the ID of obj1 to 2, but we did not actually change the ID of obj. So why is this happening? Why couldn't we just have a copy and then work independently with that copy? And the reason for that is when we actually try to copy an object into another, we are not actually creating a new memory with the ID and the name and then pasting that in obj1. What we are doing is simply we are taking a new reference of obj1 pointing to the exact same object which we created using this particular ID and name. So now what's happening is that obj and obj1 both point to the same object, and that's why when I make a change in obj1, the change is also propagated to obj. This is not something which we want. We want to work on obj1 differently, and we want to make obj to be intact the way it was. For that, we actually need to use something known as clone, and we would want to actually implement the clonable interface. So what I would do over here is I would actually implement the clonable interface, and this is an interface which Java provides to me so that I'm able to create an object clone, or I'm able to create a deep copy of this object. So here what I would do is I would create a public method which is going to return object, and that's going to be called clone. And this is actually going to let me first type in what I want to do over here. So this is simply going to return super.clone, and this is going to call the clone method of super. Now here it's saying you should add a throws declaration, because this may throw a clone not supported exception, just in case it's not supported. So this is something which we would add over here. But now we do have this clone method implemented in this object clone class, and now I can use this particular clone method to call with this particular new object which we created. So I would call the clone method, and now what we want to do is first of all we have to add the cast that this clone method should generate an object clone, because that's the class which we are using. It should generate an object clone and assign it to obj1, and this is something which it is saying to surround in try and catch, so we would be surrounding it in try and catch. And then once it is created, what I would want to do is change the ID of obj1, and then probably try to print what is the ID of obj1 for now. So when I try to do this, what we do have is 2, because we did change the ID of obj1, but what is the ID of obj now? When I try to print this, now we do have the ID of obj to be 1 only, and that is something which we have declared it using this particular statement, right? So that means whatever changes I make to obj1, now it doesn't matter to obj. Why? Because we have actually created a deep copy meaning that we actually created a new object and assigned it to obj1, and then we are able to independently work with that without worrying about what is happening within our original obj object. And this is how you should definitely use the clone method. Just implement the clonable interface, and then override the clone method just by calling super.clone, and this should be able to create a deep copy of your object for you, so that you are independently able to work with that particular copy, instead of working on the same exact object and getting troubled by the issues caused because of not using clones. So I would just format it a bit and save it for your reference. So this is how you would use a clone method of a particular object in Java. The next small thing which you need to know is the use of the var keyword in Java, and specifically this has been introduced in Java 10, and this really makes Java a dynamically typed language. Now what is statically typed and what is dynamically typed is something which we are going to see right now. To demonstrate this, I'm going to create a new class, and I'm just going to call it var keyword, and in this basically what I would want to do is create the main method first. And now in the main method, every time we have created something, we have put the data type of that particular variable beforehand, right? We have always made sure that it is either an integer or a string or a character or a boolean or an array of integers or an array of characters, or if it is a string or any particular data type, right? We never made anything which is ambiguous, of whose data type we do not know, and that is what makes it a statically typed language. So if I write integer x, this is actually going to make it statically typed. What we mean by statically typed is that Java is a typed language. The type of a variable is always mentioned in Java, okay? It is always at the compile time we know what type of a variable it is. But if we use something which is very generic, like var x and for example var y, and if we let's say assign 100 to this, now we know 100 is an integer and y is definitely having the data type of integer, but this really makes it dynamically typed. And why this is so is because until we do not assign some value to this, we do not know the type of the particular variable. And this is the use of var. If we want to use var in in any way, for example, I have z, and z is going to be, let's say, 2.4, and z becomes a double now. Or if we have a var s, and this is going to be some string, so this is actually going to be of the type string. So now this keyword var really makes it pretty flexible for us to use things. The type inference is used, in the var keyword, by which it automatically detects, the data type of the particular variable. And then, we can just, use the sysout for s or for y or for z or, anything which we do have some value associated with it. Now, we really need to understand where and when we can use var. For example, I can use var as a local variable. So now this particular thing is a local double variable. And why it is a local variable is because it is a variable of the method main, right? So if you have it within a method or within a function, then it is a local variable. So we are fine to use var in this. But it cannot be used as an instance variable. So for example, in this particular class of var keyword, I cannot have var some value. Now this is not allowed. So you can see over here, it says that, var is not allowed over here. So let's put it in a particular comment. Also, var cannot be used without any explicit initialization. So if I just remove this particular thing from here and I try to save this, it gives us an error and it says cannot use var on variable without initializer. We really need to add some value over here so that it understands what is the type of this particular variable. Also, var cannot be used in any other method call. So for example, this is method call, and now I want to pass let's say y. Okay, and now in the method call, if I try to actually create it, it gets created using int y. But if I just want to write var y over here, it would say var is not allowed over here. So this is something which is not allowed. I'll just do away with this particular line and put all of this in a comment, just because it is not allowed. So anyways, if I save this is not going to work. Also, you cannot return a var. So for example, if I just uncomment this, and even if I do have an int over here, I cannot have a var z equal to y and then return z, and then since it is returning void, I want to return a particular var, and this is not allowed. It says that var is not allowed over here. So all of this is not allowed. So I'll just put all of this in a particular comment, and here also a comment, just for your understanding. But var is something which we can use in Java 10 just within a particular method, and then assign it to some value in the beginning itself, just to have the flexibility that we can assign it any particular data type, and we need not worry about what data type we want to mention over here, whether it is an integer, whether it is a string, whether it is a double or float or anything which Java has as data types. This is a small thing about the var keyword which is introduced in Java 10. And now let's go ahead and look at some other major topics as well. Now let's look at a very important topic in Java, and we have talked a lot about these topics while we were working in Java, and sometimes it might have confused you. So I'm here right now to clear all that confusion. We are going to study about memory management, how things are assigned memory in Java, and then any problem which might come with memory management, how to deal with them is something which we are going to see. Now for this, it's really important for you to understand that there are two types of memories which are available in Java. So you have a particular Java program, and from the operating system you have two memories. One is the stack memory and another is the heap memory. The stack memory and the heap memory both share the same space, but then as much as the Java wants to add things to the heap memory, it would grow. Similarly, as much as the stack would want, it would grow in the same shared memory. This is how a Java program with a memory block works. So you do have the program text, and then you have the data on which you are working, and you have the stack and the heap part as well. Now what's the stack memory? Stack memory is a simple memory in which you keep pushing things and then keep popping things from the same end. So you push at the same end and you pop from the same end. That is known as stack memory. And one important use of this particular stack memory is to store all the function and method calls. So there is one function, let's say, the first method which we call is main, right? And then main calls another method that is going to be pushed onto the stack. And that new method also calls another method. And then this is how, the stack might keep on growing. And as soon as a method completes execution, then the stack would pop off that particular method block. And then, the second last portion or the second last method which was running would continue to run, and this is how we would come back to the main method which would complete its run and then terminate the program. So stack memory is really very important for keeping function calls or method calls in the memory so that we know where we are supposed to go back when one particular method completes execution. The next thing which stack memory is used importantly is to keep references of variables. So we always created new variables, let's say in the main method, right? Where are these variables stored? These variables are stored in the stack memory itself. Another thing is that, all the values of the local variables in each method block or a function block and the program counter, all those things are also stored in the stack memory. Now, for example, if you have this particular static method, factorial, which is returning an int and taking an int, this is just to calculate a particular number's factorial. So we do have, let's say, for example, if it is n factorial, so 0 factorial is 0, 1 factorial is 1, but 2 factorial is 2 into 1, and 3 factorial is 3 into 2 into 1. And this is how it keeps going, right? The factorial, n into n minus 1, so on, till 1. So if it is equal to 0, then we would return 1. Else we would return n into factorial of n minus 1. And this is known as recursion. We are calling the same method again within its body. And this is how, the function or the method of factorial is written. Now, when we actually try to run this, one method call of factorial is calling another method call of factorial just by changing the argument value. And what this would essentially do is actually insert the factorial call onto the stack, and then let's say, for example, the factorial of 4 would call factorial of 3, which is going to be pushed, and then factorial of 2, which is going to be pushed, factorial of 1, which is going to be pushed, and then factorial of 0. But once the factorial of 0 reaches, then we know that this is going to return 1. So we would return 1 from here, and this particular method block is going to get popped off. And then again, factorial of 1 is going to be popped off, it would return 1. And then factorial 2 is going to be popped off, and it would return 2 into 1, which is 1. And this is how, it would factorial of 3 would return 3 into 2, which is going to be popping 6. And then, finally, factorial of 4 is going to return 6 into 4, which is 24. And that's how it is going to pop off 24. And this is how, the entire execution of this particular factorial method is going to get complete. And you are going to get the result of 24 from factorial of 4. So this is how the stack memory is going to be used for all these method calls. What about the heap memory? Heap memory is going to store all the defined variable values. So you have this particular stack memory and you have all these references to the objects. But where are those objects stored? For example, I created a student class. I created an object of the student class known as S1. Where is this S1 stored? That S1 is actually stored on the heap. This is the heap memory, and these are all the objects in the heap, and these are the references to those objects. So we have the object in the heap, but the references are in the stack memory. So as I said that if I just do a student S2 and I assign S1 to S2, what's going to happen is that the object is the same in the heap, but S1 and S2 both are going to be referring to the same object on the heap. So for example, over here, you can see that this is a stack and we have a local variable int a equal to 10, and a equal to 10 is put onto the stack. Now, if we have an object instead of, a simple local variable, a primitive local variable, we have an object. For example, test a equal to new test, and a is the object of the class test. So a is the reference which is going to be present in the stack, but then the heap is going to have the object, and this is just going to refer to that particular object in the heap. So now in a particular Java program, you have this particular JVM memory, and this is going to be divided in the heap memory and the stack memory. So now heap memory is going to have, all those objects which your program is working on. These are all live objects in the heap memory. And then you may have one or more threads in the particular program, and each thread would have its own stack memory, and each thread would be calling, the methods one by one with their local variables. So this is calling the method 1 and storing the local variables of method 1, and then, it had called method 2 with this local variable 1. So this is how you would have stack memory for different threads and a common heap memory for all the threads. So as I said that if we do have, a string S1 and, for example, I'm putting the value of 1 over here. We also have a string S2 with the same value. Now these two would not be considered different. We just have one particular object on the heap with the value 1, and both of these are going to actually point to the same thing. So if I change anything in S1, S2 is also going to reflect that change just because these two are pointing to the same thing. Similarly, if we create a new S3 with the same value 1, but now using the new operator, this is going to be, at a different place altogether. Now, if we actually try to compare S1 with S2, is S1 equal to S2? This is going to be true just because it's pointing to the same thing. But if I compare S1 with S3, this is going to be false just because it's actually pointing to different things. So you really need to make sure that whatever you are working on, you know how memory is assigned to all those things. And in case you are confused, you can just, do these checks just to make sure that, whatever changes you are making to S2 should not actually hamper what is there in S1 or any other object. So Java has, a couple of memory paths. You would have the heap area, you would have the method area, you would have the stack, you would have a native method stack, and you would have, all the program counter registers also stored. Now, memory management is an important thing in Java because sometimes we may land into problems working with memory. Every program has a limited amount of memory to use from the cache or the main memory, right? Now, there is the stack, and you have one stack per thread, and all the local variables relating to that particular thread method calls are going to be stored in the stack. You have the heap, which is massive. You can store all the objects in the heap, and this is, the common thing for all the threads, and all the objects are stored over here. Now, if your program is using a lot of memory and, the heap actually gets overflowed, then you would have some problem with, memory overflow or memory leak problem or out of memory error. Now, what are memory leaks? Memory leaks occur when, memory that has been allocated is no longer needed, but it does not get released for, any other part of the program to work on. So we allocate memory using the new keyword, right? So we create different objects using the new keyword, and we allocate heap memory for those objects. Now, let's say you are not using those objects anymore, but the memory does not get released. Then your program would keep on, assigning things to new objects, not releasing it from the old objects. And now you do not have any more memory left for any new objects to be created, or for the, for the remaining of the program to use any new memory to complete its execution. And that is where out of memory error comes. And we do not want these kind of errors, right? So we really need to solve such memory leak problems, which is not allowing our program to release any unused memory. Now, for that, we really need to understand that the new keyword is going to allocate memory, and the JVM might move this memory around, as the program runs. So it's not a particular place which the object might be allocated, but it would be allocated some memory anywhere in the heap, okay? And this memory is not going to be freed until the reference of that particular object is live on the stack, okay? So we just saw that, the reference is present on the stack, right? If it is live reference on the stack, it is not going to be freed. Until you free that particular reference, that memory is going to be kept in use. The automatic thing which Java uses to free memory is known as garbage collection. And this is a pretty magical thing which happened in Java. So in earlier programming languages, before Java was developed, which was, for example, C or C++, then we actually wanted to create memory using the new keyword. But then every time we actually create a new object using a constructor, which is the same as Java, we actually also had to create a destructor for that. That's a pretty logical thing, right? You have a constructor, so you obviously also need a destructor. Always the destructor had to be called to free the memory if the object is of no use. And that was the problem which was put on the shoulders of the programmer. The programmer has to make sure that, all the objects which are not referenced are freed. But Java actually took that burden away from the programmer and gave it to an automatic method of garbage collection, which automatically checks if there is any object which is not yet referenced, by the remaining program. So why not just free that memory up and remove that burden from the programmer, just in case, the programmer forgets to free that particular memory. And that is known as garbage collection. And that really made a lot of difference in programmers' life. And that's why people moved a lot towards Java as well. Because of this automatic garbage collection, there were no more memory problems because of not freeing objects once it is allocated. Now, what is a memory leak problem, if you ask? So, memory leak is actually a situation when there are objects present in the heap, but they are no longer used, and the garbage collector is unable to remove them from memory, and that's why they are unnecessarily maintained, and that would actually cause memory overflow or out of memory error. Memory leaks, they are bad, okay, because it blocks memory resources and it degrades system performance over time. Now obviously, if you have a lot of things in the memory which are not used, they're unnecessarily taking memories, and you have very less memory remaining for your program to work on. That means the program would get slow, right? And if this particular memory leak is not dealt with, the application will eventually exhaust all its memory resources and finally terminate with an out of memory error. So we want to avoid, in any case, any memory leak problem. Now remember that there are two types of objects in a particular heap memory. One is referenced and one is unreferenced. So reference objects are those who have still, active references within your particular application. Whereas unreferenced objects are those that do not have any active references. So the garbage collector is actually going to remove all the unreferenced objects periodically, not like every single microsecond, but periodically it is going to actually work for garbage collection while your program is not doing anything specifically, heavy. Then that time is going to be used by the garbage collector to actually free that particular memory. But then it will never collect those objects that are still being referenced, right? And that's where memory leaks occur. So we do not want that, there is any severe performance degradation when your application is actually continuously running for a long time. We do not want any out of memory error for your heap in the application as well, right? And we do not want any spontaneous or strange application crashes as well. So for that, we really need to understand what to do so that we do not have a particular memory leak. And there are a couple of ways to do that. Now remember that if we avoid any particular memory leak, then we definitely have all the advantages of garbage collection. So what are the advantages? One is that it makes Java program very memory efficient, because the garbage collector would remove all the unreferenced objects from the heap memory. And another is that it would automatically be done by the garbage collector, which is a part of JVM. So we don't need to make any extra efforts. Now, as I was talking that, we can make an object unreferenced once it is, no more of use. And there are a couple of ways by which you can do. The first is by nulling the reference. To show that to you, let me just create a new file. And I would just call it memory management. And then this, I'm actually trying to have a main method, and within this, let's say for example, let's create an object of student called S, and I'm just going to create new student. So now we do have this particular S object, and let's say for example, after a lot of working, I do not need S anymore. So what we can do is, we can simply assign null to S, and then, after this, whenever the next time garbage collector is going to work, it's going to see that, S is actually not referring anything. So S is on stack, but then, it's not actually pointing to anything on the heap. So let me just clear S. So this is one way which you can do. Also, for example, you have, two more students, for example. You have S1 and you also have S2. Okay, so now you have these two live references, S1 and S2, and these are not going to be garbage collected just because we are actually pointing them to new students in the heap as well. So for example, I actually do S1 equal to S2. So now what's happening is that whatever S2 was pointing to, which is this particular object, now S1 also points to this particular object. Now what about this object? This object is no more required, right? So whatever S1 was pointing to, that is no more required, and that's what is going to be collected by the garbage collector. So now this object is going to be garbage collected as S1 points to something else later on. This is how you can actually, free this particular object over here as well. For example, if you are just working, on a simple instance, for example, you are doing a method call and then, you are wanting to pass S1. Instead of doing this, you could simply, pass a new student, and this is just going to make sure that this is anonymous. It does not have any name or any reference on the stack, and that's why, you don't actually need to create a new reference and thereby, not allow it to be garbage collected, because once this method call gets complete, then this anonymous object is going to get garbage collected. Is going to be garbage collected once method call completes. So this is how you can actually, make sure that your objects are garbage collected. Now, garbage collection really works with specifically, two methods, and both the methods are finalize and GC, and these both methods are available for us from Java itself. Basically, what we can do is we can actually override this particular finalize method. For example, in this memory management class, I can actually create this particular public void finalize, and in this finalize, the spelling, make sure it is right. In this particular finalize, I would just, do a simple sysout that, garbage collected. That's it. I would just write garbage collected. So this finalize method is actually going to run, and it's actually going to do some garbage collection, and it's going to do a simple sysout for us now. And in this main, for example, I'm creating a new object of memory management. So memory management n1 equal to new memory management, and similarly, I would do memory management m2 equal to new memory management. So now we have these two objects, and now I actually want to make m1 to be null and m2 to be null. So this is how I really want to make sure that, the next garbage collection happens. So now, instead of waiting for, till when the garbage collection would happen by the JVM and by my operating system automatically, I'm going to actually call system.gc. So this is going to be in capital system.gc. And this is actually going to call the garbage collection for me. So when I try to run this now we do not have any particular, output over here. And the reason for that is that, when we do call a garbage collection, it is not necessary that every time it's going to be garbage collected using this GC call. But if I try to actually run it a couple of times, we may, be lucky enough to get, that, both these objects are indeed garbage collected. Now, as you can see, we did get, garbage collected for one of the objects right now. And remember that this finalize method is actually going to be overridden. So we can actually add an override annotation over here as well. Let me just, make the formatting a little bit proper. So now when I actually try to run this, it's not necessary that we do get it garbage collected, but sometimes we may be fortunate to see that, both the things m1 and m2 are garbage collected and this finalize method is called. So I'll try this a couple of times now. So right now I did get, a scenario in which both the, M1 and M2 objects are garbage collected. So now this is one way, in which you can force the program to sometimes garbage collected, or you really don't need to do it. You really don't need to, worry about that. Just because you made it null at any particular garbage collection cycle in your Java program, it is going to get garbage collected. So you would not have any memory leaks problem. Also, another time in which you may have a memory leak problem is probably if you use static, huge data. For example, if I have a public static, integer array, and this is going to be new integer, and let's say, I have a big array, for example, over here. And then, every time I create this particular, I want to actually use this particular array, this is actually going to get created just because it is a part of the class. And let's say, for example, in main, after this whole thing, let me actually call a method. So let's say, for example, I have a method over here. So for example, I have public void write to array. And then, for example, I run this particular for loop for int I equal to 0, I less than, this whole big number, and I plus plus. And then what I want to do is basically, I want to add to this particular array the value of I. So at every, index, I want to actually put the value of I or any other value. For example, I just took this particular example over here. And then, for example, I actually call for a new object of memory management, let's say M3, and then I call M3 dot, and then I call, the write to array method. So what this is going to do is, it's actually going to create this whole new array, write to this array, for me. And then, this is going to take a lot of space in the heap, right? And now once my program gets complete, you would not be able to see, how much memory we have written just by creating this particular array over here. But even though now we do not use anything in M3, this static keyword is actually going to, let this particular array be there in the memory and then cause, memory issues for us. So instead of this, if we did not have, static, for example, instead of this thing, we did not have it static, we just had it, a simple integer array, 1, for example. So if I actually worked with array, this is going to give me memory leak problems. But if we used, something like arr1 I equal to I, so this doesn't give memory leak issues. And the reason is simple, because this is based on this particular instance M3. So once we wrote to the array, and then once, for example, once we made M3 equal to null, then this is going to be garbage collected and we would not have any memory issues. But this particular part, even if I made M3 to be null, but I actually wrote to this particular static big array, then this is going to give me a lot of memory issues. So I will just comment this part out, just to make sure that this is a problematic code, and that is indicated to you pretty well, that if we do have any static fields, and even if we actually use that particular static field with an object and we make that object null, but just because it is present with the class, that's why it's going to take a lot of space in our memory as well. And the last thing which you really need to know, and you might have thought while we are talking about memory, is that every time I actually open a particular resource, so any resource, for example, it could be a buffered reader or a buffered writer or anything relating to different files, different, let's say URL connection which I open, or any resource if I open, so this is for an example I have written, but any resource if you open and you do not close it, that is going to make a resource leak problem, right? I told you earlier. So this resource leak problem is actually going to result in memory leak issues as well, because resources take up memory, right? And if you do not close the resource, it's going to take up that entire memory for the entire amount of time, and you are going to land in some troubles with memories as well with that. So make sure that you always, when you open a particular resource, you are closing it to avoid any memory leak issues. Now finally, even if you make sure that your code does not have any of these problems, for example, you're working with a big software and you do get an out of memory error or a heap memory error, then what do? You need to understand that even though we have put in so much of effort, and even though garbage collection is something which is pretty good in Java, it does not prevent all the memory leaks, right? So we have some tools which we can use to check how much memory of the heap is being used at any point of time, and then we'll be able to see which thread or which process or which method call is actually causing this whole amount of memory to be used in the heap. And some of the tools, I would just name it for you. One of the tools is JPS and another would be called JVisualVM, or you could use Java Mission Control tool. You could actually install these tools and use them, and these would give you, the memory usage for various programs which are running. The image which you do get is known as object histogram, and that is basically listening of how much memory you are using and all the different types of objects which are using your memory and what is in the heap currently. So this is something which you can explore if you do land into some memory issues, but let's just keep it at this because the usage of these tools and everything is out of the scope of this particular course, and you may not even need it just because you have coded it pretty well. But just in case you do land into some memory issues, then there are these tools and many more different tools available to check memory issues within Java. So we have covered a lot of memory management things in this particular module as well. Now let's go ahead and actually take up the last topic in Java. Now let's look at the last and one of the most important topics in Java, which is known as multithreading. Multithreading is something which you might use in a lot of real world applications, and specifically because you want your programs to be very, very efficient. Now what is multithreading? Before even talking about multithreading, I actually want to tell you about multitasking and multiprogramming. Now, if you have any background with operating systems, you would know these topics. You would know that any operating system, let's say I work on Windows and somebody else might be working on Mac. But in any operating system which we use, we are able to do multiple things at the same time. So I can be browsing on my Google Chrome tab, and I can also be writing something on Microsoft Word, let's say, and I can also be, drawing something on Paint or any other program which I want to use. I can just, open it up and work on multiple things at the same time. Now, as a user, when I'm actually working with the computer, let's say I'm typing in a particular text editor and it is actually supposed to be catering to me first, right? Whatever I type, it should be able to type on the text editor in real time as I'm using it. But in between my typing, it still gets a few microseconds, let's say, and in those microseconds, it would want to do something else as well, right? Because waiting for input from the user takes a lot of time. The user might be thinking, the user might take some time, between two keystrokes, etc. Now that time is like pretty crucial for a CPU because CPU works within microseconds, right? It's not a human being which takes at least a few milliseconds to process certain things and then, input within the next few milliseconds, etc. So all the small chunks of time is something which is available for the CPU to actually work on something else. So for example, within my own application, for example, I have my Google Chrome tab, and within the Google Chrome as well, I want to actually work on multiple tabs. That is something which Google Chrome provides me with that functionality, right? And that is known as multitasking. So we do have multi-programming happening over here. We do have multiple programs working. We have Google Chrome, we have Microsoft Word, we have Paint, we have, any other text editor, my Eclipse IDE open, my PowerPoint open. There might be multiple programs running at the same time in my CPU, in my operating system. At the same time, in each program, the program would give me opportunity to actually do some other multitasking as well. Now, what is multitasking in a simple way? For example, you are, cooking in your kitchen. While cooking, is it that you only cook and you absolutely don't want to do anything else? Obviously, if you are like very passionate about cooking, you might be cooking, but at the same time, you might be checking some other blogs of cooking, some other videos on your mobile about, the same recipe which you're trying to do. Or probably if you're not very interested in cooking, but you still have to cook, you might want to, for example, your food is cooking on the stove, you might want to check something on WhatsApp, on Telegram, or on your, social media websites while the thing is happening. You might also be talking to somebody else, in the other room while you are cooking in the kitchen. Now, all these things are happening simultaneously. And this is known as multitasking. You are actually, doing multitasking. You are cooking, you're talking to somebody, or you're replying to somebody on WhatsApp. That is multitasking which you're doing. And what is the benefit of multitasking? The first and the most important benefit is that you are able to do multiple things at the same time. You don't have to actually complete a particular task to go ahead and do something. So you do have some time, between to tasks in cooking. So for example, you are waiting for something to get cooked before you actually start garnishing it as well. In between that time, you do have some time, right? So you are able to do multiple things in at the same time. And what is that helping you in? It is helping you in increasing throughput. So you are increasing in your productivity. By the time your food is cooked, you also have, replied to people on WhatsApp. You might have, completed a particular video on YouTube. You might have, done something while you were cooking. So both the things got completed at the same time, or things happened, faster for you compared to if you would have only been cooking, and then once the cooking was done, then you went on ahead and watched, that particular tutorial, or, talked on WhatsApp with somebody. So the first and the most important thing is that it helps you increase your throughput, increase your efficiency. And the next important thing which happens is that, for example, if some problem happens while you were doing something, for example, you were, wanting to reply on WhatsApp, but then your phone battery suddenly died. But at least you were able to continue cooking, and then, you have cooked food by the end of that amount of time, even though you were not able to, completely reply on WhatsApp or complete your tutorial on the phone. So multitasking really helps you in actually, not wasting your time a lot if, something fails. And to do this particular multitasking within a particular program, that is something which we do using multithreading. Now you might say that, why do we actually need to create multiple threads or create multiple things in the particular program itself? Why not generate new programs? So this is the same argument, for example, creating new tabs in a Google Chrome browser, or actually opening multiple Google Chrome browser, themselves. Now, if you actually, want to take things fast in the kitchen, let's say, you call your friend or, any family member with whom you're staying, and then you ask, him or her to do some tasks while you're doing something else. So, for example, while you are chopping, the other person can, prepare the seasoning. Or while you are cooking, the other person can prepare the garnishing items, These things really help in multitasking. If you would argue that, instead of actually adding threads to my own kitchen, why can't I actually, work on the same thing in multiple kitchens, so you actually get your neighbors also involved in their own kitchens, doing the same thing, and all those things. So obviously this is not feasible. You won't want to generate new programs. You won't want to write new programs to do, the task which you want to do fast. You want to actually improve the multitasking capabilities of your own program. You want to improve the multitasking capabilities within your own kitchen instead of getting other people's kitchen involved, okay? That is the same argument which we have for creating new programs or having multitasking within our own program. So if I can actually do multitasking within my own program, I would not want to write a new program, generate a new program and get that in the main memory. So I hope you understood why we would ever want to look into multithreading and multitasking within the same program which we are doing. Now, there are two things. One is a program which I have written in Java, and another is a process. When we actually get that written program from the disk to the main memory for the operating system to work on, that is known as a process. So the same thing, it is the program, it is written in Java, but when you actually start running it in the main memory by the operating system, that is known as the process. And each process has at least one thread. Now, what are threads? Thread is a lightweight sub-process, okay? You have your own program running, which is known as a process, and each process has at least one thread running. But you could also have multiple sub-processes within your own process. Just like I said, you could have multiple cooks inside the same kitchen, each of them helping in a particular task so that everything happens quickly. And even though one thread is waiting for, the food to get cooked, in that time, the other thread might be able to do something else. So you have all these tasks happening at the same time, and you have all these sub-processes working as threads in your own single process or single program. So with multitasking, you are able to perform many operations together, which is helping you get increased throughput. What is throughput? Throughput is the amount of work you are able to do within a given amount of time. So for example, if you were a single person doing the task of cooking, you might take 2 hours. But if you have, let's say, 2 people, it might get boiled down to 1 or 1.5 hours as well. So that actually gives you increased throughput. Or you are a single person who is cooking and also wanting to, reply to all the people on WhatsApp, or wanting to complete a particular tutorial while you are cooking. So both the things can happen at the same time, and you have increased amount of work being done within that single hour of your time. So multitasking and multithreading really helps you in that. Now remember, threads are independent. When you have a particular program, when it is running as a process, it has multiple threads, and each of those threads are independent, just like independent cooks in your kitchen, okay? Which means that if an exception occurs in one thread, or if any problem happens in one particular task, the rest of the threads can continue unaffected. Just like your phone died and you're not able to continue working on your phone, but at least you were able to complete cooking task, in the kitchen. So multithreading really helps us in actually degrading our program in a very graceful manner, instead of, the entire program crashing in and of itself. We will look at, how we could create a thread. There are two methods basically to create a thread. One is by extending the thread class of Java, and another is by implementing the runnable interface within Java. We would also see how we could schedule, various threads, because obviously it may be that, all the threads are running together and, life is, very happy. But it may be that, one thread is dependent on the other thread. So for example, one thread might be waiting for the other thread to complete the chopping process before those vegetables might be used to make the broth. So how do we do these kind of scheduling, make one thread wait for the other, etc.? That is something which we are going to see. We are also going to see, how to actually stop a particular thread, working ahead before we actually complete some other task by the sleep method. We will also see that at a particular time, we want to give the CPU cycles to only important threads. For example, you are working on the editor, and as I said that, the editor's main responsibility is actually give feedback to the user that whatever characters they entered are actually entered in the editor. And any other task which the editor might be using, like auto-saving, like, sending reports to the Microsoft website, let's say, or, Visual Studio website, just to make sure that, the performance of Visual Studio Code or the performance of Eclipse or the performance of Microsoft Word is happening properly. Those other things are of less priority, but the most important thing is how a user would use a particular text editor and gets feedback. So how do we assign priorities of threads within our program? That is something which we are going to see. Also, we are going to study what is a daemon thread, and then finally we are going to look into what are thread pools and thread groups. Now every thread which I would be creating would have different states, okay? These states are just like a life cycle. So human beings have a life cycle, right? We are, initially we are just newborns, and then we, become toddlers, and then we actually grow into teenagers, and then we grow into young adults, and then, we are in our, different stages of life. We are married, or we have children, or we are working, or we are retired, and then, finally we become too old, and then, we are a dead person. So a thread also has, these different stages in their life. So initially this thread would be simply a new thread, which is, just created newly. So that would be a new thread. When we call a method, which is known as the start method in Java, the thread becomes runnable, okay? Runnable means that CPU can now anytime start running the particular thread. And when does it actually start running? When the CPU calls the run method. So Java JVM is automatically going to call the run method. What we need to really do is make sure the thread starts. So first we need to actually start it. Then, the JVM is going to call run. It is going to be running. And then let's say, for example, we are waiting for another thread, or we go to sleep, this particular thread, we cause it to sleep. Then it actually enters the waiting state. Once it actually completes, the amount of sleeping or the amount of waiting, then the thread might go back into the running state. And then once the thread actually completes the execution, then the thread might go into, the completed or the terminated state, which is the dead state. So the thread is now over, it is dead. Now, other than start, even if, it is in a new state and, it acquires the time from the CPU, that is the time when it is actually going to resume. We also have a method known as resume. So if we actually start resuming the thread, it is going to start and it is going to become runnable. There are also other methods known as notify and notify all. That is also going to make it to the runnable state. And we are going to talk about all these things. Now the waiting state would also be called the blocked state, and the dead state would also be called the terminated state. So there's no hard and fast thing in Java or in general about threads, but these are just broad ideas about a thread, the different stages in which a thread can be. Now remember, while working with threads, that the two things which I actually talk about, multiprocessing and multithreading, both these things are used to achieve multitasking. Now different threads in your particular program, they use the same memory area, okay? As I said earlier, that the entire heap area is available for all the threads to use, okay? One important reason why, again, it's better to create multiple threads instead of, multiple programs is because if you actually create new programs, the whole context switching time of the operating system in actually working between different programs is higher. So let's say, for example, you were surfing on the Google Chrome tab and now you actually switched into your Eclipse or into your text editor. Then this particular switch time is higher for the operating system because let's say, the main memory area is going to be smaller. So the operating system would actually have to remove the entire Google Chrome data from the RAM and actually replace it with this Eclipse, and then, you are able to work on that. But let's say, for example, within Google Chrome, you have multiple tabs. So actually, changing the tabs within the same program is very, very fast for the operating system. And similarly, when we are actually going to code a program in our Eclipse, the program, when it is running, if we want to actually create new programs and actually start running multiple programs at the same time, the context switching between programs is higher, and a context switching between threads within a single program is going to be much faster. Just like having multiple cooks in the same kitchen and increasing the throughput of number of dishes which you want to actually cook is much better in a single kitchen with multiple cooks than in multiple kitchens, because obviously the entire switching between one kitchen to another kitchen of the different cooks to do certain tasks is going to be much, delayed time duration ones, right? So this is not something which we want. We want something which is very lightweight, very fast in context switching, and that is exactly what a thread is. It is a lightweight sub-process, and the entire process is actually a pretty heavyweight thing, okay? So now, for example, I am actually creating a new class, and this is just to show you a particular demo for thread. So I will just call thread demo. And in this, we do have a main method. Now within this main method, if I want to actually call a function 1 and a function 2, we do not have, these function 1 and 2 defined. So I would just, add these two methods over here. So I created this function 1 and I actually created a function 2 as well. Now these two methods are going to be called. In general, what's going to happen is that this function 1 is going to be called first, and then this function 2 is going to be called. So the general flow is main, then function 1, and then function 2. So let me just cut this from here and paste it over here just for clarity's sake. Now to show you when your main method and your function 1 and your function 2 are getting executed, I would want to include, the time of my system to show that to you. Now, if we do not have multiple threads in our program, so this is just a single process. So the first thing which is going to get executed is obviously the main method. Then it's going to call the function 1, and then it's going to call the function 2 once function 1 completes. So to show this particular sequence, I'm going to include a single line of code, and this is going to just print the system in nano time duration for us. And same thing, I'm going to put that over here and over here as well. Now remember that if we do not have multiple threads, these things cannot happen at the same time. This would happen one after the other. So when I actually try to run this, now you can see over here, I do have, these nano times over here. The first thing which is getting executed for the main method is going to have, this 619002000. Then the next one, which is going to get executed from function 1, is having 621064000, and the other one is 621 So this is the difference which you see over here in nano time duration between, the function calls over here. Now, what would happen if I do have multi-threading for me? If we do have multi-threading, then what's going to happen is that main function 1 and function 2, all of these three are going to start exactly at the same time, and it would not have all these differences with me. What I'll do is I'll actually save this in this hello.txt file, which we do have, just for our reference. And now I'm actually wanting to create a new thread over here. Now, one of the ways in which I can do that particular thing is by extending the thread class. So what I would do is I would do an extends thread, and now within this I would actually want to override my run method. So this is going to have a public void run, and within this run method, what I just want to do is probably just give the time in nanoseconds. And that's it. Within my main now, what I want to do is I actually want to create two threads of this same class. So what I'll do is I'll create two objects of this thread demo class. So thread demo T1 is going to be having created using this particular new keyword, and same thing I would do for another object T2. And what I'll do is I actually want to start the threads of both of them. So now what I will do is I'll use the start method for starting this particular T1 thread, and then for starting this particular T2 thread. So this is supposed to be the start method. And now let's do away with these two methods for now. So we have this particular run method which is going to run and show us the time duration for these two threads as well. So when I run this now as you can see over here, first similarly we do have this particular method run. So we do have 20799920 time, and then we have two things. We have thread 1 and thread 2. Now, as you can see over here, we have a very slight difference in between these two. We have 83800 and this is 47300. And can you see that my first method actually gives the time later than my second object, T2.start is actually giving the time first, and then the T1.start is giving the time. That means that we are able to actually start running this particular run method for T2 first instead of T1. And now compare that with the difference which we have seen over here. Here the difference was pretty huge. 619 and then 621064, and then this is 621 This difference is much more than this difference. Also the order is over there was exact, main, then function 1, then function 2, but here we have T2 starting before T1. So this is how we can actually work with different threads starting at their own times as soon as the CPU gets free to start them. Now another way in which you could actually do the same thing, create multiple threads, is by implementing the runnable method. So what I'll do is I'll comment this part out, and instead of this, I'm actually, instead of extending the thread, I'm going to implement the runnable interface. Now when I actually implement the runnable interface, again we have to override the run method, which we have already done over here. Now in our main, as you can see over here, we are not able to actually start the thread directly. It says the method start is undefined for the type thread demo, and the reason for that is simple, because if we are actually implementing runnable, we actually do not have any class which is extending thread for us. So what we are supposed to do is actually create a class of create an object of the thread class, and then pass this runnable implementation class in that. So what I'll do is actually I have this T1 and T2, but instead of actually just being able to start it directly, I actually have to create a new thread. So what I'll do is probably call this thread 1 equal to new thread class, and now within this particular thread bracket, I actually have to pass in this T1. So now you might have gotten a little bit confused, why this is happening. And the reason is only this, that, for example, you want to cook something. And today I'm taking a lot of cooking examples, but that's fine. If you want to really cook something, you have, all these vegetables and everything. You can't just put those vegetables directly on the stove top, right? You actually have to put them into a vessel and then put the vessel on the stove top. So earlier we were able to, simply extend thread and, we had this vessel of T1 and then, we were able to start the vessel, cooking the particular food from this vessel directly. But now what we have is, implementing this runnable method is just the raw vegetables which we have. If you really want to start cooking those vegetables, we have to put them in a particular vessel, and the vessel is going to be our thread object. Once we have this particular vessel of thread object, we are able to put that within the thread object, and then we are able to start using this thread object, thread1.start. And now this will be able to, begin this particular thread. And similarly, I'll do the same thing for thread 2. I will just use thread 2 over here and pass T2 object, and now I'm able to start the thread 2. And this is going to work exactly the same way as earlier. When I now print this, you would see that, we start it at, 092600, and then we have, 5645, and then, this is having 617600. So this is how, now the thread 1 is actually really beginning before thread 2. And that's actually absolutely fine. We do not care about, when these two things are beginning. What we really want to know is whether these two things are actually working exactly together. And to actually do that, I actually would want to now create a for loop to print something. So what I'll do is I just comment this part out, and from our hello.txt remove this part just to make sure that our serialization is done correctly. Now over here, what I'll do is I'll just create a simple for loop. Int I equal to 0, I less than 100, and I plus plus. And in this, I'm just going to, sys out the name of the thread, whatever is working with this particular point of time. Now to give a name to the method, I would actually want to add that particular name when I'm actually creating the thread, right? To give the name to the thread, I'm going to use the same, new thread, but then this constructor is having a number of different ways of using. Now, if you just go to documentation of Java and check, for the class thread, you will be able to see the constructor summary over here. And this is having a single constructor thread, and this is going to create a new thread for us. We could also pass the runnable target just the way we have passed, T1 and T2 objects within our threads. We are also able to actually name the thread by passing an extra string over here, and this is exactly what I'm going to do now. I'm actually going to create this particular thread with the name thread1, and it's a simple name which I'm wanting to give this. And over here again, the thread 2 I'm wanting to create with the name of thread 2. So these are going to be threads. And now over here, what I want to print is the name of the thread. So what I'll do is I'll actually use the this pointer, this.get. And here we are not getting the get name method which I expected, and the reason for that is that we have actually implemented the runnable interface over here, and we'll actually have to do the same thing in the thread 1 instead of actually overriding the run method in this thread demo class. So what I'll do is I'm actually going to comment this part instead and uncomment this part and comment out these lines, and I'll simply start the threads T1 and T2, and over here I'm going to give the names of the threads. This is going to be thread 1 and the other one is going to be thread 2, and I'm going to create a new constructor over here, and I'll just use the call to the super method. So I'm going to just call super and pass the string. So this is just going to create the new thread for me. So now what I'm going to do is I can simply use the this.get name. In fact, this thread would also have an ID. So what I'll do is I'll also print the this.get ID plus and a this.get name as well. So this is going to give me both the things. It's going to give me the thread ID. It's going to give me the thread name. The ID is something which the JVM will provide to the thread. The name is something which, we can provide over here just like that. So now let me just cut this from here just in case it would be a little bit confusing for you, and format it a little bit. I'll also comment this function 1 and function 2 because we do not need them. And now 100 times, what's happening is that 100 times it's going to get run by a particular thread, and we have 2 threads starting at the same time. So now let's see what's happening for us. Now as you can see over here, there's something happening. You do have your main method printing out the time over here. I'll just comment this part out as well. But then what you have is, you have 2 threads with the IDs of 14 and 15. The ID of 14 is named thread 1 and the ID of 15 is named thread 2. And each of them are actually doing the same loop at the same time, and that's why sometimes thread 1 is able to print and sometimes thread 2 is able to print. Now both the things are happening at the same time. As soon as any thread is getting the time from the CPU, for example, the CPU gets done with the loop for 1 or 2 times, then the CPU is able to give another thread a chance. So that's why we have the thread 1 working and sometimes thread 2 working, and this is how we have multiple threads working at the same time, and we have achieved multi-threading over here with this particular program. Now for example, I want to add some thread priorities out here. How can I do it? So for example, obviously the operating system is going to make sure, the JVM is going to make sure that both the threads 1 and thread 2 get to execute some part of their code in some time. But then what I want is that at least my thread 1 should have a higher priority than thread 2, and I want my thread 1, let's say for example, to complete this loop of printing the ID and the name 100 times, to be able to complete that before thread 2. So for that I actually want to give some priorities to my thread, and one way to do that is by setting priority using the set priority method. So I have my T1 and I have my T2. What I'll do is I'll set the priority of T1 using the set priority method, and this is actually going to have these 3 different values. One is the max priority, so I can give a max priority to it. I can actually give a min priority to some threads, which are not really relevant, just the way we would give a max priority to the task of actually giving the user feedback that the character they entered in their IDE or in their text editor immediately, that is going to have the max priority. But something which the software should do in the background and deliver some reports to the owning company, that should have the minimum priority. So what I'll do is I'll set the priority for T1 to be max, and I'll set the priority for T2 to be min. And let's see now, what do we have? Now when I run this, now you can see over here clearly that your thread 1 always gets the higher priority, and as you can see over here, thread 1 is something which is running a lot, and thread 2 is only getting a small amount of time, and only once thread 1 has actually completed its work by this particular time, then all the remaining cycles is something which is available for thread 2. Now obviously we cannot have this extremely hard and fast. It definitely depends on the operating system and the JVM how it assigns the amount of time of the CPU to the different threads, but at least we are able to see something which is making a slight difference by adding the max and the min priority. Now let me show you some other methods which we use while working with threads. So now whenever a thread is actually working, let's say, doing something in a loop or executing a number of lines of code, then we can actually make the thread sleep for some amount of time. So here what I'll do is I'll create another class other than, this thread demo. So I would write it to be thread demo 2. And this is again, going to extend the thread class for us. And now within this, again, I'm going to override the run method. So we have this, public void run. And in this, again, I'm going to have the same code. But now what I'm going to do is I'm actually going to make this sleep for some amount of time. So I'm actually going to make it sleep for a couple of milliseconds, and let's say for example I want to make it sleep for 2 seconds, so I would write 2000 milliseconds, and this is telling me to put it around try catch. So this is something which I would do. Now actually if I want to show this to you properly, I want to actually sleep the thread within my for loop for some times. So within my for loop itself, I would want to call this thread.sleep, and I would not make it sleep for everything for 2 seconds, right? I would, let's say for example, I would make it sleep for half a second, and I would run this particular piece of code for only 10 times now, and surround this around try and catch. That's it. So now this is something which I want to do even within my earlier run method. So I'll put this code over here as well. So now I have two classes. I have thread demo and I have thread demo 1, thread demo 2, and both these classes are something which I can work on within my main method. So instead of making it the T2 from thread demo, I would just use thread demo 2 over here. So now I have this particular thread demo T1 and thread demo 2 T2, and here again I would create a constructor similarly the way I have created earlier. Now we can definitely have two classes in the same file, and the first one is going to be the public class, which we have the name of the file as well, and this is going to have the main method, but we can have any number of more classes which we want, and we can have any number of threads. So I've just created these two threads, and now both these are actually going to work with sleeping for half of a seconds when I'm actually wanting to work on both of them. So now when I try to actually run this, just look at how the output is coming. Now the output is coming, at a duration of half a second, but then, two things at the same time. Thread 1 and thread 2, both of them wanting the attention of the CPU after half a second of duration. So that's how, we have this 14, 15, 14, 15, 14, 15, alternatively coming for us, after every half a second. Now, sometimes it may be that we do not want two threads to always work at the same time, together. We might want one thread to actually wait for another thread. So if I want to do that, I need to really use something known as the join method. So once I actually started T1, I can call T1.join, and what this would do is this would actually wait for us to complete this T1 completely, and then it's going to actually continue with something else. So when I run this now as you can see, only the thread 1 is going to run first, and until the thread 1 doesn't get completed, we do not have thread 2 working. Once we have this thread 1 complete, only then the thread 2 worked. And the reason for that is because we actually use the join method to make sure that this thread 1 is joined and completed first before doing anything else. So this is something which you really need to know when we are actually working with multiple threads and we want to do this inter-thread communication. So our main thread is actually going to wait for T1 to complete before going ahead and doing any other task. Even let's say for example, if I had a particular sysout statement and this would say thread 1 completed, this is going to get executed only once my entire thread 1 completes. So as you can see over here, my thread 1 is executing without letting anything else complete, and once thread 1 completes, only then I have any other code working ahead. Now you can also create an anonymous thread. You don't have to actually name the thread and name the runnable instance, etc. What you could do is, let's say over here, once you have completed your T2, you want to create a new thread. So what you simply do is, you could simply create a new thread object by using this new thread operator, the constructor, and within this you have to pass a new runnable instance, right? So we would simply call the runnable instance using this particular method, and now what we'll do is we'll simply override the run method, and over here we could simply write public void run and then execute whatever we want within this particular new thread. So what's happening is that, we don't have to actually call this particular thread specifically. What I'll do is I'll simply do a sysout and I'll say anonymous thread running. That's it. And once this whole run method completes, then this thread will stop execution because it will get completed, right? Now, if I just actually go ahead and start this is not going to help me a lot. So you can see the output. I started it. The thread 1 is running. Thread 1 completed. Thread 2 is running. And now it just got terminated. We could never see this anonymous thread running. And what would be the reason for that? Can you guess? The reason is that we have not started this thread. So to start this thread, we could simply call the start method over here. And this is actually going to start the thread. Now remember that when we start the thread by calling the start method, the JVM, the operating system itself, is going to, find time from the CPU and then begin the run method. So we don't have to actually specifically call the run method. Just in case you might be wondering till now, we don't have to specifically call the run method. This would get executed as soon as, the CPU finds time while doing that. Now, since we have t1.join, this is not going to, wait until thread 1 gets executed. But as soon as thread 1 completes, our anonymous thread started running, okay? And then the thread 2 started running. So both these things is something which the CPU is going to run anyways. Now this started running before, just because the program could find time with the CPU for this thread first, and then T2 started running. But that's fine, the whole point is that our anonymous thread is also running properly. So this is how we could create multiple threads and work with multiple threads together. Now the next topic is very important while working with threads, and that topic really relates to something which is common between 2 to 3 or multiple threads, and it's actually working on a common resource, and how we would actually make sure that the common resource is actually not corrupted by any other thread working at the same time with any other thread. So that is known as synchronization, and let's look at that ahead. Now, as I said, it may be that we are using multiple threads to actually work on the same resource. Just like my normal cooking example which I'm giving, that if we have multiple cooks working on the same dish, we really need to make sure that the cooks have synchronism in between them. They are synchronized so that our dish comes out perfect. If the cooks are not synchronized, if cooks are just doing haphazardly things to the dish, it would definitely not turn out as we expect, right? So let's say if we are really making tea, and we really are using 3 cooks, which may be an overkill in our situation, right? For making tea, we don't need 3 cooks. We can make tea by just using 1 cook, right? But then let's say, for example, we are making a very elaborate dish, but to simplify concept, I'm taking an example of tea. We really need to make sure that, the first cook is actually, putting water on the stove, and then, the other cook is putting tea leaves, and then, the third cook might put other garnishing items like sugar or ginger or, cardamom or anything else, right? What if before even putting water, you start putting tea leaves or other things? They would get burnt just because, the stove is on, right? So you don't want this kind of, non-synchronized efforts. You want synchronized efforts from the threads. And that's exactly what we want to achieve using synchronization. So synchronization gives us the ability to control the access of multiple threads to any shared resource. It allows us that, only one thread is able to access the shared resource at a single time. And we really want to use the synchronized keyword of Java to make sure that is happening. For example, at the same time, when the water is being poured, you don't want to pour tea leaves. It may cause, some accidents. It may cause some issues. And similarly, we don't want to work on the shared resource by multiple thread at the same time. We really want to synchronize their efforts. We use the synchronized keyword for that. This synchronized keyword would really help us prevent any thread interference of other threads happening to the common shared resource. And it would definitely prevent any consistency problem which we have. For example, if multiple threads are actually writing to a single file, we really want one thread to complete writing to the file before any other thread starts writing to the file. Or let's say, for example, we are actually printing certain things using the printer. You don't want the operating system to allow multiple programs to print onto the same page, because then you have something wrong happening on the page, right? You may be writing something and then suddenly the other program is writing something else, and you have a total mess on the printed paper. You don't want that. You really want the shared resource to be used and done with by one thread before going on to the other thread. And we use synchronization for that. Now, synchronization would make our threads mutually exclusive. So there's no dependency between, multiple threads. We really want our threads to be mutually exclusive. And it really helps, with all the inter-thread communication as well. So to make a particular shared resource or a number of lines of code mutually exclusive, we have three methods. We could use the synchronized method, meaning we use the synchronized word with a particular method, or we use a synchronized block, meaning we use the synchronized keyword for a small block. We don't have to actually use it for the entire method completely, or we use static synchronization. These are the things which we are going to see now. And this really helps us, have this whole cooperation between multiple threads, which we call inter-thread communication as well. Now, to demonstrate this thread synchronization, I'm actually going to create a new class for thread synchronization. It's going to be called thread synchronization. And within this, I'm actually going to create a new method. And this is just going to generate a simple string for us. I'm going to call it generate string. And I just want to generate a particular pattern, and I really want to make sure that my pattern is always consistent. My pattern should not have any issues. So for example, I would just, simply have a loop in this for I equal to 0, I less than 10, I plus plus. And in this, I want to make sure that, if, for example, my I is less than 5, I want to print, let's say, a star. Else, once it gets greater than 5, then I want to print a hash. And yeah, once this thing is over, then I want to just print out a new line. So this is what my generate method would do. Let me just format it a bit. Once my generate string method is created, then I actually want to call this particular generate string from multiple threads which I would want to create. So let's actually create a new class, in which I would have this worker, and this class worker is going to have my entire generate method. Now within this thread synchronization class, what I would do is I would create my main method, because that's where my program is going to begin. And in this, I'm actually going to create a new object of this worker class. So I would write worker w1 equal to new worker. And now I'm actually going to just, create a new anonymous thread. And within this, I'm going to create a new runnable method over here. And within my new runnable, I'm actually going to override, as usual, my run method. Now within run, I actually want to generate this, star and hash symbols for a couple of times. So what I'll do is, again, have my for loop, for int I equal to 0, I less than 5, let's say, and what I'll do is I plus plus, and then I'm going to actually call w1 dot generate string. This is something which I want to do in this particular thread. And then I'm going to simply start the thread. Now I'll save this. And now we really want to work on thread synchronization, right? So we need to have multiple threads. So what I'll do is I'll actually copy this entire thing again. So we actually have two threads now. We have the first thread running for, 5 times and generating the string, another thread running for 5 times and generating the string. Now let's try to actually run this program and see what happens in our console. So now when I have actually run this, you would see that there is some inconsistency happening over here. Sometimes the stars are coming ahead, sometimes, they are coming at the end as well. Sometimes we only have hashes. And every time I run this, I get a different pattern. This is not what I want. I want a consistent pattern, right? And the reason for this is because both the threads are actually working at the same time. And this is how threads work, right? They actually work at the same time. As soon as they get some time from the CPU, they run. And if I really want to generate this string properly, the way I want, initially all stars, then all hashes, and then a new line. If I really want to make sure that my threads are not working on this common method, this common resource, in a haphazard manner, I really want it to be synchronized. And the simple way in which we can do the synchronization is by adding the synchronized keyword in this particular method. So what I'll do is I'll add the synchronized keyword over here. This is simply going to make it synchronize for different threads. So just check the spelling. It has to be with the Z. And now when I actually try to run this, now you can see I always have this same consistent pattern with, 5 stars ahead and, 5 hashes after that. And every time I just run this, it's the same. And this is how, I would have a synchronized method which is going to run for different threads, but different threads are able to only work it independently, mutually exclusive. So this is mutually exclusive for my different threads working on the same method. Now it may be possible that you don't want to synchronize an entire method. For example, after the system.out.println, I have, all other code which does not need to be synchronized. And let's say it takes, some amount of time for it to actually work in this particular area. For example, I can just introduce a thread.sleep and then, I can sleep it for half a second. This particular part is not actually something which I want to synchronize. So I don't want to synchronize my entire generate string. What I want to do is I just want to synchronize this, for loop or, this part of the code. So what I can actually do is I can actually add a block around it just by using these 2 curly braces and actually cut the synchronized keyword from here and put this over here. So now this becomes a synchronized block. Now this is not complete because, it's giving us an error, right? Because we really want to make sure that synchronized is for certain thing. And what is that for certain thing? We are actually going to introduce this keyword over here for this particular object, of this worker class. So when we are actually working with the object W1, for W1, we want to add this synchronized keyword, and then every time this W1 is going to generate the string, we are actually going to have it synchronized for this particular for loop. If we have another object W2, then this is not going to be synchronized. So let me just show that. I'm formatting this and I'm running this now. Every time we have, this sequence running properly and the thread.sleep also working properly, and we have this, consistent output. But let's say I actually do not have this W1. I actually have W2. So I have actually 2 workers working now, and the synchronization is only for a particular object, right? So if I actually do a W2 over here, then if I try to run this, now you can see we do have this inconsistency over here. We do not have, a consistent output. And the reason for that is simple, right? We have the synchronized block only for that particular object. So if I have W1 object only working in different threads, then definitely it would be synchronized. But if I have multiple objects working with the same code, then, this is not going to work. So this is where it fails. But then if I have only W1 working, then, it would give me absolutely correct output. This is, giving me the exact correct output. I have the consistency required, and I also have, my remaining code working properly, the thread.sleep working properly, just the way I wanted. And avoiding synchronizing this entire method unnecessarily, avoiding, this whole delay unnecessarily, just because, I can actually, work with the delay, work with any other part of the code together, for both the threads. So this is the difference between synchronized method and synchronized block. Now, one recommended thing about Java is that, whenever we want to work with, this synchronized block, this object which we are wanting to synchronize it on should not be exposed to, the outside world. So if I have this class worker, I can actually have a private object, and I would call it a lock. And this is the lock, which is going to be used in place of this. So this object is also a lock in which we actually lock this whole synchronized block. But now we are actually creating a new lock which is called lock, and I'm just going to give a random string to it, and this is the lock on which we want to synchronize this particular block. Now when I actually try to run this is going to work exactly the same way as we would expect. And when I actually do this generates string using another object, and when I try to run this works properly, consistently as well. And the reason for that is now I'm actually not dependent on the different objects which are locking this. I'm actually only dependent on this particular single lock which I created, and that is actually locking this entire synchronized block for me. So if you had, any confusion that, we might forget using the same object for locking the synchronized block, then don't worry. This is a preferred thing of Java and something which you should definitely remember when working on multiple threads and locking certain blocks, synchronizing certain blocks for access by multiple threads. Make sure that you create a private object lock and then pass that particular object in the synchronized block to make sure that it's synchronized properly between multiple threads. Another method by which you can make sure that, even if you forget to work with, different objects, and still, the method should be synchronized, is just by making this entire method static. So for example, you do not have this synchronized lock over here, this entire, synchronized block. I'm just commenting out the irrelevant part, and I want this method to be synchronized. But I do not want to, worry about whether this method is actually being called with the same object or not. So here it's not getting called with the same object, and when I actually try to run this, I do have these inconsistencies between different threads, right? So instead of this, I would just make it static. So we would write synchronized public static void generate. And now when I actually try to run this, obviously this is going to give me warnings, just because, W1 and W2 are objects and we really don't need objects to call a static method. But anyways, when I actually now run this is definitely going to be synchronized properly. Just because it is static, it is not dependent on a particular object lock. So even if I actually don't call it using W1, I just call it using worker.generateString and then, again, worker.generateString, it's going to give me a proper result. And this is how, in another way, you can actually use a static synchronization method, a static method which is synchronized to be worked on by different threads without worrying about whether the lock is from the same object or not. So for now, I'll just get it back to how it was. And I can just write for your reference that we could also have a static synchronized method, like so. So this is pretty much about synchronized keyword and how we could have thread synchronization. The next thing which I want to talk about is inter-thread communication. One way is something which we have already seen using the join method. We also have the wait, notify and notify all method. We will also see, what is the meaning of interrupting a particular thread while it is working. We can use interrupt method, and there are other methods like interrupted and interrupted which we can use. So let's go ahead and check all of these out. Now to demonstrate this, I'm actually going to create a new class and it's going to be called thread communication. And in this, we are actually going to work on a real world scenario. Now, let's say, for example, I have a banking application, and in this, I want to make sure that I have multiple threads working. One thread might be wanting to deposit something, another thread might be wanting to withdraw something, etc. But I want to make sure that, every time my balance is consistent. Okay, so the first thing which I have, in my class is a static balance, and for now, let's have static public int balance equal to 0. Now this is the balance which I really want to make sure that all the threads are working on the same balance, but it should be consistent. Also, I want to make sure that no withdraw should happen until and unless some deposit has happened and my balance is above that particular threshold of withdrawal. So for example, if I want to withdraw an amount of 1000, then my balance should be greater than 1000. And I also want to make sure that my deposit has happened, before any withdrawals, because, initially the balance is going to be 0, right? So I'm actually going to create, two methods, withdraw and deposit. So I'm going to create a public void withdraw, and this is going to take in the amount which I want to withdraw. In this, what I'll do is I will just check, if my balance is, let's say, less than or equal to 0, or it is less than amount, then I really want to make sure that I wait in this particular thread for any other thread to actually deposit the amount in this particular account. So I would just write over here a sysout, and I would write, waiting for balance update, and then I would call the wait method. This wait method is actually going to help me waiting for any other thread to work on what we want to happen. So basically what we want is another thread to actually work and update the balance to be greater than 0 or to be greater than the amount for me, right? So I would now surround this with a try catch, and now outside this, I'm actually going to update my balance. So my balance is going to be balance minus amount, because this wait might be getting over and my balance has to be updated, right? And then finally I would write that amount withdrawn successfully. So this is all about my withdraw method. Let me also actually create a deposit method. So I would have public void deposit, and in that I have my amount which I want to deposit, and in the body of this method I want a simple sysout statement which is going to write depositing amount, and then I'm just going to update my balance. So balance is going to be balance plus amount. So we have these two methods created. Let me now create my main method, wherein I'm actually going to write some code for testing. Let me also format this a bit. Now in this main method I'm actually going to create two threads. So let me just create an object of this thread communication class in here. So I have thread communication T1, or thread communication obj equal to new thread communication, just to make sure that we know that this is an object. And now what I have is really two new threads. So I would just create new thread, and within this normally we would have two runnable, and within this runnable, just the way we have done, I would override my public void run. And in this, what I'm going to do is I'm actually going to let's call this a bank. So what I'm going to do is I'm going to do bank dot withdraw, and I'm going to withdraw an amount of 1,000, and this is something which I want to start immediately. And then for the next thread I'm just going to create this whole thing again, and now in this particular thread I really want to sleep the thread first. What I'll do is I'll call thread dot sleep, let's say for example half a second, and then once this sleep is done, then I would want to actually deposit the amount of 1,000, or let's say I want to deposit amount of 2,000. So I'll surround it with try and catch. So this is something which I'm going to start after this. Now remember, whenever you are actually trying to wait for something in a particular thread, then this wait or any other method like notify and notify all, that has to be inside a synchronized method or a synchronized block. So I'm actually going to make this withdraw to be synchronized. And even when I'm actually wanting to deposit again, I don't want the balance to be worked upon by multiple threads at the same time within the deposit. So I actually want to make the deposit synchronized as well. So now we have both withdraw and synchronized. What will happen is that first it's actually going to try to withdraw, but it would see let's say it would see that the balance is less than 0, or if the balance is less than the amount, then it's actually going to wait. It's going to wait until the amount is deposited and this deposit method is actually completed, and only then it's actually going to work on withdrawing the particular balance. Now when it is actually going to wait until the balance is going to be, above that amount of time. So now with this balance dot deposit, it's actually going to understand that, yes, the balance has gotten above the amount and I can do that. While it is waiting, can it even check whether the balance is, greater than amount? No, it's waiting, and we actually have to notify this particular, synchronized method to make sure that, okay, you were waiting, now I'm notifying you, now go ahead and check again and try to actually do your entire processing after you have done waiting. So we really do not want it to keep waiting for us. We want it to actually be notified again. Now, how do we notify? Once we have deposited, our amount over here, we could actually notify the thread which might be waiting, for balance updation to actually get notified. So we could call notify or notify all over here, or we could actually, do the deposit and then, call the notify over here, just to make sure that, now the deposit is done. Anybody waiting for this particular deposit, any thread waiting for, the balance updation, please get notified and, go ahead, stop waiting and go ahead and do your, withdrawal or anything which you are doing with this particular amount if you wanted to do. So what I'll do is, once I have done my deposit, I'll call the notify all from here. And this notify all is actually going to make sure that, all the other threads which are waiting for the balance updation can be notified. And when I actually save this, and now when I actually run this code, now this waits for balance update. It says depositing amount, and then it says amount withdrawn successfully. So this is working exactly the way in which we would want. But for example, we are waiting for balance update and nobody wants to actually, deposit the amount. Will we keep on waiting for like eternity before terminating the program? No, right? So for that, we can actually use another version of the wait method. And here it says that, you can also check specification for another type of wait. And so we do have, this wait long, and that's actually going to add timeout in milliseconds for us. We also have, another versions of wait. So for example, we really want to wait only for, 5 seconds. So when I save this and when I run this, now it does wait for the amount to be deposited and then it withdraws the amount successfully. But let's say we do not deposit the amount, in that 5 seconds. So before depositing, we actually wait for 6 seconds. When we actually try to run this, this would wait for balance update, and then it simply says amount withdrawn successfully. It basically waits for 5 seconds and then, it just does without, the amount being there within it. So this is something which is wrong, right? We really do not want to do this particular task just because we waited and, nobody did notify us. So this is something which we would do only if this part is true. So I would just, do a balance is greater than or equal to amount, only then do this updation and write that, we have done this updation. If not, then I do not want this particular thing to happen. This would simply, terminate this particular withdraw without actually withdrawing something. So now if I try to run this, now it says waiting for balance update, and then we keep waiting, but then, nothing happens. And now it says depositing amount, but then we do not have amount withdrawn successfully just because we kept waiting and nobody deposited amount in this amount of time. So this is fine for me, just in case, the amount withdrawal is unsuccessful, the user is going to actually retry amount withdrawal. That's absolutely fine. So instead of, adding the 6 second delay, I would just, add a 2 second delay. And now if we try to run this, we wait for balance update and then, we deposit the amount and then we are able to easily withdraw the amount. So now this is how thread communication works. We wait for some other thread, the other thread completes the particular task and notifies all the other threads. Another method in which we can actually notify is not by using notify all, but just by using the notify method. So instead of notify all, I could just write notify And this would work, exactly the same way as we would expect with notify all. Now, this notify is not actually going to notify all the remaining threads, which are waiting. It is only going to notify the first thread, which is waiting. So the thread which is actually waiting for the longest time, or the thread which has the highest priority, it's going to notify that particular thread. And then, that thread has the responsibility of notifying any other thread. So it's just like, people standing in a queue and everybody is waiting. And, once the first person completes their task, they are actually going to shift to make sure that, the person next to them notices that they have shifted, and, the next person can go ahead. And then it becomes the responsibility of that next person to shift once they have completed the task, so that, the next persons in the line get the task. So it's not necessary that, the first person in the queue, once they complete their task, they actually announce to everybody in the queue that, I have completed and now I'm moving, it's not necessary, right? So you can actually just call notify for the next waiting thread, the thread which is waiting for the longest, or the thread with the highest priority to get notified. So now at every stage, let's just, make sure that we are displaying the balance, just so that, our application looks complete. So now once this entire thing gets completed, whether the amount is withdrawn or not, we want to show the balance. So current balance is, and then, we would display the balance. And same thing we would do once our deposit is done. So now let's try to run this. Waiting for balance update, depositing amount, current balance is 2000, amount withdrawn successfully, current balance is 1000. This looks good to me. So this was about wait, notify all, and notify. The next thing which we want to see is how threads can be interrupted. So now one thread is actually working, it's either sleeping, it's executing code, it's waiting for another thread, anything. We can actually interrupt a particular thread while it is working, just to make sure that, any unnecessary thing is not happening in that thread. So for example, in this particular use case, so first of all, I really want to change some code over here. We were waiting for some time just to make sure that, if balance is getting updated or not. And if it does get updated and we get notified, then, if the balance is greater than amount, I really wanted to do something. If, it did not get notified within that period of time, then we were actually, just printing the balance and, not doing the withdrawal. But it may be that, the withdrawal, the balance is definitely, greater than amount. And this part is something which I want to execute also, if I do not have to wait, immediately as I actually work on this. So I just add an else if over here, and then, we should be good. But now I actually want to make sure that, any withdrawal is not illegal. So let's say, for example, I do have, a static private int illegal access. And this I would really want to make it false, that, we do not have any illegal access over here, and this would be Boolean. So we do not have any illegal access, then we are good. But what if we do have an illegal access? Then I do not want any withdraw to happen. Okay. So now I have these two threads, one thread is actually withdrawing, another thread is depositing. We are not really worried if, deposits happen, but we are really worried if, withdrawals happen. And what I'll do is, I'll create a new thread, and this thread would be called thread withdraw. And here, instead of, starting it over here, I would do a withdraw.start. But now I really want to check, if there was some illegal access or not. So if illegal access equal to true, let's say, the withdrawal does start, and then, suddenly in my own automated system, the bank, has an automated system to understand, probably notify the user that something is being withdrawn from your card or anything, and then the user immediately gives a missed call on that particular number. And then, so that's why, I will make sure that, there is a very less time duration between this particular withdrawal starting and, me checking the illegal access. But in any case, I check whether it is true or not. And then what I want to do is I actually want to interrupt this withdraw. Okay. So what I'll do is I'll call an interrupt method over here, and this is going to interrupt this particular thread. And when it actually tries to wait for any balance to come up, or probably even I can actually want to wait for some time, just to make sure if this particular withdrawal is not illegal. So I would again surround it with try and catch, and every time we surrounded it with a try and catch, you always see that this is an interrupted exception. So what happens is that when my program would be interrupted, then when my thread would be interrupted, then this particular part of the code is going to get executed. So what I'll do is I'll just do a simple sysout over here, and I'll write that thread or I would write withdraw interrupted. And similarly, this is something which I'm going to write in this particular block as well, that the withdrawal is interrupted and we were not able to complete it. So generally what we would do is we would simply return from this particular thread. I do not want to do anything. I would just want to return. That's it. I don't want to do the to do any withdrawal. So what I do is I would simply return. So now when I actually run this, nothing would happen because we have this illegal access to not be true, right? So we have this, amount withdrawn successfully. But let's say illegal access does become true over here. So somehow we get that, illegal access does become true. And, this is where I would want to really interrupt the particular withdrawal method. Now, when I actually try to run this, now this would say waiting for balance update, withdrawal interrupted, depositing amount and the current balance is 2000. So we are able to interrupt this particular withdrawal correctly, just the way we would want to in a real world scenario as well. So here I would just comment this out because we do not want to always interrupt this thing. We just want to make sure that we have this particular illegal access check every time. Another way to actually check whether this particular thread is interrupted and then return is doing a thread.interrupted check as well. So we have this particular withdraw thread. I'm starting this and I would do an interrupt over here. I could also check whether this thing is interrupted or not. So I would do thread.interrupted. So if this thread is indeed interrupted, then for here I would just do a sysout. Withdrawal interrupted and could not be completed. Now there is a difference between interrupted and is interrupted. So we could use is interrupted as well. And let me actually try to run this now. We have waiting for balance update, depositing amount withdrawn successfully. If I do this illegal access to be true, then we have this withdrawal interrupted and could not be completed. And the reason for this coming up first is because we interrupted the withdrawal and then we checked if it is interrupted or not, and then we were actually executing this particular line, and then that is actually something which got printed later on, just because these two threads are working independently, the main thread and the withdrawal thread. But the main point is that we do understand that withdrawal was interrupted and it could not be completed. There's another method which I just showed before this thing, and that is this interrupted method. And this, the only difference between is interrupted and interrupted is that interrupted is a static method which should definitely be accessed in only a static way. So for now I would just keep it as is interrupted. Okay, so if the illegal access is true, then it would be interrupted and it would show that withdrawal is interrupted. Let me try to run this again. Again, we have this withdrawal interrupted and could not be completed just because the illegal access became true. So we saw about the wait, notify and notify all method. We also saw about how we could interrupt a particular thread using the interrupt method and check whether the thread is interrupted or not using the interrupted or is interrupted method. Now let's look at the concept of thread pools. In Java, we may have, thousands of tasks which we want to do. But can we actually possibly create thousands of threads working together at the same time and then be able to make sure that, all the tasks get completed properly? I don't think so. It's better to actually have a small number of threads working, and then each thread can actually be given a particular task which is remaining to work on. So for example, let me just create a demo for that. I'm creating a new class just to make sure that, you understand the concept of thread pools. It's going to be called as thread pool. And now in this, I actually want to create another class which would be called as task. And this is actually going to implement the runnable interface just to make sure that, we have a number of runnables tasks which we want to do. And in this, what I want to do is I want to obviously override the run method. Now in this, I actually want to just, display something, probably cause the thread to sleep for some time. Let's say for half a second. And then, I was just want to do a simple sysout. And in this, what I want to actually do is I actually want to get the current thread whichever is running this particular runnable, and I want to actually get the ID and the name of that particular thread. So we could use the current thread method like this, and we could get the ID or name or priority of the thread, whatever we are working with at this moment of time. This is something which is supposed to be surrounded by try and catch. So now this is the task which I want to do. Every time I have a runnable, I want to make it sleep for some time and then, print the thread which is running this particular runnable. Now, as I said, that there has to be a thread which runs runnables, just like, we need a vessel to actually cook vegetables on. So we really need a thread to run these runnables. Now, we may have, lots of runnables, lots of tasks which we want to do. So let's say in this thread pool, I have this main method, and in this, I create a runnable R1, and I create a new task. And in this, I can actually pass some parameters as well if I have a parameterized constructor, but I'm just creating a new task as of now. And I'm actually creating a lot of tasks, I would say. I have 2, 3, 4, 5, 6, 7 tasks running as of now. And we can actually have thousands of tasks, really. In a real world scenario, we may have a lot of tasks to do in a particular program, right? Now, instead of creating, 7 or 1,000 different threads, what I would make is I would make a thread pool. And to make that, I would use the executor service class of Java. I would create a pool of this, different threads which I want to use. And I would use executors dot new fixed thread pool. And in this, I'm actually going to share how many threads I really want to create at a particular time. And let's say I just want to create 2 threads at a particular time. And at any point of time, my Java program will only have 2 threads. That's it. This is what I want. I don't want 1,000 different threads. It could be 2, it could be 50 based on the requirement. But yeah, this is exactly what you would want to do. And you import this from the Java util concurrent package, and you have this thread pool now. Now what you can do is you can actually pass these different runnables in any thread which is available from this pool. So right now we do not have any thread working, and let's pass the runnable using the execute method. So I would do pool.execute and pass the runnable R1, and then the thread which is available from the pool would execute runnable 1, and then I would keep doing that for all the runnables. So I have for runnable 2, 3, 4, 5, 6, and 7. I have, from my thread pool, any thread available, please take up this runnable and run it. This is what I want to do from here. And then finally, once I'm done with this entire thing, what I would want to do is just shut down this entire pool. So this is what I want to do. Let me try to run this now. Okay, so now I have these different runnables. So exactly we have 7 of them over here. The first one is actually being run by a thread with ID 14. Then we have another thread with ID 15. And then you see that we only have 2 threads with ID 14 and 15. And what name we have is, the name is pool 1 thread 1 or pool 1 thread 2. That's it. So we have one pool, which is pool over here, and we have 2 threads. Let's say, for example, I actually used 3 threads instead of, only 2. Now you can see I have, 14, 15, 16, 3 different IDs, thread 1, thread 2, thread 3, 3 different threads in pool 1, which is, a single pool which I have created of threads over here. So now whenever any thread is available, that thread is actually going to do that particular task for me. And now let's me actually create a constructor over here. So let me have a task name. And let me create a constructor using this particular field. So now I have a particular task name, which is going to be assigned over here. And once, I have this particular sys out, what I want to do is actually I want to write this particular task name over here as well. Now, I actually want to pass, the name of the task. So I would keep passing the different runnables. And this is just for your demonstration purpose, to make sure that you understand what is happening exactly over here. I have all these different runnables with different names. The task name are R1, R2, R3, R4, R5, R6, and R7. Let me try to run this now. And now we have, R3 running first. So the first task which actually ran was R3 from the thread with ID 16. The next task was run, which was R1 with the thread with ID 14. The next was R2 with the thread with ID 15. Now the thread with ID 16 actually ran the task R3 and now is available for running the task R4. And this is how we could actually use the threads in the pool to actually execute different tasks with different names and different things which we want to do based on whichever thread is available in our pool as of now. Now once we understood what is thread pools, JVM also has a couple of threads running in the background, and these threads are known as daemon threads. So daemon thread is actually a low priority thread that runs in the background to perform some tasks such as garbage collection, which we discussed already. And daemon threads, they do not prevent the JVM from exiting when all the user threads have finished their execution. And JVM would terminate itself, when all the user threads finish their execution. But if JVM finds, any running daemon thread, then it would terminate the threads. And after that, after it terminates all the daemon threads, only then it would shut down itself. So remember that, if you do hear this word daemon, just imagine that it is actually a very low priority background thread, running within the JVM. That's it. Now we already saw a particular method of causing synchronization between multiple threads so that it's, multiple threads are not working on the same common entity in a way that we get an inconsistent result. So we use the keyword synchronized, but really that provides us with basic synchronization, but then it is very rigid in its use. So for example, if we have a particular thread and that can be only locked once using the synchronized keyword. Synchronized blocks actually don't offer any mechanism of a particular waiting queue, and then after one thread exits that particular block or method, then any other thread can take the lock. So that probably can cause starvation of resources for some other threads which is waiting for a very long period of time. So starvation is actually a thing in which a thread keeps waiting for a particular resource, but just because other threads are able to get that particular synchronized resource before it, it actually keeps waiting and is, almost starving for the particular resource. One good way of avoiding this is known as re-entrant locks. And the study of re-entrant locks is extremely important for us to understand that, we may have things which we might be locking, and then it may be happening that, your program comes at a particular stage in which you have all the resources being locked and some threads are waiting for other resources. They have some resources locked currently and they are actually waiting for other resources to be unlocked. And they keep doing that until there is no way the system, the program can come out of that situation, and that is known as deadlock. And to understand what is deadlock and how it happens, we really need to understand about reentrant locks and how we could use it while working with multiple threads. So to demonstrate that, I'm actually going to create a new class for you, and I would just call it lock demo. Now in this, I'm actually going to create a shared resource. So for example, we have this static int count. This is something, which we really want to probably increment or decrement in, different threads. And this is the common, resource which we are going to work on. So now I'll create a main method over here. And in this, I'm actually going to create a new thread. So I'll just call it thread1. And I'm just going to create it using the new thread and just passing a new runnable as usual, the way we would do. And within this new runnable, I'm going to override the run method. So we have public void run. And in this, basically what I want to do is, let's say for I equal to 0 to 10, what I want to do is just, increment my counter. So what I would do is simply do count plus plus. And now I want to actually do, the same thing in another thread as well. So I would have a thread 2. And this would do, essentially the same thing. And this starts from a capital, but it doesn't have to start from a capital. It's supposed to be small. Okay, so we do have thread 1 and thread 2, and what we can do now is actually start both the threads. So what I'll do is thread 1 dot start, and similarly I would do a thread 2 dot start. Now let's actually try to also print what's the value of count after, both these things. So I would say count is. And now let's try to run this. What do you think would be the output? So we have count is equal to 10. Let's try to run this again. Count is equal to 0. Let's run this again. Count is 10. So now we have some sort of inconsistency happening over here. Now the reason is that this is a main thread which is actually printing count. We also have thread 1 accessing count and thread 2 accessing count. What thread 1 is doing, what thread 2 is doing at the same time in which I'm actually wanting to print it, we do not know. So that's why we have an inconsistency. Let me actually, wait for these two threads to, complete. So probably in my main thread, I would just sleep for some time, let's say half a second, and then see, what's going to be the count after that. So let me try to run this again. Now we have count equal to 20. And we keep consistently getting count equal to 20 just because we've waited for both the threads to actually complete working. So now we have both these threads working. Like in between, if I try to print the count, I do not know till where the thread 1 has gone. I do not know till where the thread 2 has gone. What I can do is I can actually also add a sysout over here. So I would write count is count, and same thing I would do in the other thread as well. And now when I try to run this, so you see that count is, keeping increasing, but, we do have, the printing happening in a pretty haphazard manner. So this is how I have, two threads, each working on the same thing, incrementing it 10 times each, and then at the end, I do have my count incremented completely by both the threads. Now, I do not want this haphazard manner thing to happen. I want to actually have a lock working, in each of these loops, in each of these threads. So I want to actually create a new lock, and that is known as the reentrant lock. And that is a static lock which I would have in this particular class, in which I'm actually, working with different threads. So this lock is actually coming from the lock class. and I would just call it lock, and this is going to be new reentrant lock. Now let's do the required imports. So I have this particular lock. If I want to actually, lock this particular, for loop, then I actually have to have something known, something like synchronized, which we saw earlier. So within my run, first I will get the lock. So I would do lock.lock, and then once I have completed this particular statement, then I would, do an unlock over here. So I would do lock.unlock. So what this essentially is doing is that, as soon as the thread 1 starts running, it would gain the lock. First, it will complete this particular thing, then release the lock. And this lock is actually a static lock value of this lock demo, right? So any thread which is, working within the lock demo is actually going to work as per this particular lock. So obviously we need to actually lock the other thread value as well, right? So I would do the same thing, lock.lock and lock.unlock after my for loop completes. Now let me actually try to run this now. Now you can see I do have this proper, my first for loop is working properly, and my second for loop is also working after that properly, and I have finally my count equal to 20 properly in the main method. So this is how I would have, my lock working in this particular scenario. What we want is that we want to lock the lines of code which is working on our shared resource, and then unlock it. Now make sure that, every time we actually lock something, we are able to unlock it. But because, otherwise, let's say, something happens, in the for loop, some error happens and this statement is never reached. So that means the lock would never be able to be unlocked, and I would never be able to work with the same lock in any other thread. And we do not want that, right? So instead of, just writing unlock over here, we should actually write it within a finally. So what I'll do is, after I gain the lock, I would start a try block. And once my try block is completed, then I would have my finally block. And as you know, finally block is something which definitely is going to work, whether there is any error in the try block or there is no error in the try block. This is definitely going to work. So I would put this try block again, after acquiring the lock, I would write everything in my try so that, any problem which happens, at least my finally block definitely is able to, work, and my lock is definitely being unlocked. So when I try to run this now, we have this exact same output. We have no inconsistencies, and we have used the reentrant lock properly. We also have made sure that, the lock would always be unlocked, whether or not my try statements cause any issue or no. Now, once you understood this locking mechanism, then you would understand that, if we are actually working in a particular shared resource, let's say count, we have used a particular lock. Let's say, for example, we had another shared resource, and let's say I would call it balance over here, and that is also 0 for now. And I actually want to work on balance, once let's say my entire for loop completes, I want to say balance equal to balance plus count. This is just a random thing which I'm doing. There's no logic behind this, but this is the thing, which I actually want to complete, doing once I complete with my for loop. So now if I want to actually work on balance, probably I might think that, I can have a new lock, let's say lock 2. And what I want to do is basically acquire my lock 2. So I would do lock2.lock. And then, once this entire balance is updated, I would say lock2.unlock. This is something, which I would want to do in the other threads as well. So I'll put the lock over here, and then I would unlock it over here. And I can actually, unlock it with the finally, block of try as well. So what I'll do is probably in this, I could add the lock2.unlock so that I'm sure that, anything happens within this, I do have this unlock happening over here. So this is fine. And if I try to actually now run this and, check what is the balance, I would actually, want to print this over here. So now when I actually run this, we do have, count is 20 and balance is 30. And then when I actually run this again, we have again, same thing, count is 20 and balance is 30. So this works fine. But, when you're actually working with multiple locks, you have, multiple shared resource, then it may happen that you are locking and unlocking every time in your code. And at some point of time, it may happen that there are multiple threads in your program. One thread is actually has a particular lock. Another thread also has a particular lock on a particular, resource, in fact. And one thread is waiting for a resource to get free, and another thread is actually waiting for another resource to get free, and both of them are stuck in a deadlock. So for example, this thread 1 over here has locked using the first lock and is actually working on the count. And then finally, that thread 1 is actually waiting for a lock 2 to work on the common thing balance. In thread 2, I'm actually wanting to work with lock 2 first. This is something which I'm doing right now, just to simulate a particular situation and show it to you that I actually have lock 2 first. I am working on balance, and now I'm waiting for lock to work on this particular count over here. So now what's happening is that if my thread 1 starts executing first, then it would acquire the lock, work on count, wait for lock 2 to get acquired to work on balance. At the same time, my thread 2 begins, it acquires the lock 2, works on balance, and now it's waiting for lock to work on count. But now lock is already acquired by the thread 1, and thread 1 is actually waiting for lock 2, but lock 2 is acquired by thread 2 and it is waiting for lock. And here we will never achieve a situation in which the thread 1 is actually getting a lock 2 just because, lock 2 is already locked by the thread 2, and thread 2 is actually getting the lock just because, lock is already locked by thread 1. Both of them will never reach the finally block to actually unlock both the locks, and this is where we would have a deadlock. So now let's go ahead and try to run this now. So now, as you can see, we somehow did not actually land in a situation in which we actually had, a deadlock. And as you can see over here that, balance is 1, and this is some sort of an inconsistency which has happened over here. Now, another way in which I could try to simulate a deadlock is by actually using locks within the synchronized blocks. So instead of, re-entrant locks over here, I would just comment this out and actually create a string lock 1. And I will just, call it a lock 1. So we have lock 1 and we have lock 2 over here. And now in the run method of my first thread, I actually want to synchronize, this whole part using my lock 1. So instead of actually, locking it like this, what I would do is I would actually create a synchronized block over here on the lock 1. And this part is going to be in the lock 1. And then this part, I would not have my lock 2, but within my lock 1, I am actually wanting to wait for lock 2. So this is going to be synchronized part of lock 2. So now within this particular block, I'm actually trying to work on this balance. So let me format it a bit. Okay. And we have to change these two to static, which is fine. And in the finally, we don't need to do anything because these are not re-entrant locks. We are just wanting to create synchronized blocks for lock 1 and lock 2 over here. Let me just terminate this program and clear the console over here. Now we do have, lock 1 and lock 2 over here. I would do the same exact thing in the second thread. Instead of, locking it like this, what I would do is I would have a synchronized block for lock 1, and within my finally, I would not have anything. And within my synchronized block of lock 1, I'm actually wanting to work on, the balance part. So I would just, cut things from there, and I actually want to gain, the synchronized lock for lock 2 as well. So now let's put this finally just where we had our try so that we do not have any parentheses error. And I'm trying to, begin with the thread start, everything. Now let's try to actually run this. Now we do have, our program terminating properly. Now, the reason is because, we have this lock1, lock2 in the same order in which we have actually acquired it. Now, when I actually try to do it in a reverse order, I first have my lock2 and then I actually have my lock1 in this particular order. And now when I actually try to run this, and this does work properly, and the reason for that would be because we can release this particular lock1 for another thread to use it, just because we do not know exact times when we actually are working with lock1s and lock2. So let me simplify this code a little bit so that I'm able to work and create a proper scenario of deadlock for you. So I'm creating a whole new file, and I would call it deadlock. And in this, I'm actually going to create my main method and simply going to create lock1 again. So this is string and this is lock2. Now in main, I'm going to create a thread 1. This is going to be new thread, and within this new thread, we have new runnable. And in this, as usual, we would override the run method. And in this, basically, I'm going to create a simple synchronized block with the lock1. Now, within this block, I'm first, telling that we are inside thread 1 on lock1. Okay, and now I'm actually wanting to work on, let's say, another resource. And I would create a new synchronized block with lock2 now. And now within this block, I would, just do a simple sysout again. I would write inside thread 1 on lock2. Now, I really want to work exact same way with my thread 2 as well, except that now I'm actually going to reverse the orders of these two locks just to make sure that, when my lock1 is acquired by the first thread, my lock2 is acquired by the thread 2, and then, at the same time, thread 1 is waiting for lock2 and thread 2 is waiting for lock1, and, we might get into a deadlock situation over here. Now, let's try to actually run these both threads. So we would do thread1.start and thread2.start, and let's see if, this thing does land into a deadlock situation or not. So let's try to now run this. We are inside, thread 1 on lock1, and then we are, so let's actually, terminate this particular program. We are in thread 1 on, so we are in thread 2 over here on lock1, and then we are on thread 2 on lock2. So yeah. Now here I'm trying to run this. We are inside thread 1 on lock1, okay, and then we are inside thread 2 on lock1, fine. And now we are not able to go ahead because thread 1 is actually waiting for lock2 and thread 2 is actually waiting for lock1, and we are in a deadlock situation successfully. And this is exactly what you have to avoid. This is exactly what might happen within, a number of threads if you're running and you do not know what is happening when. And then, at a particular point of time, you might land into a situation that, it is possible for your program to actually run successfully. Just the way, we actually worked on a complex program earlier. It may be that, your program actually runs successfully even though you have, different locks for different things, and then, you're actually locking some things and then, not locking other things, within them. But then it may be that you are in a particular situation in which you do land into a deadlock situation. And that is a very bad situation to be in. You have to actually make sure that your program never enters a deadlock situation, or you at least prevent your program to enter into a deadlock situation. One way to actually avoid, this whole deadlock situation is to use these reentrant locks. Whenever you are using these reentrant locks, you could actually try to gain the lock for some amount of time. But, if you're not able to gain the lock for some amount of time, then you would really want to, relieve any of the locks which you have acquired till now. So I would just, uncomment this part and then comment out the other locks which we have created. So I'm just trying to comment out, any problems which we would have while working with this particular, synchronized block. Okay, so now when we are actually trying to work with these reentrant locks, when we actually try for a particular lock, instead of, blocking it directly, what we can actually do is, we can actually, use lock dot, and then we could try for a lock. Okay, and now you can see there are two ways, we can do. We can, either try for a lock directly, without assuming that, we might get into a deadlock situation. But then, a better way is actually to try for a lock for some amount of time. So, let's say, for example, for 2 seconds, I would keep waiting for a particular, lock. And, here we would, I would say that, this is actually time in milliseconds, okay? Okay, so this is time unit in milliseconds. This is something which I would want to acquire. But, just in case I'm not able to acquire this particular lock, then I would, not try for this particular lock. And then, I would actually relinquish my efforts in trying to acquire any other lock. Or probably I would just, yield. If I do have any problem, in trying to acquire this particular lock, then I would just, simply yield, meaning that I would simply stop executing myself and yield for any other thread to actually, complete their execution before I go ahead. So what I would do is, once I try to, get that particular lock, I would just check, if I do get this particular lock, then, I would just go ahead. But, if I do not get this lock, so then what I want to do is I would actually, want to yield from the thread. If I'm not able to get this particular lock, forget it. I'm yielding myself. Go ahead, and other threads, please execute. Or I could, just do a wait also. Please, other threads, go ahead and, do some things while I'm waiting for any of you to notify me. So these are the various ways, in which I can actually work with locks and work with, this whole deadlock situation. So I'm just commenting this part out as well, and uncommenting this part so that, it makes logical sense to you. And, these comments also help you in understanding how we actually, whatever we discussed in this particular lecture. So, all right, in this particular lecture, we saw how we could use reentrant locks. We have lock and lock 2. First, we acquire the particular lock, try to work on count. Then we try to acquire lock 2. And then we actually, relieve both lock 2 and lock. So the order should be like this. First, lock 2 would get, unlocked and then lock. And then, in the other thread, I'm actually trying to lock the lock 2 first and then lock. And then, first relieve the lock and then lock 2. Now, as you can see over here, I had to actually, complete this particular code over here. Just because, I have something printed in the main, but I actually, could not complete the execution. That means, there was a particular deadlock which had happened. So now over here, if I just, comment out this part and we actually try to run this. Now we do have, okay, so it has gotten terminated over here. Let me actually try this again. Now it's not getting terminated. It just keeps running. It doesn't do anything. Okay. And the reason for that is because, we have that particular whole lock and unlock situation happening in such a way that we have, landed into a deadlock situation. And that is not something which we really want to do. So make sure that you are using the locks and unlocks properly. Make sure that, you actually have something, you're actually trying to lock for a couple of milliseconds and then, relieving it if you do not get that particular lock for a long time. Because now the user would not be just, sitting and waiting for your program to get executed and, just waiting infinitely in this particular deadlock situation. So this is the situation in which I was talking about. For example, you have these, trains coming in, and you only have this particular passage, and you have these 3 trains now, wanting to take this passage. And if any of these trains, come and take this passage, for example, you have this particular train, which is actually, landing over here. The train wants to either go, on this track or on this track. But then, the tracks are already full of trains which are wanting to actually now use the track in which this particular train is in. So now we have a deadlock situation, and there is no way to come out of this situation. Your program will hang forever. And similarly, the thread 1 is waiting for thread 2, and thread 2 is waiting for thread 1, and this is a deadlock situation. This is not something which we want to be in. So I would terminate my program over here. Make sure there is no deadlock in your program by, using the tactics which I just shared with you. In reality, we just, make sure that we work with locks judiciously, but, it may be that our programs might get into a deadlock situation, and it's only when we land into a deadlock situation, then we would want to actually use something like thread.yield. So don't stress a lot about that. And let's go ahead with the last topics in multithreading now. Now let's look at the last things which we want to know for understanding multitasking using multithreading, which we have been seeing till now. And that is the use of countdown latch, a shutdown hook, and a simple but an important question is, can we start a thread twice? So now to show about, the countdown latch, I'm actually going to create a new class known as countdown latch. And here I'm actually going to display to you, what I mean by a countdown latch. And what is a countdown latch essentially? So a countdown latch is just, used to make sure that a particular task waits for other threads before it to start. Okay, so if we do have a countdown latch in a particular thread, then it's actually going to wait for all those number of threads to, complete before it actually begins execution. So for example, in my main, I would create a countdown latch which is going to wait for 4 threads before it starts. So I would write countdown latch and create it using a new countdown latch. And now here I'm actually going to pass the number of threads which I'm going to wait for. So let's say I will wait for 3 threads to complete before I actually, go ahead and, continue my own self. And here I'm actually going to create, let's say 3 threads. So I am going to have new thread in which I'm going to have new runnable, and in this, I'm just going to override the run method. And I would just do a simple sysout thread 1 done. Okay, and I'm actually going to begin this particular thread over here itself. So this is my thread 1, this is my thread 2, this is my thread 3. We just need 3 threads, right? So let me just remove the 4th one. And I'll do the necessary imports over here. So now we have these, 3 threads which I just started now. And what I would do is I would actually call latch.await, because this is the statement which is actually going to make us wait for, this whole 3 threads. And I'll surround it with try and catch. And then finally, I would write all threads completed for the latch, and here I begin. Okay, so now without the latch, what do you expect? If we never had this latch, if we had these 3 threads, then what I would expect is that my main method would, print whatever it wants to print, and then, each of those threads would, print whatever they wanted to print based on, when the CPU is giving the time. So now it really doesn't depend on, what is going to be executed first. It may be that the main, sysout is going to be executed first. It may be that, any of these 3 threads would get executed first, and, we really do not know when these threads are going to get executed. So it may be that, the CPU gives time to thread 1, and then, to the main thread, and then thread 2, and then thread 3, and then, I never knew, when is going to happen what. It may be that, I have to actually write thread1.join in the main before I actually print anything, to make sure that at least the thread1 is completed before I actually, continue with my main and, all these other things. But now, I do not know what's going to happen. Let me actually, print this. I really want that my main thread should work only once these 3 threads have completed their work. So when I try to actually now run this, now it says thread 1 done, thread 2 done, thread 3 done, and we are still waiting for latch to be, for the latch to actually go and, my main thread to actually execute. But that's not happening. And there's a reason for that. Let me first, complete executing this. And the reason is because, every time my thread is running, I actually should be counting down the latch. Okay, so I have this particular latch in the main method, right? Now in this particular thread, when the thread 1 is done, I should actually be counting down the latch. So there should be a latch.countdown. So this is going to count it down once, then twice, and then thrice. And this is where, my latch.await would complete. So when I now run this, now it says thread 1 done, thread 2 done, thread 3 done, and once all these threads are done, my latch is indeed counted, completely down to 0. That's where all the threads, got completed, and, here is, what we want to do in main begins. So do something, whatever you want. So now this is how we could actually use countdown latches to make sure that, any thread which we are working in, for example, this is the main thread which we are actually working in, but any thread which we are working in actually waits for other threads to count down this particular latch, and then only I would want to, go ahead and work. The next thing which I really wanted to show you is the use of shutdown hooks. Now, what is a shutdown hook? It's just a special construct, which we want to put in our project or program, which would get executed every time the entire JVM or an entire program is shutting down. Now this may happen, if let's say your program returns, or the system, crashes and it returns with some exit code, or, some resource problem happens that, you suddenly turn out of memory and, the JVM is shutting down your program, or any other, problem which might happen in the runtime. So for that, we actually, to handle the last situations carefully, we actually create a particular shutdown hook, and then, we may add something in the shutdown hook to actually do things while the application is terminating. So over here, once, everything completes, what I would do is probably write runtime.get runtime, and here I'm actually going to add a shutdown hook with a particular thread. Now we can actually create a new thread over here itself, and this thread is going to have our normal run method overridden, and within this, I'm just going to do a simple sysout, and I would just write shutdown hook running. And then once this entire run method actually completes, it's only here when the application should be terminated. So now once, this entire shutdown hook completes, then I would write application terminated. Okay, so now let me try to run this now. We do have our certain things, happening earlier, and then what is happening is over here, my main is getting terminated, and then lastly the shutdown hook is running. So it actually makes more sense to actually write application is terminating. Okay, so now when I run this, okay, so now it says application is terminating, and then, finally we do have our shutdown hook which is running. So this is the last thing, which happens when your application terminates. Your shutdown hook is the last thing. So probably if you have opened certain resources, you would want to, close them when you are actually running this particular shutdown, or any last cleanups which we want to do. That is something which you do add it. And now the last question which I shared with you is, can we begin a particular thread twice? So now we have, all these threads over here. Let me actually create a new thread. So this would be thread 1, or let me just call it thread, and this is going to be a new thread, and within this I would just have my public void run and a simple sysout thread ran once. Okay, and over here I would now start the particular thread. Okay, now when I try to run this, it says thread ran once. Cool. Can we start this particular thread again? Let's say for example I put this thing again, and now we're trying to run this. Now there is an illegal thread state exception, and the reason for that is that you cannot start a thread twice. So even if you have started a particular thread once, you cannot start it twice, or more than one time. That is the thing. Let's say you would say that just because the thread was running, and now let's actually make the main thread sleep for 2 seconds, and then try to start it, just to make sure that this thread which was starting has actually completed. It would obviously take much less than 2 seconds to complete. Let's try to run this, and now we still have this same illegal thread state exception. Just because we waited for 2 seconds, we started it again, and still you cannot start it. Even though you have completed execution, you cannot start it again. So that actually answers our question, can we start a thread twice? And the answer is no. And these are pretty important things to know, especially if you are planning to give interviews on Java. So I just changed some formatting, and now we are good to go with everything learned within multithreading. So that was pretty much about multithreading. Let me just summarize this entire week for you. We studied, optionals and how we would work with nulls. We also studied, what are packages. We saw what is exception handling, and we saw so many ways of actually, handle a particular exception. We can create error-proof programs by using exception handling. We also saw how we would work with files. We saw what is garbage collection and how we could avoid any memory leak problems. We saw how we could use multiple threads to get things done faster. Lastly, I want to leave you with some motivational tips from this course. Remember to always choose consistency over speed. We as programmers generally tend to actually, get into a full speed mode, start programming, start learning, etc. But then we lose consistency very soon, just like a soda bottle that, loses the entire effervescence very soon. So we do not want to be like that. We want to be very consistent in our efforts. If given an opportunity to actually, work with very high speed for some amount of time, or work with an average speed but consistently, always choose consistency, because that is how you are supposed to be as a programmer. You are supposed to consistently keep learning, keep practicing, and keep getting better. Also remember that, it may be that this last module, especially multithreading, might have gotten you a little nervous about yourself, of not being able to understand, the broad topics. It's a little bit tricky to understand, definitely. But, when you actually try to just practicing once all these topics is going to make you very, very good in these things. You would remember what you have done just by doing things. When you listen to me, you remember some things. When you see me doing, you remember more. When you yourself would do, you would remember much more. Okay, so that is how you are going to get better. And remember, whatever you know, always you would feel, in the programming career that others know more than you. But it may be that you know certain things which others do not know. And this is known as imposter syndrome. Make sure that the imposter syndrome does not hold you back. The imposter syndrome will make you feel that others always know better than you. But remember that you also know certain things, or you also might have practiced certain things, or you also have those skills which others do not have. So you are unique and you are better than others in your own ways. And that is exactly what people want in programmers. Each programmer to be unique and to be better in what they like. So remember to always stay curious about, learning about programming and about solving problems, and always try to keep it fun. And do not worry if it doesn't work right initially, because if the program works right initially, I personally really get scared, how come it worked so trivially and so easily initially. And that really happens, when you actually try to run a particular program and it completely runs properly in the beginning itself. That means, probably the lines of code are never even reached which you coded. That, there is always a mind work which you have to do for solving a new problem. Because remember that if everything worked out well, you would be out of job, right? We would all be out of job. And we are here to solve problems using programming and using our skills. Remember to always have good quality code, because one man's crappy code is going to become another man's full-time job. And we do not want that. We actually really want to code nicely, and we want to keep solving problems, because there are so many more problems which we want to solve as programmers. And we really do not want to give, somebody the bad task of actually working against our, buggy code. So we don't want to do that. We want to solve problem in the best manners and create the best quality code. I hope you would keep on practicing and keep on learning the concepts which I shared in this particular course. And I hope you get very good in Java programming, especially object-oriented programming. So all the best for your assignments.
Congratulations on completing Crio.Do's ultimate guide to your introduction to Java programming. You have dedicated the past 10 hours to master one of the most essential and versatile programming languages in the world, and your efforts have paid off. Before you leave, please like and share this video. You can also comment below your doubts and queries, and we will reply at the earliest. Don't forget to subscribe to our YouTube channel for updates regarding similar courses, and check out our website to know more. Until we see you next time, goodbye and happy learning.